So most people have heard the phrase data analytics and big data. Now, I mean, how long has the industry been talking about big data itself? Seems like forever, right? Well, you probably watched, read, or sat in meetings about big data. In fact, you've probably been asked whether your organization has the big data problem or not. Well, that's an oversimplification. The real question is, what kind of data analysis solution does your business need? In other words, how should you store, process, analyze, and present data all the way from ingestion to presentation? Now, cloud computing is all about moving big things fast with minimal setup, maximum security, and low costs. The AWS Certified Data Engineer Associate exam itself, it validates the ability to implement data pipelines, to monitor, troubleshoot, and optimize cost and performance issues in accordance with best practices. Hi, my name is Syed, and I'll be the instructor for this course. I've been in the training industry for over 20 years, and I've trained thousands and thousands of students. As a senior IT enterprise architect, DevOps engineer, data engineer with cross-platform industry certifications, I'm here to give you real-world, hands-on knowledge and concepts to pass the AWS Certified Data Engineer exam. So let me tell you about the exam itself. The AWS Certified Data Engineer Associate exam validates your ability to complete certain tasks, for example, like ingest, transform data, orchestrate data pipelines while applying programming concepts. Now, choosing an optimal data store, designing data models, cataloging schemas, managing data lifecycles, operationalize, maintain, monitor pipelines, and much more, right? So there's so many things in this domain. I'm going to walk you through step by step in each of these areas so you get the required skills to pass the exam. So, for example, the course agenda and the main domain areas, let me walk you through those. The exam has about 4 domain areas, right? First is data ingestion and transformation, which is about 34% of the exam itself. So I'm going to be covering data ingestion patterns, for example, frequency, data history, streaming data ingestion, batch data ingestion, for example, scheduling ingestion, and how you take your data and stateful and stateless transactions, right? Reading data from streaming sources, for example, Amazon Kinesis, DynamoDB streams, AWS Database Migration Service, and AWS DMS, and Glue, Athena, and so on. So many areas of services that I'll be covering in this particular domain, which is the first domain covering about 34% of the exam. Domain 2 is data store management, which covers about 26% of the content, right? So in this domain, I'm going to be covering storage platforms, their characteristics, storage services, and configurations for specific performance demands, right? Data storage formats like, for example, CSV files, TFT files, how to align data storage with data migration requirements, and how to determine the appropriate solution for a specific action pattern, right? Other areas covered are how to manage log, for example, Amazon Redshift, RDS, and much more. Domain 3 is data operations and support, which is about 22% of the content. So in this domain, I'm going to be covering orchestrating data pipelines, for example, Amazon MWAA, step functions, Lambda, troubleshooting, managing workflows, calling SDKs, and calling other Amazon services through code, right, to process the data. For example, Amazon EMR, Amazon Redshift, AWS Glue, and so on. Domain 4 is data security and governance, which is about 18% of the content. Now in this domain, I'm going to be covering VPC security, networking concepts, difference between managed and unmanaged services, right? Authentication, encryption, security, and so on. So all of this is covered within this last domain, which is domain 4, right? Customer management policies and much more. So I'm going to be covering hands-on on each of these domain areas, focusing on step-by-step, giving you hands-on skills so you can pass the exam and also gain valuable experience from all these hands-on skills. Now, I've designed this course for beginners to intermediate level students who have a couple of years of experience working on the AWS platform, right? So if you are into cloud computing or want to become an AWS certified data engineer, then this course is for you. If you're already AWS certified, well, you are certainly going to gain some additional insight by taking this course. So what are you waiting for? If you want to become an AWS certified data engineer, click on the enroll button now, and I'll see you in class. Welcome back. Let's talk about the course structure and, of course, in depth the agenda, because I'm going to focus primarily on, and rather stay focused on, the exam topics, right? So that you're able to not only pass the examination, but of course get some conceptual and hands-on knowledge as well and gain some valuable skills. But before I dive into the domain areas of the course, let's set the course expectations, right? So let me first talk about what's not covered, okay? Now, all of the services that primarily relate to the data engineer aspect of the exam and the AWS tools and services are covered, right? So I'm going to talk about the foundationals, the concepts, as well as hands-on on all those services that are part of this particular exam and domain areas, right? But there are many, many other services that may not be covered in the exam, because even though they somehow may relate, but since my focus is on the exam topics and give you some valuable skills, I'm going to try to stay focused on the domain areas, right, that are part of this particular course syllabus. All right, so practice exam questions, yes, I provide those at the end of this course. You can go to the section of practice exam and take a look at different types of questions that mimic the real exam questions, by the way, or at least they do, right? All right, so that gives you an idea of how to practice, and not only practice with the exam questions, but during the live exam, you're able to easily manage as well. Then the foundational knowledge of AWS tools and services. Yes, it is expected that you should have knowledge of the AWS ecosystem and be able to work with the basic tools and understanding of different services. All right, what if I'm a beginner, right? So if you're the first time you're joining this course, taking this course, and you have no knowledge of the cloud computing or AWS, it may be a challenge for you, but I've added several lectures, right, just so that you can come up to speed quickly if you're tech savvy, or if you have some basic understanding of compute, storage, for example, or networking, then that's perfect. You can jump in, and not only jump in, but also catch up to speed with all of the domain areas within this exam. All right, so I wanted to cover the course expectations. Now let's dive into the in-depth domain areas of this exam. The AWS Certified Data Engineer Associate DEA CO1 exam guide, right? So basically this validates the candidate's ability to implement data pipelines. Now, what do we mean by data pipelines? Which simply means how the data flows from data gathering all the way to visualization, right? The entire data lifecycle and all the tools and services that you need so that you are able to efficiently monitor, manage, create data pipelines, right? And not only that, but troubleshoot and optimize performance issues, right? All right, so with that said, let's jump to the recommended general IT knowledge, okay? Now, of course, you have at least a year or two worth of experience, and if you do not, I've added several lectures that you'll be able to actually catch up to speed, right? So if you're a beginner, not a problem at all. You should be able to go through the entire course because it's a fairly lengthy course, okay? So, but in any case, you should have basic knowledge of Git commands, for example, general concept of network, storage, compute, some ETL pipelines if you have knowledge. Otherwise, I'm going to cover those extensively in the course as well. The recommendation that AWS provides is, of course, that you should have for example, how to use AWS services, or understanding of the AWS tools and services in depth, the fundamental knowledge that you require, and running SQL queries, basic SQL queries, how to create, update, analyze data, right? The exam content. Now let's get into briefly what that is. So simple, multiple choice, multiple response, not a problem there, very basic. And there are about, let's say you need about 720 to pass the score, which is it's reported on a scale of 100 to 1,000. The minimum passing score is, like I said, is 720. So it's not that bad. And it's the beta version, so it's half the price. So you should be able to gain some benefit right there. All right, with this, let's jump into the core areas, right? The 4 domains that this exam covers. So domain 1 is data ingestion and transformation, which is about 34%
of this content. And domain 2 is about data store management, which is 26%. So right here, you notice that's a little over 50%, right? Or almost 60% is covered in domain 1 and 2. And domain 3 is data operations and support, which is 22%. So enough to pass the exam, right? But hey, let's move forward. Let's check domain 4, which is data security and governance, which is 18% of the score content. So once you go through this entire course, learn the concepts and do hands-on, right, you'll have a pretty solid understanding of all these different domain areas. And each of these domains I've covered and created lectures, right, logically, so that, for example, once you start with the data ingestion and transformation, which is domain 1, the understanding of throughput and latency characteristics, all the way to data ingestion patterns, streaming data, batch data, stateful and stateless data transactions, right? I'm going to cover those in depth in domain 1. And of course, with that, you'll gain some valuable skills like in DynamoDB, RDS, understanding what these services are. So if you're new, this is your chance to learn, for example, Amazon Glue, Amazon Redshift, EMR, DMS, Lambda, Airflow, and so on. So I'm going to cover all these and give you solid understanding and, of course, hands-on demos and labs, so you're able to catch up pretty quickly. All right. So, of course, it gives you the in-depth analysis of this guide. And I'll provide this guide in the resource section, so you're able to download this as well. And there are some programming concepts, for example, continuous integration, continuous delivery, and you're able to use SDK or AWS CLI, right, to run some basic commands. And of course, lectures are there, so you can practice those as well. All right, domain 2 is data store management. So here you need to understand, for example, S3, right? All about S3. So in-depth coverage of AWS S3, which is the storage platforms and other storage aspects as well. I'm going to cover those and different formats, how to align data storage, how to determine the appropriate storage solution for specific data access patterns. So I'm going to cover this in domain 2. And of course, different tasks. For example, managing the life cycle of data is also provided, and designing data models and schema evolution is also covered within this course. All right, domain 3 is data operations and support. So right there, we'll take a look at how to automate processing by using AWS tools and services, how to troubleshoot which services accept scripting, for example, when to use EMR, what Redshift is, how, concept of data warehousing, the AWS Glue, for example, or Athena, QuickSight. I'm going to cover all these in data support. Okay. All right. So moving on, of course, it gives you the detail in those. And like I said, I've tried my best to cover all of these knowledge areas, right? Different domain areas that you see, so that you're able to gain solid understanding and also practice. And finally, we have data security and governance, which is how to use, for example, VPCs, IAM, creating policies, difference between managed services and unmanaged authentication methods, updating these VPC groups, working and rotating credentials, password management. So here you'll be able to learn how to secure your data. All right, so these are the 4 domain areas, of course, that covers the entire aspect of the exam. Now within the appendix, just go through that, right? In scope services for AWS and features, right? So here's a whole list that I've talked about. So pretty much I've provided all the details for Athena, EMR Glue, Lake Formation, Kinesis, right? QuickSight, so that you're up to speed. So go through this. Let me know if you have any questions. Pretty much this covers the entire exam in our course. Okay. So with this, let me know if you have any questions. If you're new, not a problem, because you can learn as a beginner. Like I said, I've provided many additional lectures, so that if you do not have the foundation knowledge, you can actually come up to speed. But ideally, of course, you need to have some experience of the AWS ecosystem. For example, if you're an AWS certified cloud practitioner, that's perfect. That's a great way to start your AWS certified data engineer journey. All right, with this, let me know if you have any questions, and let's move to the next lesson. Welcome back. Let's talk about the new Amazon Management Console. Well, they constantly update and change, and here it is. Now, if you create the AWS free tier account and you log on to the AWS Management Console, you will be brought to this particular page, which is the console home itself. Now, there are many widgets that AWS has already added. For example, they're recently visited. There's application, there's cost and usage, where you can see all of the billing and details for what is happening with your AWS account, health, welcome to AWS, of course, and then building a solution, exploring, and there are many other widgets. You can actually scroll down and take a look at all these, and you can add more widgets as well. Now, if you need to access services, for example, if you need to take a look at Amazon S3 bucket, right, on the top left, you will see the services option. So if you click on services, you will be given a whole list of all the services that are available on the AWS ecosystem. And all the way on the bottom here is the storage itself. So once you click on storage, you will then be presented with another list where you can choose what type of storage you're looking to gain access to. For example, S3, EFS, AWS Backup, and so on. So if I'm looking at the S3 bucket, if I need to create an S3 bucket, I will simply click on S3 and it will take me to that particular dashboard where I can now navigate and work on my buckets. Okay, so let's go back because I want to talk about other services and the console, the management console itself. All right, so this is how you access services. So now the list is on a drop-down list where you can see and then choose the service that you require. Under applications, you can create a new applications right from the application widget here, and of course choose the region where you are, which is US East 1 in my example. And then on the right side, you'll notice there's the new service that Amazon just launched, which is Amazon Q, which is the AI-powered chat assistant, right? This is where you can actually use the power of AWS and use the generative AI assistant. You can ask anything about the AWS services or how to create something, what you're looking for, and you can simply type anything right here on the search bar. So for example, if I want to create a new application, right, web application using WordPress, so I can say, give me the steps, create a web application using WordPress, right? So if I hit the enter key, what this is going to do, Amazon Q, which is still in the preview, it's a brand new service, right, that they just launched, very powerful. It's going to give me the list of all the steps, for example, right? So here are the basic steps to create a web application using WordPress on AWS. So first, you launch an EC2 instance, you connect the instance to the Apache web server, right? And then you run the command, the sudo yum install command for the web server, download the latest version of WordPress, create an AWS RDS database, right, for your data, and then update the WordPress configuration file, test your installation, and then complete the WordPress installation. And what's good about this is it also gives you these sources, right? So you can actually take a look at some additional documentation and then go through that way. So again, you can answer any questions. This is just an example that I gave. And then of course, if I close this down, you have the cost and usage. You can directly navigate to the AWS cost management console right here, or you can check your AWS health, for example, or you can build a solution, for example, build a web app, deploy a serverless microservice, right, virtual servers, launch a VM, and you name it. And of course, their announcement and blog. So they've simplified the AWS Management Console, very powerful. Another feature right here is on the top search, where you can actually search for S3, right? For example, if I search for S3, it's going to give me the whole list of services. So that's a shortcut way of directly navigating to your S3 buckets, right? And you can take a look at other features as well. And then you can also look at documentation, knowledge articles, and then resources is something new. So for example, if I click on resources, it's going to give me introducing resource search. And I can go to Resource Explorer, and then, which enables me to show cross-region, the entire ecosystem I can actually search, right? So which is the AWS Resource Explorer. And you can take a look at this as well. So let me demonstrate. Let me give you some hands-on. So you see the power and harness the power of the AWS Management Console, as well as some of the services. So I'm going to be using the latest service, which is Amazon Q, to create an S3 bucket, right? So for example, let's go ahead and open up our AI-powered assistant right here. and then it says ask me anything about AWS. Now before I actually do this, you'll notice there's another option, the Cloud Shell, right here on the bottom left corner, or you can actually open up your Cloud Shell from the top navigation bar as well. And once the Cloud Shell is open, you can then simply start to create or give some commands so that you can actually run commands right on the AWS platform itself. So if you need to create an S3 bucket, you will simply write the command here and it will do it for you using command line interface or the CLI. Now, a point to note here, which is a simple notification, the Cloud Shell will migrate from Amazon Linux 2 to Amazon Linux 2023 starting December 4, 2023. So just give you a handy notification if you need to take a look at this also, right? All right, so here's the Cloud Shell. I've already opened it, and here's my cursor right here, but I don't know the command. So for example, if you do not know the command how to create the bucket using CLI, well, I'm going to ask the Amazon queue. So navigate to Amazon queue and just simply ask the question, give me the command to create an S3 bucket named CLIDESK. So I'm going to create an S3 bucket and I'm going to name the bucket CLIDESK. Well, sorry about the typo right here, right? It should be THE. There you go. So give me the command to create an S3 bucket named CLIDESK. And if I search for it, it's going to go ahead and search. Let me close the PowerShell right here so you can see the screen here. Perfect. So it gives me the command to create an S3 bucket named CLIDESK using the AWS CLI, which is right here. AWS S3 API create -bucket -bucket called CLIDESK, right? So I can simply copy the command. I can copy the code, but some key points about this command are also explained. So this is a great learning way also as you're doing hands-on and creating and working with AWS tools and services. So the -bucket, for example, parameter specifies the name of the bucket to create, which is CLIDESK in this case. You can name it anything you want, and as a homework, go ahead, just simply follow these steps and create some buckets. The region does not need to be explicitly specified. So for example, the command itself is AWS S3 API, right? You can simply say create bucket. So you don't need to use the region itself. By default, the bucket will have public access disabled, and access permissions can later be modified once the bucket is created. Then you can set bucket policies and assign roles and groups and so on. Okay. So once you have the command copied, open up your shell right here, and I'm going to go ahead and paste, okay? And hit the enter key, and it's going to go ahead and it's going to create the S3 bucket. Well, how do I know if the bucket has been created, for example, or not? So let's go to S3. I'm going to go to services, of course, and then navigate to storage, S3. And this will take me to the S3 dashboard. And right here, you will see the bucket created. How easy is that? And it's absolutely powerful. So now you have the CLI within Management Console right handy at you. You don't have to create or download CLI from or on your machine. Or if you want to, you can. But on the fly, you can create the bucket using AWS commands. And that's a great learning way to start learning the CLI commands. And of course, Amazon Q is perfect because it gives you now the ability, which is your generative AI powered assistant, to run commands. And here's my bucket. So if I click on CLIDESK, for example, then this is my bucket. Now here I can set properties, permissions, and so on. Okay, so I hope this helps. I wanted to cover and also give you a short demo on the Management Console itself, Amazon Q, and then how to use Amazon Q and create a bucket as an example. Let me know if you have any questions. With this, let's move to the next lesson.
Welcome back. So let's talk about what is data analytics and the solutions, right? So in this lesson, I'm going to talk about data analytics solutions and discuss challenges when working with large data sets, which must rapidly produce meaningful insights. We also introduce you to the 5 challenges, right? The 5 Vs, as we say. And then also I'm going to talk about how to plan your data analysis solution. So data analytics is vital to businesses large and small. So data analytics processes are combined to create data analysis solutions, which help businesses decide whether and where to launch new products, when to offer discounts, for example, and when to market into new areas. So without the data provided by data analytics, many decision makers would base their decisions on intuition and, of course, pure luck, right? So businesses began to implement data analysis solutions, challenges arise. Now, these challenges are based on the characteristics of the data itself and analytics required for the use case. So in the past, these challenges have been defined as big data challenges. But in today's cloud-based environment, these challenges can apply to small data sets as well, right? Fast data sets, for example. Now, we've become a digital society. The amount of data we create and collect has grown significantly, and the pace of growth is accelerating, not to mention. Now, we've built systems to handle data collection, and those systems store all the data very, very efficiently. But think about this. What happens if you get your mail every day for months, right? Instead of opening it, you just set it on the kitchen table, and it's just staying there. It just piles up. That's what happens with data. Now, you're going to miss stuff, important stuff from this data. Now, think about big corporation. Now, organizations can spend millions and millions of dollars on data storage. And just like the mail on that table that never gets analyzed, well, sometimes just because it's just too costly to analyze it, right? You need a lot of resources. Now, let's talk about where the data comes from. So as you probably know, you can get data from a wide variety of sources. So human-generated data is data created by humans, typing information into a system or application. So it is the largest and best-known form of data. Now, it includes emails, documents, spreadsheets, images, data stored in databases, and much more. So computer-generated data is created by applications itself without direct human instructions. So it results from human-generated input combined with additional information gathered by a system itself. For example, I can fill out a form online and fill in my name, occupation, and address, right? Now, from this human-generated data, the application can then search for the occupation and learn the average income for my occupation based on the zip code. Now, the application can correlate the job openings and even send an email to me, right? So all of this is fetching data. So the average income and job openings are computer-generated data. Now, there's another form of computer-generated data that, has nothing to do with humans, right? This data is generated by the actions of applications and behavioral systems and network devices within a network itself. Now, this data is often in the form of semi-structured log files. It can also be stored in binary and log files, right? Now, these structures are sometimes hard to analyze, but provide great value and pattern matching by making correlations, right? Now, this helps businesses make decisions faster with better information. So the problem isn't finding the data. The problem is failing to do anything with it, right? And that can result in lost opportunities, escalating costs, reduced productivity, and then, decreased competitiveness. Now, developing a sound strategy for analyzing such large amount of data can help you reduce costs and gain operational efficiencies. Now, data analysis solutions, which are broader than big data solutions, are made up of gathering, storing, and processing and visualizing data itself. Now, how does big data fit into data analysis solution? Well, big data solutions can be a part of data analysis solution. The term big data itself basically describes the challenges of working with massive data sets with blazing speeds, producing rapid insights. But not all organizations are doing all three of these things, right, at the same time. Well, at least in my experience, right? And not all data analysis solutions will be performed at massive scale. Now, this is the key difference between the two, okay? Now, businesses fighting for digital advantage recognize the need to learn about their customers and use that information to better serve their customers. Now, these businesses need a data analysis solution. Big or small, the process for implementing one is exactly the same. Now, this is what I'm going to be discussing in the next several lessons. Now, organizations use data analysis solutions to extract value from their data. Now, what does a data analysis solution do? It helps you simply manage the entire data management cycle, from collecting to storing to processing and analyzing and visualizing in the form of a report or dashboard. So some benefits of big data, of course, big data is generated in many ways, right? The big question is how to put it all, how to create value, how to generate competitive value and challenges, right? Now, many data analysis solutions can be summarized by 5 key channels: volume, velocity, veracity, volume, value, okay? Not all organizations, face these challenges, but many do. Some struggle with ingesting large volumes of data rapidly. Others struggle with processing massive value or massive data and create new predictive insights. Still, others have users who need to perform detailed data analysis on the fly on simple data sets. Now, the components of a data analysis solutions. Data analysis solution has several components. The analytics performed in each of these components may require different services and different approaches. So I hope this helps. Let me know if you have any questions. Let's move to the next lesson. So the AWS Certified Data Engineer is a professional who specializes in leveraging Amazon Web Services, AWS, for example, to design, implement, and manage data solutions. So the primary responsibilities revolve around handling data-related tasks and utilizing AWS services to drive insights, manage, process, and analyze large volumes of data efficiently and securely. So I'm going to give you some key tasks. What does an AWS Certified Data Engineer might perform on a daily basis, right? So designing data solutions is first. They architect data solutions using AWS services, choosing the most effective, suitable based on requirements such as scalability, performance, and cost effectiveness. Data ingestion and storage is another responsibility, right? Mechanism to ingest, collect, and store data from various sources into AWS, and then utilizing services like Amazon S3, AWS Glue, Amazon Redshift, and more services to ensure data integrity and reliability. So third is data processing and transformation, like developing data pipelines and workflows to process and transform raw data into usable format for analytics and other purposes, right? Using services like AWS Glue, AWS Lambda, and Amazon EMR. Fourth is data analysis and visualization. So utilizing AWS tools such as Athena, right, Amazon QuickSight, or Redshift Spectrum to perform data analysis, generate insights, and then create visualizations for stakeholders in the company. Next is data security and compliance, how to implement security measures to protect data confidentiality, integrity, and availability within AWS services. Now to ensure compliance with relevant HIPAA compliance or regulations. Next is performance optimization and monitoring, right? So optimizing data workflows, monitoring system performance, identifying bottlenecks, and troubleshooting to ensure smooth data processing. So collaboration and communication is also an important area, right? Among cross-functional teams, communicating technical concepts to non-technical stakeholders, and then providing guidance to data-related decisions. Now, continuous learning and staying updated with the latest AWS tools and services is also a key responsibility for the AWS Data Engineer, right? So that you can enhance existing data solutions. So in essence, the AWS Certified Data Engineer is responsible for leveraging AWS services effectively to manage, process, analyze, and then drive actionable insights from large volumes of data while ensuring data security, compliance, and optimal performance at the same time. Now, they play a crucial role in enabling data-driven decisions so that companies can make effective decisions by harnessing the power of AWS platform.
Welcome back. Let's talk about the value of an AWS Certified Data Engineer. In other words, what do you get out of this particular certification? So basically, just in a nutshell, the AWS Certified Data Engineer implements data pipelines, right? Is responsible for not only managing data pipelines, but making sure that everything is accurate, performance issues are not there anymore, the data has high integrity, and so forth. Another thing that the AWS Certified Data Engineer does is monitor, troubleshoot, and optimize cost, because data comes in with a lot of cost, right? Because there's huge amount of data that an organization has, and in order to manage the entire data lifecycle, there's a huge cost associated to it. So one of the prime responsibilities is, of course, optimizing cost. For example, if you're not managing data properly, right, whether it's structured, whether it's unstructured, then you could have huge database costs, okay? For example, if you're using Amazon DynamoDB or RDS, and if you're not properly architecting the solution itself, right, then the cost could increase. And another benefit, by the way, this is my favorite, right? Because 73% of respondents, according to Jefferson Frank, reported a salary boost of earning an AWS certification, receiving an average increase of 27%. Now, this could be any certification, right? They don't limit themselves to the data engineer, but on average, that's what you'll get out of this certification. All right, what you should have, in other words, what are some of the prerequisites, right? So if you have 2 to 3 years of experience in data engineering, that's wonderful. If you do not, that's fine too, because I've designed this course to be fairly lengthy, okay? It covers everything. So if you are an experienced individual, then jump to the right section within the course so that you could benefit from it, right? And if you're a newbie or a beginner, not a problem, because you go through all of the lectures and you'll gain valuable skills. You should also have at least 1 to 2 years of hands-on experience working with the AWS ecosystem with all the services, or if you have, let's say, the AWS Cloud Certified Practitioner certification, that's perfect because you have knowledge, the fundamental knowledge of all the AWS services, and you have worked with some of the basic key services. And of course, you should also have general IT knowledge, working with Git commands, networking concepts, subnets, and then of course, compute knowledge as well. All right, so here's the exam content. Now, I've covered this previously in depth, but just so you know that the exams are reported from 100 to 1,000 scale, and 720 is the passing score. So you need about 72%, and you'll have about 170 minutes to answer 85 questions, okay? And the questions are multiple choice or select the best answer, okay? And there are 4 domains, and I've covered these domains extensively. The primary domain is data ingestion and transformation, which is about 34%. Data store management is 26%, where you're basically working with understanding data cataloging systems, the life cycle of data, and so on. Then you have the data operations and support, which is automating data processing by using various AWS services, right? Not only that, using QuickSight, Athena, Glue, and different services that I'm going to cover in this course. And of course, domain 4 is data security and governance, where you'll apply authentication mechanism, working with AWS IAM security groups, policies, and applying authorization mechanisms, and ensuring data encryption and masking, okay? So these are the 4 domains that I'm going to cover pretty much in depth, starting from domain 1, which is data ingestion and transformation. All right, great. So in summary, the value of the DevOps engineer is, of course, high salaries. We know that because the median salary is about $140,000, right? Now this could go as high up to 175, or I have students who are actually earning more than 200,000 per year, right? The validity of the exam is about 3 years after you pass it, right? So if you take the exam right now, of course you get a discount, right? It's half the price, which is not bad. So the standard exam will be coming in first quarter or maybe by March. So I hope this helps. You understand the value of the AWS Certified Data Engineer. Let me know if you have any questions. With this, let's move to the next lesson.
So if you have a need for a comprehensive data analysis or even a basic analysis solution, well, ask yourself, are you struggling to support certain increases in the volume of data that you're dealing with, or the speed on which data arises, right? Or the variety of data sources, for example, the accuracy of your data, whether you're drawing value from your data or not. So if these are the questions that you're actually talking about, right? I'm going to be talking about all these challenges, right? So it's veracity, value, volumes, right? So let's take a look at each of these, right? So when I say volume, I mean the amount of data that the solution must handle. Now the solution must do it efficiently and be able to distribute the load across servers to handle the next V, which is velocity. Now velocity is the speed at which data enters and flows through your processes. Now, many businesses use large volume of real-time streaming data, so that solutions must be able to rapidly ingest, rapidly process this data. Third V is variety. Ingesting data, many different types from many different sources, can be many challenges, right? So smart companies build solutions to work with structured, semi-structured, and completely unstructured data types. So I'm going to get to data types later, but for now, just focus on this. The fourth V is veracity, which is the trustworthiness of your data. So have you ever heard the saying, my word is my bond, right? So it's supposed to instill trust. So let you know that the person that you're talking to is trustworthy, right? And that's veracity. To have trustworthy data, you have to know the problems of your data. Okay, so next is chain of custody of your data, right? So you can say with certainty that the data has not been altered falsely. So collecting data is easy. Making sure it's accurate and consistent, that's the challenge, right? That's the hard part, and that's veracity. The fifth V is the value, which is the bottom line, really, right? The whole point of this effort is to get the value from your data. Now that includes creating reports and dashboards that, create critical business decisions. It also includes highlighting areas as to improve your business, and includes making it easier to find and communicate critical details about business operations. So there you have it. These are the 5 V's of data. Now that I've discussed these indicators, you may need a data analysis solution. Let's talk about what you need to know to prepare for one. First, you need to know where your data is coming from. The majority of analytical data comes from existing on-premise databases, right, and file stores. So streaming data is becoming increasingly popular as the use of public data to enrich the other data sources that your solution can handle. Next is you need to know the options to process your data. So the term processing includes collecting, cleaning, transforming, and loading data into an analytic data store. Now that's a lot of work itself. Now this process can be handled manually or by using applications to assist in automating this process. Finally, you need to know what you need to have learned from your data itself, right? So the result of collecting and processing all this data should be actionable insight. It should give you some value. Now these insights are often presented in forms of reports and dashboards. Now, due to increasing volume, veracity, variety, and value of data, some data management challenges cannot be solved with traditional database and processing solutions. Now, that's where data analysis solution comes in. So running a data analysis solution is basically incorporates many forms of analytics to store, process, and visualize data. Now, planning a data analysis solution begins with knowing what you need from the solution itself. Know where your data comes from. The majority of data ingested by a data analysis solution comes from existing on-premises databases and file stores. Now this data is often in a state where it requires processing where the solution will be minimal. And of course, streaming data, for example, is also gaining popularity, right? And now this data source is less structured. Now, it may require special software to collect the data itself and specific processing applications to correctly create, analyze in real time. And that's really what this data sets are all about, right? So next is public data sets, for example. So census data, health data, population data, and many other data sets, large data sets, right? So they're collecting on their customers, for example. Now, this data may need to be transformed so that it contains only what the business needs. So you need to know the options to process your data. Now, there are many different solutions available for processing your data. Now, there's no one-size-fits-all, by the way, right? You must carefully evaluate your business needs and match them to the services that will combine to provide you with the required results. Now, throughout in future lessons, I'm going to talk about like AWS services, which it does offer for each of these components, right? So you need to learn from your data. You must be prepared from learning from your data and optimizing so that teams can learn from your data. So it is vital to spot trends and make correlations and run more efficient, profitable businesses, right, based on your data. So it's time to put your data to work, and that's really what this is all about. So I introduced the concept of data analytics and data analysis solutions. I talked about the 5 V's, right? Different challenges that come from large data sets, which you can actually use solutions to create actionable insights and value for the organization. So I hope this helps. Let me know if you have any questions. Let's move on to the next lesson. Welcome back. Super excited. I'm going to talk about the concept and the differences between throughput
and latency. All right, so what is throughput, right? So basically throughput is something that sort of like handles or goes in the bandwidth, and latency measures the length of this, right? So throughput is the sort of like, think of this as the size, okay? Size of the bandwidth pipe itself that allows data to be pushed in. And latency is the length, or how long does it take, right, within that bandwidth. So, but let's focus on throughput first. So basically it refers to the rate of which data can be transmitted, right? That's throughput, simply put. It determines how quickly data can be ingested. Like I said, it's like a pipe, right? So you push data from one side, and then we need to measure how long data takes from point A to point B, right? So how quickly can be ingested, processed, and then stored. That's throughput, which is essential for architectures where, for example, there's large amounts of data that you need to ingest continuously. Now, latency, on the other hand, is basically, like I said, the length, right, or the time delay between the start and the finish, okay? So either you initiate an action and then the occurrence of its effect. That's latency, which is basically measurable, right? So if the latency is low, which is critical for real-time applications, and high latency can impact the responsiveness of the applications. And then, of course, as a result, you can have critical delays or insights derived from ingested data. So makes sense about latency, right? Now, what happens when we talk about AWS services in regards to data ingestion? Now, you can use service or tools like Amazon Kinesis Data Firehose, right? And there are many, many use cases for data ingestion. I've covered Kinesis, Stream, or Data Firehose as well. And throughput ensures the efficient data processing, while low latency enables real-time insights. So in regards to the homogeneous data ingestion patterns, okay, now these patterns aim to move data into a destination in the same format or storage engine as it was in the source. So for example, the relational data and the data files ingestion, it basically maintains the same format. And in terms of large objects or blob ingestion, it's the same. So if it's homogeneous, it stays the same. And on the other hand, if it's heterogeneous data, okay, that data must be transformed. So either through an ETL process, for example, as it's ingested into the destination storage system. So if you're storing it into a data warehouse or Amazon Redshift, then you can transform it and then store it. In terms of the relational data ingestion, you can use different engines, okay? And data ingestion patterns, of course, vary based on your project needs or what the data needs to be transformed and whether historical data is involved or not. So basically, that's heterogeneous ingestion data patterns. So I hope this helps. I just wanted to cover the concept of throughput and latency, a basic concept. You may get a question on this, or understanding of these two concepts and terms and how they relate to data is helpful. Let me know if you have any questions. With this, let's move to the next lesson. Welcome, everybody. In this lecture, I'm going to talk about replayability, stateful, stateless transactions. Okay, another important concept when we talk about data ingestion. So let's dive right in. First, before I move to what is replayability, let's talk about stateful and stateless applications. Basically, they refer to how they manage and store information or state data. Now, stateful applications retain the state or memory of past interactions and data itself, and state information is stored and remembered by the application, often on the server or in a database. Now, these stateful applications also maintain, by the way, they not only remember, but they maintain a memory of previous client interactions, allowing them to remember context and past actions. So for example, databases, sessions in a web applications, and online games that track user progress. Now, on the other hand, the stateless applications, do not retain session data or memory of past transactions. So it's just the opposite. And here, each request is processed individually without the knowledge of previous requests. The stateless applications also do not store client state information on the server and rely on the client to send all required information with each request. For example, they are commonly found in RESTful APIs where each request from a client must contain all necessary information from the server, right, to understand and process requests. I hope this makes sense between stateful and stateless applications. But let me give you quickly the key differences right here, right? In stateful, applications maintain the state of past interactions, while stateless applications do not retain this information. Okay, so that's the first key difference. The second key difference is that stateful applications store data either on the server or in a database, whereas stateless applications require all necessary information to be provided with each request. All right, let's move on to the next, which is replayability. Now, in the context of data ingestion, replayability refers to the capability of a system or process to reprocess or re-ingest data that has been previously processed. It involves the ability to replay or rerun data pipelines, workflows, or ingestion processes to ensure data integrity, correctness, or to address errors that might have occurred during the initial ingestion, right? So the replayability in data ingestion, right, is important, by the way, for several reasons. First is error handling. Okay, so ingestion process might encounter errors or failures during data processing. So the ability to replay data allows for reprocessing of failed or erroneous data. Okay, the second important reason is that data consistency, because in certain scenarios, especially in distributed systems, data might need to be reprocessed to maintain consistency. Right. Third is upstream changes, where when data upstream data sources or schema change, it might be necessary to re-ingest data, right? And the fourth is testing and development. Now, for example, in a development or testing environment, the ability to replay data is crucial for debugging, testing new features, or simulating scenarios without affecting the live data. Now, to implement replayability in data ingestion, right, there can be many strategies that you can actually use. For example, the idempotent operations. And what are these? These are simply designing ingestion processes to be idempotent ensures that replayability or replaying the same data does not result in duplicate records or unintended side effects, right? Second strategy that you can actually deploy or use is logging and auditing, okay, which is basically maintaining detailed logs. And then you can also use a strategy called checkpointing, which is implementing checkpoints or markers at various stages of the ingestion pipeline. Kind of makes sense, right? And this will help you track the progress, by the way, and identify the point from which data needs to be replayed. Another strategy that you can use is backfilling mechanisms. Now, this is having mechanisms to backfill or reprocess data from a specific time or event can actually help in efficiently addressing issues without reprocessing the entire data set. So that makes sense, right? So replayability, we talked about the importance of replayability and of course several strategies, because ensuring replayability in data ingestion is critical for maintaining data integrity, reliability, and consistency. All right, let's talk about challenges, right? I've briefly mentioned some challenges. The first is idempotency, right? Because you need to ensure that replaying the same data does not cause duplicate records, right? I've talked about that previously. Now, this can be challenging, by the way, especially when dealing with distributed systems or complex data transformations, right? So order dependency, for example, or data dependencies. Next is data volume and performance. Re-ingesting large volumes of data can strain system resources and impact performance. And you can also have, let's say, timeliness and latency. So in some cases, the timeliness of data ingestion is also crucial, right? And then you could also have data consistency and dependencies. For example, you could have order data dependencies, right? Like I talked earlier. So ensuring these consistency across various data sources, especially when reprocessing data, can be complex. So dependencies between different data sets or systems might pose challenge in maintaining consistency. And then you're going to also have error handling and recovery, by the way, right? That could simply means that identifying where and why errors occurred during initial data ingestion. So all of these are challenges of replayability. Another challenge could be resource management, right? You could be managing resources such as storage, compute, or network bandwidth for re-ingestion processes can certainly be challenging, especially when dealing with large scaled data. Okay. Another challenge that is important is testing and validation. So verifying the correctness of reprocessed data and ensuring that the changes made in the ingestion process do not introduce new errors require basically comprehensive testing and then validation strategies. So that's another challenge of replayability. And of course, I cannot say cost because cost considerations is also a challenge, right? Because re-ingesting large volumes of data can incur additional costs because you have to do it all over again, right? Especially in cloud-based environments where you build by the minute or by the second, right? Because it's even though it's a pay-and-go service, but you still have to bear the cost as well. So optimizing costs while ensuring effective replayability is certainly a challenge. Now, once you address these challenges that I've just talked about, involves a combination of careful system design, basically, or having the right technologies and frameworks, and of course implementing robust error handling and monitoring, and then continuously refining, not just one time, right, but continuously refining processes to improve efficiency and reliability. Let's talk about stateful transactions, and then I'm going to talk about later stateless transactions. So stateful and stateless transactions refer to how a system manages the context or state information during the interactions or operations. So here, let's focus on stateful first. So in stateful transactions, the system basically maintains the state or context of the interaction across multiple transactions or requests. And here, the system keeps track of past transactions, storing information about the ongoing session or conversation. And stateful transactions, by the way, often involve the server retaining information about a client's session, which simply allows for continuity between requests. Now, stateless, on the other hand, do not maintain any state or context between transactions, and each transaction is absolutely independent and self-contained without relying on past interactions or session data. So in a stateless transaction, every request, right, from a client must contain all the necessary information from the server to process it. So finally, let's summarize. We talked about stateful systems that remember past transactions, the stateless systems that treat each transaction independently without retaining any context, and of course, importantly, we talked about replayability and the strategies and the challenges, right? Which basically ensures data integrity, recovery, and flexibility in maintaining and managing data pipelines. I hope this helps. Let me know if you have any questions. Go through these slides one more time. I've also provided these slides for you to download and of course take a look at those. And with this, let's move to the next lesson.
Welcome back. Now, I'm going to discuss the challenges posed by high volume of data. I'm also going to be talking about data source type that you may need to ingest and store. And of course, lastly, in this lesson, I'm going to talk about the options available for storing data. Okay, so mainly, let's talk about the Amazon S3, which is the simple storage. So I'm going to talk about introduction to data lakes also, and then of course, different storage methods. So that's the objective of this lesson. So if you're able to analyze and process data, of course, this is a volume problem, right? So I just talked about the 5 V's in the previous lesson already, okay? Now the volume of data is the first challenge. Now there are a huge number of businesses struggling with massive amount of data. It's true, by the way, we generate data in huge volumes. So practically everyone has a tablet, mobile phone, laptop, and we generate tons and tons of data every day. So if you have a wearable device, for example, right, that records your health activity, right, think about it, that's data, right? So your device is collecting data constantly and then sends it to servers, and processes, are happening at every step, and then return the results back to you, and only you can see those results whenever you want. So this is just one example of a whole set of devices, right? So each individual is just generating massive content. IoT businesses also get a flood of information from devices like these, and it doesn't stop there, by the way, right? So social media has changed the way businesses market their products to customers. So it's changed the way you handle complaints and even customer service. So can you imagine the amount of data generated, just created in every minute just through social media? So let me give you some examples here. So I read recently that more than 100 million spam emails are sent every minute. Netflix users stream more than 70,000 hours of video every minute. Now, YouTube users watch more than 4 million videos every minute. And of course, the IDC, according to their research, right, they're forecasting massive growth from data between now and then the next 5 years. So this corporation predicts that the global data sphere, right, that's all the data that is collected everywhere, will grow from 33 zettabytes, right, to over 200 zettabytes in the next few years. Now, that's 21 zeros, by the way, in zettabytes, right? So just 3-4 years ago, right, we were in exabytes, and now we're talking about zettabytes, right? Who would have thought all of this, right? But hey, that's the reality. So what is this rapid increase in data volume, right, means for decision makers? Well, they need data analysis solutions. For one thing, businesses manage a massive volume of data, and they must work efficiently across distributed systems, even one that spans countries or even globally spread. And those solutions must be easily scalable so they can accommodate huge spikes in volume and traffic. Let me boil that down for you. A data analysis solution has to support large, scalable, and durable data storage, and must also be able to gather this data from multiple sources. So that's really where the types of data, let's talk about different types of data, okay? First, let's take relational or structured data. Now, that data is commonly stored in relational databases, okay? Like a database. It's highly structured by rules and constraints set within the database itself. Now, this kind of data is the backbone for transactional applications. Second is semi-structured data. Now, this data is often stored in non-relational, often called NoSQL databases, or even XML or JSON files, right? Now, this data does not have a structure itself, and it's temporary in nature. For example, rules you make in an online video game, right? For example, or your internet browser cache, or social apps that automatically delete your post after a certain amount of time. And then the third is unstructured data, right? This data often takes a form of files or objects, now has no single structure and represents everything else, right, that the business collects and generates. Now, this data is often considered untouchable because it does not need conventional aspects, right? It requires tagging and cataloging in order to be analyzed, and this prevents many businesses from using it in their data analysis solution. So, for example, images, email messages, text files, social media content, right? Text messages, and videos. So, only 10% of data connected and generated by businesses is structured data. Only 10%, right, is structured. So this is the simplest you can include in your data analysis solution, right? Which is really a small percentage. Now, it can be shocking to realize this, by the way, okay? That 10% of all data generated or collected by businesses is semi-structured, right? And the rest, 80%, is unstructured data. So in other words, the largest part of your business data is also the most difficult to analyze, right? Now, businesses, they struggle building data analysis solutions that can accurately and effectively find the valuable data to provide meaningful insights. Now, sometimes it feels like data is frozen in file servers and too hard to make sense of, but it doesn't have to. So that's really what you need to focus on when we're talking about data analysis solution, the challenges and the types of data that I just talked about, and some statistics so that you understand that majority is unstructured data, and that's really the challenge for all these organizations. I hope this helps. Let me know if you have any questions. With this, let's move to the next lesson. Welcome back. Let's talk about the types of data, right? So exponential growth of business data, for example, and businesses have been storing data for decades. Now that's nothing new itself, right? What has changed in recent years is the ability to analyze certain types of data. Now there are three broad classification of data source types, okay? Structured data, first, is organized and stored in the form of values that are grouped into rows and columns in a table, right? Semi-structured is often stored in a series of key value pairs that are grouped into elements within a file. So others may contain just metadata, for example. So any internet article which has a huge amount of information is sitting on unstructured data. New applications being released can now catalog and provide incredible insights into untapped resources. So what is unstructured data? Let's talk about that, right? It's in every file that you store. Every picture you take, for example, any email that you send has this, right? So modern data management platform must capture data from diverse sources, speed, and scale. Now, data needs to be pulled together into manageable and central repositories, breaking down traditional silos. Now, the benefits of collection and analysis of all business data, by the way, must outweigh the cost. Now, where can you store data? Well, AWS itself has an S3 bucket, which is a powerful tool, right? So let's talk about that. So in previously, I talked about, and I promised that we're going to talk about storing data in all types, right? So we started with understanding the components of a data analysis solution, and storage, by the way, is a big part of this solution. So you have to collect data and store somewhere, right? So you may have to store data temporarily while it's being processed, for example, and then you have to store the results in a way that makes them accessible for people who need to see them. Now, the backbone for any good solution is a good storage platform. AWS has a storage service called Amazon Simple Storage Service, which is S3 for short. Now, this service is an object store, which means you can store just about any kind of discrete object in this. An object is how Amazon S3 refers to files, right? So images, files, documents, you name it, right? It's scalable and can grow to any size you need. It's durable, means your files will be, available when you need them. It implements scalability, security, and performance. Now, people use Amazon S3, for example, for websites, mobile applications, data analytics, just to name a few use cases. So when you start using S3, you create buckets, okay? Now, they're like file folders, only larger, better organized, and with more security mechanisms built in. Okay, next, you move data into those buckets, right? And then AWS gives you a lot of ways to do that, no matter how great the volume is, right? You can even move exabytes into a single delivery. Now, you'll find several areas, and I'm going to talk about those later on, where I'm going to demonstrate how S3 works. So basically, the storage underlays the entire data analysis solution. Now, there are many, many ways you can implement S3. And of course, like I said earlier, I'll give you a demo, hands-on demo on how to use S3, right? So first with S3, you can separate the ways you can store data in S3. And this is decoupling storage for processing. Now you may have separate buckets for raw data, temporary processing results, right? And final results should be stored in a separate data, right? Next is parallelization, for example. With Amazon S3, you can access any of these storage locations from any process in parallel without negatively impact other processes. And then finally, S3 becomes a central location to store analytical data sets, right? Providing access to multiple analytic processes at the same time. Now, this allows the solution to avoid costly processes of moving data between storage system and then processing systems. So S3 is a great solution, by the way, for meeting your storage needs for your data analysis solution. Next, I'm going to give you a demo, and then we'll talk about additional S3 concepts. So for example, if you want to get the most for Amazon S3, there's a few concepts I'd like to highlight here. First, S3 stores data as objects, like I mentioned earlier, as buckets, right? And of course, object is just like a file, metadata that describes the file. And to store an object in S3, you simply upload the file and you store it in the bucket itself, right? And you can set permissions, and that's important on any of these objects, right? And buckets are logical containers for objects. You can have one or more or as many as you like, and you can control access. You can create groups, allow them access. You can create individual permissions. You can also create bucket policies, right? Retention policies, and so on. There's a very powerful tool in Amazon itself. So you can access S3 through the Amazon Management Console, okay? So the concept here is the storage of data, okay? So you can use, for example, create bucket names, give them names that you can remember. You can use other areas to actually access those objects within the bucket, okay? That's really what the S3 storage is all about, okay? So for example, the object key itself is a unique identifier, okay? Because the combination of a bucket key and the version ID uniquely identifies each object. You can think of Amazon S3 as a basic data map between bucket plus key plus versions and the object itself. Now, every object in Amazon S3 can be uniquely addressed to the combination of, the endpoints, bucket name, key, and then optionally the version itself. So data analysis solution on Amazon S3 has numerous advantages, right? Using S3 as a storage platform for your data analysis solution. So decoupling of storage for compute and data processing is number one, which is really, really nice. Now with Amazon S3, you can cost effectively store all data types in the native format. And you can then launch as many key virtual servers, for example, and then use S3 as a source, right? For example, you can launch EC2 instance and use AWS analytic tools to process your data. And you can optimize EC2 instances also to provide the correct ratio of CPU, memory, and bandwidth for best performance. Now, decoupling your processes and storage provides a significant number of benefits, including the ability to process and analyze the same data with a variety of tools. Centralized data architecture. Let's talk about that, what that means, right? So S3 makes it easy to build a multi-tenant environment where many users can bring their own data analytics tools to a common set of data. Now, this improves both cost and data governance over traditional solutions, right? Which requires multiple copies of data to be distributed across multiple platforms. Now, this may require some additional step to load your data into the right tool. Using Amazon S3 as your central data store provide even more benefits over traditional storage options. Now, integration with serverless AWS services, like Lambda, for example, you can actually use and leverage that also. So combine S3 with other AWS services to query and process data. Now, Amazon S3 also integrates with Lambda or serverless computing, for example, to run code without provisioning or managing servers. Amazon Athena, for example, can query S3 directly using structured query language, SQL, without the need for data to be ingested into a relational database, right? So all of these capabilities, you only pay for the actual amount of data you process or the compute time you consume. Pay as you go. Standardized application, APIs, for example, you can use those within your S3 bucket as well, right? You can leverage those. So REST APIs, for example, are basically programming interfaces to interact with files in Amazon S3. So S3 RESTful API, for example, are simple, easy to use, and supported by most major third-party software vendors, right? So for example, Apache Hadoop and other leading vendors also. Now, this allows customers to bring tools that they're more comfortable with and knowledgeable to help them perform analytics on data stored in S3. So I hope this helps. This gives you a good understanding of the actual storage capabilities when you're designing your data analysis solutions. Let me know if you have any questions. With this, let's move to the next lesson.
Hi everybody, and welcome to this lesson on AWS Storage. So in the next few lessons, we're going to be looking at the different storage options that Amazon Web Services offers. So let's first take a look at all of the options that are available to us in terms of storage in AWS. Now, cloud storage is a critical component of cloud computing, holding the information used by applications. Big data analytics, data warehouses, IoT, databases, and backup and archive applications all rely on some form of data storage architecture. Cloud storage is typically more reliable, scalable, and secure than traditional on-prem storage systems. Now, AWS offers a complete range of cloud storage services to support both application and archival compliance requirements. You have the option to select from object, file, and block storage services, as well as cloud data migration options to start designing the foundation of your IT environment. We're going to take a look at some of the most popular ones that are used, and that will be covered in the exam. So the 5 main storage options that AWS offers are S3, which is by far the most popular. There's the elastic block storage, we have the elastic file system, and then we have 2 of the lesser known or less used options, which is Glacier and the storage gateway. So in this lesson, let's go ahead and take a little bit deeper dive into the S3, or also known as a simple storage service. And just an exam tip, sometimes AWS is known to ask simple questions such as what does S3 stand for? So just keep in mind that it stands for Simple Storage Service. Now S3 is an object storage service that offers scalability, availability, security, and performance. So this means that customers of all sizes and industries can use it to store and protect any amount of data for a range of use cases such as websites, mobile apps, backup, restore, archive, and so on. Now S3 provides easy to use management features so you can organize your data and configure fine-tune access controls to meet your specific business, organizational, and compliance requirements. Now some of the key benefits of S3 is, first and foremost, it's the industry-leading performance, scalability, availability, and durability. Now, I know that's a mouthful, but just keep in mind the term known as 11 nines. Now, S3 is designed for 99.9999, basically 11 nines of data durability, because it automatically creates and stores copies of all S3 objects across multiple systems. This means your data is available when needed and protected against failures, errors, and threats. The S3 also has a wide range of cost-effective storage options, which we'll look at later on in this lecture. It has unmatched security, compliance, and audit capabilities. You can store your data in S3 and secure it from unauthorized access with encryption features and access management controls. It maintains compliance programs such as the PCI DSS, the FedRAMP, the EU Data Protection Directive, and many more. And AWS also supports numerous auditing capabilities to monitor access requests to your S3 resources, which we can do through CloudTrail, which we'll look at later on in this course. Additionally, you can use management tools for granular data control. You can classify, manage, and report on your data using features such as the S3 storage class analysis, or the S3 lifecycle, or the cross-region replication. And again, we will look at these when we do the lab towards the end of this lecture. You can run big data analytics across your S3 objects and other data sets in AWS with their query and place services. And finally, store and protect your data in S3 by working with a partner from the AWS Partner Network. Now, the S3 offers a range of storage classes designed for different use cases. So there are 5 main ones that are there. First, you have the standard one, which offers the high durability, availability, and performance object storage for frequently accessed data. Now, because it delivers low latency and high throughput, the standard is appropriate for a wide variety of use cases, including cloud applications, dynamic websites, content distribution, mobile and gaming applications, and big data analytics. Now, keep in mind that storage classes can be configured at the object level, and a single bucket can contain objects stored across S3 standard, tiering, IA, and so on. There's also the S3 intelligent tiering. Now, the tiering is something new that has been introduced by Amazon just recently, and the 2019 exam version is most likely going to be covering this also. Now, this storage class is designed to optimize costs by automatically moving data to the most cost-effective tier without performance impact or operational overhead. It works by storing objects in 2 access tiers. One tier that is optimized for frequent access, and another lower cost tier that is optimized for infrequent access. The next one is the standard IA, or the standard infrequent access, is for data that is accessed less frequently but still requires rapid access when needed. The IA offers the high durability, the high throughput, and low latency of the standard, with a low per GB storage price and a per GB retrieval fee. Then you have the one zone infrequent access, or one zone IA. It's meant for data that is accessed less frequently but requires rapid access when needed. Unlike the other storage classes, which store data in a minimum of 3 availability zones, the one zone IA stores data in a single availability zone, but it costs 20% less than the standard IA. The one zone IA is ideal for customers who want a lower cost option for infrequently accessed data, but do not require availability and resilience of the standard or the standard IA. So it's a good choice for storing secondary backup copies of on-prem data or easily recreatable data, because keep in mind, one of the main drawbacks of the one zone IA is that it is not fault tolerant. And then lastly, you have the Glacier, which is a secure, durable, and low-cost storage class for archiving data. You can reliably store any amount of data at costs that are competitive with or cheaper than on-prem solutions. Now keep in mind that the Glacier provides 3 retrieval options that range from a few minutes to a few hours. You can upload objects directly to S3 Glacier, or use the S3 lifecycle policies to transfer data between any of the storage classes, and we'll look at the lifecycle policies when we do the lab towards the end of this lecture. So this table that you guys see gives you a good comparison of the different options that are available. And again, there's an asterisk by the tiering because it's a newly introduced service by Amazon. But I highly suggest that you guys take a close look and memorize the different options, the different S3 storing options that are available, because there will be a few questions that are solely based on the storage classes for S3. So it's good to know the difference between standard IA and the one zone IA and the Glacier for storage purposes. Now, one thing to keep in mind for exam purposes and for real world application purposes is that the S3 is an object-based storage class. It means that it cannot be a boot volume and it cannot hold applications. It can only hold objects. So think of an S3 bucket as a folder in which you can put files and other folders. So you can put any amount of files, any amount of folders within an S3 bucket. And lastly, another thing to keep in mind for S3, which again I will mention again when we do the lab, is that the names have to be unique across the AWS platform. Their names are DNS based names, so they have to be unique. So let's go ahead and create our first S3 bucket.
Welcome back. Super excited. Moving forward, I'm going to talk about the cross-region replication for S3 bucket. So I'm just going to demonstrate with this simple example, and it's important because the region that you're working in, for instance, right now, I'm working within the North Virginia region. You notice within the drop-down list, I have several other regions listed. So by default, I've selected or I've been working with the US East, North Virginia. So AWS instances and buckets work with this particular region. What if I have another region and I have instances, I have S3 buckets in a different region, for instance? So how do I make sure that everything is replicated within the S3 buckets? Because remember, S3 buckets are global, right? And virtually unlimited space that you can have within the S3 buckets. And you can store objects, you can store images, you can store data, any kind of information within the S3 bucket. So in this instance, I only have, at this point, I'm working with the US East Virginia region. In this lesson, I'm going to demonstrate how to create our S3 buckets, how to configure the versioning, and then eventually demonstrate the replication of data from one S3 bucket in one region to another S3 bucket in a different region. Now, note that this could also apply to different accounts. So right now I'm using the CloudDesk e-learning account. If you have a different account in a different region, equally applicable. Perfect. So let's jump right in. Let's go ahead and take a look at our S3 buckets. If not, then we're going to go ahead and create one. So you need two things, right? We need the source S3 bucket, which is this region, North Virginia. And then we'll go ahead and change the region and create a destination S3 bucket. And then we'll figure the replication of objects that we will place. Perfect. All right, so I'm going to go ahead and click on services. So what you will need to do is navigate to the storage section and then simply click on S3. And this will take you to the S3 Management Console page. And at this point in time, there are 0 buckets in 0 regions. So I'm going to go ahead and quickly create a bucket. So click on the plus sign. And few steps, just name and region, configure the options, set the permissions, and then review before you can actually create the bucket itself. So here's the bucket name. I'm going to go ahead and just give it a name. I'm going to call it. So this is the name of the bucket within this region, which is US East North Virginia. I could also copy settings from an existing bucket, but since I do not have one, so I'm just going to create a new bucket with this particular name. Click next. Here's the important part. Here's the versioning. So make sure this option is checked where it says keep all versions of an object in the same bucket. And it's important to note that let's say you already have a bunch of objects within a bucket and you create or enable versioning later on, right? So keep in mind that versioning or replication will only affect those objects that are created after you set these or configure these options. So I'm going to go ahead and click on versioning, which is make sure that keeps all versions of an object in the same bucket. I can also log request for access to your bucket that I'm going to take a look at later on throughout this course you'll learn. But right now, I'm just going to demonstrate versioning and replication. You can also tag to track project costs, need be. And I can also choose object level logging, okay? But for right now, I'm just going to keep versioning. Click next. There are other options too, by the way, if I scroll down, just so that you know that under advanced settings, I can lock an object. So it'll allow me to permanently lock objects in the bucket. And I can also use the management and use AWS CloudWatch where I can create billing alerts or alerts and notifications, right? And other metrics that I can work with. So I'm going to go ahead and simply click next. Third is set the permissions. So we can grant the permissions to specific users after you create the bucket. Right now it's public access settings for this bucket. So here by default, notice all of these 4 checkboxes are checked. In other words, manage public access control list for this particular bucket and manage public bucket policies for this bucket as well. If I scroll down, I can manage system permissions. At this point, do not grant Amazon S3 log delivery group write access to this bucket, or I can choose the other two, one of the other 2 options as well. So I'm going to leave this to as do not grant Amazon S3 log. All right, so I'm going to set this as default, leave this as it is in the permissions area, click next. And here I can simply scroll up and down all the way to review these settings. So here's my bucket name, the region, and then the versioning is enabled. Okay, so that's all we really did in this. So I'm going to go ahead and click on create bucket. And this is going to go ahead and create the bucket for me. So I have 1 bucket and 1 region, which is at this point global, because if I click on the global option here on the menu, S3 does not require region selection. So all we're configuring is the replication from one region to the other. So once I have the bucket created, let's go ahead and create another bucket. And this time I'm going to change the region first and then create the bucket. So let's navigate to the AWS Management Console homepage. I'm back to my North Virginia. I'm going to scroll down and change my region. So let's pick any one of these. I'm going to go ahead and select, let's say, Canada, different region, central. So if I click on the Canada Central region, I'll be navigated to that particular Management Console page. So now I'm working with the central region. So within the central region, I'm going to go ahead and go to services, go to your storage, click on S3, and I'm going to go ahead and create another S3 bucket. So let's go ahead and click on create bucket, give it a name, destination. And notice the region here is important because this is the region that I'm actually creating the bucket in, which is Canada and the central region. So even though the buckets are global, but I could create in any region. Now I did take the longer route, right? I just wanted to show you the fact that you can, even though you change the region, but global is going to show you for S3 no matter where you are. So if you're searching for a different region and you're thinking, wow, wait a minute here, why is my region not showing? So I just wanted to walk you through in the series of steps. Otherwise, it's fairly a shortcut method is just go ahead and create the S3 buckets and select the region during creation. Okay. All right, so I'm going to make sure that I have Canada here. Click next. And of course, the versioning needs to be enabled in this bucket. Basically, you're just copying the same step as you did when you created the first bucket. Click next, and then one more time, and then create bucket. Okay. And this is going to go ahead and create the destination bucket for you. Now you have two buckets in two regions. And this is important because now here you can see that you have two regions. You have two buckets. However, if I click on the global option or the menu here, you will still see the S3 does not require region selection. Okay. So I just wanted to walk you through a little bit slower pace so you understand exactly how the S3 and versioning would work. But once you get experience, all you would do is just go to S3 and create a bunch of buckets in different regions. Okay, so that's straightforward. Great. So once we have these two buckets created, source and destination, I'm going to navigate to my source first, which is in US East North Virginia, and the destination is in Canada Central. So let's go ahead and navigate first to the source and place an object into the source bucket. So let's go ahead and open this bucket. This bucket is currently empty. I'm going to go ahead and upload something to it. So what you need to do next, of course, is to go ahead and upload an image or a document or anything that you wish to be replicated. So I'm going to go ahead and click on upload, and this brings up the dialog box. Again, a series of 4 simple steps. Let's go ahead and click add files. Brings up your Windows Explorer. I'm going to pick any one of these, I guess. How about this logo that I wish to replicate from one region to the other? So just select the logo, click open, and then click next. The second step, of course, is to manage the users, or at this point in time, the owner for this bucket is Shah, which is myself, and then the object read-write permissions and the object permissions also read-write are enabled. I can also access for other AWS account. I can add another account. In other words, that account will also be one of the owners or managers for this bucket as well. And then manage public permissions. Do not grant public read access to this object as recommended. I can also have or select other options as well, such as grant public read access to this object, which means if I choose this option, if I click on this, you'll notice AWS kind of gives me a little warning, right? This object has public read access. Everyone in the world will have read access to this object, so it's definitely not recommended. So let's stick to do not grant read access to the public, right? All right, so I'm going to go ahead and click next. Set the permissions. So this is the standard storage class. It's designed for frequently accessed data, and then it's either equal to or greater than 3 availability zones, and so on. Otherwise, I can also choose other options as well. So I can scroll down, and there are a bunch of options. The encryption is kind of nice because it gives you an added security. For instance, I can use the protect data at rest by using S3 master key or by AWS KMS master key. KMS is encryption based, which kind of works with CloudTrail and it logs all the keys. So it's just an added level of security that you can use. Or you can use the standard S3 master key as well. And then you can tag and provide the values of metadata. So I'm going to stick to the standard permission. Click next. Just set the properties. And then eventually do the upload. And this is going to go ahead and start the upload process and upload the image for me in this source bucket, which is US East North Virginia. Great. Now, once I have object or objects, right, in the bucket here, for demonstration purposes, just one image. Notice on the tab up on top, there's a tab called Management. So I'm going to go ahead and click on Management, and there's a button called Replication. So I'm going to go ahead and click on Replication. And at this point, it says I've not configured or created any cross-region replication rules for this bucket. I'm going to go ahead and click on Add a Rule. This brings up a dialog box. A couple of options here. I can either choose or select the entire bucket, which is by default it is selected, and it shows the name of the bucket. Or I can prefix or tags. So it depends. If I choose prefix or tag, for example, then I need to type or add the prefix or tag filter. So I don't need to worry about replicating the entire bucket. I can only replicate objects that start with a certain prefixes. Okay, maybe I have HR department files that I like to replicate only. So all of my files that relate to or belong to the human resources department will have the prefix HR, right? So if I type HR, then all of the objects within the S3 bucket will be replicated. Great. So let's stick to the entire bucket. I can, of course, replicate objects encrypted, like I mentioned earlier, with AWS KMS. So I'm going to go ahead and click on Next. It asks me for the destination bucket, right? Great. And of course, we know that our destination bucket is the Canada 3 destination, which is region Canada Central. Shows me in the list, right? Because I already have it created. If I'm using a bucket in another account, then I can simply choose this option and the account ID, bucket name, and I'm good to go. So I'm going to click on or choose the bucket in this account and select Canada 3 destination. And once I select the destination bucket, it says Amazon S3 cannot detect whether versioning is enabled on the destination bucket. Just a warning, even though we know that we have enabled versioning, but we'll verify that ourselves and validate that as well. But it's a nice warning, okay? So because you need to have version on both buckets enabled before you can actually start the replication process. A couple of other options is change the storage class for the replicated objects or change object ownership to destination bucket owner. So if I select this option, then this means that the ownership will transfer from one to the other. Since I'm the owner of both buckets, therefore, grayed out at this point. But if there was an option where you were doing it in a different region, for example, or different account, then you could set these options. So simply select the destination bucket or choose that bucket, click Next. So I'm going to go ahead and create a new role, even though you could choose an existing role. But just for quick demonstration and following along, right on the fly, AWS provides you the ability to create a new IAM role. So let's go ahead and click on select a role here and simply choose create a new role. I'm going to go ahead and type a name for this. I'm going to say S3 role, right? Or role replication. Status is enabled, click next. And then once I'm satisfied with all of these options, I'm going to go ahead and click on save. And this is going to add the replication rule and give me a message. Congratulations, like cross-region replication updated successfully, and gives me the detail as well. So now I have a source bucket, which is Virginia S3 source, and a destination bucket, Canada S3 destination, in two different regions. And here are the permission sets. If I scroll down, here is the rule, the S3 role replication, which is the entire bucket, that's the scope. Storage class, the replicated object owner, the KMS objects, and the status is enabled. So it gives you an idea of how easy it is to configure and set up your cross-region replication of different objects. So note that even though we have configured successfully the cross-region replication, what about that image that we had in the source? Was that to be replicated? Think about it. And the answer is not at this point, because we uploaded the document first and later on successfully configured the replication, right? So remember the initial part of the lecture that we need to have this configured in the first instance before adding objects to be replicated. So if I were to, let's say, navigate to my S3 buckets here, I'm going to quickly show you this, and then go to my Canada S3 destination, you'll notice this bucket is empty because Canada has not received the replicated image at this point in time because the image was uploaded before we configured the replication. So let's go back to our Amazon S3, go to our source, and now if I add a new image, that should be replicated. Let's go ahead and quickly take a look at that. So I'm going to go ahead and click on Upload, Add Files, and this time I'm going to choose, let's say, all Excel file. And this is again an Excel file. So I'm going to click Open, click Next, and just simply continue on. I'm going to navigate fairly quickly because we've been doing this, and upload. So as soon as I upload within my Virginia 3 source, which is the source bucket in the US East region, and this is now being uploaded, has been uploaded rather. Let's navigate to our S3 again. Click on the Canada S3 destination. Let's go ahead and refresh, and perfect. So congratulations. You have now successfully configured the cross-region replication between 2 different regions in the AWS ecosystem. So as a homework, go ahead, try it with 2 different accounts. So if you're able to create another account for AWS, perfect. I hope this helped. If you have any questions, post them in the discussion area. We'll be glad to answer. And with this, let's move to the next lesson.
Welcome back. Let's talk about data lakes, right? So storing business content has always been a point of contention and often frustration within businesses of all types, right? Should contents be stored in folders, right? Should you use prefixes and suffixes to identify file versions, right? Or should content be divided by department or specialty, right? So the list goes on and on. The issue stems from the fact that many companies start to implement document or file management systems within the best of intentions, but don't have the foresight or the infrastructure to maintain the initial data organization. So out of the dire need for organizing the ever-increasing volume of data, right, data lakes were born. So a data lake is a centralized repository that allows you to store structured, semi-structured, and unstructured data at any scale. So now let's talk about how data is organized in S3 before I get to data lakes, right? So S3 is an object container, and I've talked about this previously as well, okay? You can put content in an orderly fashion, or you can just dump your data in S3. But no matter how data gets there, once it's in S3, you need a way to organize it in a meaningful way so you can find it when you need it. So this is where data lakes come in, okay? So a data lake is an architectural concept that helps you manage multiple data types from multiple sources, both structured and unstructured, through a single set of tools. So let's break that down so that it's easier. A data lake takes Amazon S3 bucket and organizes them by categorizing them by data inside the bucket. So it doesn't matter how the data got there or what kind it is, right? You can store both structured and unstructured data effectively in an Amazon S3 data lake. Now, AWS offers a set of tools to manage the entire data lake without treating each bucket as a separate, unassociated object. So many businesses end up grouping data together into numerous storage locations, right, called silos. Now, these silos are rarely managed and maintained by the same team, which can be problematic. Now, inconsistencies in a way data was written, collected, aggregated, or filtered can cause problems when it is compared or combined for processing from all these different silos. For example, one team may use the address field to store both the street number and street name, while the other team might use separate fields for street name or street numbers. Now, when these data sets are combined, now there is now an inconsistency the way the address is stored, and it will make analysis very, very difficult, right? But by using data lake, you can break down data silos and bring data into a single central repository that is managed by a single team. Now that gives you a single consistent source of truth. Because data can be stored in a raw format, you don't need to convert it or aggregate it or filter it before you store it. Now instead, you can leave the pre-processing to the system that processes it rather than the system that stores it. So in other words, you don't have to transform the data to make it usable. You keep the data in its original form however it got there, however it was written, right? Now, when you're talking exabytes of data, you can't really afford to pre-process the data in every conceivable way that may need to be presented in a useful state. So let's talk about having a single source of truth, right? So when we talk about truth in relation to data, you need the trustworthiness of data. Is it what it should be, for example? Has it been altered, right? Can you actually validate the chain of custody? Now, when creating a single source of truth, you're creating a data set, right? In this case, the data lake itself, right? Which can be used for all processing and analytics. Now, the bonus is that, it needs to be consistent and reliable, right? It's trustworthy. So, to bring it all together, we know that businesses need to easily access and analyze data in a variety of ways, using the tools and frameworks of their choice. Now, remember, the second principle that I talked about in previous lectures, right? Moving data between storage and processing is really costly. Now, Amazon S3 Data Lake provide a single storage backbone for the entire solution that meets all these requirements and tools for analyzing data without any additional tools. Now, data lakes promise the ability to store all data in a business, right, in a single repository. You can leverage data lakes to store large volumes of data instead of persisting the data into a data warehouse or warehouse. Now, data lakes, such as those built in Amazon S3, for example, are generally less expensive and specialized than big data storage solutions. So that way you only pay for the specialized solution when using and processing and analyzing data and not for long-term storage. Now, your extract, transforms, load, ETL or analytic process can still access this data for analytics. Let's talk about some of the benefits, right? So you understand why companies should implement data lakes or create this architecture. So the first benefit of AWS data lakes, right, are that it's cost-effective storage solution. Now, you can durably store nearly unlimited amount of data using Amazon S3, right? You can implement leading security measures and compliance, right? AWS uses stringent security, by the way, okay, and compliance and privacy and protection mechanisms on S3 bucket, which allows you to take advantage of many different data collection and ingestion tools to ingest data into your data lake. Now, these services include Amazon Kinesis, for example, for streaming data, and AWS Snowball, right, for large volumes of on-premise data. So it helps you to categorize and manage your data simply and efficiently. Now, use AWS Glue, for example, to understand data within the AWS data lake, prepare it, and load it reliably into data stores. Now, once AWS Glue catalogs your data, it is immediately searchable, can be queried, for example, and is available for ETL processes. Now, it also helps you turn data into meaningful insights. You can use, for example, analytic services like a wide ways of use cases such as interactive analysis, data processing using Apache Spark, for example, or Apache Hadoop, data warehousing, real-time analytics, right? Operation analytics, dashboards, visualization, you name it. For example, Amazon EMR and data lakes, right? So businesses have realized that the power of data lakes is absolutely crucial, right? So data within a data lake, you can actually distribute the source and use frameworks such as those supported by Amazon EMR, for example. Now, Apache Hadoop, on the other hand, and Spark are both supported by Amazon EMR as well, which helps the ability to help businesses and cost-effectively implement data processing solutions, right, based on Amazon S3 data lakes. Now, the data lake preparation is basically, think about this, data scientists spend 60% of time cleaning data, right? And that's a lot of time. Now, data preparation is a huge undertaking. Now, there are no easy answers, right, when it comes to cleaning data or transforming data and collecting data for your data lake. But there are services that can automate many of these time-consuming processes. Now, setting up and managing data lakes today, for example, can involve a lot of manual and complicated and time-consuming tasks. Now, this work includes loading the data, monitoring the data flows, right, setting up partitions for the data itself, and then, of course, encryption. Now, you may also need to reorganize data to duplicate it, right? For example, match link records and audit data over time. Now, AWS Lake Formation makes it easier to ingest, clean, catalog, transform, and secure your data and make it available for analysis and, of course, machine learning as well. Now, Lake Formation gives you a central console where you can discover data sources, set up transformation jobs to move data to an Amazon S3 data lake, or remove duplicates and match records. Catalog data, for example, so that analytic tools can access it, right? And security policies can also be implemented. You can audit, you can control access from AWS analytic and machine learning services. Now, Lake Formation automatically configures underlying AWS services to ensure compliance within your defined policies. Now, if you've set up transformation jobs, for example, right, using AWS services, Lake Formation can figure out the flows, centralize their orchestration, and then lets you monitor the processing of all the jobs. So I hope this helps you understand the concept of data lake, right? And creating an efficient data lake architecture is crucial when you're designing the data analysis solution. Let me know if you have any questions with this. Let's move to the next lesson.
Welcome back. Super excited moving forward. In this lesson, I'm going to talk about a few core concepts because we will be actually using data, right, as a data source, and then bringing and using some of these Amazon services to transform our data, to prepare our data, and then, of course, shifting our data into QuickSight. So it's important to understand these concepts so that you're not actually going all over the place and trying to understand some of these buzzwords and how the entire process works. So I'm going to lay it down fundamentally so it's easier for you to understand and follow as we move, and I demonstrate how to use and work with preparing your data using the storage that Amazon provides. So in this lesson, I'm going to talk about Amazon Athena, which is a serverless query service. I'm also going to talk about AWS Glue, the Store S3, and so on. So a few important concepts. First, the AWS Athena. What is this, right? So the Amazon Athena is an interactive query service. So by query service, it rings a bell, right? So what that means is I can now query my data. In other words, I can, sort, filter, ask questions from my data before it actually ends up all the way down to Amazon QuickSight. So Amazon Athena is an interactive query service that makes it easy to analyze data stored in Amazon S3 buckets using standard SQL, right? So it's a simple SQL query language that I can say, and I can run statements like select, update, and so forth to query my existing data sets. Athena is serverless. Now what that means, the basic definition of serverless, by the way, if you've come across this term, think of this as you don't have any servers, right? On premise, you're actually using everything that the cloud provider offers to you. In our instance, it's AWS. So that's why Athena is serverless, so there's no infrastructure to manage on your end, and you pay only for the queries that you run. I believe it's 1 terabyte worth of queries before you actually pay like $5 or something like that, okay? It's easy to use. The performance is pretty fast, secure, and Athena is also integrated with AWS Glue, okay? This is where you can actually build your database schema, your tables, and so forth. And I'm going to demonstrate and talk about that a little later. We can also point your data within Amazon S3 buckets, define the schema, and start querying using standard SQL. So that's really what AWS Athena is, right? So you go from your instances to, let's say, Amazon S3, you have different buckets created, you have different data sets stored in those buckets, right? Bucket is just a file system, okay, in high level or broader context as a fundamental concept. Just think of this as Windows Explorer, right? So you have all these files in your storage. From this storage, Amazon Athena goes into action. You can run interactive queries using AWS Athena, and then with that data, right, with that query results, you can then take them into Amazon QuickSight and run some visuals or do some analysis, run stories, perform calculations and whatnot. Okay, so that's the whole idea. I hope you understand the concept pretty clear. So AWS Glue is the next buzzword, right? From S3 to a QuickSight. So when using Athena with the AWS Glue data catalog, you can use AWS Glue to create databases and tables schema to be queried in Athena. So now you know what AWS Glue does, right? So here you are actually creating databases. Within databases, you're creating tables. And then, of course, you're using Athena to run the interactive query sessions. So what AWS Glue is a fully managed ETL, which is extract, transform, and load data. It's a service that can categorize your data, clean it, enrich it, and move it reliably between various data stores. So this is your like a data warehouse, or the service that does transform your data, extracts your data. And I'm going to demonstrate later on too how to use the actual wizard to do all of these, right? So this is not just concept. I'm going to do a hands-on demonstration so you understand and see it in action, not just concepts, but actually application of these concepts. AWS Glue crawlers automatically infer database and table schema from your source data, storing the associated metadata in the Glue data catalog. And when you create a table in Athena, you can simply choose to create it using the AWS Glue crawler. So the workflow is fairly straightforward. You go from your S3, which is your buckets, then you crawlers will interact with that stored data sets, right? So it will extract, transform, and load. The metadata is stored in the Glue data catalog. And then you get to the Amazon Athena part where you run the interactive queries, right? You prepare your data according to your own requirements or needs. Eventually, you get to Amazon QuickSight, which is, of course, where you run the visuals, you create the visuals, you run the analyses, and so forth. So finally, you get to the AWS QuickSight, right? Of course, the high-level overview, once again, for QuickSight is that you can use any of these data sources. You can have your data sets. You can run the analyses on these data sets. Of course, you can create different dashboards, multiple dashboards. You can publish these dashboards. You can share these dashboards, email anyone within the organization so that they can actually take a look at your dashboards that you've created. A story is just a snapshot, right? So it's a snapshot of all these dashboards. Maybe, for instance, let's say you run an analysis on a particular data set, right? So one of the visuals you create is all about the count of customers. So you save it as a story. The next set of dashboard or visual that you create is all about profitability. So you save that as a story. So you build the story. Think of this as a, overall or high-level PowerPoint slides, right? So you're actually, when you're presenting to someone or you're playing the story, it kind of walks you through from the customer and the profitability and the sales and so forth. So that way it's easier for your maybe marketing department or sales department to take a look at all these stories that you've created based on the analyses on those data sets that you've created. It's easier for them to manage and just kind of take the necessary action accordingly. So in this lesson, just wanted to briefly talk about the AWS Athena, AWS Glue, and of course QuickSight, and the concept and the workflow as well. So I hope this helps. The next step, of course, is for us to practice, right? So understand these concepts, take a look at what those are. And before I actually end this lesson, let me quickly show you where all these services reside. So I'm going to go ahead and switch to our AWS console. Perfect. So once you're in the console, right, you're logged in, just go to services and notice you'll see all these services that AWS has. So for instance, my storage is right here, S3 that I mentioned, right? That is the storage service where all the buckets are. So if I click on S3, you'll notice it'll give me the list of all of my storage buckets that I've created. You can, of course, create additional buckets as well. So each bucket contains whatever you want to store in it. So for instance, the bucket called GB88 contains the 5,000 sales record.csv file. Okay. Similarly, let's go back to our homepage here. Let's go to services again. So I want to show you the Athena, right? So under analytics section, you'll see the Athena service. Simply click on this, and this will take you to the actual query editor, right? Remember, Athena is just an interactive query builder. So you have your databases on the left, and then you can execute queries based on your data, and then of course your tables. You run a query, you can save a query, format a query, and so forth. And this is where you would actually use to eventually get to QuickSight. So you prepare this data here. You can always prepare the data directly in QuickSight as well, certain fields, but this is a little bit more powerful area because now you can actually query and create as complex queries as you wish to actually hone in your data. And the reason I'm showing you this, the importance here is the obvious question, why, right? Why do we want to use Athena if we can do this in QuickSight? Well, QuickSight doesn't really give you a whole lot of flexibility, okay, to prepare your data. It only prepares just the field sizes or maybe simple calculations. But here in Athena, let's say you have millions and millions of records, right? What if you have 10 million records and you only want to, obtain a chunk of those records? Let's say out of 10 million records, you want to query maybe 1 million records based on a certain criteria. So this is where Athena would be very helpful, and then you will take the result derived from Athena to QuickSight. So at this point, I just want to show you what it looks like. Okay, perfect. Let's go to our services one more time. And then, of course, AWS Glue. Okay, that's under analytics as well. So I'm going to go ahead and click on AWS Glue. And this is where you would be able to, once you get on the AWS Glue dashboard, you can take a look at all these tables that you've created within those databases. So that way, which is an area where a table, you can store these tables to be used by Athena and then eventually by QuickSight. And that was a workflow we just talked about earlier in this lesson. Of course, it uses crawlers, right, to basically extract, transform, and load, ETL, okay? So in synonym to AWS Glue, think of ETL, okay? Where you can extract data, you can transform data, and you can load data as well. So just briefly wanted to demonstrate where these services are within AWS, okay? So we looked at the S3, looked at the Athena, and then the AWS Glue. So practice with these. Hope this helps. If you have any questions, post them in the discussion area. I'll be glad to answer. And with this, let's move to the next lesson.
Welcome back. Let's talk about data storage methods, right? As the volume of data has increased, so has the option for storing data. So traditional storage methods, such as data warehouses, for example, are still very popular and relevant. But data lakes have become more popular recently. Now, these new options can confuse businesses sometimes that are trying to be financially wise, right, and technically relevant. So which is better, data warehouses or data lake? Well, neither and both is the answer, right? Now, they're different solutions that can be used together to maintain existing data warehouses while taking full advantage of the benefits of data lake. So, last topic, right? I talked about Amazon S3 data lake, right? The architecture and the object level storage. I've already talked about this. Here, I'm going to talk about structured data storage. Now, structured data storage is performed through databases, okay? Like RDS, Amazon DynamoDB. So I'm going to focus on one specific database and a data warehouse, the most common solution. Now, data warehouses are used as a central system for storing analytical data for multiple sources. So, for example, let's say a company has a lot of different databases because different departments use them to track different things. Now, that's perfectly all right, but that makes it difficult to get a good idea of what's happening across all departments. Now, a data warehouse is a central repository of structured data for many data sources. Now, this data is transformed, aggregated, and prepared before it's loaded into the data warehouse. Now, data within the data warehouse, right, is then used for business reporting and analysis. Now, data warehouses are databases that store transactional data in a format that accommodates large, complex queries. Now, warehouses have been the backbone of businesses, by the way, for decades. From small businesses which have relatively small data sets to large businesses with exabytes of data, you can use data warehouses to make sense of all kinds of data. Now, on-premise data warehouses, right, take a significant investment to plan for the hardware cost and maintain. Now, many smaller businesses, that's just not an option, right? However, AWS provides a data warehousing service also, called Amazon Redshift. Very important. And I'm going to give you a demo also, right? So you can deploy data warehouse in minutes. It's built to store query data sets ranging from gigabytes to petabytes, right, in size. So now what we've got is Amazon S3 that can host the data lake and Amazon Redshift that can host a data warehouse. Perfect, right? What if you need to query across both spaces? Well, there is a solution for that. Let's introduce Amazon Redshift Spectrum, right? Now, this Spectrum allows you to combine your data lake and data warehouse as if it were a single source of data. Now, no data movement, no crazy query logic, just clean queries of all your data. So now it's possible to run a single query against exabytes of data, right? That's pretty incredible, okay? That's really a change of concept, right? Let's talk about the pros and the disadvantages of data hosting in the cloud, right? So the biggest benefit right here of data warehousing is fast, centralized retrieval of data. Now, data warehouses provide curated data sets that can be used for a variety of analysis and recording needs. Now, this allows you to use timely business insight, so it helps you make better decisions. Now, traditional on-prem data warehouses do have some downsides that can be significant, mainly their cost. Now, small businesses may not have the time or the resources to purchase the hardware and software required or configure rules and constraints to keep the data consistent within a data warehouse, right? Or even do ETL processes. And then there's the ongoing maintenance and security concerns. So it's difficult for a small business, right? And of course, the scalability of a traditional data warehousing cannot scale to meet the unpredictable demand of business workload. Now, using Amazon Redshift, right, which is a cloud-based data warehouse solution, can help you address those concerns. It's cloud native and provides up to 10 times performance that can be achieved, which is pretty comparable to on-prem data warehouse solutions. Now, I've talked about analytics a few times, right? And I want to make sure that you create the connection between data and storage thoroughly. So in traditional on-prem data analysis solution, ETL operations gather data. For example, these operations transform the data into the required format and then place it into the data warehouse on a schedule. You would then run a required analysis that you need against this relational data warehouse, right? Now, these analysis processes are limited to the data within the data warehouse. So in today's data landscape, now this is a huge limitation, right? So considering the breadth of data available to businesses, for example. Now, business applications commonly store data in the form of CSV format, XML, or JSON files. Now, data lakes combined with Amazon Redshift data warehouses are an elegant way to complement the data stored in a data warehouse. Now, you can create a data analytics solution that spans structured data into a data warehouse and then semi-structured and unstructured data stored in a data lake, for example. All data becomes visible and available for reports, dashboards, and insights. So another key advantage of the AWS ecosystem, right, is the ability to use everything in a data lake, from machine learning and real-time analytics, right, to accurately predict future outcomes. So let's recap, right, before we move on. Now, I've talked about several recommendations for storing data, right? At the object level, for example, I recommend Amazon S3 when storing massive volumes of data, both structured and unstructured. Definitely Data Lake is recommended on AWS. Now, when you store massive amount of structured data for complex analysis, right, it's recommended to store your data into a data warehouse using Amazon Redshift. And then, of course, finally, it's recommended. Now, this is for the ETL processes that generate analytical data sets. Now, within the AWS ecosystem, there is a tool for creating ETL operations called Amazon EMR. Now, Amazon EMR is a managed Hadoop framework. Remember, I talked earlier about the challenge of ingesting huge volumes of data quickly, right, and rapidly, producing insights? Well, this is where Amazon EMR does. Hadoop is an open source framework that has been around for a long time and well established in the data processing world. So, hang on for a second, right? Before I continue talking about what Hadoop is, let's define what Hadoop is not. Okay? It's not a database or a replacement for existing data systems. It is not a single application, right? Instead, it's a framework of tools that helps you both store and process data. So for now, let's focus on the storage part of this framework. So Hadoop supports rapid data transfers, which means you can speed up the processing time itself for complex queries. Now, whether you use Hadoop on-premise or Amazon EMR, you are going to use the same tools with one major exception. Amazon EMR uses its own file system. And that means you can use your own S3 data lake as a data store. So there's no need to copy data into the cluster as you would do with Hadoop on-premise. In fact, Amazon EMR file system, right, can catalog data within an Amazon S3 data lake and from an on-premise Hadoop file system at the same time. Now, it combines the greatest benefit of traditional Hadoop system with the advantages of Amazon EMR to give you the best of both worlds. The first principle of data analysis is to separate storage from processing. Amazon EMR, by the way, is a perfect example of this principle. So it's important to remember that AWS supports many different ways of storing data. Now, this gives you the flexibility of choosing the solution, right, that are best for your needs. So I hope this helped. Very important. Just go through this so that you understand different areas of data storage, the way data is ingested, and the way it is being held in data storage or warehouse or Amazon S3, for example, right? So I hope this helps. Let me know if you have any questions with this. Let's move to the next lesson. Welcome back. Let's take a look at data warehouses now, right? So a data warehouse is a central repository for data for many data sources, right? Now this data is transformed, aggregated, and then prepared for business reporting and analysis. A data warehouse is a central repository of information, right, coming from one or more data sources. Now data flows into a data warehouse from transactional systems, relational databases, right, and other sources. Now, these data sources can include structured, semi-structured, and unstructured data. Now, these data sources are transformed, right, into structured data before they're stored into a data warehouse. Now, data is stored within a data warehouse using a schema. That's an important word, right? So a schema defines how data is stored within tables, columns, and then rows. Now, the schema enforces constraints on the data to ensure integrity of the data. Now, the transformation process often involves the steps required to make the source data conform to the schema. Following the first successful ingestion, for example, of data into a data warehouse, the process of ingesting and transforming the data can continue at a regular pace. Now, business analysts, data scientists, and decision makers, right, they access the data through business intelligence, right, BI tools, SQL clients, for example, and other analytic applications. Now, businesses use reports, dashboards, and analytics tools to extract insights from their data, monitor business performance, and then support decision-making. Now, these reports, dashboards, and analytics tools are powered by data warehouses, which store data efficiently to minimize I/O and then deliver query results at blazing speeds to hundreds and thousands of users concurrently. Talk about data marts, right? So AI tools, SQL clients, and other subset of data warehouse, for example, right? Data warehouses can be massive. Now, analyzing these huge stores of data can be challenging and confusing. Now, many organizations need a way to limit the tables to those that are most relevant to analytical users, right? Now, a subset of data from a data warehouse is called a data mart. Now, data marts only focus on one subject or one functional area. Now, a warehouse might contain all relevant sources for an enterprise, but a data mart might store only a single department source. Now, because data marts are generally a copy of data already contained in a data warehouse, they're often, fast and easy to implement. Now, Amazon Redshift allows you to do that, right? Let's talk about this is where actually Amazon Redshift comes in. Because Amazon Redshift overcomes all of these negatives by providing a cloud-based, scalable, secure environment for your data warehouse. So Redshift is easy to set up, deploy, and then manage, and then provides up to 10 times faster performance than other data warehousing solutions out there. So data storage on a big scale. Now, I've talked about many recommendations right earlier for storing data. Now, when storing individual objects or files, definitely it's recommended storing in S3. When storing massive volumes of data, both semi-structured and unstructured, it would be nice to build a data lake on S3. And when storing massive amount of structured data, right, for complex analysis, remember, store data in Amazon Redshift. Now, from storage to processing. Each of the AWS processing services, right? I'm going to cover subsequently in the next lesson, the temporary storage layer, right, that houses data while it's being processed and analyzed. Now, this data is eventually moved to permanent storage within one of the other solutions. We've already talked about it in previous lectures. Now, many people think of working with massive volumes, fast-moving data. The first thing that comes to mind is Hadoop, right? Pretty popular. Now, within AWS, Hadoop framework are implemented using Amazon EMR and AWS Glue. Now, these services implement the Hadoop framework to ingest, transform, analyze, and move results to analytical data stores. So Apache Hadoop, right, uses a distributed processing architecture in which a task is mapped to a cluster of commodity servers for processing. Now, each piece of work distributed to the cluster servers can be run or rerun on any of the servers. The cluster servers frequently use the Hadoop Distributed File System, HDFS, to store data locally for processing. Now, the results of the computation performed by those servers are then reduced to a single output set. Now, one node is designated as a master node, which controls the distribution of tasks and can automatically handle, several failures, for example, right? Why do you want to use Apache Hadoop, right? So Hadoop facilitates data navigation, discovery, and one-time data analysis. Now, with Hadoop, you can compensate for unexpected occurrences, for example, by analyzing large amounts of data quickly to form a response. Unlike traditional database systems, Hadoop can process structured, semi-structured, or unstructured data. Now, this includes virtually any data format currently available. So in addition to natively handling many types of data, such as XML, CSV, text, log files, objects, right, SQL, JSON, you name it, or binary even, you can use Hadoop to transform data for better integration into your existing data set. Also, you can store data with or without schema and perform large-scale ETL operations to transform your data. Because Hadoop is open source, several ecosystem projects are available to help you analyze multiple types of data that Hadoop can process or analyze. Now, these projects give you tremendous flexibility when you're developing data analytics solutions. Now, Hadoop's programming framework, for example, such as Hive and Pig, can support any data analytic use case for your application. Now, because of Hadoop's distributed architecture, right, Hadoop clusters can handle tremendous amount of data affordably. Now, adding additional data and processing capability is simple as adding additional servers to your cluster, right, horizontal scaling. Implementing Hadoop with Amazon EMR now is great because Amazon EMR is the AWS service, right, that implements Hadoop's framework. Now, the service will ingest data from nearly any data source type, right, at nearly any speed. And Amazon EMR has the ability to implement two different file systems, HDFS, which is Hadoop, right, or the Elastic MapReduce file system. Now, a file system is a set of organizational rules, right, that govern how files or how data is stored. HDFS is Hadoop's, right? To handle massive volumes of data rapidly, the processing system requires a way to distribute the load of reading and writing files across different high-powered servers. Now, HDFS is distributed storage, allowing files to be read and written to clusters of servers in parallel. Now, this dramatically reduces the overall length of each operation. And it's helpful to understand the inner workings of the HDFS cluster, by the way. Now, HDFS cluster primarily consists of a name node, which manages the file system metadata. And then, of course, other nodes store the actual data. Now, HDFS architecture components, right? So you understand better. Now, Amazon EMR is the AWS service, like I mentioned earlier, that implements Hadoop framework. Now, Amazon EMR, it begins by ingesting data from one or more data sources and then storing the data within a file system. Now, if using HDFS, the file system is stored as an elastic block store volume, EBS. Now, this storage volume basically means that it's temporary nature, right? Now, once the data has been copied into the HDFS volume, the transformation and analysis of the data is performed. Now, the results are then sent to the analytic data store, such as S3 Data Lake or Amazon Redshift Data Warehouse. So EMR, it provides an alternative to HDFS, right? The EMR file system, basically EMFRS, right, can help ensure the persistent source of truth for HDFS data, right, which is stored in Amazon S3. Now, when implementing EMRFS, there's no need to copy data into the cluster before transforming, which is really helpful, right? Which is pretty powerful. So EMFRS can basically catalog data, right? And the time that is saved to eliminate copy can dramatically improve the performance of the cluster itself. So, storage is the foundation for any data analysis solution. It's vital to understand your options so you can decide which solution is best for your organization. So, I've covered the object-level storage and the benefits of creating a data lake to bring data from many sources, for example, right, and many forms together into a single location. I've also talked about the advantages and disadvantages of structured analytical storage, right, using data warehouses. And of course, I covered the importance of carefully considering how to create ETL operations. I've also talked about Apache Hadoop, its capabilities, the benefits, and how it integrates with Amazon EMR, including the file systems themselves. I hope this helps. Let me know if you have any questions. With this, let's move to the next lesson.
Hi everybody, and welcome to this lesson on the Relational Database Service, or RDS, that is offered by Amazon Web Services. So the RDS makes it really easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks such as hardware provisioning, database setup, patching, and even backups. It frees you to focus on your applications so you can give them the fast performance, high availability, security, and compatibility they need in order to provide superior service to either your internal employees or your customers. Now, the RDS is available on several database instance types, either for optimized memory, for performance, or I/O, and provides you with 6 familiar database engines to choose from, such as the Amazon Aurora, the PostgreSQL, MySQL, MariaDB, Oracle Database, and the Microsoft SQL Server. And Amazon also has a database migration service which allows you to easily migrate or even replicate your existing databases to Amazon RDS. So they've made it very easy for you to start utilizing RDS in a simple and easy fashion. So let's go ahead and take a look at some of the advantages and benefits that RDS has. So First and foremost, it is extremely easy to administer. It makes it very easy to go from project conception to deployment. You can use the AWS Management Console, which we will look at when we go through the demonstration, or the command line interface to access capabilities of a production-ready relational database in a matter of mere minutes. So there's no need for infrastructure provisioning and no need for installing and maintaining a complex database software. It's also highly scalable. Like most of the AWS offerings, the RDS is extremely scalable and utilizes the global infrastructure that AWS has. It's also available and durable because it runs on the same infrastructure. It's extremely fast and it supports the most demanding database applications. You can choose between two SSD-backed storage options, one optimized for high performance OLTP applications and the other for cost-effective general purpose use. In addition, when we look at the Amazon Aurora a little bit closely, it provides performance on par with commercial databases at 1/10 of the cost. The RDS also makes it easy to control network access to your database. The RDS lets you run your database instances in a virtual private cloud, which enables you to isolate your database instances and to connect to your existing IT infrastructure through an industry standard encrypted IPsec VPN. The engine types offer encryption at rest and encryption in transit. Lastly, it is extremely inexpensive when compared to other options. You pay very low rates and only for the resources you actually consume. In addition, you can benefit from the on-demand pricing that comes with AWS, which allows you no upfront or long-term commitments or even lower hourly rates if you want to use the reserved instance pricing. So let's go ahead and take a closer look at the 6 different instances that are offered by Amazon. So the PostgreSQL has literally become the preferred option, the preferred open source relational database for many enterprise developers and startups. Now RDS makes it easy to set up, operate, and scale deployments of PostgreSQL in the cloud. With RDS, you can deploy scalable deployments in minutes with cost-efficient and resizable hardware capacity. It manages the complex and time-consuming admin tasks such as the software installation and upgrades, storage management, replication for high availability and read throughput, and backups for disaster recovery. Now, the RDS for PostgreSQL gives you access to the capabilities of a familiar PostgreSQL database engine. This means that the code, applications, and tools you already use today with your existing databases can be used with the Amazon RDS. So with just a few clicks in the Management Console, you are able to deploy a PostgreSQL database with automatically configured database parameters for optimal performance. Now, once provisioned, you can literally scale it up to 16 terabytes of storage and 40,000 IOPS. And the RDS for PostgreSQL also enables you to scale out beyond the capacity of a single database deployment for read-heavy database workloads. Now, MySQL is the world's most popular open source relational database, and RDS makes it easy to set up, operate, and scale the MySQL deployments in the cloud. It frees you up to focus on the application development by managing time-consuming database admin tasks such as it did with the PostgreSQL. It supports MySQL community versions 5.5, 5.6, 5.7, and 8.0, which means that the code, applications, and tools you already use today can be used with RDS. It also comes with the standard backup and recovery that Amazon Web Services offers, along with the high availability and read replicas, which makes it easy to elastically scale out beyond the capacity constraints of a single database instance. Additionally, the RDS provides Amazon CloudWatch metrics for your database instances at no additional charge, and the RDS Enhanced Monitoring provides access to over 50 CPU, memory, file system, and disk I/O metrics. Lastly, just as with PostgreSQL, you are given an isolation and security with the utilization of a Amazon VPC or through the Amazon Key Management Service. Now, the MariaDB is not as popular as the PostgreSQL or MySQL, but it was literally created by the original developers of MySQL. And it's got most of the same benefits that are given in the other database engines that come with RDS. One main one that I want to point out is the high performance. So you can provision, again, up to 16 terabytes of storage and 40,000 IAPS per database, and select instances with up to 32 CPUs and 244 GB of memory. So it's a very easy option to deploy a MariaDB if that is what you are using on-prem, and have it deployed on an AWS infrastructure, which allows you to not only scale it out, but give away some of the administration tasks to Amazon Web Services, such as the fault tolerance or such as the backups. So let's go ahead and log into our management console and see what the different options are in configuring and provisioning some of these database instances. Hi everybody, and welcome to this lesson in which we're going to look at the DynamoDB database offered by AWS. Now, DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. DynamoDB lets you offload the admin burdens of operating and scaling a distributed database, so you don't have to worry about hardware provisioning, setup and configuration, replication, software patching, or cluster scaling. Also, it offers encryption at rest, which eliminates the optional burden and complexity involved in protecting sensitive data. Now, with DynamoDB, you can create database tables that can store and retrieve any amount of data and serve any level of request traffic. You can scale up or scale down your tables' throughput capacity without downtime or performance degradation, and use the AWS Management Console to monitor resource utilization and performance metrics. It provides on-demand backup capability. It also allows you to create full backups of your tables for long-term retention and archival for regulatory compliance needs. You can create on-demand backups as well. Enable point-in-time recovery for your Amazon DynamoDB tables. Point-in-time recovery helps protect your Amazon DynamoDB tables from accidental write or delete operations. You can also restore that table at any point in time. And just for your reference, they store it up to 35 days by default. It also allows you to delete expired items from tables automatically to help you reduce the storage usage and the cost of storing data that is no longer relevant. Now, some of the core concepts of DynamoDB. First, we have tables, items, and attributes. Now, tables are similar to other database systems. DynamoDB stores data in tables, which is basically a collection of data. Now, each table contains 0 or more items, which is a group of attributes that is uniquely identifiable among all of the other items. And then finally, we have attributes. Each item is comprised of one or more of them. An attribute is basically a fundamental data element, something that does not need to be broken down any further. Now, when you create a table, in addition to the table name, you must specify the primary key of the table. The primary key uniquely identifies each item in the table so that no two items can have the same key. It supports a partition key and a partition and sort key. Then you have secondary indexes. You can create one or more of them on a table. It lets you query the data in the table using an alternate key in addition to queries against the primary key. Now, DynamoDB does not require that you use indexes, but they give your applications more flexibility when querying your data. And then lastly, there are DynamoDB streams, which is an optional feature that captures data modification events in DynamoDB tables. The data about these events appear in the stream in near real time and in order that the events that they occurred. Now, DynamoDB also supports eventually consistent or strongly consistent reads. Eventually consistent means that there will be a little bit of lag in terms of the consistency, whereas the strongly consistent means that the data is replicated in a matter of mere milliseconds. Now, this table just gives you a good difference between a relational database management system, or also RDS, that AWS supports, and the Amazon DynamoDB. Now just keep in mind that DynamoDB is schemaless and again uses a key value store. You can also specify the required throughput capacity, and DynamoDB, being a fully managed resource, does the rest. Now DynamoDB also fully synchronizes on the backend the data across all of the availability zones within the region that you created the tables in. It also integrates very easily with other AWS services such as the Elastic MapReduce or EMR, and can easily move data to a Hadoop cluster in the Elastic MapReduce. Now, some of the popular use cases are IoT, gaming, and mobile. And again, you guys can see a good differentiation between the two types of main databases that are offered by AWS. So let's log into our management console and see if we can create a database instance and see if we can access it through our EC2 instance. Hi everybody. So now that we know a little bit about what Amazon DynamoDB is, how fast and how powerful it is, what I'm going to do is just take you through a small tutorial where we're going to create some simple tables, data, scan and query the data, and then finally go ahead and clean it up using the DynamoDB. So again, it's a NoSQL database that supports both document and key value store models. It's very flexible, reliable, and again, best part about it is you can automatically scale it up and scale it down based on your need. It's used quite often in a lot of IoT, gaming, web, mobile. For example, whenever there's the Amazon Black Monday, they use primarily the DynamoDB to fulfill their orders. So the millions of requests that are coming in are serviced by DynamoDB. So as you guys can see, I'm already logged into my AWS Management Console, and I've gone into my Amazon DynamoDB management dashboard. So the first thing I want to do is I'm going to go ahead and create my first table. In the table name, just going to go ahead and give it a simple name. Now the partition key is used to spread data across partitions for scalability. So it's important to choose an attribute with a wide range of values, and that is likely to have an evenly distributed access patterns. So since I'm going to use a table name called music, I'm going to use a partition key called artist. And again, this will be totally dependent on the type of business that you guys are doing and the type of table or what this database is going to be primarily used for. Now, for the purposes of this example, right? So now each artist can write more than one song. So with this, we can enable easy sorting with a sort key. So we're going to go ahead and click on add a sort key. And here we're going to type in title for the title of the song. And here again, you guys can see that we can either have a string, a binary, or a number for the keys. So since again, these are going to be an artist and title, these are going to be strings, we're going to leave them as strings. Now, DynamoDB can also auto scale, again, up and down based on your need, and it will change the read and write capacity of your table based on the request volume. So by using the IAM or Identity and Access Management role called the DynamoDB Autoscale, it will manage the auto-scaling process on your behalf. Now, it creates this role for you the first time you enable auto-scaling in this account. What we're going to do is we're going to instruct DynamoDB to create the role by clearing the use default settings. This checkbox, we're going to go ahead and clear this up. So as you guys can see, once we get rid of the default settings, there's quite a few different things that we are able to change and modify. For example, we can add secondary indexes. We can change the write capacity. So for example, provisioned is the free tier eligible. We can do on demand. We can do the provision capacity. For example, the read capacity per units, 5 tables, the write capacity. It gives you an estimated cost if you auto scaling. Again, the target utilization, the write capacity. So these are all default settings. So what we're going to do is we're going to leave all of these default settings the same. And here is where it creates the auto scaling service link role. We can also have it use an existing role. If we have a role created already, we can type in the role name here. Or if we don't have one, we can let DynamoDB create the role on our behalf. Encryption at rest, it also supports encryption at rest. We can either have the default, which is the server-side encryption using the AWS own CMK, or we can use the key management service, which is again using the customer master key. So we're going to go ahead and click on create. It'll take a few minutes, few seconds to a few minutes to get this provisioned and up and ready. There we go. Now we see that we have this music table that's created. These are all the default settings for this music table that we just simply created a few seconds ago. So that's essentially how easy it is to create the table. So now we're going to go ahead and add data to this table. So we're going to go ahead and select the items tab up here. These are all the different tabs we can do for this table. We're going to go ahead and create an item for the artist string to make it simple, because I know there's going to be people all across the globe that will be taking this course. So we're going to keep it agnostic. After that item's created, we're going to go ahead and click on save. We'll add a couple more just so we can make this a little bit more comprehensive. There we go. So I've created basically 4 different items, 2 with one artist and 2 with another artist. So now that we have our table created, we have our items created, let's see how we can query this table. So here's the drop-down list. Here we have a few options. We can either scan or query. So we're going to go ahead and query an operation. Now you can use the console to query the table in various ways. So for the first query, we're going to do in the artist box. We're going to go ahead and type in a specific name and start search. There we go. As you guys can see, those 2 options show up on the bottom. Or we can delete this. We can try searching for the other one. We can do ascending. We can do descending. So quite a few different options that we have in terms of querying based on the artist, based on the title. Again, this is the partition key and this is the sort key. We can additionally add filters for entering attributes. We can do descending. We can do attributes all. We can cancel all these changes. And here on the drop down, we can pick various tables, but since we only have one table, it's only listing one table. So lots of different options we can do in terms of querying the table. And again, most of the time you'll have apps that will be linked into this DynamoDB table that will be querying it for various items. And since this is a NoSQL table, a NoSQL database, it's extremely fast. And again, like I said, this is the main database that Amazon also uses during its Black Monday sales. This is the table, this is the database that they use to process all of their items. And these tabs on top just take you through various things. For example, the backups, you're able to create and prioritize backups. You can create, restore, delete backups. You can automate backups also if you want, or you can restore it. Just one thing to keep in mind, it maintains the continuous backups of the table for the last 35 days. If you want to change that, you'll have to contact AWS and they are able to change it. But by default, it's a maximum of up to 35 days. So that's a basic overview of DynamoDB. And if you are doing on the free tier and practicing, you have to make sure that we go ahead and delete the NoSQL table. Otherwise, you will start getting charged for it. So here, once you go close, once you go back into the main console, we're going to go ahead and click on our table and we're going to delete this table. Optionally, if you're in a production environment, you can create a backup of it. Let's say you're deleting a table. You want to make sure you have a backup for future use. You can create a backup before deleting the table. But since this is for testing purposes, we're just going to go. There we go. The table is deleted. So we're back into having no tables or no items back into our DynamoDB. So that's essentially how easy it is to start working with DynamoDB. If, for example, your organization requires something that has or that will be utilizing a NoSQL database, that wants something that's great fit for mobile, web gaming, ad tech, or even IoT, where again, scalability, you want to make sure you go up and down based on your demand. This would be the perfect option. Hi everybody, and welcome to this lesson on taking a closer look at what is Amazon's SageMaker. So the SageMaker is basically a fully managed ML service. Now, data scientists and developers are able to quickly and easily build and train machine learning models. and then directly deploy them into a production-ready hosted environment through SageMaker. It provides an integrated Jupyter authoring notebook instance for easy access to your data sources for exploration and analysis. So through that, you don't have to manage any servers. It also provides common machine learning algorithms that are optimized to run efficiently against extremely large data in a distributed environment. It also has native support for bring your own algorithms and frameworks, and we'll take a look at that when we're going through our demonstrations. It also offers a flexible distributed training options that adjust to your specific workflows. Deploy a model into a secure and scalable environment by launching it with a single click from the console, which again we'll also take a look at later on in the course. Now, one thing I want to mention is that it is a fully managed service provided by AWS, so you're able to do an A to Z deployment of your ML models and do it directly into your production environment. So let's take an overview of what we are able to do through the SageMaker environment. First, we're able to collect and prepare training data. It helps us build and manage highly accurate training datasets quickly. It also offers easy access to public and private human labelers and provides them with pre-built workflows and interfaces for common labeling tasks. Now just keep in mind that that service has an extra charge because those are actual people that will be doing the labeling for you, if, for example, you don't have any people in-house. You can also choose and optimize your ML algorithm. It automatically configures and optimizes, for example, TensorFlow, Apache MXNet, PyTorch, Chainer, SparkML, and many more. And commonly used ML algorithms are built in and tuned for scale, speed, and accuracy with over 100 additional pre-trained models and algorithms available in the marketplace. And when we're going through the details of machine learning, we will take a look at what built-in algorithms are available and also take a quick peek at configuring our own algorithms. Additionally, you're able to set up and manage training environments, and the best thing about it is it has one-click training. You can begin training your model with simply a single click, and it handles all of the underlying infrastructure to scale up to, for example, petabyte-size datasets. You can also tune and optimize your model. Automatic model tuning uses ML to quickly tune the model to be as accurate as possible. Now, this capability lets you skip the tedious trial and error process of manually adjusting model parameters. Instead, over multiple training runs, the automatic model tuning perform hyperparameter optimization by discovering interesting features in your data and learning how those features interact to affect accuracy. So by doing this, you're essentially saving days or even weeks depending on the size of your data and maximizing the quality of your trained model at the same time. And then lastly, you're able to deploy and manage models in production. And again, as with everything, it does have one-click deploy to production once your model is trained, and you're able to do real-time or batch data. And the model runs on auto-scaling clusters of the SageMaker since it is a managed service that are spread across multiple availability zones, and it delivers both high performance and high availability. And the SageMaker also includes built-in A/B testing capabilities, and that basically helps you test your model and experiment with different versions to achieve the best results. Because as with anything in machine learning, it is an iterative process, so it is a trial and error process where you try one thing. If it does not work, you go on to another. So that whole process is simplified through SageMaker because it automates a lot of that for you. So you're able to concentrate on looking at the data and working on the data rather than trying to figure out which model what works best. So these are some of the basic features that are offered by SageMaker, and we'll take a closer look at each one of these as we go on throughout the rest of the course. Hi everybody, and welcome to this lesson on looking at machine learning that's offered by AWS. Now, AWS has a pretty broad and deep set of machine learning and AI services to cater to almost any business of any size. So there's many different things you can choose from, such as pre-trained AI services for computer vision, language, recommendations, forecasting. And then there's also the Amazon SageMaker, which you can use to build, train, and deploy machine learning models. And we'll look at SageMaker a little more deeply in another section. But just to give you guys an overview, SageMaker is basically one of the main machine learning services that are offered by Amazon. And it's very customizable in that you are able to build, train, and deploy your own customized machine learning models based on even your own algorithm, or you can use one of the built-in algorithms that are offered by AWS. And again, like I mentioned, there's an entire section in this course dedicated to Amazon SageMaker. So we'll look at specifically how you can build your machine learning model, train it using the different algorithms, and then how you can deploy it in Amazon Web Services. To give you guys an overview of some of the other services that are offered by AWS. These AI services, you can basically very easily integrate them with your applications to address common cases, such as if you want personalized recommendations, or if you're trying to improve safety and security, or if you're trying to increase your customer engagement and trying to get more analytics to improve your marketing campaigns or improve your operations. These various services allow you to do that very easily and quite often very simply. So there's one service called Recommendations, which personalizes experiences for your customers with the same recommendation technology that's used by Amazon.com. So again, I'm sure all of us are familiar with Amazon.com and the robustness of it and how it personalizes almost everything for you when you go on it. So you can use that same technology and that same service that they use to personalize your experience when you go on their website and implement that within your own organization, whether it's an e-commerce website or whether you have your own corporate website. You can use the same information that Amazon.com is using and try to implement that maybe at a smaller scale in your own organization. There's also, you can build accurate forecasting models based on machine learning technology. For example, if you're trying to forecast your sales for the next quarter or for the next year, or you're trying to forecast the amount of users that are going to be hitting your website or your e-commerce site that you're launching or that you're building up, you can use those machine learning models to forecast even, for example, how much stock to order, so you can minimize the stock that you guys have or that you keep in your warehouse. So there's various applications that you can use the forecasting for. There's also image and video analysis that you can add to your applications to catalog assets, automate media workflows, extract meaning, and much more. Additionally, you can use natural language processing to extract insights and relationships from unstructured text. You can also do document analysis. For example, you can extract text and data from millions of documents in amount of hours, reducing a lot of manual effort that a lot of us do in trying to analyze the different documents, regardless of which industry that we're currently in. And various other ones, for example, there's voice. You can turn text to lifelike speech. You can use chatbots, which are referred to as conversational agents. You can use translation services. There's also transcription services, which is basically you can easily add high quality speech to text capabilities to your applications and to your workflows. So there's a host of different AI services that are offered by machine learning that AWS offers. So depending on what we're trying to do within the AI framework or within the machine learning framework, we can pick and choose to implement various services within that AI framework you guys see and implement that in our applications, in our business processes. And to add to those AI services, AWS also offers a host of other services to make it a complete package for you. For example, you can get the right compute for any use case. You can leverage a broad set of powerful EC2 instances ranging from GPUs for compute-intensive deep learning to FPGAs for specialized hardware acceleration to memory instances for running inference. So these EC2 instances, which are basically your virtual machines or VMs, offer a range of hardware options that you can pick and choose from. And the best part about it is you don't have to provision them on a permanent basis. You can use, for example, something called on demand. So they're only provisioned when you need them. So if there's off-peak hours, you can scale down your instances. On peak hours, you can scale up your instances. So it's a very, very cost-effective way to manage your infrastructure on the cloud. And they also offer analytics and security for machine learning. So in order to do machine learning successfully, you not only need the capabilities, but you also need the right security, you need the right data store, and you need the right analytics service to work together in harmony in order to have a very good and well-functioning machine learning model. And with AWS, it offers all of that through the S3 services for storage, through AWS Analytics, and the AWS Security. So it kind of brings everything together for you in one package. Additionally, there's a couple of neat learning tools that are within the AI framework. You can get deep with machine learning through something called the AWS Deep Racer, which is the car that you guys see on there. So it's basically a fully autonomous 18th scale race car designed to help you learn about reinforcement learning through autonomous driving. And we'll talk about reinforcement learning a little bit later on in a bit more detail, because that's one of the most up and coming areas of machine learning that's especially used for autonomous driving. So you can experience, for example, what it's like to race in the real world when you deploy your own reinforcement learning model into the AWS Deep Racer. There's also the Deep Lens, which is the camera you guys see on the bottom right. So it's basically the world's first deep learning enabled video camera that's primarily developed for developers. It's integrated with SageMaker and many other AWS services and allows you to get started with deep learning in minimal amount of time. And most times, if you're trying to set it up, you can probably do it in less than 10 minutes. And the best part about it is it's all integrated to AWS, and you can watch the results real time through the AWS console. So this is basically just to give you guys an overview and a broad understanding of what AWS offers through machine learning and the capabilities that it offers. So it's basically a one-stop shop for you to do everything that is AI or machine learning related. And for me, the best part about it is everything is available in one console, in one area, so you don't need to go to several different platforms or several different programs to do machine learning. Everything can be done right here within the AWS framework. Hi everybody, and welcome to this lesson on looking at how we can build a machine learning application. So building applications or building ML applications is an iterative process that involves a sequence of steps. So to build a machine learning applications, there's generally 5 different steps that one should follow. For example, there's formulate the problem, then we collect and label data, analyze the data, feature processing, and splitting the data. So what do I mean by formulating the problem or formulate a problem? So the first step in machine learning is to decide what you want to predict, which is known as the label or target answer. So imagine a scenario in which you want to manufacture products, but your decision to manufacture each product depends on its number of potential sales. So in this scenario, you want to predict how many times each product will be purchased, which is predicting the number of sales. So there's multiple ways to define this problem by using machine learning. So choosing how to define the problem depends on your use case or specific business need. For example, do you want to predict the number of purchases your customers will make for each product? In that case, the target is a numeric and you're solving a regression problem. Or do you want to predict which products will get more than 10 purchases? In that case, the target is binary and you're simply solving a binary classification problem. So it's very important to avoid overcomplicating the problem and to frame the simplest solution that meets your needs. However, it's also important to avoid losing information, especially information in the historical answers. For example, converting an actual past sales number into a binary value of over 10 versus fewer would lose valuable information. So you have to make sure you invest the time in deciding which target makes the most sense for you to predict will save you from building models that don't really answer your question. So that's basically formulating the problem will lay the groundwork for making sure that the model that you're trying to build and what you're trying to predict will essentially meet your needs and meet your business case. So if you do that incorrectly, the rest of the process kind of falls apart. So it's very important that we spend the right amount of time and resources in making sure we get this right. So after we have that, then we need to do the data. So machine learning problems obviously start with data, preferably lots of data for which you already know the target answer. So what I mean by that is basically historical data. So in the example that I had given, you would need to get the historical data for all of your past sales. So data, again, the data for which you already know the target answer, is what's called the labeled data. And in supervised machine learning, the algorithm teaches itself to learn from the labeled data examples that we provide. So each observation or each example in your data has to have two elements, the target and then the features. And the target is the answer that you want to predict, for example, the number of sales. And the features are the attributes of the example that can be used to identify patterns to predict the target. So for example, for the email classification, the target is a label that indicates whether an email is spam or not spam. So examples of variables are the sender of the email, the text in the body of the email, the text in the subject line, the time the email was sent, and so on. So all of those variables will help the machine learning model predict whether that email is spam or not. Now, often data is not readily available in a labeled form. So collecting and preparing the variables and the target are often the most important steps in solving a machine learning problem. So the example data should be representative of the data that you will have when you're using the model to make a prediction. So for example, if you want to predict whether an email is spam or not, you must collect both positive, which is, you should collect both spam emails and non-spam emails, so the machine learning can learn what is spam and what is not spam. So, and once you've labeled the data, you might need to convert it to a format that's acceptable to your algorithm or software. For example, the Amazon machine learning, you need to convert the data to a CSV format, with each example making up one row of the CSV file. So this is specifically for the Amazon machine learning. And if you're using another software, you have to make sure that the data is formatted according to the requirements of that program or of that software. So after we have the data, and before feeding that labeled data to the algorithm, it's a good practice to inspect your data to identify issues and gain insights about the data you're using. And the predictive power of your model will only be as good as the data you feed it. So you have to make sure you analyze your data and keep the following things in mind. It's useful to understand the values that your variable take and which variables are dominant in your data. So you could run these summaries by a subject matter expert for the problem that you want to solve. So ask yourself, or whoever the expert is, does the data match your expectations? Does it look like you have a data collection problem? And so on. So you have to make sure that you run it by an expert to make sure that the data makes sense. And also the second is knowing the correlation between each variable and the target class is helpful, because a high correlation implies that there is a relationship between the variable and the target class. And in general, you want to include variables with high correlation because they're the ones with higher predictive power, and leave out the variables with low correlation. So now that we have the labeled data, we've analyzed to make sure that it's proper and that it's correct, that we have the right correlations. That's when you might want to transform your variables further to make them more meaningful. And this is what's known as feature processing. So for example, say you have a variable that captures the date and time at which an event occurred. Now this date and time will never occur again and hence won't be useful to predict your target. However, if this variable is transformed into features that represent the hour of the day of the week, the month, now these variables could be useful to learn if the event tends to happen at a particular hour, a particular day of the week, or a particular month of the year. So such feature processing to form more generalizable data points to learn from can provide significant improvements to the predictive models. Now obviously it's not always possible to know the features that have the predictive influence in advance. So it's good to include as many features as you potentially can and that are potentially related to the target label, and let the model training algorithm pick the features with the strongest correlations. So your job should be to include as many features as possible and let the machine learning do its work. Let it learn from all of that data, because if you remember, as I mentioned, you want to make sure you have as much data as possible and feed as much data as possible into the machine learning model. But that does not mean that feeding data that's unstructured or data that's not analyzed or data that's not relevant. We have to make sure that all of that is done, but after all of that is done, we have to make sure, and we want to make sure that we have as much data as possible into the machine learning model so it can learn and make correct predictive answers. And then finally, splitting the data. Now, the fundamental goal of machine learning is to generalize beyond the data instances used to train models. We want to evaluate the model to estimate the quality of its pattern generalization for data and model has not been trained on. However, because future instances have unknown target values and we cannot really check the accuracy of our predictions for future instances since we don't have a crystal ball, we need to use some of the data that we already know the answer for as a proxy for future data. And evaluating the model with the same data that we use for training is not really useful because it rewards models that can remember the training data as opposed to generalizing for it. So a common strategy is to take all available labeled data and split it into training and evaluation subsets, usually commonly with a ratio of 70 to 80% for training and 20 to 30% for evaluation. And the machine learning system uses the training data to train models to see patterns and uses the evaluation data to evaluate the predictive quality of the trained model. And the system evaluates the predictive performance by comparing predictions on the evaluation data set with true values, or known as ground truth, using a variety of metrics. And usually you see the best model on the evaluation subset to make predictions on future instances for which you do not know the target answer. Now, the Amazon machine learning splits data sent for training a model through the console into 70% for training and 30% for evaluation. And that's done by default. Now, it also allows you to select a random 70% of your source data for training instead of using the first 70% and using the complement of this random subset for evaluation. And you can use the APIs that are provided by Amazon Machine Learning to specify custom split ratios and provide training and evaluation data that was split outside of machine learning. So if you have done it outside and you would like to pump in that data, you do have that capability with Amazon Machine Learning if you do not want to use that automated system. So these are the 5 main steps that we need to make sure that we follow in order if we want to have a properly working machine learning model that predicts our future sales or forecasts our future sales or predicts spam emails in the examples that I had given properly and effectively. Because if we do not follow these steps to the T, then we can have issues of making wrong predictions, and essentially if you are going to be doing this in a production environment, that can have pretty dire consequences for you and for your organization. So these are simple steps to follow, but nonetheless ones that we need to make sure that we follow in detail in order to have a properly working machine learning model. Hi everybody, and welcome to this lesson on understanding a little bit more detail the data sources that are going to be used within Amazon Machine Learning. Now, data source objects contain metadata about your input data. Now, when you create a data source, the Amazon Machine Learning reads your input data, computes descriptive statistics on its attributes, and stores the statistics, which is called the schema, and other information as part of the data source object. Now, after you create a data source, you can use the data insights which are provided by the Machine Learning Console, which we'll take a look at, to explore the statistical properties of your input data, and you can use the data source to train a machine learning model. Input data is, like I mentioned, the data that you use to create the data source. And you must save your input data as a CSV format for AWS. Now, different programs and different software have different requirements, but for Amazon Machine Learning, it has to be in a CSV file. And each column in the CSV file contains an attribute of the observation. For example, in the figure that you guys see, it's basically a snapshot of a CSV file that has 4 observations, each in its own row. And each observation contains 8 attributes, which are separated by a comma. Now, the attributes represent information about each individual represented by an observation. For example, it starts off with a customer ID, then it goes into a job ID, the education, whether it's basic, whether it's high school, the housing, the loan campaign, the duration, and whether they will respond to a campaign, which is classified by either a 0 or a 1, 0 being no and 1 being yes. Now, Amazon Machine Learning requires a name for each attribute, and you can specify these attribute names by either including them in the first line, which is again known as a header line of the CSV file, or including them in a separate schema file that can be located, or that should be located, in the same S3 bucket as your input data. Now, the CSV file that contains your input data has to meet a certain set of requirements. For example, it must be in plain text, consists of observations, and each line should have only one observation, and they should be separated by commas. And if an attribute value contains a comma, the entire attribute value must be enclosed in double quotes. Each observation must be terminated with an end-of-line character. And attribute values cannot include end-of-line characters even if the value is enclosed in double quotes. Every observation must have the same number of attributes, and each observation must be no longer than 100 kilobytes. So these are requirements that must be met by the CSV file that you're going to be using as your data source. And like I mentioned, you can provide your input to machine learning in a single file or as a collection of files, and these must satisfy a few other conditions. For example, all files must have the same data schema, and they must reside in the same S3 bucket and path. And for example, you guys see the three paths that I've given. So if your input data files are named input 1, 2, and 3, and your S3 bucket is, for example, the example bucket, your paths should look like what you guys see on the screen. And lastly, when you create a CSV file, each observation, like I mentioned as a requirement, will be terminated by a special end-of-line character. Now, this character is not visible, but is automatically included at the end of each observation when you press enter or the return key. Now, the special character that represents the end of line varies depending on the OS that you're using. For example, Linux uses a line feed character that's indicated by a /n. Windows uses two characters called carriage return and line feed that are indicated by /r/n. So when you're saving those files, you have to make sure that you specify the correct format that those files should be saved in based on the operating system that you're using. And especially if you're using a Mac OS and using a Microsoft Excel on a Mac OS and you create your CSV file, you have to make sure that you save it as a Windows comma separated or a Windows CSV file in order for it to work properly within Amazon Machine Learning. So it's very important that we make sure that our data format is correct before feeding in the data to the machine learning model. Otherwise, if you started to format your data, especially if you have large amounts of data, it can become a hassle to correct it later on. So we want to make sure that we know what the requirements are and we start following them when we're preparing the data for ingestion into the machine learning model. One of the fundamental goals of machine learning is to make accurate predictions on future data instances. Now, before using a machine learning model to make predictions, we need to obviously evaluate the predictive performance of the model to see if it's actually working properly. And to estimate the quality of machine learning model predictions with data it has not seen, we can reserve, or what's called split, a portion of the data for which we already know the answer and define that as a proxy for future data and evaluate how well the machine learning model is actually predicting it. So with Amazon Machine Learning, we have three options for splitting the data. We can pre-split the data, which is you can split the data into two data input locations before uploading them to the S3 bucket and create two separate data sources. You can use what's called a sequential split, or which is basically telling Amazon Machine Learning to split your data sequentially when creating the training and evaluation data sources, or the random split, which is it will split it randomly. And it just for your purposes, by default, Amazon Machine Learning splits the data in a 70-30 format, meaning that 70% will be used for training and 30% will be used for evaluation. Now, a simple way to split your input data for training and eval is to select the non-overlapping subsets of your data while preserving the order of the records. Now, this approach is useful if you want to evaluate your models on data for a certain date or within a certain time range. So for example, say that you have a customer engagement data for the past 5 months and you want to use this historical data to predict customer engagement in the upcoming month. Now, using the beginning of the range for training and the data from the end of the range for evaluation purposes might produce a more accurate estimate of the model's quality than using records data drawn from an entire data range. So the two figures you guys see give an example of when you should use a sequential splitting strategy versus when you should use a random splitting strategy. And when you create a data source, you can choose to split your data source sequentially. And again, like I mentioned, Amazon will use the first 70% for training and the remaining 30% of your data for evaluation. So it's very important that we know what data we're working with, what predictions we want to make. That will help us define what the right way of either sequentially splitting it or randomly splitting it. So it's very important that we understand our data before we get to this point, and it'll help us split the data properly, because if we split it incorrectly, the machine learning model, regardless of how good the back end is, it will predict the wrong answers because the data that we have ingested into it and the way we're splitting it is incorrect. And finally, the data schema. So there's two different options we can use for the data schema, and I had mentioned this briefly before. You can either allow AWS to infer the data types of each attribute in the input data file and automatically create a schema for you, or you can provide a .schema file when you upload your data into the Amazon S3 bucket, and you have to make sure it's uploaded in the same bucket. So either or, and depending on how your business is operating, how advanced your machine learning capabilities are of your organization, will determine whether you provide your own schema file or whether you want AWS to infer automatically for you. For most of the small to even medium-sized organizations, it's probably best to let AWS infer the data types. If you are pretty heavy into data science and you have your data structured properly, you are able to provide your own schema file. And just for your information, a schema file is basically a skeleton structure that represents the logical view of the entire data. So it's basically telling the machine learning model what the data is and what it's structured as. And again, you can also either let AWS do it for you, which is an automated way of doing it, a simple way of doing it, or if you have a more advanced need for machine learning, then you can also upload your own .schema file, but please make sure that you upload it, or it has to be uploaded in the same S3 bucket that has your original data source. So I hope you guys got a good understanding of the data structures and how they're utilized by AWS machine learning, and the importance of making sure that we have our data structured properly in terms of the CSV file and following the certain requirements that are there that are put by AWS in terms of what the CSV file should be, where it should be located, and so on. Hi everybody, and welcome to this lesson on looking at the different training models that are offered by AWS. So the machine learning supports three different types of models. You have binary classification, multi-class classification, and regression. So models for binary classification problems predict a binary outcome, one of two possible classes. And to train these models, it uses the industry standard learning algorithm known as logistic regression. So for example, some examples are, is this email spam or not? Which again is a yes or no. Will the customer buy this product? Is the product a book or a farm animal? Is this review written by a customer or a robot? So again, an either or. In the multi-class, it allows you to generate predictions for multiple classes, which is predict one of more than two outcomes. And for this, AWS uses an algorithm known as the multi-anomial logistic regression. So for example, is this product a book, movie, or clothing? Is this movie a romantic, comedy, a documentary, a thriller, or horror? Which category of products is most interesting to this customer? And you would have a list of products. And then finally, the regression model. And that basically predicts a numeric value. And for this, AWS uses the algorithm linear regression. So for example, what will be the temperature in Dubai tomorrow, or how much will this sell for, and what's the price of this house, so on. So these are the three main model types that are used by Amazon machine learning. So to train the machine learning model, you need to specify a few things. First of all, you need to do an input training data source, name of the data attribute that contains the target to be predicted, the required data transformation instructions, and then finally training parameters to control the learning algorithm. And during the training process, the machine learning automatically selects the correct learning algorithm for you based on the type of target that you specified in the training data source. So it's a very automated and easy way of starting out and doing your machine learning. And typically, machine learning algorithms accept parameters that can be used to control certain properties of the training process and of the resulting model. Now, in AWS, these are called training parameters, and you can set these parameters using the console, the API, or even the command line interface. Now, if you don't set any parameters, don't worry, because the AWS will use default values that are known to work well for a large range of machine learning tasks. So you can specify values for the following training parameters that you guys see. You can specify parameters for the model size, the max number of passes, the shuffle type, the regularization type, and the amount. Now, all of these parameters are set by default, and the default settings are adequate for most machine learning problems, but again, depending on your specific business case, you are able to choose and define your own values and fine-tune them based on your data. Now, to discuss a few of these in a little bit more detail, I won't discuss all of them for you, but I'll discuss a few of them for you. So what do we mean by saying maximum model size? That's basically, in the units of bytes, the total size of your model. So by default, AWS creates a 100 meg model, and you can instruct it to create a smaller or larger model by specifying a different size. Now, if it, for example, cannot find enough patterns to fill the model size, it creates a small model for you automatically. So for example, if you specify a maximum model size of 100 megs, but it finds patterns that are only 50 megs, the resulting model will only be 50 megs. So it's not going to enlarge the data for you, it'll only reduce it. So choosing the right model basically allows you to control the trade-off between the predictive quality and the cost of use, because small models can cause the AWS to remove many patterns to fit within a maximum size limit, affecting the quality of predictions. But the smaller models also cost less. So again, there's a trade-off that you need to decide. The maximum number of passes, now for best results, it may need to make multiple passes over your data to discover the patterns, because most of the time, by just going over it through one pass, it will not be able to correctly predict and discover all patterns. So by default, it makes 10 passes, but you can change the default by setting the number up to a maximum of 100 passes. So for example, if you set the number of passes to 20, but AWS discovers that no new patterns can be found by the end of 15 passes, then it will stop. So even if you specify a maximum of 100, it will stop when it stops discovering new patterns. And then you can also shuffle your training data. And what that basically does, it mixes up the order of your data so that the algorithm doesn't encounter one type of data for too many observations in succession. So for example, if you're training a model to predict a product type, your training data includes, let's say, a movie, a toy, video game product types. And if you sorted the data by the product type column before uploading it, the algorithm sees the data alphabetically by the product type. And it sees all of your data for movies first, and your model begins to learn patterns for movies. Then when your model encounters the next option, which is toys in this example, every update that the algorithm makes would fit the model to the toy product type, even if those updates degrade the patterns that fit movies. So this sudden switch from movie to toy type can produce a model that doesn't really learn how to predict product types accurately. So shuffling basically shuffles all those up and allows the model to predict it more accurately by doing random shuffling. Now lastly, the regularization, both type and amount. Now most predictive performance of very large or complex models suffer when the data contains too many patterns. As the number of patterns increases, so does the likelihood that the model learns unintentional data artifacts rather than true patterns. So when that happens, the model does very well on the training data, but doesn't really fare well in the generalization of new data. And this is basically what a lot of people or what the industry refers to as overfitting the training data. So regularization helps prevent linear models from overfitting training data examples by penalizing extreme weight values. And I'm not going to get into too much of the details of the regularization because it does get a bit outside of the scope of this course, but just wanted to familiarize you guys with the different parameters that are used by AWS machine learning in times of training. Hi everybody, and welcome to this lesson on looking at feature transformation and the importance of it in the machine learning process. So let's just consider if a machine learning model whose task is to decide whether a credit card transaction is fraudulent or not. Now, based on your application background knowledge and data analysis, you might decide which data fields or features are important to include in the input data. So for example, you might include the transaction amount, the merchant name, the address, and the credit card owner's address are important to provide to the learning process. On the other hand, a randomly generated transaction ID carries no beneficial information. Now, once you've decided on which fields to include, you transform these features to help the learning process. Transformations add background experience to the input data, enabling the model to benefit from this experience. So for example, you guys see a merchant address as represented a string. So for example, the 1625 32nd Avenue, New York, New York, 45678. Let's see if that by itself, the address has limited expressive power. It is useful only for learning patterns associated with that exact address. Breaking it up into constituent parts does create additional features, such as address, specifically being 1625 32nd Avenue, city specifically being New York, state specifically being New York, and the zip code specifically being 45678. Now the learning algorithm can group more disparate transactions together and discover broader patterns. Perhaps some merchant zip codes experience more fraud activity than others. So it's very important that we learn and we transform our data properly. Now there are two ways to transform data features either before creating the machine learning models with Amazon Machine Learning. You can either transform your input data directly before showing it to AWS, or you can use the built-in data transformations of Amazon Machine Learning. Now, AWS Machine Learning recipes contain instructions for transforming your data as part of the process. Now, they're just defined using JSON-like syntax, but they have additional restrictions beyond the normal JSON restrictions. So there's three different sections that recipes have. First, we have groups, which enable grouping of multiple variables for ease of applying transformations. So for example, you can create a group of all variables having to do with free text parts of a web page, for example, the title or the body, and then perform a transformation on all of these parts at once. Then you have assignments, which enable the creation of intermediate named variables that can be reused in processing. And then finally outputs, which define which variables will be used in the learning process and what transformations, if any, apply to these variables. Now, when you create a new data source in Amazon Machine Learning and statistics are computed for that data resource, it will also create a suggested recipe that can be used to create a new model from that data source. Now, the suggested data source is based on the data and the target attribute present in the data and provide a useful starting point for creating and fine-tuning your models. Now, there are various different types of data transformations that are used by AWS. For example, there's the n-gram, which takes a text variable as input and provides strings corresponding to a sliding of a window of user configurable n words, generating outputs in the process. So for example, consider the text string, "I really enjoyed reading this book." Specifying the n-gram transformation with a window size of 1 simply gives you all individual words in that string. For example, each word will be by itself. "I really enjoyed reading this book." If you specify an n size or a window size of 2, it'll group 2 words together, and 3, and so on. And I won't discuss each one of these in detail. That gets a bit outside of the scope and a bit too involved in the details of the types of transformations. But just know that these are the main types of transformations that AWS uses if you're using the AWS service for doing the transformations, if you're not going to do them by yourself or on your own. Now, it also has a data rearrangement functionality, which enables you to create a data source that is based on only a portion of the input data that it points to. So for example, when you create a model using the wizard and choose the default evaluation option, it automatically reserves 30% for evaluation and uses 70% for training. Now, this functionality is enabled by the data rearrangement feature of Amazon Machine Learning. Now, you can use the Amazon Machine Learning API or command line interface if you want to change some of those parameters. And it does allow you to change certain parameters, such as, for example, the %begin to indicate where the data for the data source starts, or the %end to indicate where the data for the data source ends. The complement parameter tells AWS to use data that is not included in the range of %begin to %end. And the complement parameter is useful if you need to create complementary data sources for training and for evaluation. And then there's also the strategy, which splits the data for a data source from other than the 70-30 default that it does it. So if you want to use 50-50, 50 for training and 50 for evaluation, you can use a strategy string to go ahead and change those options. So I hope you guys got a good overview of the types of data transformations that are offered by AWS and how important it is that we make sure that our data is transformed properly and correctly in order to make sure that our machine learning model predicts the correct answers and learns properly and trains itself properly. Hi everybody, and welcome to this lesson on looking at evaluating the machine learning models developed by AWS. So you should always, as a good practice, you should always evaluate a model to determine if it will do a good job of predicting the target on a new and future data. Now, because future instances have unknown target values, you need to check the accuracy metric of the model on data for which you already know the target answer, and then use this assessment as a proxy for predictive accuracy on future data. Now, to properly evaluate a model, you hold out a sample of data that has been labeled with a target from the training data source. And evaluating the predictive accuracy with the same data that was used for training is not really useful because it just kind of rewards the model for remembering the training data rather than generalizing from it. Now, in Amazon Machine Learning, you can evaluate a model by using or by creating an evaluation. And to create an evaluation for a model, you need a model that you want to evaluate, and you need the labeled data that was not used for training. So let's go ahead and look at how we can evaluate the different types of models from the insights. Now, when you evaluate a model, it provides, or Amazon Machine Learning provides, an industry standard metric and a number of insights to review the predictive accuracy of the model. Now, the outcome of the evaluation contains a number of insights. For example, it contains a prediction accuracy metric to report on the overall success, visualizations to help explore the accuracy of your model beyond the prediction accuracy metric, the ability to review the impact of setting a score threshold, just keep in mind that's only for binary classification, and alerts on criteria to check the validity of the evaluation. Now, the choice of the metric and visualization depends on the type of model that you're evaluating. So it's important to review these visualizations to decide if your model is performing well enough to match your business requirements and your expectations. Now, the actual output of many binary classification algorithms is what's called a prediction score. Now, the score indicates the system's certainty that the given observation belongs to the positive class. Binary classification models output a score that ranges from 0 to 1. And as a consumer of this score, to make the decision about whether the observation should be classified as 1 or 0, you interpret the score by picking a classification threshold, or what's called a cutoff, and compare the score against it. Any observations with scores higher than the cutoff are predicted as target 1, and scores lower are predicted as 0. Now, the default cutoff is 0.5 for Amazon. So you can choose to update this cutoff to match your business needs. You can also use the visualizations in the console, which we'll look at in the demonstrations, to understand how the choice of a cutoff will affect your application. Now, it provides an industry standard accuracy metric for binary classification models called AUC, or R area under the curve. Now, that measures the ability of the model to predict a higher score for positive examples as compared to negative ones. Now, because it is independent of the score cutoff, you can get a sense of the prediction accuracy of your model from the AUC metric without picking a threshold. It usually returns a decimal value from 0 to 1. And values near 1 indicate a model that's highly accurate. Values near 0.5 indicate a model that's no better than guessing at random. And values at 0 are unusual to see and typically indicate a problem with the data. So essentially, an AUC near 0 says that the model has learned the correct patterns but is using them to make predictions that are opposite from reality. And just keep in mind the baseline for the AUC metric for binary model is 0.5. So it is the value for a hypothetical machine learning model that randomly predicts a 1 or 0 answer. Now, to explore the accuracy of the model, you can review, and we will review the graphs in evaluation through the console. And a model that has good predictive accuracy will predict higher scores to the actual ones and lower scores to the actual zeros. A perfect model will have two histograms at two different ends of the x-axis showing the actual positives all got high scores and actual negatives all got low scores. However, ML model makes mistakes, obviously, and a typical graph will show that the two histograms overlap at certain scores. An extremely poor performing model will be unable to distinguish between the positive and negative classes, and both classes will have mostly overlapping histograms. And then the examples you guys can see on your screen in terms of the good chart and the bad chart on the right hand. Now, for correct prediction, there's what's called a true positive, or a TP, which predicted the value as 1 and the true value is 1. Whereas a true negative, the model predicted the value as 0 and the true value is 0. And then you have erroneous predictions, which is a false positive or a false negative. And then you can also adjust the score cutoff. Now, by changing the score cutoff, you adjust the model's behavior when it makes a mistake. So just keep in mind, when you're moving the cutoff to the left, it'll capture more true positives, but the trade-off is an increase in the number of false positive errors. Moving it to the right captures less of the false positive errors, but again, there's a trade-off that it will miss some true positives. So for your predictive applications, you can make a decision, you have to make a decision which kind of error is more tolerable by selecting an appropriate cutoff score. And as I mentioned in the very beginning of this course, machine learning is an iterative process, so most likely you will have to test out a different cutoff points to see which ones will work better for your business case. Then we have the multi-class, and the actual output of this class is a set of prediction scores. So the scores indicate the model's certainty that a certain observation belongs to each of the classes, and unlike binary, you do not need to choose a score cutoff to make predictions. The predicted answer is the class, for example, the label, with the highest predicted score. So typical metrics used in multi-class are the same as the metrics used in binary classification case after averaging them over all classes. Now, in AWS, the macro average F1 score is used to evaluate the predictive accuracy of a multi-class metric. Now, the F1 score is basically a binary classification metric that considers both binary metrics precision and recall. It is the harmonic mean between precision and recall, and again, the range is from 0 to 1. Our larger value indicates better predictive accuracy, and you guys can see the mathematical calculation for the F1 score. Now, the macro average F1 is an unweighted average of the F1 score over all classes in the case. It does not take into account the frequency of occurrence of the classes in the data set. So a larger value indicates better predictive accuracy. Now, keep in mind that AWS does provide baseline metric for multi-class models. For example, if you're predicting a genre of movie and the most common genre in your training data set was romance, for example, the baseline model would always predict the genre as romance. You would compare your model against the baseline to validate if your ML model is better than the ML model that predicts this constant answer. And then this is where you can use the performance visualization, which you guys see on the right hand side. It basically provides a confusion matrix as a way to visualize the accuracy of the multi-class. And the confusion matrix illustrates in a table form the number or percentage of correct and incorrect predictions for each class by comparing an observation's predicted class and its true class. So for example, going back to the movies, if you're trying to classify a movie into a genre, the predictive model might predict that this genre is romance. However, its true genre might actually be a thriller. So when you evaluate the accuracy of a multi-class classification model, AWS identifies these misclassifications and displays the results in a confusion matrix, as you guys can see in that illustration. So it basically displays a number of features: the number of correct and incorrect predictions for each class, the class-wise F1 score, true class frequencies in the evaluation data, and the predicted class frequencies for the evaluation data. So it does provide a visual display, and it can accommodate up to 10 classes in the confusion matrix, listed in the order of most frequent to the least frequent class in the evaluation data. Now, the output of a regression model is a numeric value for the model's prediction. So for example, if you're predicting, let's say, housing prices, the prediction of the model could be a value such as 300,000 or 357,455 or and so on. So for regression tasks, AWS uses the industry standard root mean square error, or RMSE. So it's a distance measure between the predicted numeric target and the actual answer. So the smaller the RMSE, the better is the predictive accuracy of the model. And a model with the perfectly correct predictions would have a value of 0. Now again, like with most things, AWS does provide a baseline metric for regression models, and it's the RSME for a hypothetical regression model that would always predict the mean of the target as the answer. So for example, if you're predicting the age of a house buyer and the mean age for the observations in your training dataset was 35, the baseline model will always predict the answer as 35. And again, just like with the other ones, you can also use the performance visualization, which you guys see on the right hand side. It basically gives you a histogram of the residuals on the evaluation data when distributed in a bell shape and centered at 0, indicating that the model makes mistakes in a random manner and does not systematically over or under predict any particular range of target values. Then we have cross-validation, which is a technique for evaluating models by training several models on subsets of the available input data and evaluating them on the complementary subset of the data. So basically you would use cross-validation to detect overfitting, or also known as failing to generalize a pattern. So basically the diagram that you guys see shows an example of a training subsets and complementary evaluation subsets generated for each of the 4 models that are created and trained during a fourfold cross-validation. So the first model uses the first 25% of the data for evaluation and the remaining for training. The second one uses 25% for evaluation, and then so on. Now each model is trained and evaluated using complementary data sources, and the data in the evaluation data source includes and is limited to all of the data that is not the training data source. So basically by performing this validation, you would generate 4 different models, 4 data sources to train the models, 4 to evaluate them, and 4 evaluations for each model. And then finally, AWS does provide insights to help you validate whether you evaluated the model correctly. And if any of the validation criteria are not met by the evaluation, AWS will alert you by displaying and letting you know that the validation criteria has been violated. And it will do so according to these 5 metrics that you guys see. Either the evaluation model is done on held out data. For example, if you use the same data source for training and evaluation, if sufficient data was used for evaluation of the predictive model, for example, if the number of records in your evaluation data is less than 10% of the number of observations you have in your training, for example, or if the schema is matched or mismatched. All records from evaluation files were used for predictive model performance evaluation. And finally, the distribution of the target variable. So I hope you guys got a good overview in this lesson on how AWS evaluates the different models and how we can use the metrics provided by AWS to evaluate if the models that we have developed for our data and for our business case are working properly, or if we need to change them, and then see how and which options are available for us to use based on the binary or multi-class classifications to see how we can fine-tune the machine learning models to help us predict the correct answers. Hi everybody, and welcome to the first step in putting all of that knowledge to action. And the first step in actually implementing a machine learning in AWS is obviously preparing your model. So the data that I've used for the purpose of this tutorial, the data set that I've included as a downloads is basically from the UCI machine learning repository, and it's formatted to conform to the Amazon ML guidelines. Now there's two separate files that you're going to be downloading. There's the banking.csv and the banking-batch.csv. So the banking.csv it basically contains the historical data for customers who have purchased products similar to the bank term deposit. And the banking-batch.csv is a file that we're going to be using to predict whether potential customers will respond to the marketing offer. So in the banking.csv that you guys see on the screen, you'll see rows, and you do see rows and columns of data. The header row contains the attribute names for each column that you guys see. So for example, column A has age, the job, marital status, education, default, housing loan, and so on. Now, if you guys remember, an attribute basically is a unique named property that describes a particular characteristics of each customer. So for example, the NR employed row that you guys see in column T indicates the customer's employment status. And each row represents the collection of observations about a single customer. Now, we want our machine learning model to answer the question, will this customer subscribe to my new product? Now, in this data set, the answer to this question is attributed by Y, which is the last column, which contains either a 1 or a 0. 1 means yes, 0 means no. So the attribute that we want the machine learning model to learn how to predict is also known as the target attribute. So our target attribute is Y. And we've basically gotten historical data based on customers who have subscribed either yes or no, and given all of that information in this data set for the ML model to use and predict our answers. Now, obviously, if, for example, you've downloaded this raw data set, most of the times your data will not be provided by either a 0 or a 1. It'll probably say yes, no, yes, no. So we want to make sure that we format it in its binary classification and change all the yeses to 1s and all the nos to 0. Now, the banking.-batch.csv file, as you guys can see, does not contain a Y column or a Y attribute. Now, after we've created our machine learning model, we will use the model to predict the Y for each record in this file. So what we want to go ahead and do is upload both of these files to our Amazon S3 bucket. So I'm going to go ahead and quickly go into my S3. I'm going to create a new bucket specifically for this tutorial. I hope this name is available, and it sure is. I'm going to keep everything as standard and go ahead and create this bucket. After this bucket is created, I'm going to go ahead and upload those two CSV files that I have downloaded. There we go. So now I have my data prepared, my data is ready, and my data is updated or uploaded into the S3 buckets that I've specified to be used for this machine learning tutorial. Hi everybody, and welcome back. So in this tutorial, we're going to go ahead and create our first training data source. Previously, we had uploaded both of our CSV files, the one that's going to be used for training and the one that's going to be used for predicting, onto our newly created S3 buckets. So after we go ahead and do that, we want to create a data source, which is a object that contains the location of the input data and important metadata about our input data. And the Amazon Machine Learning uses the data source for operations like model training and evaluation. So before we create the data source, we have to make sure that we have the following things. We have a location of our Amazon S3 bucket, the schema, again, which includes the names of the attributes in the data and the type of each attribute. For example, if it's numeric, if it's text, if it's categorical or binary, and the name of the attribute that contains the answer that you want Amazon Machine Learning to learn to predict, which in our case is that Y, whether the customer is going to subscribe to our product or not. So let's go ahead and open up our Amazon Machine Learning Console. So we're going to go ahead and choose on Get Started. And we want to go ahead and, since we have nothing launched, if we had stuff launched, we can go directly into our dashboard. But since this is the first launch that we're doing, we're going to go ahead and click on Launch. Now here's where we can specify where our data is located, whether it's in the S3 bucket, or we can also use the Amazon Redshift. So if we have massive amounts of data, then we would want the Redshift. But since we have a small pieces of data, we can use our S3 bucket. And just for your purposes of your information, this is the same data that I have downloaded. So that you have downloaded and I have provided. It's provided by AWS. So you can also download it right directly from here. If you have not downloaded it previously from the course section in Udemy. So here's where we can specify the S3 location. So I'm going to type in the path of the bucket and the CSV file. And for the data source, I'm going to go ahead and type in, I'll just put a 1 just so I can differentiate the two sets of data that I provided, one for training and one for prediction. I'm going to go ahead and click on Verify. And here is going to ask me that Amazon Machine Learning needs permission or read permission to the S3 locations. We want to make sure we grant it read permission. And once it can access and read, you'll see a page similar to what you guys see here. You can review the properties of what the data is. It's a CSV format. The schema is auto-generated because I have not provided a .schema source for it. Number of files and the size. I'm going to go ahead and click on Continue. So here's where we establish our schema. And again, a schema is basically information that machine learning needs to interpret the input data for the model, including the attribute names, the data types, and any special attributes. And if you guys remember, there's two different ways of providing the schema. Either let AWS do it automatically for you like it has done here, or provide a .schema file. So the one option we're going to be using for this demonstration is allow AWS to infer the schema. And here's where you can see the inference that is made for us. So here we can review the data types that machine learning inferred for the attributes, and it's important the attributes are assigned the correct data type to help the machine learning ingest the data correctly and to enable the correct feature processing on the attribute. So attributes that have only two possible states, such as yes or no, should be marked as binary. Attributes that are numbers or strings that are used to denote a category should be categorical. Numeric ones should be numeric, and attributes that are strings that you would like to treat as words should be text. So you're more than welcome to go through each one of these attributes, but for the purposes of this demonstration, let me just tell you that the machine learning has inferred the correct attribute or the correct schema for all of these attributes. So next, what I'm going to go ahead and do is go to my last column, which if you guys remember is the Y column. And this is where we had specified either a 0 or 1 or a yes or a no to let the machine learning know whether this person had subscribed to the product or had not subscribed to the product. So this is what I want to specify as my target attribute. And if you guys remember, the target attribute is the one that we want the machine learning model to learn how to predict. So after I do that, I'm going to go ahead and click on Continue. So here it's going to ask if the data contains an identifier, and that's basically an optional row identifier. It helps understand how prediction rows correspond to observation rows from the input data. So if you choose to make an attribute the row identifier, the model will add that column to the prediction output. And row identifier is intended for reference purposes only. So it does not really include the row identifier when training the models. But for the purposes of this simple demonstration, we're going to just make sure and we click on No. And then click on Review. Here it gives us an option to go ahead and edit any of our options that we had done if you want to go ahead and change anything. But let's just say that we've done everything correctly, and I'm going to click on Continue. So now that we've created our training data source, we can use it to create the machine learning model, train the model, and then evaluate the results. Now to create the machine learning model, and because Amazon Machine Learning automatically uses the training data source that we just created, it'll take us directly to this model settings page. And here we can give the model a name, depending on how we want to classify it. And for the purpose of this demonstration, we've just specified a default evaluation settings. We can specify custom settings if we want to go ahead and utilize some of the advanced machine learning training features. Let's say if we want to change that 70-30 rule that AWS automatically offers in terms of using 70% of the data for training and 30% for prediction, we can change all those variables through the custom settings. But let's just stick to the default settings. We're going to go ahead and give this evaluation the same name. Again, we'll just classify it as 1. I'm going to go ahead and click on review. And here again, it gives us a chance to go ahead and change any of the options. And then we're going to go ahead and create the machine learning model. So now while your machine learning model is in queue while it's processing, it's going to give the status as pending while it goes and creates all of your model. Now this will change to in progress and then finally to completed once the model has been fully completed and trained on. So there you have it. This is the steps that are involved to create your data source and to create the machine learning model using the Amazon Machine Learning Service.
Welcome back. Let's talk about velocity of data challenges, right, that are associated with the velocity of data. So the various processing methods and how also to architect solutions using AWS services. So I'll be talking about 3 main areas. First, I'm going to talk about the data processing methods. I'm also going to be talking about batch processing, and then of course the stream data processing. So first, when business needs rapid insights from data they're collecting, right? But the systems in place cannot meet the need. There's a velocity problem. The problem of velocity, right, is really the speed at which data is being generated is ever accelerating in the first case. Now, emails, photos, Twitter, Facebook posts, log files, and IoT devices are all examples of data that is being generated rapidly and must be collected, processed, analyzed, and stored at high speeds. The collection and processing of data are combined into a single concept known as data processing. So, by definition, data processing means the collection and manipulation of data to produce meaningful insights or information. Data collection is divided into 2 parts, by the way. First is data collection, and then second is data processing. Now, I've already talked about the first part of the data analysis, which is volume, in the previous lecture, right? Here, I'm going to cover the second V, which is the velocity. Now, the velocity of data is the speed of which data is collected and processed. Now, we generate data more and more quickly these days, by the way, right? So think of how often you actually create and share things like email, photos, tweets, and Facebook posts. And then there are log files, right, from everything you do on your devices, right, and data from IoT devices like, trackers and smart doorbells and whatnot. Now, this data is being generated rapidly and must be collected, processed, analyzed, and stored. Now, if there's one thing I've learned over the years of working with data analysis, by the way, it is basically when businesses need rapid insights from data they're collecting, and the systems in place simply cannot meet the need, there is a velocity problem. No doubt. Data is being generated faster, by the way, all the time. Now, I've also talked about how much data is being consumed in the previous lecture. Let's talk about how fast, as consumers, we require the data to move. Now, we demand text messages to be sent instantly, right? But with email, we expect that it'll take a couple of minutes for the email to be received. Now, this is the challenge of velocity. Now, when we consider this challenge, right, we must recognize that between collecting and processing data, it is processing where most time will be spent. Now, I think it's time for the basic definition, right? Data processing is the process of collecting data and the process of manipulating data to produce meaningful information. Now, data processing methods, let's talk about how we do it. Now, it's vital to any data system, right? Data processing defines the methods that are used to collect data and present it to storage for analytic purposes. Let's talk about data processing in depth, right? So generally speaking, there are two types of processing. One is batch processing and the other is stream processing. Now these require different architectures and enable different levels of analysis. Now batch processing means processing, content in batches, right? So when you have a lot of data, for example, to process, and you need to process at certain intervals, for example, on a schedule or when you reach a certain volume of data. Now this kind of processing is performed on datasets like server logs, financial data, reports, and stream summaries. Third is the stream processing, which means processing data in a stream. In other words, processing data that is generated continuously in real time. Small data sets measured in kilobytes. Now you would use stream processing when you read real-time feedback or continuous insights. This kind of processing is performed on data sets like IoT-centered data, for example, e-commerce purchases, and game player activities, or where information from social networks. Now, many organizations use both types of processing, stream and batch, on the exact same data sets. Now, stream processing is used to get initial insights and real-time feedback, while batch processing is used to get deep insights from complex analytics. For example, credit card transactions is a good example, right? So have you ever received a text just moments after swiping your card? Well, we have. Now, this is a streaming data fraud prevention alert. This is a stream process that happens instantaneously. Now, another process going on regularly using the same data will be the credit card company processing, days, takes time, right? So same data, two completely different business being met, two different velocities. So data processing and the challenges associated with can often be defined by the velocity at which the data must be collected and processed. Now, batch processing comes into two forms, scheduled and periodic processing. Scheduled batch processing is a very large volume of data processed, right, on a regular schedule, hourly, weekly, or, daily. It is generally the same amount of data each time, so the workloads are predictable. On the other hand, the periodic batch processing happens at random times on demand. Now, these workloads often runs, a certain amount of data once the data has been collected. Now, this can make workloads unpredictable and hard to plan around. Now, it may seem that these processing methods would have a slow velocity, but just because they're scheduled for periodic does not mean that it can take hours to process. They may still require high velocity processing. For example, when an airplane lands at the airport, right, the data from the flight computers and the IoT sensors on the engines must be collected and processed. Now, the ground crew has just minutes to determine if the data proves and the plane is ready for another flight. Now, stream processing also comes in two forms, real-time and then not so real-time. Now, both types involve streaming data, which is, as you already know, processed quickly in small batches. Now, the difference comes into velocity. Real-time processing occurs within milliseconds, whereas near real-time occurs within minutes. Now, processing is always performed against the storage location. So, let's talk about how storage works in each type of data processing. Now, in batch processing, we often use a single application to collect, process, and then temporarily store data while it is processing. So the final step in batch processing is to load the data into an analytical data store. Now, Amazon EMR, or Managed Hadoop framework, right, uses tools like Apache Spark and Hive to perform complex data processing. Now, part of the processing includes performing analytics on the data itself. Now, in batch analytics, the entire data set is made available for these analytic queries. Now, this allows for highly complex analytics to be performed on the data. Now, batch processing is commonly implemented in cases, for example, where you need deep insights, advanced analysis is required. The latency in a batch processing system is minutes to hours, depending on the complexity of the analytics being performed. Now, in stream processing, we use multiple services, right? One service to ingest the constant stream of data, and one service to process and analyze the stream, and another service to load the data into an analytical data store if required. Now in AWS, we have a number of services for this purpose, including Amazon Kinesis Data Firehose and Amazon Kinesis Data Streams, which are used to ingest data streams and load the data streams into analytical data stores. Now, Amazon Kinesis Data Analytics, for example, is used to process and analyze the data streams. And Amazon Kinesis Data Analytics, by the way, allows you to query and rolling time window data, right? Say the last 2 minutes. Now, the analysis is limited to only those records collected within that window of time. Now, because of these limitations, analytics on streaming data are often simple aggregates. Now, the result of the analysis is made available within a dashboard or be stored in an analytical data store. The latency in this type of processing is seconds to milliseconds. So streaming fast, by the way, is a solution's ability to process data depends heavily on the requirements placed on it. So choosing the right solution is critical for successful implementation. Now, understanding your requirements for batch size and speed will help you select the proper service. Perfect for exam questions, right? Now, having said this, it might not be that easy in the real world, but it's fair to be skeptical when we make everything sound so simple. Now, it's not that simple, okay? We'll get to the hard concept later on, but here, let's look at 2 real-world scenarios and the type of processing I recommend for each. Now, imagine a retail chain is trying to analyze point-of-sale data from its franchise store, right? Now, the stores are located all over the world, and each location transmits batches of data to the central data center periodically throughout the day. Now, the customer prefers to hold the analysis of the data set until 1:15 a.m. Eastern Standard Time, for example, right? Now, at that time, all data sets must be rapidly processed so the reports can be generated and delivered to branch managers across the world as soon as possible. So, the collection of data followed by a rapid processing requirement is a common challenge. Now, the best solution for this environment would be a batch processing system. So imagine next, the advertising company that uses clickstream data from social media to identify product trends. Now, the sheer amount of data produced per second is huge. Collection must be fast enough to gather all data without missing anything. Now, once collected, this data must be processed just as fast as it continuous streams, right? So the company can decide which trends to jump on. Now, rapid collection of data followed by the rapid processing of data is another common challenge, of course. The best solution for this would be a stream processing system. So let's talk about characteristics of data processing velocity, right? So the system's ability to process data, of course, depends heavily on the requirements placed on it. Choosing the right system is critical, by the way, for successful implementation. So, let me give you some characteristics on both collecting and processing data. First, in terms of collecting data, okay, you have batch. Velocity is very predictable with batch processing. Now, it amounts to large bursts of data transferred at scheduled intervals. And periodic, on the other hand, velocity here is less predictable with periodic processing. So the loss of scheduled events can put a strain on systems and must be considered. Now, near real-time, velocity is a huge concern with near real-time processing. Now, these systems require data to be processed within minutes of the initial collection of the data. Now, this can put tremendous strain on the processing and analytic systems involved. Real-time. In this case, velocity is of paramount concern in real-time processing systems. Information, for example, cannot take minutes to process, right? It must be processed in seconds to be valid and maintain its usefulness. Now, in terms of processing data, you have batch and periodic, right? Once the data has been collected, processing can then be done in a controlled environment. Now, there's time to plan for the appropriate resources. In near real-time and real-time, here the collection of data leads to an immediate need for processing. Now, depending on the complexity of the processing, cleansing, scrubbing, data curation, and this can slow down the velocity of the solution significantly. So, you must plan accordingly. Another key characteristic of velocity on data is data acceleration, which means the rate at which large collection of data can be ingested, processed, and analyzed. Now, data acceleration is not constant. It comes in bursts. Take Twitter as an example, by the way. Hashtags can become hugely popular and appear hundreds of times in just seconds, or slow down to 1 tag an hour. Now that's data acceleration in action. So your system must be able to efficiently handle the peak of 100 tags per second and the lows of 1 tag an hour. So I hope this helps, right? We talked about data velocity, which is important. Let me know if you have any questions. With this, let's move to the next lesson. Welcome back. Let's talk about batch data processing. So you may think of batch processing as often thought of as a slow process, by the way. Well, this is not really the case. Now, batch processing must quickly and efficiently consume a huge amount of data all at once. Now, this poses challenges that do not exist with stream processing. Now, batch data processing provides companies with the ability to dive deep into the data that they have collected to produce complex analytics, right, that simply cannot be achieved with streaming analytics. Now, batch processing is a processing of a series of programs or jobs on one or more computers without manual intervention. Data is collected into batches asynchronously. Now, the batch is then sent to a processing system with specific conditions are met, such as specified time of day. The results of the processing job are then sent to a storage location that can be queried later as required. Now, let's dive deeper into batch processing and discuss the services that are available to perform it. So in the previous lecture, I talked about a definition of batch processing, right? Now, the more complex definition is that batch processing is the processing of a series of programs or jobs on one or more computers without manual intervention. Now, data is collected into batches asynchronously, like I mentioned earlier, right? Now, each batch is sent to a processing system when specific conditions are met, such as, for example, a specified time of day. Now, the results of the processing jobs are then sent to a storage location to be queried later. Now, what's great about batch processing system is that you can run them with less expensive capacity is available. Now, with modern architecture, you can optimize batch processing systems to the frequency and size of the batches you're processing. Now, this avoids the, compute resources, for example, or storage capacity often associated with traditional on-premise systems. Batch processing enables prioritization of jobs and aligning resources, based on your business objectives. So in traditional on-prem systems, a single large centralized system collects and processes data. So for small and medium data sets, this is totally reasonable, makes sense. But in today's world, batches could be millions or even billions of records. Now, this massive batch size makes it very difficult for these systems to meet the velocity requirements of most businesses. I mean, imagine trying to shove a ham sandwich in the garden hose, right? So that's what happens when the volume of data gets so large, as compared to the system's ability. So when the requirements and collection systems and processing systems are out of balance, the result is high latency, right? And potential data loss. Now, I've heard of imbalanced processing jobs taking upwards of 8 hours to complete, for example. Now, Amazon EMR has mitigated this problem by decoupling the collection systems from the processing system. Now, this is accomplished by implementing one of two common frameworks. First is Hadoop or Apache Spark. Now, both frameworks process high-velocity data, but they do it in different ways. Hadoop, running on Amazon EMR, configures a cluster of EC2 instances, for example, to serve as a single distributed storage and processing solution. Now, this provides speed, fault tolerance, and the ability to scale the instances in supporting collections separately from the instances supporting processing. Now, Hadoop complements existing data systems, right, by simultaneously ingesting and processing large volumes of data, structured or non-structured, from any number of sources. Now, this enables deeper analysis for any one system can provide. The analytical results can be then delivered to any existing data store for further use. On the other hand, the Apache Spark is a competing framework to Hadoop. Now, the difference is that Spark uses in-memory caching and optimized processing for faster performance. Analytics are performed by first filtering the data and then aggregating it. Now, Apache Spark avoids writing data to storage, preferring to keep the data in memory at all times. Now, both Hadoop and Spark support general batch processing, streaming analytics, machine learning, graph databases, and ad hoc queries. Now, I've talked about some of the inner workings of Amazon EMR, okay? And let's take a look at how the system works with other AWS services. So let's start with a really simple architecture here. So here, the solution is simple. We start with the data sources, for example. Remember, data sources can come from any source. Now, the data from these sources is first added to an Amazon S3 bucket, right? Now, this bucket becomes the repository for all the data that will eventually be processed. Next, let's use a processing service called AWS Lambda. Now, uses Lambda, you can create a program that runs every 4 hours to grab any new data from the Amazon S3 bucket and then send it to Amazon EMR for processing. Now, this program creates batches, right? Now, once the analytics and processing has been completed, the results are then sent to a service called Amazon Redshift. Now, Redshift is a fast, scalable data warehouse that makes it simple and cost-effective to analyze all of your data across your data warehouse and data lake. Now, Amazon EMR provides a significant amount of control, right, to configure your processing needs to your exact specs. But what if you're looking for a more managed solution that requires even less configuration on your part? Now, this is where AWS Glue comes in, right? Now, AWS Glue is a fully managed ETL service that categorizes, cleans, enriches, and then moves your data reliably between various data stores. Now, AWS Glue simplifies and automates difficult, time-consuming data discovery, right? Conversion, mapping, and job scheduling tasks. In other words, it simplifies data processing. So, we took a look at a simple example of an architecture of Amazon EMR, right? Now, what would it look like if we were to use AWS Glue instead? So basically, we implement the same data architecture as I talked about. Now, you're using AWS Glue in place of Amazon EMR. It really is that simple. So now, I'm going to talk about deeper into stream processes in the next lecture, right? But batch data processing with Amazon and Apache Hadoop, where organizations that need big data solutions are working with data at such a high volume and high velocity that traditional environment cannot meet their needs. So Amazon EMR is a managed service, right, that I've already talked about that works with Hadoop workloads. In addition to running Apache Hadoop framework, you can also run other popular distributed frameworks such as Apache Spark, HBase, Presto, or other solutions. So you have the added advantage of being able to interact with data and other AWS data stores such as Amazon S3 and Amazon DynamoDB. Now, Amazon EMR Notebooks, for example, provides a serverless development and collaboration environment from one-time query and exploratory analysis. You can manipulate the data and then generate, data plots using rich graphical tools. So EMR notebooks are pretty powerful. They monitor jobs, help you debug code. So let's take a look at Apache Hadoop and what that can do for you, right? So Hadoop is a scalable storage and batch data processing system. It uses commodity server hardware, right, and provides fault tolerance through software. So Hadoop complements existing data systems by simultaneously ingesting and processing large volumes of data, structured or not, from any number of sources, which basically enables deeper analysis than any one system can provide. Now, these results can be delivered to any existing enterprise system for further use and independent of Hadoop itself. So Hadoop is a platform that provides distinct modules, right? For example, Hadoop Common module, right? So Hadoop Common is a set of Java utilities and libraries that support the other Hadoop modules. Now these libraries help extract file systems and file processing components, right? And these Java files and scripts are required to start Hadoop. And Hadoop Distributed File System, HDFS, by the way, is very powerful. It has its own file system, right? So what HDFS is basically a file system that stores the data in a high output environment, community nodes. Now this architecture ensures very high aggregate bandwidth access to application data. Hadoop Yarn is the next. What Hadoop Yarn is basically, YARN, is a resource management framework which is responsible for scheduling and processing jobs. And next is Hadoop MapReduce. What MapReduce does in Hadoop, for example, is a YARN-based system that allows for parallel processing of large data sets on the cluster. So, batch processing architecture will now work in a very, very powerful manner, right? So, for example, it can be performed in different ways. You can use AWS services, for example. You can use Amazon S3, right, for storing data to begin with. You can use Lambda for intermediate file level ETL. You can use EMR for aggregate ETR heavy lifting, consolidated transformation, right, and loading engine. Or you can use Amazon Redshift as a data warehouse, hosting data needed for reporting. Now, batch processing use cases, let me give you some examples. First is log analytics, right? So Amazon EMR can be used to process logs generated by web and mobile applications. Now, the service helps customers turn key, structured or semi-structured into useful insights about their applications or users. Now, in such use cases, logs are usually collected in batches, right? And aggregated and analyzed at the end of the day for meaningful insights. Now, unified view of data across multiple data stores is also helpful, right? And you can use that AWS Glue data catalog to quickly discover and search across multiple AWS datasets without having to move data. Now, once data is cataloged, it is immediately available for search and query using Amazon Athena, Amazon EMR, or Amazon Redshift Spectrum. So in terms of predictive analytics, let's take a look at what that is, right? So Apache Spark on EMR, is scalable machine learning algorithms, or you can use your own libraries if you want to. Now, by storing data sets in memory, Spark can provide a great performance for common machine learning workloads. Whereas against an Amazon S3 data lake, for example, data lakes are an increasingly popular way to store and analyze both structured and unstructured data. So if you want to build your own custom Amazon S3 data lake, right, AWS Glue can make all of your data immediately available for analytics without having to move data. So I hope this helps. I've talked about batch data processing in depth, right? So let me know if you have any questions. With this, let's move to the next lesson.
Hi everybody, and welcome to this lesson on looking at how we can use the Amazon AWS infrastructure to do batch processing work. So now there are lots of different batch-oriented applications in place today that can leverage this type of infrastructure. For example, claims processing or large-scale transformation, media transcoding, and multi-part data processing work. Now, batch processing on AWS allows for the on-demand provisioning of a multi-part job processing architecture that can be used for instantaneous or delayed deployment of a heterogeneous and scalable grid of worker nodes that can quickly crunch through large amounts of batch processing tasks. And the best part about it is they can do that in parallel. Now, lots of batch processing architecture are often synonymous with highly variable usage patterns that have significant usage peaks. For example, in finance, you usually have month-end processing, which is followed by a significant period of underutilization. So the best part about AWS is it can help you overcome that variable. So let's look at how we can develop an architecture to overcome some of these issues. So here we have the basic architecture of how we can get a batch processing infrastructure set up in AWS. So the first obviously is that the users are going to interact with a job manager application, which is going to be deployed in an EC2 instance. Now this is the main component that's going to control the process of accepting, scheduling, starting, managing, and completing batch jobs. Additionally, it's also going to provide the final results after all the crunching is done. So after the user interacts with the first EC2 instance, what's going to happen is the raw job data is going to be uploaded into an S3 instance. So we have that big S3 bucket that's going to store all of the raw data for the job. Now what we're going to do is, instead of just making that entire large batch job flow through the infrastructure, which is going to cause bottlenecks, what we're going to do is break that up by using the simple queue service, or SQS. So individual job tasks are going to be inserted by the job manager in an SQS input queue on the user's behalf. Then what's going to happen is the worker nodes, or basically a host of EC2 instances, which are deployed in an auto-scaling group, and that auto-scaling is going to accommodate for the peak and off-peak instances. And additionally, you can utilize the spot instances if that batch work is going to be done during off-peak hours. Let's say if it's big data processing and it can be done during off-peak hours, you can utilize spot EC2 instances to save even more costs. So getting back, those EC2 instances are going to be in an auto-scaling group. And the group is basically a container that ensures health and scalability of the worker nodes. So worker nodes are going to pick up the job parts from the SQS queue automatically and perform single tasks that are part of the list of a batch processing steps. So after they've processed those tasks, the interim results from the worker nodes are stored back into the Amazon S3 bucket. Then in the sixth step, progress information and statistics are stored in an analytics store. And depending on what type of data you have, that can be either a Amazon SimpleDB or a DynamoDB domain, or a relational database. If you require the complex relationships, then you would use an RDS service. If it's a simple data, you can use the DynamoDB. And then lastly, you can also have a chaining process. So in the seventh step, you guys can see completed tasks can be inserted in an SQS queue for chaining to a second processing stage. So it all depends on what type of batch processing work you will be doing. It can additionally be changed on a second stage if required. So this infrastructure optimizes the flow of batch processing jobs by breaking up that huge batch job into smaller tasks, which are handled by SQS queues, and additionally the worker nodes in an auto-scaling group, which can accommodate for the usage peaks. So again, in summary, the services that are required to build a optimal batch processing architecture are the EC2 instances. Again, one would be the main one that the user will interact with, and then you have the worker nodes. Then you have the Amazon RDS or the DynamoDB, the simple database. You can have the Amazon S3 buckets. We're going to have the auto-scaling group for the worker nodes, and then finally the SQS queue to break up that large batch processing job into smaller tasks.
Welcome back. Let's talk about stream data processing. Okay, so this is one of the fastest growing areas of processing data. Now, the number of devices that are collecting information in real time is growing rapidly. Now, this drives the need for processing solutions that can match the velocity of data generation. So stream data processing, provides companies the ability to get insights within seconds of the data being collected. Now, companies can no longer afford to neglect or avoid vast amount of data that is streaming in from web applications, e-commerce purchases, and game player activities, for example, right? And information from social networks. So let's dive deeper into stream processing and the services that enable it. So stream processing is the collection and processing of a constant stream of data. Now, in batch processing solutions that I've talked in the previous lecture, the batch size and velocity is relatively stable, right? But with stream processing solution, the amount of data being transferred and the size of the data packets is not always consistent. So stream data processing provides businesses with the ability to gain immediate insight into the data that you've collected. Now, streaming data solutions excel at working with data with a value that diminishes over time, like sensor data from, let's say, your lawnmower. Now, the sensor may, send a ping every 60 seconds whether the lawnmower has stopped or not, right? So that way, the system can send the alarm if something is missing. Now, that's important when it's actually missing, but otherwise, the fact that the lawnmower, loses value immediately. Now, let me give you some benefits of streaming data. The first is all about control. Now, with streaming data solutions, right, the default is to decouple the collection system, called the producer, from the processing system, called the consumer. Now, the streaming solution provides a persistent buffer for your incoming data. Now, the data can be processed, and you can send the data at your own rate, depending on your needs. Second benefit, each of the stream producers can write the data to the same endpoint, allowing multiple streams of dispersed data can be combined into a single stream for processing. For example, in an IoT solution, 1 million devices can write their unique data into the same endpoint easily. Third benefit is the ability to preserve the ordering of data. Now, it can be vital to preserve the sequence of events within a stream. For example, the producer sends data in the order 1, 2, 3, 4, right? And the consumer receives the data in the same order, 1, 2, 3, or 4. And then lastly, the consumer itself, right? Now remember, this is the service that will process the incoming streams. Now, parallel consumption of data is one of the greatest benefits where velocity is concerned. So parallel consumption allows multiple consumers work simultaneously on the same data to build parallel applications on top of the data and then manage the on-time frames. So how do you process streaming data within AWS? Well, with Amazon Kinesis, right? Kinesis makes it easy to collect, process, and analyze real-time streaming data so you can get timely insights and then react quickly to new information. Amazon Kinesis offers key capabilities to cost-effectively process streaming data at any scale, along with the flexibility, by the way, to choose the tools that best suits your requirements, right, of your application. Now, I've talked about briefly Kinesis earlier, right? But let's take a look at Kinesis. It has primarily capabilities. You can work, these capabilities together or independently. Now, I've already talked about 3 of them: Amazon Kinesis Data Firehose, Amazon Kinesis Data Streams, and Amazon Kinesis Data Analytics. Now, the 4th capability of Kinesis is Amazon Kinesis Video Streams. Now, this service makes it easy to securely stream video from connected devices to AWS for analytics, machine learning, for example, and other processing. So, let's take a look at a basic architecture, right? So, within this particular architecture that I'm about to talk about, right? Here, the sensor data is being collected as a stream by Kinesis Data Firehose. Pretty straightforward. Now, this service is configured to send the data to Kinesis Data Analytics, which will process the data, and then Kinesis Data Analytics filters the data for relevant records and then sends into the next Kinesis Data Firehose process. Now, in parallel, a second process selects relevant records from the original Kinesis Firehose and then places that data into an Amazon S3 bucket. Now, all of the non-relevant records in this stream are simply discarded. Now that the relevant data is in S3, you can use Amazon Athena to query those records. Now, Amazon Athena is an interactive query service that makes it easy to analyze data in Amazon S3 using the standard structured query language, or SQL. Now, Athena is serverless, so there is no infrastructure to manage, and you pay only, of course, for your data scanned by the queries you run. You can then use the results of these queries to produce insightful dashboards, right, and reports for stakeholders using Amazon QuickSight. Now, Amazon QuickSight is a fast, cloud-powered business intelligence service that makes it easy for you to deliver insights to everyone in the organization. But let's go back a second, right? So in this architecture, we talked about the solution was dumping non-relevant records, right? Now, what if I want to dig into those non-relevant records, right, and see if there are patterns or other helpful information? Now, there could be really information that I'm looking for in the non-relevant information, right? So this is an exam question, right? So I'm going to talk about this later on also, right? And how you find value from non-relevant data. So another benefit of Kinesis, Firehose is constant streams sent to multiple consumers. Now, here is another sample architecture, right? So a data Kinesis Firehose stream, all records are then sent to Amazon S3 bucket. Notice that there is no filtering stack within this architecture, right? Now, let's spice things up a little bit, right? Now, let's say your company also uses device settings that are being stored in a different Amazon S3 bucket. Now, use AWS Glue, for example, to create combined results, from data being collected from the Kinesis data Firehose stream and this device data. Now, you can query these results, that works with Amazon Athena, and then visualize them with Amazon QuickSight, just as we talked about in the previous architecture. Now, let me take it one step further, right? Now here, both data paths in a single architecture that you can see. Now, batch data process is really on the top. The stream data process is on the bottom, all from the same originating source. Keep in mind, there are two different S3 buckets, right? And storage layer. Now, keeping the results from the two processes in separate buckets will allow for better analysis from both Amazon Athena and Amazon QuickSight. So processing big data streams, how do we work with those? Okay, let's take a look at the many reasons, by the way, right, for streaming data solutions. Now, in a batch processing system, processing is always asynchronous, right? And the collection system and processing system are often grouped together. Now, with streaming solutions, the collection system, producer, and the processing system, which is the consumer, are always separate. Now, streaming data uses are called data producers, for example, right? Each of these producers can write the data to the same endpoint. And I've mentioned this earlier, right? So that multiple data points can be combined into a single data stream. Another huge advantage is basically the client ordering of data and the ability to perform parallel consumption of data. Now, this allows multiple users to work simultaneously on the same data. So stream data processing with Amazon Kinesis, right? For example, in here, we use multiple services. One service to ingest the constant stream of data, one to process and analyze the stream, and then one to load the data into an analytic data store if required. Now, Amazon Kinesis meets each of these needs, and you can use the Kinesis service independent of the other, right, to create an optimal streaming solution. So, Kinesis Firehose, for example, okay? Now, what this does, which is the easiest way to capture, transport and load data streams into AWS data stores for near real-time analytics with existing BI tools. Now, Kinesis data streams are also very powerful. The way you use them, it enables you to build custom real-time applications that processes data streams using popular streams processing frameworks. So Amazon Kinesis video streams, right? It's also very powerful. How it works is that basically makes it easy to securely end stream videos from connected devices to AWS for analytics, machine learning, ML, for example, or other processing. Now, Amazon Kinesis Data Analytics, on the other hand, the way it works, basically, it also the easiest way to process data streams in real time with SQL or Java without having to learn new programming languages or processing frameworks. So, for example, the streaming data is being collected from a sensor device, right? For example, on your car, okay? Now, this service is configured to send the data to be processed using Amazon Kinesis Data Analytics. Now, this service filters data for irrelevant records and then sends the data into another Kinesis Firehose process, which then places the results into an Amazon S3 bucket at the serving layer. Now, using Amazon Athena, data in the Amazon S3 bucket can be queried now for insightful dashboards or reporting for stakeholders. Now, combined processing architecture is where you can take both of these architectures, and it's important to remember that streaming analytics is limited, right? Now, due to the size of each data packet and the speed that each data is moving, you're limited to simple data limits. Now, due to this limitation, like the aggregate limits, right, it's common for businesses to incorporate batch analytics to produce deeper insights before producing dashboards and reports on the data itself. Streaming data here is collected within a Kinesis Firehose stream, right? And once that is collected, this time, however, data is placed directly into the S3 bucket. So you don't have to go from one service to the other. Rather, everything goes directly into the S3. And AWS Glue is basically used, right, to transform into a single result set, which is loaded into a third Amazon S3 bucket at the serving layer. Now, using Amazon Athena, data in the third Amazon layer S3 bucket, for example, can now be queried easily. And Amazon QuickSight, you can use that to produce dashboard, right, from both Amazon Athena and the first Amazon S3 bucket, right, where the raw streaming data was originally loaded. Now, this allows the business to perform comparative analysis, right, on two different buckets on the data. So finally, talk about the stream processing use cases, right? You can build video analytics application. You can use Amazon Kinesis, for example, to securely stream video from camera-equipped devices and homes, offices, factories, and public places to AWS. You can then use these video streams, for example, for video playback, security monitoring, face detection, machine learning, and other analytics. Now, integrating this data into your applications allows for a wide variety of customer enhancements and data mining capabilities. Evolve from batch to real-time analytics, right? For example, with Amazon Kinesis, you can perform real-time analytics on data that is being traditionally analyzed using batch processing in data warehousing or using Hadoop frameworks. The most common use case includes data lakes, right? Data science, and machine learning. You can then use Kinesis Data Firehose to continuously load streaming data into your Amazon S3 data lakes. You can then also update machine learning models more frequently as new data becomes available, right? Ensuring data accuracy and data reliability and the outputs. Analyzing IoT device data, for example. Let's say you have sold your solution to various police cars, right? They use all these blinkers and they have IoT sensors and they constantly stream data, right? And we can use that data to send real-time alerts or take other actions programmatically, right? Where sensor exceeds certain operating threshold. And we can use the sample IoT analytics code, by the way, and AWS has those, right? So you don't need to start from scratch. They're templates that you can actually use. So, in summary, talked about the possibility of each method and understand how data collection and then how data dictates the velocity itself. I hope this helps. Let me know if you have any questions. With this, let's move to the next lesson.
Hi, everybody, and welcome to this lesson on the basics of EC2 infrastructure. So in this lesson, we're going to take a look at some of the basics of EC2s, what they are, how they operate, how the infrastructure is, and so on. So an EC2 or an elastic cloud compute provides basic scalability computing capacity in AWS. So in other words, they are basically virtual machines or virtual servers that are offered by AWS. They're referred to as elastic cloud compute, hence the name EC2. Now, EC2s provide a host of features. They are very powerful. They're very robust. Again, first and foremost, they're virtual computing environments or instances. So, in other words, virtual machines. There's lots of different things we can do with EC2 instances. We can configure them in a number of ways, which we'll take a look at throughout the rest of this course. So the first and basic concept of EC2 infrastructure is something called Amazon Machine Images or AMIs. Now, AMIs are basically a template that contains a software configuration. So for example, an OS and a number of applications. So for an AMI, you basically launch an instance or launch a EC2, which is a copy of a Amazon machine image running a virtual server in the cloud. So you can have you can launch multiple instances of an AMI, for example, like the image that you guys see on the screen now. So your instances keep running until you stop them or terminate them, or they fail for one reason or another. And if, for example, they fail or you stop and you can launch a brand new one from a new AMI. So AMIs are essentially just machine images that are hosted on AWS, through which we can launch our EC2 instances. Now you can have pre-configured AMIs or you can have customized AMIs, and we'll take a look at AMIs also in a lot more detail a little bit later on in the course. Now, an instance is basically a virtual server in the cloud. Its configuration at launch, again, is a copy of an AMI. Now, you can launch different types of instances from a single ANI. An instance type essentially determines the hardware of the computer that you're trying to launch. And there are a number of instance types that we can launch in terms of the hardware configuration. Another concept of the basic infrastructure when you're launching EC2 instances are availability zones and regions. Now, EC2s are hosted in multiple locations worldwide. Now, these locations basically are composed of regions and availability zones. And if you're not familiar with a region or an availability zone, a region is basically a geographic area. And within a region, you have availability zones, or essentially data centers. And each region has at least a minimum of 2 availability zones or physical data centers for high availability and redundancy. And AWS, operates very robust and state-of-the-art data centers with some of the latest hardware and software that's out there today. Now, each region is completely independent. Each availability zone is isolated, but availability zones in a region are connected through low latency links, as you guys see in the diagram. Now, EC2 resources are either global or tied to a region or tied to an availability zone. Now, when you view the resources in your AWS environment, you'll only see the resources that are tied to the region that you specify. Now, that's because regions, like I mentioned previously, are isolated from each other. And when you launch an instance, you must select an AMI that's in the same region. Now, if an AMI is in another region, you can copy the AMI to the region that you're using. So those are a couple of things that you need to keep in mind with the regions and availability zones. With availability zones, when you're launching a EC2 instance, first and foremost, you're selecting a region. Now, with availability zones, you can also select which AZ you want to launch your EC2 instance into. Now, if you distribute your instances across multiple availability zones and let's say one fails, you can design your application so that an instance in another availability zone can handle the request, hence the redundancy and the high availability. There are also a host of other things that we can do with availability zones, such as using elastic IP addresses to mask the failure, so the users or the application does not know that a host computer has failed, and so on. Now, an availability zone is usually represented by a region code followed by an identifier, like the example you guys see, US-East-1A. Now, to ensure that resources are distributed across availability zones for region, AWS independently maps availability zones to the names for each AWS account. So for example, for US East 1A, you might not be in the same location as US East 1A for another AWS account. And you can pick and choose which region you want to operate in or you want to launch your EC2 instance into along with the availability zone. Now, when you're launching EC2 instances, you can either let AWS select a default availability zone or you can select your own customized one. It's always recommended to let AWS choose the availability zone within the region just because they pick the one that will be the most efficient for your organization, based on what kind of load they have in each availability zone, because that information obviously is not available to us. So that's why it's recommended you let them choose which availability zone the EC2 instance should be launched into, but you do have the option to select which availability zone. Now, obviously, launching an instance requires storage, right? So when you launch an instance, the root device volume basically contains the image or AMI that you use to boot the instance. Now, all AMIs are basically backed by what's called an EC2 instance store, which means that the root device for an instance launched from an AMI is an instance store volume created from a template, which is usually stored on Amazon S3. Now, recently, not so recently, maybe about a year to a couple of years ago, AWS introduced EBS, which is Elastic Block Storage. So that means, so now what basically happens is the root device for an instance launched for an AMI is usually backed by an EBS volume or an EBS snapshot. Now, you do have an option to choose between AMIs that are backed by instance stores and AMIs that are backed by EBS volumes. And we'll take a look at what the difference is between instance stores and EBS volumes in the storage section. But you do have an option to pick which one you want to choose, but it's recommended that you use EBS just because it's a lot more robust than an instance store in terms of its operability. Now, for instances that use instance stores for the root device, automatically have one or more instance volumes available, with one volume which is going to serve as a root device volume. Now, when you launch an instance, the image that's used to boot the device or boot the instance is copied to the root volume. Any data on the instance store volume persists as long as the instance is running, but the data is deleted when the instance is terminated. So keep that in mind. That's why it's recommended to use EBS, because with EBS, the data is not deleted when the instance is stopped or terminated. But with the instance store, the data is basically deleted if the instance is terminated or if the instance fails. So if you have mission critical data hosted on the instance and you're using an instance store backed storage volume, and for some reason, if you accidentally terminate it, or even if, for example, hardware fails, all of your data is going to be lost. Now, EBS, on the other hand, if you use for the EBS as a root device, EBS snapshot referenced by the AMIs are used, and you can optionally use other EBS volumes depending on, again, the instance types. Now, for EBS-backed instances, they can be stopped and later restarted without affecting the data that's stored in the attached volumes. And there are various instance and volume-related tasks you can do with EBS-backed instances. So, for example, you can modify the properties of an instance, change its size, update the kernel. You can attach your root volume to a different running instance for debugging, or any other purpose. So that's why it's recommended to use EBS-backed EC2 instances, is because they are a lot more robust and the configurability is considerably more for EBS-backed EC2 instances. Now here you guys see the basic process that an EC2 instance takes, for example, when a volume is created. So when you create a volume, it goes into the pending state, and from the pending, it can go either to the available. Now if you're creating it, it's going to go to the available state. After it's available, you can attach the volume to your EC2 instance. Now these are for, again, this process flow is for EBS-backed volumes. Now, multiple things we can do. Once it's in the available stage, we can delete the volume. If you delete the volume, it goes back in the pending state, and from the pending, it goes into the deleted state. You can optionally attach a volume, or you can detach a volume. So let's say that I've attached a volume to an EC2 instance, but I've just started up a new EC2 instance. I can detach a volume and attach it to a new EC2 instance. So again, like I said, the process flow for EBS volumes is considerably more robust than it is for instance store volumes. Now here's a quick comparison in terms of if you are using a Windows server as compared to if you're using a EC2 Windows instance. This gives you a good chart in terms of what the differences are for your traditional on-prem hardware as compared to using virtualized hardware, which is provided by AWS. Now, if you're using an on-prem physical server, again, your resources and capacity are physically limited to the capacity of the server, whereas for EC2 instances, they're scalable. So let's say that you launched initially an instance, that might have, 8 gigs of memory. If you are in a physical environment, if you have it on-prem, upgrading that is a considerably long task. Whereas for an EC2 instance, with a couple of clicks of a button, you can essentially upgrade the hardware of your server in an instance. So that's the main benefit provided by migrating to the cloud or by EC2 instances, is the scalability. And obviously, you're only paying for the infrastructure that you're using. So as soon as you terminate the instance, your charges are stopped. You stop paying for it. Whereas obviously, if you bought a server, you have it until the end of life, or you get rid of it, or you resell it, and so on. So it's a good chart to help you differentiate between a traditional Windows PC, Windows server that's sitting on your premises, as compared to using a EC2 instance, which is on the cloud. Here's also a comparison of the boot process of if you have a on-prem server as compared to an EC2 instance. So on the top left-hand side, you guys see, a traditional process of booting up a server. It's in the off mode. You power it on, it goes into cold booting, and then in the running state. And then there, you have a soft reboot, you have a hibernate, or you have a sleeping mode. So that's the essential process that a server follows in terms of the different power states. Now compare that with the power states of an EC2 instance. Again, this process is specifically for EBS-backed instances. So when you're launching from an AMI or from an image, it goes from the pending to the running. Running, you can reboot, you can shut down, you can terminate. That's specific to the actual server. Now, the best part about EC2 instances, and especially EBS-backed instances, is that the hard drive essentially stays separate from the physical server. So you can take the hard drive, detach it, and attach it to another physical instance. So let's say that you launched an AMI on a Windows server. You notice that your application is using more resources than you had initially thought. Let's say that you thought it would only use 8 gigs of memory, but it requires 16 or 32. What you can do is detach the volume that has the application, launch a new instance with 32 gigs of RAM or with 64 gigs of RAM, and attach that volume back into that instance. And hence you've essentially upgraded your hardware without affecting your application, your configuration, your software. Now, doing that on a on-prem server, again, it would be probably a few days task in terms of taking it offline, adding the physical memory, booting it up, configuring it, and so on. Whereas for AWS or EC2 instances, essentially in a couple of minutes, you can upgrade your hardware without having any adverse effects on the users or on the application. So this is the basic infrastructure or basic setup of EC2 instances. And essentially a lot of people get confused when they hear the name EC2 or Elastic Cloud Compute. But in layman's terms, essentially they are virtual servers or virtual instances which are provided by AWS. Very robust, very scalable, very configurable, as we will see when we go throughout this course. Hi, everybody. So in this lesson, what we're going to take a look at is the life cycle of an EC2 instance. Now, by working with EC2s to manage your instances, from the moment you launch them through the termination, you're basically ensuring that you have the best possible experience with your applications or sites that you're hosting on your instances. Now, the illustration that you guys see basically represents the transition between the instant states. Now, one thing to notice is that you cannot stop and start an instance-backed instance store. And the reason behind that is recently AWS has introduced EBS-backed instances, which is Elastic Block Storage. Now that's a lot more robust as compared to your instance store, which is usually utilized in the EC2 classics. So that's one thing to keep in mind. Another thing to keep in mind is that EC2 instances, essentially you can detach and reattach the EBS volumes into EC2 instances. So let's take a look at each one of these states in a little bit more detail. So here we have the different states of the EC2 instances. Now, when you launch an instance, it enters what's called a pending state. Now, the instance type that you specified at launch basically determines the hardware of the computer, right? So you use the AMI you specified at the launch, which is, again, the Amazon Machine Image, which is the software or OS that you are launching. Now, after the instance is ready, it enters the running state. So you can connect to your running instance and use it any way you want, configure it, and basically start working with it. Now, as soon as the instance transitions to the running state, you're basically billed for each second with a 1 minute minimum. So as long as you keep your instance running, you are going to be charged. Now, for the free tier account, there is a certain instance type, which we'll take a look at in our labs, the T2 Micro, which is free for up to 750 hours a month. So that's a considerable amount of time for you to use the instance for your testing purposes on AWS. But for your production services, when you're in the organization, just keep in mind that as soon as it's in the running state, you are going to be charged for each second with a 1 minute minimum for EC2 instances. Now, if your instance fails a status check or is not running your applications as expected, or if the root volume of your instance is an EBS volume, you can stop and start the instance to start to fix the problem. Kind of like what you would do when you restart your server. So when you stop your instance, it goes into the stopping state and then the stopped state. Now, AWS does not charge usage or data transfer fees for your instance after you stop it, but they do charge the storage for the EBS volumes that have been connected, because when you stop the instance, the EBS volume still stays. So while the instance is in the stop state, you can modify the certain attributes of the instance, such as changing the instance type, which means increasing the memory, changing the processor, and so on. So when you restart your instance, it enters the pending state, and then in most cases, they move the instance to a new host. So let's say that when you shut down, you change the instance type, and when you start it up again, most of the time it's going to be restarted up in a new host machine. Obviously, you're not going to know the difference, but that's just for your informative purposes, or for your FYI, that most likely it will be started in a new physical host. Then obviously you have the instance terminated, which is the instance is permanently deleted and cannot be restarted, which again, you're not built. But just keep in mind that your EBS volumes will persist. If, for example, you detach the volume, it will persist when you terminate the instance. If you do not detach the EBS volume when you terminate the instance, obviously your EBS volume is also going to be deleted. Now, here's a table that summarizes some of the key differences between rebooting, between start and stop, hibernate, and terminate, in terms of what happens to your host computer, to your IP addresses, to your instance store volumes, to your root device volume, which is the EBS, and then the billing. So when you're rebooting, the host computer stays on the same physical host. The IP addresses stay the same. The elastic IPs remains associated. The IP6 address stays the same. Even in the instance store, your data is preserved. And then the billing, the instance billing hour does not change. Now, obviously, as you go on down in terms of the stop and start, in terms of hibernate and terminate, things kind of change. One thing to keep in mind is, again, for the instance store volumes, the data is erased when you stop and start, when you hibernate, and when you terminate. And then for the root device volume, the volume is deleted by default when you terminate the instance. Again, like I mentioned, unless you detach the volume before terminating the instance. So this is a good information to keep in mind and kind of have memorized of how things change in terms of the different states when you reboot, when you stop and start, hibernate, and terminate, because obviously this is considerably different as compared to if you're coming from a traditional on-prem server. So it takes a bit of understanding and a bit of practice to get used to what happens in these different states to your data, to your physical machine, and so on. Because if you have not worked in the cloud, or if you're not worked in the EC2 instances, if you've always worked with on-prem servers, it does get a bit of practice or to get used to how these things operate. Hi everybody, and welcome to this lesson in which we're going to be talking about the different instance types that are available within AWS. So EC2 provides a pretty good selection of instance types which are optimized to fit various different kinds of use cases. So instance types basically, what I mean when I say instance type, they're basically the hardware of the EC2 instance, such as the CPU, the memory, the storage, the networking capacity, and so on. And each instance type includes one or more instance sizes, so it basically allows you to scale your resources to the requirements of your target workload. Now, there are various different types of instances that you can provision within AWS. So there's the general one, which is obviously referred to as general purpose. Now, those instances basically provide a balance of compute, memory, and networking resources, and can be used for a wide variety of diverse workloads. And these instances are ideal for apps that use resources in equal proportions. A very good example of this would be web servers or code repositories. And even within the general purpose, there are various different types of EC2 instances. So I'll after these slides, I'll log into the AWS console and show you the different various types that we are able to configure and provision within AWS. Some of the benefits of general purpose and the hardware that AWS provides. They use the Nitro system. It's basically a combination of dedicated hardware and a lightweight hypervisor. So the Nitro system is basically the underlying platform of the next-gen EC2 instances. It allows them to be quite faster, along with reducing your costs. So what they've basically done is they've kind of tried to reimagine the virtualization infrastructure. So traditionally hypervisors protect the physical hardware and BIOS. They virtualize the CPU, storage, and so on. Now with the new Nitro system, they're able to break apart those functions, offload them to dedicated hardware and software, along with reducing your costs. So the Nitro systems are about 3 times as faster than the old systems that are provided by AWS or generally in the market. Then you also have the compute optimized. Now these are ideal for compute-bound apps that benefit from high-performance processors. So, the instances that belong to this category or this family are suited for, let's say, batch processing workloads, media transcoding, high-performance web servers, or HPC, which is high-performance computing, scientific modeling, gaming, and so on. So, if you want that extra juice, then you would want the compute-optimized instances. You have the GP, which is general purpose burstable. These are the T3 instances, which are ideal for microservices, low latency, small and medium databases. You have the storage optimized if you have a NoSQL or in-memory databases, or if you're trying to use Elasticache, this would be a good one. You have the scale out and ARM, which is basically ideal for web servers, containerized microservices, caching fleets. Then you have the machine learning. Obviously, which is for if you're trying to build machine learning models, build them, test them, do some kind of AI at the basic level, then the machine learning computing instances would be good for you. You have the high single thread and you have the high memory, which is the next one. So the high single thread, ideal for if you're doing some design, AutoCAD work, if you're doing some gaming, if you're doing some relational databases, such as a Microsoft SQL Server, which would require some high performance. Or if you have the high memory, let's say if you're doing Elasticache, you're doing some in-memory transcoding, in-memory databases, this would be best for you. So lots of different options. What I'm going to do is let me go quickly let me go into the AWS website. So here we can see all of the different instance types that AWS offers. As you guys can see, there's quite a lot of them. So there's the general purpose, and even within the general purpose, we have the A1s, we have the T3s, we have the T2, the M5, and this table basically shows you, the different configurations within even the T3, the A1s in terms of the CPUs, the memory, the storage, and the network performance. Here it gives you a little snapshot of what the general purpose is used for. Same goes for compute optimized, and even again within the compute optimized, there's multiple ones. There's the memory optimized. If you're trying to use some intensive memory applications, large workloads, large data sets. Accelerated computing, if you're trying to mine Bitcoin, accelerated computing, which takes into account some GPUs, graphic processor units if you want. Storage optimized if you're trying to do file servers or large storage databases. And here it basically gives you the different instance features. So quite a lot of the instance features, they feature burstable performance instances. It allows them to temporarily boost their performance over and above their current infrastructure. So this web page, again, you guys can see the URL up here. It's EC2 instance types. Now, this is not something that obviously you would want to have memorized unless you're going for the solutions architect professional exam. Then you would need to know the specific EC2 instances and what they're capable of. But I always use this as a reference. I always keep this bookmarked, and whenever I'm launching EC2 instances or I am researching an architect or designing an architecture for an organization, I always come here and refer to which instance would be best suited based on what the organization is trying to do and what is there available currently. So it's a very, very good, useful reference site to keep in mind. And eventually, the more you start working with it, the more you'll have these instances memorized in terms of which one is memory optimized, which one is compute optimized, and so on. Hi everybody, and welcome to this lesson on launching our first instance. So as you guys can see, I've already navigated into my EC2 dashboard. So this is the main dashboard for EC2 instances. A couple of places I can go to launch my new instance. So I can launch it directly from the dashboard right here. Or if I were to go into instances, I can also launch an instance from here. So if I click on a drop-down arrow, I can launch my first instance. Now, when I go, the first screen that we see is the AMI. So we'll discuss what Amazon Machine Images are. So basically, it just allows us to pick what OS we want are installed on our machine that we're launching. So multiple options we have from the Linux machines to Red Hat to Microsoft. Some come with pre-built software. So we have a deep learning AMI for Ubuntu that comes with that comes pre-installed with various software packages that allow you to do deep learning without much additional configuration and so on, or a Windows server that's built with SQL Server already 16 or 17. So it just depends. It saves us some time because these are pre-installed images that we can use from AWS. Now if you click on the free tier box, it basically filters them to only images that are available in the free tier account, because the other images are cost-based, so they're chargeable when you use the other images, just because some of the software is not free. So if I were to select this box, it narrows down the list to only images that we can use in the free tier account. So let's say if I want to go ahead and launch a Windows 2019 based server. So if I were to select this option, now here's where I can select the instance type. As you guys can see, it's a laundry list of various different instance types that I can choose from depending on what this server is going to be used for. And this table just gives us information in terms of the CPUs, the memory, whether it's EBS backed or instance, whether it's EBS optimized available or not, the network performance, whether it has IP6 support or not. And once the instance is selected, here it gives us a bit more information in terms of the speed of the CPUs, what type of CPU it is, the memory, and so on. So two options that are available for us within the free tier, either the T1 micro or the T2 micro. By standard, most of the time I always work with a T2 micro. It's a bit more powerful than the T1 micro, but it just depends on your usage. But if I were to select, let's say another one, let's say if I select a T2 2XL, here it changes. So this one has 8 virtual CPUs, each with 2.3 gigahertz, 32 gigs of memory. It lets me know what kind of CPU it is, and so on. So multiple options we have, and again, this would depend on what type of server this is and what type of applications you're going to be running on the server if you're working in a production environment. So we're going to stick to the T2 micro. In the configuration details here, we can select various different information in terms of our instance. So we can launch more than one instance at one point in time. We can launch it directly into an auto scaling group. So let's say if I want to launch 5 instances because they're going to be part of an auto scaling group, I can do that right here. Here's where I can select spot instances, and it gives me basically the current price, which is available in the availability zones in Northern Virginia if I want to do spot instances. And here's where I can do my bidding. I can do valid from and to if I want this bid to be valid for a certain point in time, or if I want this persistent request. Let's say if I'm going to be doing batch processing overnight, I want to make sure that I have spot instances every single night, or whenever they come into my budget, I can do a persistent request. So this request stays persistent, or I can have this request valid from a certain point in time. The network, it launches by default into your default VPC, but if you had multiple VPCs, you would be able to select which VPC you want to launch it into. Same goes with subnet, and whether you want to auto assign it a public IP. By default, it is enabled. So by default, every instance has a public IPv4 assigned to it. You could disable it by default, because let's say if you want this to be your internal server and it's going to stay within your VPC, then that would be a reason to disable this option. Whether you want to add it into a placement group, again, that's a logical grouping of your servers. Whether you want to create a capacity reservation, domain join directory. So let's say if you have an Active Directory working and you want to do an AWS single sign-on, you could do it. You could have it join a domain right away, whether you want any IAM roles attached to this EC2 instance. And we'll discuss these options a little bit later on in more detail in terms of what they mean and why you would want a IAM role attached. But this is where you would go and attach an IAM role to an instance. Shutdown behavior. This basically just lets you know what state you want this server to go into when you go to shutdown, whether you want to stop it or whether you want to terminate it. Termination protection basically protects against, like the name says, against accidental termination. So if I have this checkbox selected, there's an extra step that I need to take before I terminate an instance. Whether I want to do CloudWatch detailed monitoring, tenancy, this is where I can do a dedicated host or dedicated by itself. For a T2 micro, I cannot do a dedicated host. The only option I have for a T2 micro is a dedicated, run it on a dedicated instance. That's because this is free tier eligible, because it's a fairly low level hardware machine. That's why it only has this option. I can also do graphic acceleration if I want to add GPUs to this instance, and whether I want burstable performance, right? But keep in mind that charges are going to apply if you do GPUs or if you want burstable performance, and whether you want any scripts to run when the server boots up. So let's say if this is a Linux machine and you want to run scripts to download and update the Linux kernel to the latest version, you can have scripts run on this server or on these servers when they're launched. So these are basic configuration details that we can select. Next is the storage. So by default, there's going to be one root volume, the EBS backed root volume. We can select different type, whether we want IOPS or magnetic one. IOPS we can only change, obviously, if we do provisioned IOPS, then we can change the IOPS. In the GP2 we do not have this option. Delete on termination. This just basically means that this EBS volume is going to be deleted when I terminate this instance. I can uncheck this if I want to have this EBS volume persist separately from this instance. And then I can also encrypt this EBS volume if I want. Here I'm able to add tags, again for my own reference purposes. Also, tags come into play when you're doing lifecycle management in terms of snapshots, or in other words, your backup policies. So then you would need tags in your resources in order to create those lifecycle policies, so it can basically back up the right instance at the right point in time. Here I can do security groups. So since this is a Windows machine, it's going to open up the RDP port for this. And then I can review the final screen in terms of what's being installed for everything. And then I can go ahead and launch this machine. Here it asks me for a key pair. So I can either create a new key pair or choose an existing one if I have one already and download that key. But we're going to choose an existing key pair that I have and launch the instance. So that's essentially how straightforward and fairly easy it is to launch your instance in EC2 in Amazon AWS. Hi everybody, and welcome to this tutorial in which we're going to look at what happens to EC2 instances in the different states. So we've looked at the theory part in terms of the different states that a EC2 instance goes when you provision it, in terms of starting, stopping, hibernating, and so on. So what I want to do is actually show you guys, how that actually plays out in terms of when you've actually launched an EC2 instance. So you guys can see I've already logged into my AWS console. This is the EC2 main dashboard, and I currently have one instance running. As you guys see here, it's a T2 micro. It's a Windows server that I have launched. It's the basic launch configuration. There's nothing that's customized on this. It's got the public IPv4 address. It's got the private IP address, and it's got the public DNS, and so on. So this is a standard T2 micro Windows 2016 server that I have launched into my EC2 console. As you guys can see in the state, it's currently in the running state. So this basically shows the different states that an instance goes through. So just as a refresher, when you stop an instance, which is what we're going to do first, multiple things happen. It performs a normal shutdown in terms of, if you had an on-prem server and you did start and shut down. That's essentially what happens when you stop an instance. The EBS value that we have attached to this instance, as you guys can see, if I go into my volumes on the left-hand side, you guys can see that there is one volume that is attached to this instance. You guys can see that it's a 30 gig volume that's attached to my EC2 instance. It's in use. So that's going to stay intact. Data stored in the RAM of the host computer or in the in-store volumes is going to be gone. And in most cases, it's going to be migrated to a host computer, a new host computer, a new physical computer. So this virtual machine, essentially 90 to 95% of the time, AWS migrates it to a new host machine, because usually when you shut down a machine, it tells AWS that there is something wrong, that something is not working within that physical machine or within your VM. And to overcome any new issues from arising when you restart the machine, they actually physically move the VM to a new physical host. Again, we don't know if that happens and when that happens, but that does usually happen in the background. It's going to retain its IPv4 address and any IPv6 addresses, but it's going to release the public v4 address and assign a new one. So you guys can see that the public v4 address right now is 34204.100.6. So what I'm going to quickly do is I'm just going to copy this onto my notepad, just so we can see when I restart this, what happens to this public v4 IP address. It's going to retain the elastic IP addresses and so on. So what I'm going to do is go into my dashboard, make sure that this EC2 is selected. In the actions, what I want to do in the instance state, again, I have multiple options: stop, stop, hibernate. Again, this instance doesn't have the enabled at launch, means I didn't select the hibernate option when I was launching the EC2. I can reboot it or I can terminate it. Terminate it, again, gets rid of it from my consoles. What I want to do is just simply stop. It gives me, again, a warning saying that any ephemeral storage, which is the instance store, is going to be lost, the RAM is going to be lost, and so on. So I'm going to just confirm this and click on stop. So right now it is changing states, right? So right now it's not stopped, it is stopping. So right now we are shutting down, physically shutting down the machine. There we go. As we can see that the instance has stopped. You guys can also see down here that the public v4 IP address is gone, but the private IP address is still there and the private DNS is still there. And you can see the instance state is currently stopped. So in order to restart it, I go back into actions, go on the instance state. I can again either terminate it if I want to get rid of it, or I can start it up again. It just confirms if I want to start it. If I click on yes, it's going to, again, change the state. Currently, the state is pending because it's going from the stopped state to the starting state. There we go. Now the instance state has gone from stopped to running. As you guys can see, the public IPv4 address is 34201.220.99. If I just reconfirm, you guys can see that it has assigned a new public v4 IP address. So just keep those small things in mind when we're changing states. As you guys can see right now, we still won't be able to connect because it's doing some status checks, but it is up and running. Every time it runs, it restarts, it does some initial health checks to make sure that everything is operational and you're able to work with it. Now we can also do the same thing from the command line interface. So if I open up my command line, I log into AWS. A good thing about the AWS CLI is once you've logged in, because I logged in in one of the previous labs, it remembers the access ID and the secret key. So all I have to do is just simply press on enter. It remembers the region. So it remembers all my previous choices. So it's not like I have to put in the key ID and the secret every single time. I just do it once, and the next time I can simply click on enter and it logs me in. So now if I want to do the same thing, let's say if I want to start and stop the instances from the console, I can do the same thing. So this is the command if I want to stop the instance. AWS EC2 stop instances, instance IDs, and this is the instance ID. And if I go into my console, you guys can see that I just grabbed the instance ID from here. So I just simply copied it, the instance ID from the console, and pasted it in here. So if I press on enter, what it's going to do, it's going to do the same thing that I did within the console. You guys can see stopping instances, current state, it's in the stopping, and so on. So if and it also lets me know the previous state. So it's went into the stopping state from a running state. And if I go back into my console, if I just click on refresh, oh, there we go. So it is currently in the stopping state. So again, like I mentioned, everything that we're able to do with the console, we can also do with the command line interface. And then the last option we have is in the states is again terminating it. It gets rid of it from our dashboard. And just to go into the volumes, you guys can see that the volume, regardless if I stop it, stays intact. Nothing happens to the EBS volume. That's why they always recommend, instead of using the instant store volumes, you always have EBS backed EC2 instances, just to make sure that your data persists regardless of the different states of your instances. Hi everybody, and welcome to this lesson on working with our EC2 instances. So now that we have a Windows 2019 server launched in AWS as an EC2 instance, how do we go about connecting to it and starting to work with it? So as you guys can see, I have one Win server launched in AWS for the EC2 instance. It is a Windows 2019 server in terms of the AMI that I have used. So if I want to go ahead and connect to it, if I select the server, and again, this can happen with any server you want to connect into, there's an option up here for connect. Now for Windows based servers, this option shows up. If you have a Linux one, a different one will show up, in which, because for Linux machines, obviously you have to SSH into it. For Windows machine, we can RDP into it. So what we can do is we can download this RDP file. AWS makes it very easy for us to connect into our Windows 2000 or Windows servers. So I'm going to save this RDP file. And once I open this file, it's going to just confirm that I want to connect to it. I'm going to go ahead and connect. And here it's going to ask me for the password. Now if I go back into my console here, I can select on get password. Now this is where the keys come in. This is where you have to have the key that you downloaded or that you specified to generate when you launch the EC2 instance. Even for Windows instances, we still need that key in order to generate that password. So I'm going to browse for my key. There we go. After I put in the key pair, it puts in basically a very long hash. What I need to do is go ahead and click on decrypt password. And this is the password that I need to put into my remote desktop file. And there we go. So right now I am currently logged into my EC2 instance, my Windows 2000 server EC2 instance in the AWS US East 1 region, which is in Northern Virginia. So now it's basically setting everything up in the background. And now I'm able to go ahead and do and configure my server as and how I please. And just for your reference here, on every EC2 instance that you launch, it will have in the background screen all the information in terms of the host name, the ID, the public IP, the private IP, and the availability zone, and so on, just for your reference. Now, connecting to a Linux machine is a bit different in terms of if you're working on a Windows PC or if you're working on a Mac or a Linux machine, because obviously you need to SSH into the Linux machines if you're going to be working in a Linux server. But if you are working in a Windows environment, which most enterprise organizations are, but again, not all. But if you are working in a Windows environment, this is essentially how simple it is to launch and connect to our Windows-based instances. Hi everybody, and welcome to this lesson in which we're going to take a look at how we connect into our Linux machine. So you guys just saw how we connect into a Windows machine. We can RDP into it. Now for a Linux machine, we have to SSH into the machine. So it depends on what OS you're using. So if you're working in a Windows machine, or if you have a Mac or Linux machine or laptop that you're using to connect into these EC2 instances. If you have a Mac or if you have a Linux, you can simply SSH into the machine. And how you would do that, so if I have this machine selected, the EC2 instance that I want to connect into, and if I click on connect, here it gives me basically details on how I can connect to this machine. So multiple options I have. I can use a standalone SSH client. Again, in a Mac or a Linux machine, you can simply SSH into it. Or I can do EC2 instance connect based. So I can simply connect to this EC2 instance via my browser, or a Java SSH client directly from the browser. And again, this Java is required. And at this point in time, it's letting you know that Chrome no longer supports plugins. So this is a bit iffy. The first two options are more widely used. I think the most used is the first option, a standalone SSH client. So we'll look at both of these options. So standalone SSH client, if you're in a Mac or Linux, you can simply SSH by using this command. If you are in a Windows machine, there's a couple of extra steps because we need to use a certain software in order to SSH into it, since Windows does not support SSH by default. So for that, we need to download something called PuTTY. So after we've downloaded PuTTY, a couple of things we need to do. First, we need to open up PuTTY Gen. It gets downloaded at the same time with the program. So when I open up PuTTY Gen, what I have to do is I have to change the extension of the key that I downloaded for this machine. So what I have to do is I have to load and find the key pair that I downloaded. Keep in mind that if you don't see the key pair you downloaded, make sure that here you do all files, and then you can see and then you will be able to see the .pem extension, which is the key pair that was downloaded from AWS. So I will load this into the PuTTY generator, the key generator, and what I want to do is save the private key. You can optionally add a passphrase for security purposes, but I'm just going to leave it blank. I'm going to name this the same, and here it's going to save it as a .ppk. Now PuTTY requires the key pair to be in a .ppk format as compared to a .pem format, which is what is downloaded from AWS. So when I save this, I can go ahead and close this out. Now I can open up the PuTTY program. Now the host name or IP address, I have to simply copy everything after the @ sign, paste it here. A couple of other things that I have to do. So I have to go into the data, and in the username, everything before the @ sign is the username, so EC2-user. And lastly, by going into SSH and in the auth section, here is where I have to load the .ppk file. So I would browse for the ppk file. The only option I have is for the ppk, and load this in here also. Now you would have to do this every single time to log into this machine. To make it a bit more simpler, you can save this option. So I can save this. And next time I would just simply double click on this and click on open. And now I'm basically logging into my EC2 machine, and there we go. I'm currently logged into my EC2 machine. Here we can verify the IP address, 172.319.2.201, and same thing here, 172.319.2.201. So that's essentially how you would log in or SSH into your Linux machine via a Windows computer. If I exit out of here, now a second way to connect is via the browser. So if I do the EC2 instance connect, again, username is EC2-user, and I click on connect, it's going to open up another browser and essentially SSH into the machine via the browser. So this one is a more simpler way to do it, but might not be preferable to everybody. People like that SSH command line, so that's how they do it that way, but this is also an option, and it connects into my EC2 instance. And this is, like I mentioned, a lot more easier as compared to doing it the PuTTY way if you're on a Windows machine, but it might not be your choice, especially if you're in a Mac or a Linux machine. Hi everybody, and welcome back. So in this lesson, what we're going to look at is different ways in which we can configure our Windows EC2 instance. So as you guys can see, I've already logged into or RDP'd into my Windows EC2 instance that we had launched earlier. So this is the Windows 2016 server EC2 instance on AWS. As you guys can see from the top right hand corner, it gives us the host name, the instance ID, the IP addresses, it's a T2 micro, the zone, and so on. So one of the things we're going to look at first is something called the EC2 launch. So EC2 launch is basically a set of Windows PowerShell scripts that replaced what AWS initially had was called EC2 config, and it's basically used to configure various different tasks within our Windows EC2 instance. So it performs a number of tasks, right? So some basic things is like you can change the computer name, you can change the wallpaper, it sends instance information to the console, sends the RDP certificate thumbprint, a random password for the admin account, DNS suffixes, and so on. So what we want to do is we want to go ahead and I'm going to open up PowerShell. So basically what this script basically does is going to verify the installed version of EC2 launch. As you guys can see, it's the current version on this Windows 2000 server is 1.0 1.3.2. So now the EC2 launch is basically installed in the program data area of Windows 2000. And the launch directory, if we navigate to the launch directory, so in the program data, we would go to Amazon, we would go to EC2 Windows, we click on the launch. So this is basically where the EC2 config resides in terms of the settings. So the launch directory has multiple things, right? So the first, there's something called scripts. It contains all the PowerShell scripts that make up EC2 launch. So if I double click on it, these are all the scripts that actually make up the EC2 launch. The module contains the module for building the scripts related to the AWS EC2. Then we have the config, which contains the script configuration files that we can customize if we want in terms of event log, launch config, and the drive letter mappings. And then we have the sysprep, which contains, obviously, just like the name says, the sysprep resources. In the settings, we have where the applications for the sysprep GUI. So in case we want to do the sysprep GUI base, we can use this, and then the logs, which obviously contain the logs that are generated by the script, if any, right? So this is the main repository of the EC2 launch and everything that it contains. So now after the instance has been initialized the first time, we can configure EC2 launch to run again and perform different startup tasks. So we can specify settings in the launch config.json. So here, the launch config.json, if we open it up, we can specify different things. We can set the computer name, we can set up wallpaper, we can add a DNS suffix, we can extend the boot volume, and we can set the administrator password. So let's say if I want to change the computer name to Qasim, so I'm just going to go ahead and change this one variable, and I'm going to save the launch config.json file. So now what I can do is I can basically, in the PowerShell, I can run with this command. I can schedule the script to run as a Windows scheduled task, and the script basically runs one time during the next boot and then disables these tasks from running again. So the next time I reboot the machine, my computer should be renamed to Qasim. Now we can also schedule the EC2 launch to run on every boot instead of only the initial boot. So to enable the EC2 launch to run on every boot, so here basically what I'm saying is it's going to schedule per boot, meaning it's going to run on every single boot. So here it confirms that every time that the instance boot, it's going to run this command. Or we can also run the executable. For example, if we want to run it right away, we can issue a command for it to run right away rather than have a parameter, such as, for example, we had a parameter of schedule and then schedule per boot. If we don't have a parameter, it should run the executable right away. Now, one thing to keep in mind or note, now when you enable EC2 launch on every boot, so the following changes are going to be made to the launch config.json. So the admin password type is going to be set back to do nothing, and the handle user data will be set back to false. So just a couple of small things to keep in mind if you run this for every boot. So a couple other things quickly I want to show you. So another thing we can do is we can specify settings in the event log config.json to send Windows event logs to the EC2 console log. So if I open up this file, now we can configure this with the following settings. So here basically what it's going is going to send the logs, the system logs, to the EC2 console. So after I do this, I'm going to go ahead and save this. And if I go back into my PowerShell, and I basically run the following command, so that the system schedules the script to run as a scheduled task each time that the window boots. Same thing that we did with the scripts before. We're going to do the same thing with the log scripts. There we go. So it's saying that this is also scheduled. Now the EC2 config service can also send a Windows is ready message to the EC2 console after every boot. So the EC2 launch basically sends this message only after the initial boot, right? So for backwards compatibility with the EC2 config, you can schedule the launch to send this message after every boot rather than only the initial boot. So what we can do is in the PowerShell, if we basically launch a script which is send windows is ready.ps1 and schedule this. So just like with the previous two, what it's going to do is every time that the window boots, it's going to run this or send this message to the EC2 console saying that Windows is ready. So these are just some of the few things we can do and configure with the EC2 launch command. Just keep in mind that modifying these files is optional, so it's not something that is mandatory, but for customizations, you are able to do this with the sysprep also. Hi everybody, and welcome to this lesson on looking at AMIs, or Amazon Machine Images. So there's various different AMIs, and they're very useful in terms of launching your instances, keeping them configured, and for your daily routine IT activities. The Amazon Machine Images come in very handy, whether they're shared images, whether they're the ones provided by AWS, or whether they're your own customized images that you've uploaded into AWS. So let's go ahead and take a look at the various different types of AMIs that are provided by AWS and those that we can work with. So what I'm going to do is I'm going to go ahead and head on over to my EC2 dashboard. So on the left-hand side, we have an option for AMIs, and this is the main dashboard within the EC2 instances for the Amazon Machine Images. So there are various different types of Amazon Machine Images. The most common ones are the shared AMIs. And shared AMI is basically an AMI that a developer has created and made available for other developers or users to use. And one of the easiest ways to get started with EC2s is to use a shared AMI that has components that you need and add custom content. So the instances that we've launched so far within this course have all been utilizing shared AMIs. One thing to keep in mind especially is that you're using the shared AMI at your own risk. Now, Amazon cannot vouch for the integrity or security of AMIs shared by other Amazon EC2 users. Now, that's not to say for the AMIs that AWS has created for us, those are fine because obviously they are provided by AWS, but shared AMIs that other users have uploaded into the AMI console, if you use those, you are basically using them at your own risk. Now, how do we go ahead and find the shared AMIs? So as you guys can see right now, there are no AMIs. Now on here in the top, this is basically the filter that we can use to specify the different AMIs. So if I click on the drop down arrow, I basically have three options. I have AMIs that are owned by me, so the ones that I have created and uploaded or created within the AWS environment. There are the public images and the private images that have been shared with you by other EC2 users or by other accounts. Or by other administrators within your organization. Just depends again how the organization is set up, if there's different AWS accounts within the organization based on geography or so on. If I click on the public images, so these are all of the images that are within the AWS environment and available for us to use. And we can again filter more by, for example, the instance type or the AMI ID, the AMI name, or even the owner. We can do Amazon images. So if the owner is Amazon images, these are basically developed by AWS. So obviously they are, you can rest assured that they're secure and there's no quote unquote risk associated with them because Amazon is the owner. Now, if I were to get rid of this, and let's say if I were to add the owner as the AWS Marketplace. Now, these are images that might have been created by other AWS users. So again, if you use these, you are using them at your own risk. A number of images that we can use and we can filter. So let's say if I know what type of image I want, I can search for it by name, by architecture, by creation date. Let's say if I wanted the newest ones and so on. So this is a very good way for us to launch our instances by minimizing the configurability. Now I can obviously do the same thing within the command line interface. So I'm going to go ahead and open up my command prompt. There we go. So I'm logged into my AWS console through the CLI. I'm just going to run a command to describe and list all public AMIs. So this command basically is listing to describe all of the images that are made available in AWS. So if I run this command, it'll basically give me a laundry list of all of the images or AMIs that are available for me to use and utilize in terms of launching my own EC2 instances with. Now, if I were to change, let's say instead of users all, if I were to change that to users self, that would be the images that are owned by me. Or if I change that to, let's say, owners Amazon, then it would list all of the lists or all of the AMIs that are owned by Amazon. So various different ways that we can use to list our AMIs. And again, like I said, everything that you can do with a console, you can do with a command line interface. And where possible, I will try to give you both examples. So if I go back into my AWS console, like I said, these are all of the AMIs that are available for us to use. So if I were to go into, if I wanted to pick one of these and launch an instance with it, I can just select the AMI that I want, and I can launch an instance with it. Or another way to do it is if we go into the instances, and if we launch an instance, these are all AMIs also. So these are again all AMIs that have been provided by AWS. If I click on the free tier, it lets me only view the AMIs that are eligible for the free tier. They're not chargeable. So there's 19 AMIs. I can pick whichever AMI I want. In the My AMIs, this list would have AMIs that you have either uploaded or created within the AWS environment. I can have owned by me or shared with me, and again, different filters based on if you have multiple AMIs. This is the AWS Marketplace. So the Marketplace allows you to buy software that runs on the cloud by third-party vendors. So like by, again, example, you see like Juniper, Barracuda, and so on. So there's a host of software that you can use and configure and buy from this marketplace, essentially based on what your organization is trying to do or what the server is trying to do or will do, whether it's a CRM, e-commerce, application stack, so on. You can also install WordPress from here if it's going to be e-commerce website or Joomla. So marketplace, instead of you uploading the software or buying a disk, which traditionally you would when you buy the software, they mailed you a disk, you put in the disk in the server. And now since you're not physically sitting in front of the server, this is the best place for you to either purchase or configure software that you want to be configured on the server that you're launching as an EC2 instance. In the community AMIs, now these are AMIs that other users in the Amazon world have created. Whereas if we scroll up a little bit, the quick start, these AMIs Amazon has created, the community AMIs are the ones that other users have created. So if you are using these, just keep in mind you're using them at your own risk. So you want to make sure if you use them after they're deployed, just run some tests to ensure that there's no pre-installed credentials in there, there's no backdoors, and so on. But most of the time, again, Amazon does do a pretty good sanity check in terms of ensuring that there's no malware in the Amazon machine images when they're uploaded to the marketplace. Here we can filter further by, let's say, the architecture, the operating system, and so on. So again, lots of different options for using AMIs within the AWS environment. So let's say if I want to create my own image. As you guys can see, I have one server that's already up and running. So let's say this was my EC2 instance and on which I had installed applications. I configured it, the way that I want my future servers to be configured in terms of the application, the patches, the network configurability, and so on. And I want to create an image. So next time or in the future when I launch a new instance, or for example, if I'm going to be creating an auto scaling group, it has to have an image to launch new computers with when it scales up or scales down. So I want to create an image. So if this is the server that I want to create an image of, I simply select it. And in the actions, there's an option for image. And here I would simply create an image. And here it allows me to give it an image name. I'm going to call that a test image. You can give it an image description. Here we also have an option for no reboot. So no reboot, it basically creates a live image. It does not shut down the machine to create the image. It creates the image while the machine is running. Just keep in mind that it could possibly have some adverse effects on some file systems or some running applications since it is creating a live image. It is always recommended that when you're imaging a machine, it's always shut down or in a state where there are no changes being made to the file system. So just keep that in mind. I'm going to keep this selected because obviously I have nothing that is created on this machine, nothing that's installed on this machine. Here's the default root volume that is going to create the image of. Now, optionally, I can add volumes on this image. So if I want to, let's say in the image, I want to have an extra volume. So when this image is launched on the new server, there will be 2 hard disks or 2 EBS volumes instead of 1. I can go ahead and change this also. Additionally, optionally, I can also upgrade the hard drive on the image. So if I've noticed that in any future servers, I want a provisioned IOPS, I can go ahead and upgrade the hard drive also. So I'm going to keep everything the default and go ahead and create the image. There we go. So the image is created. Now if I go into AMIs, and if I filter to images which are owned by me, as you guys can see, this image, this test image is currently being created. Right now it's in the pending state because it's currently imaging the machine. As soon as it's done, it will become available. Now let's say if I want to make this image available to other users in Amazon. As you guys saw in the marketplace, in the community images, those were images that other users had shared with the community for them to use. So let's say if I also want to make this available for the community while it's imaging and while it's pending, I can show you guys that. So if you click on the action, there's an option to modify the image permissions. So if I modify the image permissions, I have multiple options. So this image currently is private because only I know about it. So let's say that in my organization, there are separate AWS accounts based on geography. So let's say our US office has a separate AWS account and our Europe office has a separate AWS account and so on. So I'm able to create an image and share with various other AWS accounts. So in this sense, if there is another AWS account for our US office, I would simply share this image and put in the account number here. So then it would show up in their AMIs also. That way we can also have separate AWS accounts in terms of keep management separate, yet centralize some operations because obviously it's still the same organization. And this happens quite often in enterprise-wide organizations where they're geographically diverse. They have separate AWS accounts in terms of management, in terms of budgetary, and so on. So this way you can still keep certain things centralized and then the other things you can keep decentralized. Or I can simply make it public. Public basically means that everybody in the Amazon world will be able to see and use this AMI. So those are the 3 main permissions that I can select for the AMI: either keep it private, share with certain AWS accounts, or simply make it public. Hi everybody, welcome back. So in this lesson, we're going to talk about copying Amazon machine images or AMIs within or across AWS regions through the Management Console. So copying a source AMI basically results, as the name kind of suggests, an identical but distinct target AMI with its own unique identifier. So in a sense, it's a copy, but obviously the UID or the unique identifier is different. Now, in the case of, let's say, EBS-backed AMI, each of its backing snapshots is by default copied to an identical but distinct target snapshot. So there's no charges for copying AMIs, but just keep in mind that standard storage and data transfer rates apply in terms of your EBS volumes or if you're going to be transferring those images across regions. So when copying, there's a few things that we do need to keep in mind. First and foremost are the permissions. So if you use an IAM user to copy an instance store-backed AMI, the user must have some permissions. So as you guys can see in the example policy, this allows the user to copy an AMI source in the specified bucket in the specified region. So as you guys can see, the effect is allow. The action in the S3 is list my bucket. So this basically gives them access to the S3 buckets. Next is giving them access to get an object, right? So the source bucket. And then the last effect is allowing them to either create a bucket, to get the bucket, and put object in the bucket. So it's basically, in other words, the read and write permissions in the S3 to allow them to both read and write objects within that. And then the ARN, which is the Amazon resource name. So these permissions, make sure if you are using an IAM user, which again is always recommended to use. So when you're working in AWS, make sure that this user has this specific permissions in order to copy AMIs. If they're going to be copying them to S3 buckets, make sure that they have read and write permission to those buckets. So copying an AMI across geographically diverse regions provides a number of benefits, right? So for example, if you want consistent global deployments, right? If you have offices spread across the globe, you want to make sure that all the deployments, regardless of where they are geographically, are consistent with your organizational policies and procedures. Then you have scalability. Again, you can more easily design and build global applications centrally. And then performance and high availability. Obviously, you can increase performance by distributing your app, as well as locating critical components of your app in closer proximity to your users. And then make sure that they're highly available by designing and deploying across multiple regions to increase the availability. So the diagram that you guys basically see shows a relation among a source AMI and 2 copied AMIs in different regions, as well as the EC2 instances that are launched from each. So when you launch an EC2 instance from an AMI, it obviously resides in the same region in which the AMI is. So if you make changes to the source AMI and want those changes to be reflected in AMIs in the target regions, you have to recopy the source AMI to the target regions, because EC2 instances do not cross over regions, and neither do AMIs. So just keep that in mind, because obviously if you are managing everything centrally, you would assume that, or you might think that if you modify your original AMI, that change is going to be propagated across the globe to all of the places where you've copied the AMIs, but that is not the case. You also have an option for encryption. So the table that you guys see on the bottom supports, and shows the various types of AMI copying scenarios. So for example, you have, in the first scenario, you have encrypted to unencrypted, which is supported. So all of them are supported except from encrypted to unencrypted, right? So you can't go from encryption to non-encryption in terms of copying, but you can always go the other way around. So by default, without specifying, if you don't specify any encryption parameters, the backing snapshot of an AMI is copied with its original encryption status. So copying an AMI backed by an unencrypted snapshot results in an identical target snapshot that's, you guessed it, also unencrypted. And if the source is encrypted, then the destination will also be encrypted. So let's just keep these scenarios in mind if encryption is going to be playing a key role within your organization. So the scenario you guys see on the top, right? So there's an AMI backed by an unencrypted root snapshot is copied to an AMI with an encrypted root snapshot. So the copy image action, right, so which is going to copy the image, is invoked with 2 encryption parameters, including a CMK. So as a result, what happens is the encryption status of the root snapshot changes so that the target AMI is backed by a root snapshot containing the same data as a source, but encrypted using the specified key, which is the CMK, right? So just keep in mind that you'll also be incurring, the storage costs for the snapshots in both AMIs, as well as charges for any instances you launch from either AMI. So while copying AMIs does have its benefits, it does have a few limitations, right? So they're not big limitations, but there are limitations that you do need to keep in mind, especially if you are going to be managing everything centrally. Hi everybody, welcome back. So in this lab, what we're going to do is we're going to quickly take a look at the operations of copying and AMI. As you guys can see that I'm still working with the AMI that we created earlier. As you guys can see that it's available now. So what if I wanted to copy this AMI? If I have this AMI selected in the actions, I have multiple options I can do with this AMI. I can deregister it, I can deregister it, I can register a new AMI, I can launch an instance from this, I can do a spot request with this AMI, I can modify the permissions, add tags, or modify the boot volume setting, which is the ABS. So in the copy AMI, once I do this, it opens up a fairly simple dialog box in which I can specify the operations to copy. So the destination region, I can specify which region I want to copy this into or copy this to. Currently, I'm working in Northern Virginia, which is US East. So from here, let's say if I have an office in Mumbai or if I have an office in Singapore, I can choose to have this copied to the destination region in APAC, Singapore. The name, I can keep it the same. Most of the time, you would want to keep it the same because you want to make sure that you're distinctly that you're keeping distinction between the servers if you have multiple AMIs. The description in here again was the encryption that we talked about in terms of if you want to encrypt the target EBS volumes. And if I do the encryption, obviously I have to specify the master key, whether to use a default one or have specific master keys. And here it gives specific key details for the encryption. So if I just keep this unchecked, so here's letting me know that it will be copied to a new AMI, and these are the settings for the new AMI. So if I click on copy, There we go, it's saying that the copy has been initiated. So if I click on done, there we go. So as you guys can see that I've navigated over to the Singapore region, and here the image is currently pending because it's copying over. So as you guys can see, I can only see one image here, right? Because images are region specific. So I will only be able to see the images that are within this region. So in Singapore, I see one, and in Northern Virginia, I also saw my original one. So I'm just going to quickly go ahead and just deregister because I don't want another image floating around in the AWS world. And once I go back into my original region, which was US East, my original AMI should still be there. There we go. So the original AMI is there. So that's essentially how fairly straightforward the copying process is within AWS for AMIs. But it is very robust in terms of it helps you manage everything centrally, and it gives you greater control and conformity to your organization's policies and procedures in your especially if they're geographically diverse. Hi everybody, and welcome to this lesson on looking at how we can monitor our EC2 instances. So monitoring is, a very important part of your IT responsibilities, especially in terms of reliability and availability and also performance. So you should collect monitoring data from all parts in your AWS solution so that you can be more easily, be aware of what's going on, be in a better position to debug if there is a failure and so on. But before you start monitoring the EC2 instances, there are a few things that you need to keep in mind and especially ask yourself in terms of a plan, because it's always good and recommended to have a monitoring plan when you are implementing monitoring in EC2 instances. So here are a few questions to ask yourself before you actually start monitoring and implement a monitoring plan. So what are your goals for monitoring? What are you trying to accomplish in terms of monitoring EC2 instances? Are you trying to see if there's a high CPU utilization? Are you trying to just see the overall health of your EC2 instances? So what's your eventual goal in terms of monitoring, and why do you actually want to monitor? Is there even a need to monitor your EC2 instances? So after you define your goals, next thing is what resources are you going to monitor? Now there are various resources that you can monitor, and even within EC2 instances there are various variables of EC2 instances that we can monitor. So after you define your goals, that's going to help you define what resources are you actually going to monitor. And after those resources, then you can decide how often do you want to monitor it. Because again, we can monitor it on a regular basis, on a daily basis, weekly basis, monthly basis, and also minute by minute basis, right? So if we implement that detailed monitoring in EC2 instances, then we can monitor our instances. It'll give us stats every single minute in terms of our utilization of EC2 instances, right? So after we have all of those defined, that's when we can actually pick and choose what monitoring tools that we want to use and that we could possibly use to monitor our EC2 instances. Can we just monitor through the EC2 dashboard, or do we need to do CloudWatch? Do we need to do CloudWatch alarms? Do we need to do CloudTrail? So that can be defined after we figure out and define what resources we want to monitor and how granular of data do we actually want to monitor. And then who's going to perform those monitoring tasks? Is it going to be the IT manager? Is it going to be the users? Do you want to actively monitor? Means, do you want somebody to be logged into your EC2 console to monitor, or do you want to be notified by exception? If there's a high CPU utilization or if an instance failure, do you want to be notified? So you want to make sure you define those tasks in terms of the responsibilities. And then again, that goes hand in hand with the last one, the notifications, right? So if instance failure happens, who should be notified? Do you want the head of IT to be notified? Do you want the person that's actually going to be recovering from the failure to be notified? So again, that depends on your organization's policies and procedures in terms of that. But these questions are very important to answer before you actually start implementing any type of monitoring in EC2 instances, and even in general, any type of monitoring for your IT resources that you want to implement. You want to make sure that you have these basic questions answered, or at least in mind, before you start implementing an EC2 monitoring plan. So where should we start, right? So to establish a baseline, now at minimum, we shouldn't be monitoring these items, right? So the CPU utilization, the network utilization, the disk performance, the disk read and writes, and then the memory utilization. Now, these are very, very basic things that we need to monitor in any monitoring plan for EC2 instances, because this actually tells us the health of our EC2 instances, and it lets us know, do we need to upgrade, or do we have too much hardware dedicated to this server? Can we downgrade our hardware? So these metrics are minimum what you should be monitoring for our EC2 instances. Now, how often, again, that depends on your goals and your overall monitoring plan. But in terms of the metrics, these are the minimum that you should at least be monitoring in your monitoring plan for EC2 instances. Now, AWS provides, again, various different tools to monitor your EC2 instances. So we have two ways to monitor. We have automated and manual. So in the automated, you can use multiple tools that you guys see in the list to do automated monitoring for EC2 instances and report back when there's something wrong. So there's the system and instance status checks. So again, the system, AWS basically monitors any hardware failure, loss of network connectivity, system power, software issues on the physical host. So system status checks are usually something that AWS needs to take care of physically at their data centers. It's not something that would be under our control. What we would be able to do is, we could restart the instance, or we could stop the instance and start it up again, because usually when you do that, it usually starts up in a new physical host. Again, I say usually because we don't know if it's 100% of the time, but AWS does say that usually they dedicate a new host when you stop and start the instance. So that's something that is under our control, that we could do with a system checks. Or we could do an instance status check. Again, that's monitoring the software and network configuration of your individual instance. So these checks are basically going to detect problems that require your involvement to repair. So if there's a failed system check, or if the memory is exhausted, or if there's an incompatible kernel, and so on. So these two are automated, along with the CloudWatch, alarms, events, and logs. So again, we can watch single metric over a time period that we can specify, perform one or more actions, based on the value of the metric. So let's say if we want to be notified if the CPU is above 70% for, over 5 minutes or over 2 minutes, we can set alarms, we can set events, and then we can obviously do the logs, in which, we can monitor, store, and access our files through CloudWatch and CloudTrail and even other resources where they can be saved on S3 buckets. So we can do some audits, we can do some analysis after the month to see if the resources we've dedicated to AWS are actually, optimal for our organization. There's also EC2 monitoring scripts, so basically Perl scripts that we can monitor memory, disk, and swap file usage for our instances. And then finally there's a management pack for the Microsoft System Center Operation Manager. So again, this is specific to Microsoft, but basically links EC2 instances and the Windows operating systems running inside them. So the management pack is basically an extension of the Microsoft Systems Operation Manager, and it uses a designated computer in the data center called a watcher node, and the AWS APIs to remotely discover and collect information about the AWS resources. So again, these are some automated monitoring tools that we can use and implement to do automated monitoring of our EC2 instances. Then we have, again, manual monitoring. So another important part of monitoring EC2 instances is manual monitoring. So it's not like you only want to do automated monitoring. In a comprehensive monitoring plan, you also want to have manual monitoring, right? So these are, some of the tools we can use to monitor manually. Again, manually would obviously mean you sitting in front of a computer or opening it up on your mobile phone or your tablet and actually looking at the health of the EC2 instances, whether it's through the EC2 dashboard, whether it's through the CloudWatch dashboard, whether you're using to graph EC2 monitoring data to troubleshoot issues and discover trends, doing the resource metrics, looking at the alarms to see if you're actually being notified of everything, and just overall, getting a glance, a 360 holistic view of everything that's going on within your AWS environment, just so you know everything, firsthand, rather than relying only on alarms or only on the automated monitoring. It's always good, once a day or once a week, go on to the EC2 dashboard or your AWS console in general and just look at everything that's configured, everything is working properly, everything is healthy, and so on. So these are some of the things that you want to keep in mind and make sure we implement in terms of monitoring our EC2 instances. And again, first and foremost, make sure that we answer the questions, that we define our goals, what we want to monitor, and how we actually want to monitor them. Hi everybody, and welcome back to this lesson in which we're going to talk about the EC2 monitoring. So there are basically two different types of status checks that we can do with EC2 instances. So there's the system status checks, and then there's the instance status checks. So for the system ones, they're basically used to detect any underlying problems with your instance that would require AWS's involvement to repair it. So when a system status check fails, you can either choose to wait until AWS kind of fixes their hardware problem or their networking problem. Or for instances that are backed by EBS, you can simply start and stop the instance yourself, because those instances, once they're started, they're usually started on a new host, and that would usually fix the problem if it fails the system status checks. And again, it can be for loss of network connectivity, system power, physical failure of the hard drive, or physical failure of the processor. So it can be any number of issues in which the AWS's physical involvement is required. For the instance status checks, we can monitor the software and network configuration of our individual instance. So for the EC2 checks the health of the instance by sending an address resolution protocol, or ARP, request to the network interface card. Right? So these checks, they basically detect problems that require your involvement to repair, not necessarily AWS's involvement to repair. So example of some problems that can cause instance status checks, that would be a failed system status check, incorrect networking, if you're exhausting the memory, if the file system is corrupt, if there's any viruses or malware in the systems that are so prevalent that they've been detected by the monitoring. So those are the two main types of status checks that we can do. So in order to view the status checks, as you guys can see, I've already logged into my AWS Management Console and navigated to the EC2 dashboard. So here in the instances, I currently have one instance running, which is the T2 Micro, a Windows instance. So here on the bottom, once I select the instance, I can view all the different information about this instance. So here I have an option for status checks. So basically the status checks column, it does list the operational status of each instance. Here we can see that the status checks its reachability check is passed and the instance reachability check is passed. So both types of checks, the system and the instance, have both passed, so they're both working properly. We can also view the status using the command line. So if I were to log into my AWS, there we go. So I'm logged into my AWS console. So what I want to do is I want to run an AWS EC2 command, and I want to describe instance status. There we go. So as you guys can see that it returned everything is running since I only have one instance. So it's running. It gives me the instance ID, the status. Again, the reachability is passed and the system status is passed. So both the instance and the system statuses are also okay. So we can quickly run this in the command line rather than having to log into the console to check the status of our instances to make sure that both tests are running properly. Now you can also provide feedback if you're having problems with an instance whose status is not shown as impaired, or if you want to send AWS additional details about problems you might be experiencing with a failed instance. So within the AWS console, right? So here we're still within the system status checks. In the bottom, we have additional resources. So here we can submit feedback to AWS and let them know if we are experiencing any issues with this instance that might not be shown. So if everything is okay, but we are still experiencing issues, then we can submit this instance status form to AWS, which will basically force them to physically look into this instance and make sure that it is working properly.
Welcome back. Let's talk about the data variety problem, right? And what that means in terms of source data. So speed is an incredibly important factor when planning a data analysis solution. So no less important is the understanding of many data stored in different systems. Now, they say that there are just as many types of data as there are people, right? So if you've ever been overwhelmed by the sheer number of data sources that you have to analyze, and you can't find systems to do the analysis, right? You know what I'm talking about here. Now, it means that you have a variety problem, and that can be challenging when you're looking for diversity in your analytics. So here in this video, I'm going to talk about how to store a wide variety of data so you can make good decisions about how to meet the analytical needs of your business. And the challenges of variety in data analysis solution, right? I'm going to talk about that also. And also, I'm going to talk about various types of data sources and the databases that source the data. So in essence, let's talk about structured data stores, right? I'm also going to talk about semi-structured stores, and then finally, when your business becomes overwhelmed with the sheer number of data sources to analyze and you cannot find systems to perform the analytics, you know you have a variety problem. Now, the problem of variety is really what, right? So since there are many types of data as there are people, right? So that's where variety becomes a challenge for businesses that are looking for diversity in their analytics. Now, data can generally be classified based on storage types that are used. So every data analysis solution, for example, begins with data sources. Now, a data source can be just about anything. A folder on a file server, could be a database, could be a web page, or even a wearable device can be considered a data source. Now, each of these data sources, data is stored in a specific way. So some data sources use schema for indexes, right, to improve performance. Now, others organize data in a more flexible way and are called schemaless. Now, schemaless data sources still use indexes to improve performance. Now, when people talk about data variety, sometimes they mean numbers, text, dates, but those are actually data types. To really talk about data variety, you need to talk about how these data types are organized in the data source. So, we can talk about data variety without talking about data source types, right? And how each one organizes various types of data. Now, every data analysis solution begins with a data source. It can be just about anything, a folder on a file server, a database, a web page, or even a wearable device, like I mentioned earlier. And in each source, data can be organized in different ways to meet different needs. So, let's talk about the three data sources: structured, semi-structured, and unstructured. Now, structured data is data that is stored in a tabular format, often in a relational database management system, or RDBMS. Now, this data is organized based on the data relational model and standardizes data elements and the relations to one another. Now, this is called a schema. Now, through the schema, RDBMS systems have the ability to enforce compliance. So, structured data is organized into tables, columns, and then rows. Now, you can find structured data in both transactional and analytical databases. Now, transactional databases have heavy write and update operations, while analytical have heavy read operations. Now, there's a downside to structured data, but it's limited flexibility once the initial development is complete. So let's say you've decided to keep track of an age of your customer in an existing database. Now, you must reconfigure the schema to allow for this new data, and you must account for all records that do not have a value for this field. Now, it's not impossible, but it can be very time-consuming. The next data source type is semi-structured. So, semi-structured data sources organize data into elements and attributes. Now, when semi-structured data is housed in non-relational, often called NoSQL, right, databases, it does not impose a schema or a specific set of rules and constraints on the data. Now, when semi-structured data is stored in file, it is considered to have a self-describing structure, meaning that the file itself will tell you how to interpret the data. Now, the advantage is that this allows that every database table or file to have its own structure or schema. So unlike structured data, semi-structured data is highly flexible, right? Now, each element can contain different attributes, for example, so it can scale to meet the changing demands of the business much more rapidly. The trade-off for this flexibility is a loss in analytics. Now, it can be more difficult to analyze semi-structured data because there is no single enforced schema. You also lose the ability to join two tables or files together, which is a key capability of structured data. So, structured data is easy to analyze, right? But the structure is difficult to change. And semi-structured data is easy to generate and highly flexible, but can be harder to analyze. So the last data source, right? Unstructured data. Now, unstructured data is data that is stored in files, right? Similar to semi-structured data. But this data does not conform to a predefined data model and is not organized in a predefined manner. Now, unstructured data can be text-heavy. PDFs, CSV files make up the bulk of this data source type. So the files can also contain little to no text at all, in case of images and videos, for example. Now, with unstructured data talked about, the analysis is performed on the metadata stored for each file. Now, to perform meaningful, analysis on the data, you need to pre-process those files. Now, there are a couple of key ways you can do though, right? You can use a service to add text to the database on the rules you define, or you can catalog the data to make it available for query services. Now, it sounds like it might take some pretty radical thinking to figure out how to use unstructured data and structured data in the same solution. So that is the whole point of this particular lecture, right? To help you understand the data source types, so you're able to, you're prepared to take these data source types and then incorporate in the data analysis solution. It requires new systems and applications to get to the value of the data itself. And that's where many companies have stopped, right? But they shouldn't stop, right? New services and features are being released all the time. And the cost associated with mining unstructured data is decreasing rapidly. Let's bring some perspective to the popularity and usage of these three data source types. Believe it or not, by the way, there is a company that gathers data from online conversations, right? Posts, articles, questions, and then posts it to online forums. They focus on conversations about data and databases. Not surprisingly, by the way, right? They found that 75% of all communication is about relational database and structured data. So NoSQL databases and semi-structured data only comprised about 15% of the communication. So all of this is really that relational databases and structured data are the most commonly implemented data source type. Let's talk about data source types, right? Structured data is stored in a tabular format, right? Within a RDBMS system, for example. Now, this data is organized based on a relational data model, right? Which defines and standardizes data elements and the relation to one another. Now, data is stored in rows, with each row representing a single instance of a thing, right? For example, a customer, these rows could be, due to the table schema, are well understood, by the way, right? Now, this makes structured data easy to query. The downside, like I mentioned earlier, is a lack of flexibility. So let's say you want to track the age of your customer, for example. So for this, you have to reconfigure the schema altogether, right? Before you can actually accomplish this. So that's really the problem with this type of data, right? So here I talked about three different data types. So structured data is hot, immediately ready to be analyzed, right? Semi-structured data is lukewarm, right? Some data will be ready to go, and other data may need to be cleansed or pre-processed. And unstructured data is the frozen option, right? So you need to tell exactly what you need, and it's filled of all kinds of stuff that you don't need. So new tools are emerging, helping businesses to integrate and analyze all types of data. Now, when it comes to business analytics, structured data is often the go-to, right? Because it's so well formatted. Businesses have begun to realize that the necessity of including both semi-structured and unstructured data into their business intelligence solutions. So, since I've talked about these types of data, the majority of data businesses have unstructured data, right? Because that's the bulk of it. So, database engines, for example, I talked about a company that scours the internet, right? And talks about data and collects information about data itself, right? And I also mentioned that 60% of the talk is about structured data. But unstructured data is often overlooked by many, many organizations. So I hope this helps you understand the three types of data structures, right? Let me know if you have any questions. With this, let's move to the next lesson. Welcome back. So in the previous lecture, I talked about the basic characteristics of the three main data source types. Now here in this lecture, I'm going to talk about structured data specifically. So structured data is classified as data that is stored in a database or database management system, DBMS. So a database is a structured set of data held on your PC, right? One that is accessible in various ways. So a DBMS provides structure to the data and the ability to maintain the data throughout its life cycle and the ability to manage interactions with other processes and other systems. Different database management systems manage data organization in different ways to achieve specific goals, such as complex analysis, rapid relationship navigation, or session state retrieval. Now remember that structured data is stored in a tabular form, well, often within a database management system. Now, I'm going to explore why these management systems were created in the first place. So, flat file data is extremely common. So who hasn't had to work on a worksheet, for example, Excel worksheet or a spreadsheet, right? These files contain data in the form of columns and rows. Now, flat file data is often generated without any rules or restrictions on the values that can or should be entered into a specific column. Now, this causes a lot of problems for analysis later on. With flat files, there is no consistency from one file to the next. Now, joining data together is nearly impossible without pre-processing, and there is no way to gauge the integrity of the data itself. Now, let's not get things wrong, right? So in spite of some issues with the data in this format, flat file data storage has its advantages also. So it will continue to represent a large portion of data that your data analysis solution may need to collect. So when organizations need to go beyond simple flat file storage, they often move to databases to store their data. Now there are many types of databases to choose from. Now when we talk about database types, it's important to know that there are specific ways to organize data to dramatically improve data analysis. So relational databases have a lot to offer. Now they allow you to rapidly collect, update, and then query data. One of the greatest strengths, by the way, is the ability to enforce asset compliancy. Now this is a mechanism used in transactional systems to ensure data integrity. Now I'm going to talk about this later on also, right, in later lectures. But here, to be fair, let's talk about that relational databases can struggle storing other structured data. It's important to consider carefully data you need to store and whether relational databases are the best option for you. So the term relational database is really quite broad. Now under this particular heading, there are two primary information systems or methods for organizing information: online transactions processing, or OLTP, and online analytical processing, or OLAP. Now why two different systems here? Well, it all comes down to how the resources supporting the database are being used. Now when you interact with databases, there are really only two things you can do: put data in or pull data out. So adding data to a database is called a write operation, and querying data in a database is called a read operation. Now these two operations use the same resources, right, but in different ways. Now this makes it difficult to optimize for one or the other. Smaller databases tend to have tolerance for write and write operations to happen at the same time. However, in large databases, you are forced to sacrifice the performance of read operations to allow high-performance write operations, or sacrifice the performance of write operations to allow for high-performance read operations, right? The other way around. Now that doesn't sound desirable, does it? It's not really, right? But it's a reality for businesses that are growing out of the database systems. Now the solution is to have one database optimized for write operations, OLTP, and the other database optimized for read operations, OLAP. Now in practice, data is written to the OLTP database with a very high frequency. Records from that system are copied over to the OLAP system on a scheduled basis. Now, in many solutions, the database being copied to the OLAP databases also transforms to provide clearer answers for analytic questions or pre-aggregated to enable rapid query results. Now, this is all done with ETL operations, drag, transform, load, right? So I'm going to talk about in-depth ETL later on also, right? But here, flat file data is really or generally resides in a worksheet or spreadsheet like I mentioned earlier, right? So it's not really a database, but it does meet all the requirements. Now, this format provides a solid foundation for understanding some of the considerations when choosing a DBMS. In terms of relational database, right? Flat file storage may not fit the structured data storage needs. So the next logical step would be move to a more robust solution, right, which is a relational database. So this is process known as normalization, help business takes flat file data and then turn it into a relational database. So normalization is a set of rules that work together to reduce redundancy, increase reliability, and then improve the consistency of data storage. So relational databases are built to store structured data so it can be collected, updated, and then queried easily. Relational databases also rely on series of structures called tables, right, which hold the collected data. Now, these tables are navigated using the structured query language, or SQL. So logically, relational database tables group data based on person, place, things, or event related to that data. Now, these groupings are referred to as entities. Now, each entity is stored as a table. A column, known as a field, for example, is used to describe one attribute of the entity. So a row, known as a record, in a table represents a single instance of an entity. So think of a spreadsheet, right, where each row has a cell for each column. So each cell can contain a value. And rules within a schema defines the attributes that are required or are optional. So relationships are then created by first ensuring that every row in a table is unique, using the primary key, right? And that's really the concept of being unique. So this primary key value can then be used to create relationships between tables. So a foreign key, by the way, is a key that uses the value of the primary key from a different table, right, to define a record in that table. Now, this really what builds the relationship between tables. Some database engines can enforce this relationship to ensure that all those values that are primary key can be used in a foreign key. So, let me talk about briefly the strengths, right? First, ACID compliance. So data is easily stored, edited, and retrieved using a common SQL language. The structure can be scaled up quickly. And some of the weaknesses, on the other hand, right? So struggling storing unstructured data, right? Or querying, slow querying, right, due to complex requirements. Or the schema can make the scaling out quite difficult. And then the types of information systems also matter, right? So there are two main ways known as information systems of organizing data within a relational database. So the data can be organized to focus on the storage of transaction or the process of analyzing transactions. So transactional databases are called online transaction processing, OLTP, databases. The data gathered by OLTP databases, right, is often fed into another type of database that focuses on analyzing the transactional data. So online analytical processing, or OLAP, where databases gather data from OLTP systems, right, for the purpose of organizing for analytical operations. OLTP databases, for example, are operational databases. And online transaction processing, OLTP, for example, databases, they often called operational databases as well, right? Logically organized data into tables with a primary focus on the speed of data entry. Now, these databases are characterized by a large number of insert, update, and delete operations, right? So all decisions about the organizations about data and storage attributes is based on ensuring rapid data entry and then updates. The effectiveness of the OLTP system is often measured by the number of transactions per second. OLAP, on the other hand, right, data warehouses are the ones that typically use, for example, the online analytical processes, right? They're called data warehouses also, right? Logically organized data into tables with the primary focus here is the speed of data retrieval for queries. Now, these databases are characterized by a relatively low number of write operations and lack of update and delete operations. So all decisions about the organization of data and storage attributes are based on the types of queries and other analytics that will be performed using the data. The effectiveness of the OLAP system is often measured by the response time of the query result. Now, there's one more very important concept that I'd like to cover when discussing structured data, and that is how to optimize the retrieval of the data. Now, databases use something called the index to organize the record where records are within tables. Now, index tables return query results much faster than tables that are not indexed. For example, let's assume you're looking for all orders placed on January 10th. So every single row will be scanned in an unindexed, right? That all matching rows are returned. Now, scan operations are very resource intensive. Imagine doing this against a 50 million rows, right? Well, it will take forever. So as opposed to an index table, the primary key field is used to organize all rows in a table. Now, if the index is placed on the order date field, all orders will be organized based on the order date. Now, this means that when the query is run, the system could see automatically or jump to the correct data within the index, skipping all rows before this date and all rows following the date. Now, this results in a much faster response. This form of indexing is called row-based indexing and is best suited to systems that need to return the entire rows of data regularly. Now, within the OLTP system, these are the most common queries. Now, these queries return several columns of data for each matching row. The filters on this data are generally based on the key columns in that table. For example, returning all of the customer's address information or all of the details for a specific order. Now, both OLTP and OLAP systems can run efficiently using row-based indexing, but there is a second form of indexing that's also important to cover. It's called columnar indexing. Now, in case of OLAP system, the most common queries are aggregate queries. Now, these queries are often very complex, right? So they take large numbers of rows and reduce them by aggregating the values. For example, counting the numbers of customers or totaling shipping costs. So running a row-based index for an OLAP database can cause an excessive amount of unneeded data, called data waste, to be read into memory for every query, because every column of every row must be loaded. So another common issue for OLAP databases running row-based indexes is that the amount of compression that can be achieved is limited by the unique values that must be entered into the tables to identify each row. Now, this is where columnar indexing comes in. So columnar indexing changes the way indexes are built. So instead of row by row, they index columns, right? The advantages are clear for OLAP systems. By indexing the columns themselves, the query only needs to load the column required for the query, rather than every single column as in row-based indexes. Now, this nearly eliminates a data waste just mentioned earlier. So the other key advantage in compressing the data, right, is, so what are the options here about AWS for OLTP and OLAP databases? So for OLTP or OLAP databases using row-based indexing, Amazon Relational Database Service is there, also called Amazon RDS. Now, the service makes it easy to set up, operate, and then scale a relational database in the cloud. The service provides cost-efficient and scalable capacity, at the same time automating many time-consuming admin-related tasks, such as hardware provisioning, database setup, patching, and backups. So when you implement Amazon RDS, you have the choice between many popular database management systems, such as Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and SQL Server. So for OLAP databases using columnar indexing, we have Amazon Redshift, which is a fast, scalable data warehouse that makes it simple and cost-effective to analyze all the data across the data warehouse and data lake. Row-based and columnar-based indexing. So data within a database should be indexed to allow query to quickly find the data it needs to produce the result. Now, indexes control the way data is physically stored on disk, right? They physically group records into predictable order based on the key values within the table. Now, this plays a huge part in the speed and efficiency of queries. So in OLTP system, the most common queries are called lookup queries. Now, these queries need to return several columns of data for each matching record. The filters on this data are generally based on key columns in that table. Now, in this type of system, for example, you might query to get details for a specific order. In an OLAP, on the other hand, the most common queries are aggregate queries. These queries take large numbers of rows and then reduce them to a single row by aggregating the values in one or more columns. Now, in this type of system, you might query to find the total number of items sold on a specific day. Both OLTP and OLAP systems can use either indexing methods. However, there are advantages of choosing the method that is best suited based on the project or the solution needed. So relational database rows and columns, for example. The primary benefit of a relational database, right, using SQL, for example, that it is a proven technology that is widely adopted and understood. There is less risk involved in a relational database, right, especially due to asset compliance and a large community of experts available for you. Now, there's an expectation that transactional latency, right, for example, especially on appropriately sized hardware and relational databases are considered outstanding for OLTP for relatively small data sets. Now, there are scalability concerns within relational database also. As data sets grow, the only way to maintain performance is to increase the hardware capacities of the servers that run the application. Now, another key issue is the fixed schema of relational databases. Now, it's difficult to make non-disruptive changes to the underlying database architectures, which can affect the development times for a new functionality. Now, preparing relational data for data processing simply means, for example, when working with a relational database, you must also pay attention to how the data will be used within the data analysis solution. It's very common to perform multiple types of analytics on the same data. OLTP data may need to be transformed into a denormalized form and placed into a data warehouse or data mart. OLAP data may not require any transformation. Now, there may even be opportunities to transform data into staging databases that can be used as a data source for other analytic processes. So, I've talked about the structured data in depth, right, and relational databases. So I hope this helps. Let me know if you have any questions. Go through this lecture a few times because I've covered very, very important concept between OLTP, OLAP, and then structured database, right? And for exam purposes as well. Hope this helps. Let me know if you have any questions with this. Let's move to the next lesson. Welcome back. So I talked about the structured data stop in the previous lecture, right? And the important concepts. But here in this lecture, I'm going to talk about the semi-structured and unstructured data stores. I'm also going to talk about how these data types are stored and what you should know when working with these data stores. So semi-structured and unstructured data are often stored in a non-relational database system, sometimes called NoSQL databases. Now, this term can cause a bit of confusion sometimes, right? But it's important to remember that SQL is a way of querying data. It implies precise structure. Non-relational or NoSQL does not mean that the data stored cannot be queried using SQL. But a better way is to think about that not only SQL, right? So let's dive deeper. It's important to be clear on the terminology because it can be quite confusing, especially for the exam purposes. Now, the first term is SQL, which is a language used to query data. Now, unfortunately, sometimes this term is referred to relational databases, which can be confusing in a discussion. For example, now when SQL is used, you have to pay close attention to determine whether the speaker is referring to SQL as a query language or SQL as a database type. So semi-structured and unstructured data can be stored in a NoSQL databases, right, which is very common for semi-structured data. Now these types of data stores can also be stored on file servers or in data lakes, which are both common for unstructured data. So for our purposes, I'm going to focus on data is stored in a NoSQL databases, right? So before moving forward, let's clarify the term NoSQL. NoSQL databases store data that has no need for relationships. A better term might be not only SQL, right? So NoSQL databases were created at a time when rapid ingestion of data from websites and online games could no longer be handled by relational database systems effectively. Just think about the times you've started to order something, right? And then decided to wait until later. Now that abandoned data in a shopping cart has to be dealt with, right? Now in a relational database, there could be dozens of records across numerous tables that would have to be deleted. But with NoSQL databases, there's a single record for your entire shopping cart. Now when you abandon your shopping cart, only that one record needs to be removed. Now this is the superpower of NoSQL databases. Let's stay focused that the relationship between NoSQL databases, right? For example, when a first customer adds a product to the shopping cart, it's stored in a NoSQL database. Now once the customer begins the checkout process, the data from the NoSQL database can then be passed to a relational database, right, for permanent storage. With data safely stored in a relational database, right, the customer completes the order and then the record in a NoSQL database can then be deleted. This partnership between database types is one way that massive e-commerce sites can meet the needs of thousands of customers every minute. So we have the basics now, right? Now let's dive deeper into how relational databases differ from NoSQL databases. The data within relational databases, right, is organized so that the values in one table can be used to further define the data in another table. In other words, a relationship exists between the tables of data themselves, right? For example, let's say you have a relational database storing product orders. There could be a table that defines all of the products that could be sold, right? Now, imagine there's another table that defines the product suppliers. So in a relational database, you can run a SQL query that shows all the data on every product and the associated suppliers, even though the data is stored in two different tables, right? Now this is the superpower of our relational databases. NoSQL databases store data in a single table. The name NoSQL indicates a form of SQL query is not required. Now this means that you can use a SQL query for data stored in a NoSQL database if you need to. Now getting back to the example, right? In a NoSQL database, all of the information, like I said, of each product, including the associated supplier, would be stored in a single item within a database table. Now that means that there's redundant data, but NoSQL databases require us to think of data storage in a new way also. Remember that we're not replacing relational databases. So instead, we're taking the tasks that relational databases aren't so good at and then moving them to databases that are better suited to them. So a lot of people struggle with the concept of data being stored in an unstructured ways. So Let's talk about some specific SQL database types. Why not, right? So NoSQL databases are built to store semi-structured and unstructured data in a way that provides for rapid collection and retrieval. Now, there are several broad categories of NoSQL databases. For example, document stores that store semi-structured data in a form of files. Now, these files range in form, for example, JSON, XML, right? You can navigate the files using many languages, including Python and Node.js. So, semi-structured files contain data stored as a series of elements. So each element or item in an instance of a person, place, thing, or event. So for example, the document store may hold a series of log files from a set of servers. Now every server is a little different and can generate log files specifically to the way it is configured. Now there's no need for every server's log file to contain the same attributes. The greatest strengths of document stores is their flexibility itself. So users don't need to plan for a specific type of data when the document store is created, and they're easy to scale also because of the lack of strict schemas. Now, it's important to note the trade-off between this flexibility because it can be a deal breaker also. Document stores sacrifice asset compliance to gain this flexibility. Remember that asset compliance is how you can guarantee the quality of the data within a relational database. Many businesses have strict requirements to support asset compliance, so pay close attention to this. Another key disadvantage to document store is that you cannot query across files. This means that although you can collect server logs from 10 servers, you cannot run a query that compares events across all 10 files without aggregating them or performing some other transformation. So key value databases are another types of NoSQL database. Now they store semi-structured data in a form of key value pairs. Logically, data is stored in a single table. Now this table contains items, and each item contains one or more attributes. Now each item must also contain a unique identifier, right, or primary key. An important distinction to make between key value tables, right, and relational tables is that key value tables are schema-less. Now this means that you do not have to specify what each attribute before you actually use it. You also have the advantage of creating nested attributes. Now these are attributes that have their own attributes, for example, right? For example, you can have an address attribute with street, city, state, and zip code, right? Nested inside. So a relational database would likely move this nested information into a different table. So let's say the business has decided that you need to start tracking the rating for each product. How would each database type need to be changed? Okay, so let's start with a relational database. And that's really the hard one, right? To add this new data, you would have to add a new column to the table. Now, once the column is added, this column would be empty, right? This can cause problems because it is common for relational databases to require values in every column. So you would have to create a process to determine the correct value for each existing record in a table. Now, once the process was completed, you could begin adding new records for the rating. All right, so any guesses for the next step with the NoSQL database? Well, no need to guess, okay? You just start adding new items with the new attributes. That's all you do. You can go back and deal with the existing records, but you don't have to do anything with them if you don't want to. And then there's the second big advantage that NoSQL databases have over relational databases. Within AWS, for example, Amazon DynamoDB is the service used for NoSQL data storage. DynamoDB is a key value and document store database that delivers single-digit millisecond performance at any scale. Now, it's a fully managed multi-region, multi-master database with built-in security, backup, and restore. And then, of course, in-memory caching for internet-scale applications. In other words, DynamoDB gives you the best of both of these NoSQL database systems. That's right. So, I've covered two types of NoSQL databases, right? But there's one more that I want to talk about, which is graph databases. Now, they're supposed to be the next big thing, right? Graph databases are really about connections and relationships. So if you have an application, for example, that is primarily focused on traversing those relationships for finding patterns in them, then a graph database is probably a good fit. So graph databases are purpose-built to store any types of data, whether it's structured, semi-structured, or unstructured. The purpose for organization in a graph database is to navigate relationships. So data within a database is queried using specific languages associated with the software tool that you have implemented. Now there's a lot to learn about graph databases, but the basics are here. They allow simple, fast retrieval of hierarchical structures, and they work well with real-time data mining. Graph databases can also rapidly identify common data points between nodes, and they're great for making relevant recommendations and rapidly querying those relationships. But they also have limitations too, right? Now, they can't adequately store transactional data, and analysts must learn new languages to query the data, and perform analytics on the data may not be as efficient as with other database types. So, let's dive deeper into the inner workings of a graph database. Suppose you want to gather information on a product, right? Or a social recommendation. Now, here in this graph, you see that Bill knows Mary and Mary knows John, right? So in addition to the information on the individual, the database can track purchase history. Now here you have a product that both Bill and Ahmed have purchased. Now you can see that Carrie also purchased this product, right? But does not know any of the other three in the graph. Now you can go a step further also and track their interests, such as their favorite sport. Now with this information, you can now see another relationship layer that can be used to make recommendations. John, for example, may be interested in what products are purchased by other customers who like sport. Mary might be interested to know how the other customers that her friends know. So, yes, and many, many more types of relationships, right? Now this graph is pretty simple, but it gives you a good idea of the potential. The AWS Graph Database Service is called Amazon Neptune. So it's a fast, reliable, fully managed graph database service that makes it easy to build and run applications that work with highly connected datasets. So I mentioned earlier that graph databases like Amazon Neptune, for example, are purpose-built to store and navigate relationships. Now these databases have advantages over relational databases for use cases like social networking, like I mentioned earlier, right? Recommendation engines and fraud detection, where you need to create relationships between data and quickly query these relationships. So, after covering so much content, right, it might be helpful to compare the database types briefly. Let's start with the representation of data within a database. So relational databases store data in tables that are related to one another, right? Now within the table, there are columns and rows which are defined by a schema. NoSQL databases store data as a collection of documents, right? Or key value pairs. Now in DynamoDB, this is represented as a table. In Neptune, this is represented as a series of nodes and relationships. So, next, now that you have the design for the data, in a relational database, a schema determines the design, right? It's normalized and dimensional and data warehouses. NoSQL databases are denormalized and have the option of using internal document structure or no structure at all. NoSQL graph databases, right, are also denormalized and are based on entity relationships. So databases are always optimized to achieve a specific goal. So in relational databases, the goal is optimized storage. In NoSQL databases, places the emphasis on compute power, and NoSQL graph databases are optimized for relationships, right? So in terms of querying data, relational databases uses a structured query language, SQL. NoSQL and graph databases both have multiple languages that can be used to query their data, and they both focus on object querying. And we can't forget scalability, by the way. As databases grow, they scale in different ways. So relational databases are very good at growing by adding more resources. Now this is known as vertical scaling, right? NoSQL databases are good at being distributed across multiple servers or instances. This is known as horizontal scaling. NoSQL graph databases are good at both types of scaling, horizontal and vertical. And finally, let's compare the likely implementation of these database types. So relational databases are commonly used as a backbone for OLTP business systems and OLAP data warehouses. NoSQL and graph databases are both commonly used for OLTP, web, and mobile applications. So non-relational databases, for example, non-relational databases are built to store semi-structured and unstructured data in a way that provides for rapid collection and retrieval. So I hope this all helps, right? Because very, very important. I've covered unstructured data, semi-structured data, right? And then the types of relational database, NoSQL, and then graph database in depth. So let me know if you have any questions. Go through this lecture a few times so you understand the concepts, make notes, and then with this, let's move to the next lesson.
Hi everybody, and welcome to this lesson on the Relational Database Service, or RDS, that is offered by Amazon Web Services. So the RDS makes it really easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks such as hardware provisioning, database setup, patching, and even backups. It frees you to focus on your applications so you can give them the fast performance, high availability, security, and compatibility they need in order to provide superior service to either your internal employees or your customers. Now, the RDS is available on several database instance types, either for optimized memory, for performance, or I/O, and provides you with 6 familiar database engines to choose from, such as the Amazon Aurora, the PostgreSQL, MySQL, MariaDB, Oracle Database, and the Microsoft SQL Server. And Amazon also has a database migration service which allows you to easily migrate or even replicate your existing databases to Amazon RDS. So they've made it very easy for you to start utilizing RDS in a simple and easy fashion. So let's go ahead and take a look at some of the advantages and benefits that RDS has. So first and foremost, it is extremely easy to administer. It makes it very easy to go from project conception to deployment. You can use the RDS Management Console, which we will look at when we go through the demonstration, or the command line interface to access capabilities of a production-ready relational database in a matter of mere minutes. So there's no need for infrastructure provisioning and no need for installing and maintaining a complex database software. It's also highly scalable. Like most of the AWS offerings, the RDS is extremely scalable and utilizes the global infrastructure that AWS has. It's also available and durable because it runs on the same infrastructure. It's extremely fast and it supports the most demanding database applications. You can choose between 2 SSD-backed storage options, one optimized for high performance OLTP applications, and the other for cost-effective general purpose use. In addition, when we look at the Amazon Aurora a little bit closely, it provides performance on par with commercial databases at 1/10 of the cost. The RDS also makes it easy to control network access to your database. The RDS lets you run your database instances in a virtual private cloud, which enables you to isolate your database instances and to connect to your existing IT infrastructure through an industry standard encrypted IPsec VPN. The engine types offer encryption at rest and encryption in transit. Lastly, it is extremely inexpensive when compared to other options. You pay very low rates and only for the resources you actually consume. In addition, you can benefit from the on-demand pricing that comes with AWS, which allows you no upfront or long-term commitments or even lower hourly rates if you want to use the reserved instance pricing. So let's go ahead and take a closer look at the 6 different instances that are offered by Amazon. So the PostgreSQL has literally become the preferred option, the preferred open source relational database for many enterprise developers and startups. Now, RDS makes it easy to set up, operate, and scale deployments of PostgreSQL in the cloud. With RDS, you can deploy scalable deployments in minutes with cost-efficient and resizable hardware capacity. It manages the complex and time-consuming admin tasks such as the software installation and upgrades, storage management, replication for high availability and read throughput, and backups for disaster recovery. Now, the RDS for PostgreSQL gives you access to the capabilities of a familiar PostgreSQL database engine. This means that the code, applications, and tools you already use today with your existing databases can be used with the Amazon RDS. So with just a few clicks in the Management Console, you are able to deploy a PostgreSQL database with automatically configured database parameters for optimal performance. Now, once provisioned, you can literally scale it up to 16 terabytes of storage and 40,000 IOPS. And the RDS for PostgreSQL also enables you to scale out beyond the capacity of a single database deployment for read-heavy database workloads. Now, MySQL is the world's most popular open source relational database, and RDS makes it easy to set up, operate, and scale the MySQL deployments in the cloud. It frees you up to focus on the application development by managing time-consuming database admin tasks such as it did with the PostgreSQL. It supports MySQL community versions 5.5, 5.6, 5.7, and 8.0, which means that the code, applications, and tools you already use today can be used with RDS. It also comes with the standard backup and recovery that Amazon Web Services offers, along with the high availability and read replicas, which makes it easy to elastically scale out beyond the capacity constraints of a single database instance. Additionally, the RDS provides Amazon CloudWatch metrics for your database instances at no additional charge, and the RDS Enhanced Monitoring provides access to over 50 CPU, memory, file system, and disk I/O metrics. Lastly, just as with PostgreSQL, you are given an isolation and security with the utilization of a Amazon VPC or through the Amazon Key Management Service. Now, the MariaDB is not as popular as the PostgreSQL or MySQL, but it was literally created by the original developers of MySQL. And it's got most of the same benefits that are given in the other database engines that come with RDS. One main one that I want to point out is the high performance. So you can provision, again, up to 16 terabytes of storage and 40,000 IOPS per database, and select instances with up to 32 CPUs and 244 GB of memory. So it's a very easy option to deploy a MariaDB if that is what you are using on-prem, and have it deployed on an AWS infrastructure, which allows you to not only scale it out, but give away some of the administration tasks to Amazon Web Services, such as the fault tolerance or such as the backups.
Welcome back. Let's talk about the data veracity, right? So the ability to make good decisions, for example. So the Datadog said that bad data cost US more than $3 trillion each year. Now that's something data engineers and data analysts must be aware of. Now, this challenge is known as data veracity. Data veracity is the degree to which data is accurate, precise, and trusted. Now, data must be properly cleansed and curated so that reports from that data are accurate. Now, that's the only way business can make good decisions from their data. But there's another side to this as well. Now, many businesses have a huge amount of data that's just collecting dust in databases, right? And on file servers. This is the lost opportunity to gain value. Now, that's different from a loss from analyzing bad data, by the way, but it's just as bad for businesses. Now, this is what really interests me, right? So going back to, if I were to look at a list of, let's say, tables or, different rows and columns, right? It's difficult sometimes to take a look at data and then understand, right? The truth is that the companies have known for years that this veracity problem exists. Now, they even know how to solve it, but they have not invested the time, money, or resources to fix it. They can write applications that have built-in protection, right? Build analytic systems that perform extensive cleansing and hire talent that curates and evaluates the data on a regular basis. So here, I'm going to talk about and give you many important areas that relates to data veracity. So when you have data that is ungoverned, right, coming from numerous dissimilar systems and cannot curate data in meaningful ways, you have a veracity problem. Let me give you some basic yet important definition. First is curation, which basically is the action or process of selecting, organizing, and then looking after the items in a collection. Second term is data integrity, very important, which is the maintenance and assurance of the accuracy and consistency of data over its entire life cycle. And third is data veracity, which basically is the degree to which data is accurate, precise, and then trusted. So let's talk about the problem of veracity, right? Now, we know that data changes over time. As it is transferred from one process to another and through one system to another, there are opportunities for the integrity of the data to be negatively impacted. Now, you must ensure that you maintain a high level of certainty that the data you're analyzing is trustworthy. So, data veracity is contingent on the integrity of the data. So, what is data integrity itself, right? Now, as the name reads, data integrity is all about making sure that your data is trustworthy. Which means, does it have integrity, right? Was the entire data chain secure and uncompromised? So understanding the full life cycle of your data and knowing how to protect it effectively will greatly strengthen the integrity of your data. Now, having high data integrity means that the data source is reliable for planning, decision-making, and then operations. Now, this is the goal of every data source that businesses use. However, not all data is generated equally, by the way. So data integrity is a broad term that is applied in different ways in each phase of the data lifecycle. Now, this lifecycle includes creation, aggregation, storage, access, sharing, and archiving. So, in the creation phase, data integrity means ensuring data accuracy. Now, this involves a certain amount of trust in the system that collects the data. Now, relational databases use asset compliance to enforce data integrity. Now, making sure that your data is accurate requires regular audits of your software systems to confirm two things, right? First, they're producing valid data or files, and that changes won't negatively affect the system's integrity. Now, aggregation is the next phase. Now, data isn't always aggregated, but it's a key phase for many analytical systems where metrics must be well defined. So data integrity in this phase ensures that the user gets the value they expect from the aggregate provided to them. So the loss of integrity in this phase is often the result of poor naming, aggregate values, and poor planning on the part of the developer in meeting the needs of the user. So in the storage phase, data integrity is about maintaining the data in a secure form and making sure all changes are accurate. Some data is highly volatile, meaning it is subject to frequent change, while other data is stable and does not change. So securing data means that ensuring stable data does not change and that volatile data can only be updated by authorized users and services. Now, in the access phase, your data becomes visible to users, right? At this stage, data is provided in a read-only format. Now, this means there are no changes allowed to the data, and data's integrity cannot be changed. Now, data integrity at this phase is a proof of the integrity of all the other phases because the end users are looking at it. This is for business analysts that begin to query the data they use to populate the data for reports and dashboards. Now, this leads to the sharing phase. Once reports and dashboards have been created, now you are going to share among businesses, among stakeholders. So much like the access phase, data is read-only at this phase as well. So data integrity is simply proven to be good or suspected or to be good at this stage. Now, there will come a point where data no longer has value. Now, this is where the archiving phase comes in. So at this point, data integrity is about ensuring proper archiving. Now, you could delete the data, but more commonly, you would aggregate it into another form and discard the original. For example, once an individual, sales records is 10 years old, its data might be aggregated into daily or monthly totals, right? While the original record would be discarded. Now, when you have taken steps to ensure high data integrity across each phase, you'll be ensuring the trustworthiness of the data. In other words, you'll have a high veracity system. So beyond the life cycle of data, there are also concerns surrounding the integrity of the data, both internal to your organization and external to the organization as well. Now, within internal data sources, you may be able to make recommendations for improvements if you notice integrity concerns. With external data sources, such as Census Bureau data sources, for example, you'll need to identify the integrity of the data and perform transformation to the data in situations where accuracy or precision issues are identified. Now, hope this helps. Talked about the data lifecycle, the different phases, and more importantly, data integrity and how it relates to the veracity problem. I hope this helps. Let me know if you have any questions. With this, let's move to the next lesson. Welcome back. So I'm going to talk about common data issues in this lecture. So in the data that needs to be ingested into your data analysis solution, right, there's a possibility that the data may contain some form of data corruption. So corrupted data can include incomplete entries, entries that violate business rules, or random values that have been entered into the records or files. Now, during the ingestion phase, it is recommended that you perform data cleansing to remove these corruption. Now, data cleansing is the process of detecting and correcting corruption in data, whether it's in a record, table, or database, or a file. Now, data cleansing is applied as part of an ETL operation. Now, each time data is pulled from the source, it will be evaluated and cleansed by the ETL operation all over again. Now that we have talked about data cleansing, right, the next concept is how data integrity is enforced. Now, when it comes to ensuring data integrity, database schemas are your main line of defense. So a database schema is used to organize objects and enforce integrity constraints such as relationships. The database schema also defines attributes of the database, providing descriptions of each object and how it interacts with other objects within a database. Logical schemas are often created to help analysts understand how data flows in a database. Now, these schemas depict tables and views alongside the relationships that connect them to one another. Now, this information is valuable when you're writing queries, right? Now, basically, logical schemas help analysts write good queries. Information schemas also help databases provide data to those queries as well. Now, this kind of schema is a database of metadata on every object in a database. Now, this metastore also contains statistics on the distribution of data within tables, indexing, and partitioning of the data. Now, these three factors are considered when the database executes a query. So, managing, maintaining, and navigating these schemas can be time-consuming, and it can also be a challenge to optimize hardware and software performance and integrity. This is where AWS comes in, right? Managed services like Amazon RDS, Amazon Redshift, and Amazon DynamoDB can take care of that for you. Now, these services can enforce schemas and optimize database performance. For example, Amazon RDS database instances, right, are pre-configured with parameters and settings that are appropriate for the engine and class you have selected. You can launch a database instance and connect your application within minutes. Now, data cleansing and enforcing data integrity are not the only factors that should be considered when evaluating the veracity of your data. So, I'm going to talk more about this later on also, right? How they enforce compliance. But let's take a look at some more important terms here first. First, data cleansing, which is a process of detecting and correcting corruptions within data. Now, referential integrity is a process of ensuring that the constraints of table relationships are enforced. Domain integrity is a process of ensuring that data is being entered into the field that matches the data type defined for that field. And entity integrity is the process of ensuring that the values stored within a field match the constraint defined for that field. And identifying data integrity issues, right, are important to know, because as a data analyst, you may be called upon to perform data integrity checks. Now, during this process, you'll be looking for potential sources of data integrity problems. Now, data can come from both internal and external sources as well. Now, it is highly unlikely that you'll be able to take a look at data that is generated outside of the business, right? You can't control it. But within your business, you may have the ability to make recommendation on improvements of the data sources that you'll be interacting with. Now, when changing the way source systems are ingesting data is not an option, right? It is often the responsibility of the data engineer or the business analyst, right, to check the integrity of data source and make adjustments to account for any areas where the source may be lacking integrity. So, here comes the best practices, right, for data cleansing. First is to know what clean looks like, right? Now, before you do anything else, come to a consensus on what clean looks like for your project. Now, that might mean data in its raw format with business rules applied. It could also mean that data that's been normalized, aggregated, and has value substitutions applied to regulate all entries. Now, these are two very different definitions of clean, right? Next, you need to know where the errors are coming from. So as you find errors, trace them back to their sources. Now, this helps you predict which data loads have integrity issues, right? And improve the efficiency of ETL operations. Know what acceptable changes look like, for example, right? Looking at data values, right, without context can lead to big problems. For example, let's say you're, cleaning a student scores table, right? Entering a 0 in a column that is empty may seem like an easy data cleansing decision, but beware of the effects of this change. A 0 in a student score column will negatively affect the student's average, where a blank will not, right? So likewise, combining unordered or stock inventory numbers for monthly reports may seem inconsequential. However, that data may get into the hands of an inventory manager who now believes that there's an inventory loss problem. Now, these are the small examples and details that can make a huge negative impact, by the way. So finally, you must know where the original value has important value. For example, in some systems, the original data is no longer valuable once it's being transformed. But in highly regulated data or highly volatile data, it is very important that both the original data and the transformed data are maintained in the destination systems. For example, in an online gaming system, right, there may be no value in recording every direction that the player makes on the map, right? The only important value is when the player enters or exits the key areas of the map. So in a different application, for example, like the banking app, right? All details of every transactions are vital for auditing, even though a customer may only care to see if their transaction was successful or not. Now, I've briefly talked about database schemas, right? So relational databases rely upon database schemas to organize the content within the database and to enforce both referential and domain integrity. So programmers, developers use these schemas when writing software, right, to interface with the database. So a data schema is a set of metadata used by the database to organize data objects, right, and enforce integrity constraints. Now, the schema defines the attributes that the database, providing descriptions of each object, for example, and how it interacts with other objects within the database. Now, one or more schemas can reside on the same database, by the way, right? Now, there are two types of schemas, logical and physical. Now, logical schemas focus on the constraints to be applied to the data within a database. Now, this includes the organization of tables, views, and integrity checks. Tables and views can be related to one another. Now, the schema defines the information for each relationship and how it is to be enforced. The schema can also provide domain integrity by defining constraints on the values allowed in specific fields within the table, providing domain integrity. Now, integrity checks come in different forms, by the way, but the goal is to ensure that any changes made to the database will not result in a loss of data consistency. Physical schema, on the other hand, they focus on the actual storage of data on disk or in a cloud repository. Now, these schemas include details on the files, right? Indices and partition tables, clusters, and much more. Now, data engineers often use physical schemas, right, to calculate estimates on the storage space needed and potential growth of the system. Now, these schemas are also important for disaster recovery and infrastructure planning. Then, there's also information schemas, by the way. Now, have you ever wondered how DBMS manages all of the databases, tables, and relationships? Well, the answer is found in the information schema. An information schema is a database of metadata that houses information on the data objects within a database. Microsoft SQL Server has all the information, right? Has the schemas in the master database. Oracle uses, for example, data dictionary tables and a metadata registry. Apache Hadoop uses a metastore, right? Each DBMS may have different names, but the data structure primarily is pretty similar, right? And the purpose is the same, to define where all of the objects in the database are, record vital information about them. Now, these databases store information such as the name and size of the table, the indexes on the table, and the constraints on data in a table. So, security settings for users in terms of external data assets and management settings, right, can also be included. Now, given the proper permissions on the database, you can query the information schema to learn about the object within a database. Now, when queries are processed, this information is used to ensure the best optimization for the query itself. Now, the information schema can also be used in a maintenance of the database itself, right? So I hope this helps. I've talked about different areas of common data issues that you have to be aware of as a data engineer, right? And of course, the solutions that I've in depth talked about. Let me know if you have any questions with this. Let's move to the next lesson. Welcome back. In this lecture, I want to talk about a very important concept called database consistency, right? So when data is stored as files, consistency is controlled by the application that is developing the files. Now, when data is stored in a database, consistency is the responsibility of the database that is housing the data itself. Now, here I'm going to discuss two methods that how databases implement ACID and base, ACID and base, right? So, let's see how we can enforce high veracity. Now, data can be stored in many different ways, but for now, I'm going to focus on data stored within a relational and non-relational, often called NoSQL databases. So in the previous lecture, I've already talked about how to check and enforce data integrity, right? Now, another key factor to Veracity is the ability to ensure compliance for the consistency and availability of data within a database. Now, there are a few different methods for this. First, I want to talk about the two, right? Like I mentioned, the ACID and base. Now, these two methods are very different in how they enforce consistency and availability of data. So let's start with ACID first, which stands for atomicity, consistency, isolation, and durability. Now, ACID is the most common way to achieve and maintain data consistency and availability in a relational database. So in a database like Amazon RDS, for example, a sequence of operations is called a transaction, right? Now, millions of transactions can be performed consecutively. Changes to the data are very common, and so are the constraints on the data. The goal of an ACID compliance database is to return the most recent consistent version of all data and to ensure that all data in a system meets all rules and constraints of all times. Now, this process introduces latency into the system, which must be accounted for. Now, all of these properties, atomicity, for example, consistency, isolation, and durability, ACID, work together to enforce integrity through consistency and availability in a relational database. Many regulations require businesses to implement ACID compliance databases. Now that you have briefly understood ACID, right, into a relational database, let's talk about how consistency is enforced in NoSQL databases, right? So many of these NoSQL choose not to enforce ACID consistency, but why is that, right? Well, it comes down to the fact that ACID consistency is most concerned about the absolute consistency of all data. Now, enforcing this consistency takes time. This is time that many NoSQL databases cannot afford if they are to meet the demands of the applications using them. Now, this is where base consistency comes in. Now, base is an acronym for basically available soft state, eventually consistent, right? It is a method for maintaining consistency and integrity in a structured or semi-structured database. Now, base consistency is most concerned about the rapid availability of data itself. Now, base is commonly implemented for NoSQL databases and distributed systems and on unstructured data stores. To ensure availability, changes to data are made available immediately on the instant where the change was made. But it may take time for that change to be replicated across all instances. So eventually, the change will be fully consistent across all instances. Now, in both ACID and base consistency methods, it is the database that implements consistency rather than the application being used to access the data. The process of enforcing consistency is hidden from the users, right, to offer a clean, predictable experience with the data itself. Now, I'm going to talk more about ETL in the next lecture, but here let's focus on these two methods. First is ACID. Let's dive deeper. So, like I said, is atomicity, consistency, isolation, and durability. Now, it is a method for maintaining consistency and integrity in a structured database. Now, ACID compliance really means that it is a long-standing bastion of data integrity, by the way, right? So in a database such as Amazon RDS, a sequence of statements processed together is called a transaction, like I mentioned earlier, right? Now, millions of transactions are performing on a regular basis, consecutively. So the data and the constraints on the data are very active in a relational databases. Now, the goal of an ACID compliance database is to return the most recent version of all data and to ensure that all data entered into the system meets all rules and constraints assigned at all times. So, like I said, right, the A stands for atomicity, okay? Now, transactions can contain multiple statements or instructions. Atomicity ensures that all statements either succeed together or fail together. No one statement can succeed without the others. The C stands for consistency. Now, For a transaction to complete successfully, all of the statements within must meet all of the constraints set in a database. Now, if any single statement violates these checks, the whole transaction is rolled back and the database returns to its previous state. Now, this also ensures that data updates are not made available until all replicates have been updated as well. The I stands for isolation. Now, isolation ensures that one transaction cannot interfere with the other concurrent transaction. Databases are busy places, right? Because isolation ensures that when multiple transactions request the same data, the data isn't corrupted as a result. Now, isolation means that there are rules in place governing data changes, right? And it's a little like a turnstile, right? For example, if two transactions want to update the same record, one must wait till the other completes or fails. The D stands for durability. Now, data durability is all about making sure that all your changes actually stick. Now, once a transaction is complete, durability ensures that the result of the transaction is permanent, even if there is a system failure. Now, this means that all completed transactions that result in a new record or an update to an existing record are written to storage and do not remain in memory only. Now, many regulations require businesses to require ACID-compliant databases. But in a world where unstructured data exists, non-relational data exists, and distributed systems are taking up ever-increasing percentages of a business data consumption, another option is also necessary. This is where base comes in, right? Which is basically available soft state, eventually consistent base. It is a method for maintaining consistency and integrity in a structured or semi-structured database. Now, base compliance, right, means that it supports data integrity in non-relational databases, which are sometimes called NoSQL databases. So non-relational databases like Amazon DynamoDB still use transactions for processing requests. Now, these databases are hyperactive, right? And the primary concern is the availability of the data over the consistency of the data. Now, to ensure the data is highly available, changes to data are made available immediately on the instance where the change was made. But it may take time for that change to be replicated across the fleet of instances. The aim is that the change will eventually be fully consistent across a fleet. Let's break this down further, right, and dive deeper into what base is. So the B stands for basically available. Now, this lets one instance of the database receive a new record or update an existing record, right, and make that change available immediately for that instance. So as this change is replicated across all the other instances will eventually become consistent. Now, in an ACID system, the change would not be made available until all instances were consistent, right? And that's the key right here. In a base system, complete consistency is traded for immediate availability. Eventually, you get complete consistency and availability in both consistency models. Now, the difference is which comes first, right? The S in base stands for soft state. Now, in a base system, there are allowances for partial consistency across instances. Now, for this reason, base systems are considered to be in a soft state, also known as a changeable state. Now, to contrast this, in an ACID system, the database is considered to be in a hard state, right? Because users can only access data that is fully consistent. The E in base stands for eventual consistency. I talked about earlier, right? Eventual consistency means that the change is available immediately in one instance, and the change will be eventually made to every copy. Now, in the meantime, the data is always available in some form, right? New or the old. So, let me give an example. Amazon DynamoDB transactions, for example, they use ACID. Now, back in those days, Amazon introduced Amazon DynamoDB transactions, right? Now, these features implement ACID compliance across one or more tables within a single AWS account and region. Now, you can use transactions when building applications that require coordinated inserts, right? Deletes or updates to multiple items as part of the single logical operation. So I hope this helps. I've covered extensively the ACID concept and the base concept, right? Where database consistency is ensured. Let me know if you have any questions. With this, let's move to the next lesson.
Hi everybody, and welcome to this lesson on looking at what do we mean when we say if something is serverless. So let's look at what is serverless. So conventionally, applications were written and run in servers which were allocated fixed resources, such as hardware. So what happened was there were a lot of problems with sudden spikes of traffic. So let's say if the demand increased and servers were not available to handle the enormous amount of data. And with the ever-growing globalization, when somebody's launching an online website, you might see great spikes in data. So that in that traditional sense, there were issues in terms of handling the hardware, or how can that hardware handle all of that spikes in traffic, both up and down. So to address that, that's where came the platform as a service, or PaaS, in which basically providers offered scaling, but it had its drawbacks compared to serverless architecture. So let's look at serverless. So in a typical stack, most of the time the CPU remains idle because the server is busy with networking and input-output requests. So these drawbacks are basically what's handled by serverless architecture. When I say serverless, I certainly do not mean that there are no servers involved. Serverless does involve servers, only the implementation and management is different. So traditional servers or compute instances had fixed resources that run all the time and need administrators to manage them. In a serverless architecture, on the other hand, it's basically run in compute instances that are event-driven. So what basically means is that each event or request to the server, a state is created, and after the request is served, the state is automatically destroyed. So unlike typical servers, serverless provisions are completely managed by the provider using automated systems that eliminate the need for server administrators. And in the architecture, you have short-lived functions that are invoked upon each request, and the provider, for example, would build a client for each individual function or logic. So that's where basically the term FaaS, or function as a service, came in. So FaaS provisions allow running code without the need to manage the server system and server applications. And you will see that when we go through the labs later on in this course. So basically, what's the difference between third-party managed servers and FaaS? Now, both seem the same, as you don't need to manage the server system in either of them. So the fundamental difference is that in FaaS, you also do not need to manage server applications, which were not possible in typical systems. So let's take an example. So let's say you have a social media application. So as users interact with the site, the application collects behavioral data and processes them in a dedicated server to learn more about the users and provide relevant data. Now, the server is only dedicated to machine learn those behavior patterns. So in the case of FaaS, it is replaced with functions that do not require that physical server to run and can be executed among other functions in a shared pool of resources. And there's also another advantage to this architecture. You, for example, do not need to code your app to any particular framework or library. Any language can be used. And what's even more interesting is that FaaS functions written in different languages can interact with each other. So multiple functions can be connected and chained together to implement reusable and composable systems. So now all of us might be familiar with IaaS, CaaS, and PaaS. So now we're going to add in FaaS, or FaaS. So just to briefly give you an overview, so infrastructure as a service, or IaaS, it basically provides only the base infrastructure, the virtual machine, the storage defined network, storage attached. So end users have to configure and manage platform and environment, deploy applications on it. So as you guys can see, in the blue is what's handled by the organization, such as AWS, and the rest is handled by the organizations themselves. And one that you do not see on here is also software as a service, or SaaS. And sometimes people also call it on-demand software, which is typically accessed by users using thin client via a web browser. So for example, Microsoft's Office 365 is considered a SaaS platform, or if you're using Gmail, is also a SaaS platform. Then you have PaaS, which is platform as a service. So that basically provides a platform allowing end users to develop, run, and manage applications without building and maintaining the infrastructure. So everything, all of the infrastructure, the containers, the OS, the hardware is all handled by third-party organizations such as AWS. Now, what I also have on there is container as a service. It's being used more and more nowadays. It's basically a form of container-based virtualization in which container engines, orchestration, and the underlying compute resources are delivered to users as a service. So for example, in AWS, you have the Elastic Compute Services, or ECS, or you have in Azure, you have the ACS, and Google also has your container engine, the GKE. So after all of that is when we come to the last stack, which is FaaS, Function as a Service. And that, like I mentioned, it provides a platform allowing customers or users to develop, run, and manage application functionalities without having to deal with the complexity of building and maintaining the entire infrastructure. So the only thing you're dealing with are functions, and everything else is handled by the third-party service providers such as AWS. So let's look at both advantages and disadvantages of using FaaS. So some of the advantages, for example, you have fewer developer logistics. Server infrastructure management is handled by someone else. Then you have more time focused on writing code or app-specific logic, which means higher developer velocity. And it's also inherently scalable. So rather than scaling your entire application, you can scale your functions automatically and independently with usage. And very important, especially for management, you never pay for idle resources. It also has built-in availability and fault tolerance, and business logic is necessarily modular and conform to minimal shippable unit sizes. But it's not all on the upside. There are also some disadvantages of using this. For example, you have decreased transparency. So someone else is managing your infrastructure, so it can be tough to understand the entire system. It's also potentially tough to debug. And there are tools that allow remote debugging, and in some services provide a mirrored local development environment, but there's still a need for improved tooling because it is a very, very new service. Then there's also auto-scaling, or function cells often mean auto-scaling of costs. And again, that can also increase your expenses. And then you also will have a ton of functions deployed, and it can be very tough to keep track of them. So this comes down to need for better tooling in developmental, diagnostics, and visualization. So it can be managed, but again, you need to plan for it accordingly. And then lastly, solutions for caching resources between stateless requests, such as DB connections, and recycling network requests are still pending, meaning they're still in the development stage for this service. So FaaS really isn't a solve all problem kind of service. It is still fairly new, but the advantages that it offers far outweigh the disadvantages for some business cases, not for all. Hi everybody, and welcome to this lesson on looking at ElastiCache service that is provided by AWS. So a lot of us might not be familiar with ElastiCache or what it does. So ElastiCache is basically a service in which you can very easily deploy, run, and scale popular open source compatible in-memory data stores. So kind of like what the name says, ElastiCache, you're caching in memory. So it's basically a fully managed Redis and Memcache, which allows you to again deploy in-memory data stores. So it allows you to build data-intensive apps or improve the performance of your existing apps by retrieving data from high throughput and low latency in-memory data stores. So it's a popular choice for, let's say, gaming or ad tech or financial services and even IoT apps. So the benefits again are immense. First and foremost, extreme performance. So again, it works as an in-memory data store and cache to support the most demanding apps that require sub-millisecond response times. So again, by utilizing an end-to-end optimized stack running on the dedicated nodes, it provides secure and extremely fast performance. It's fully managed, so you no longer need to perform management tasks such as hardware provisioning, software patching, setup, configuration, monitoring, and so on. It continuously monitors your clusters to keep your workloads up and running so that you can focus on the higher value application deployment. And lastly, scalable. Again, you can scale out, scale in, scale up to meet the fluctuating demands of your organization or of your application. You can write, and memory scaling is supported with sharding, and replicas provide read scaling. Lots of options, lots of benefits for utilizing ElastiCache if, for example, you have those memory-intensive applications or use cases. This is a very, very good service and powerful service which is offered by AWS. Now, how it works in terms of how it interoperates within your environment. So let's say you have internet scale applications, whether you're using gaming, media streaming, social media, any app or any service that requires fast data access. This is where ElastiCache comes in because it has a in-memory data store for use as a database, cache, message broker, and a queue. So you can store ephemeral data in memory for sub-millisecond response. Because if, for example, you had all that data stored in a database, whether it's Aurora, whether it's SQL, the time and the response would be considerably slower as compared to ElastiCache. And again, some of the use cases are real-time transactions, chats, your business intelligence, your analytics, because users nowadays, they require fast access or fast response. And if there's a delay, and even if there's a second delay between your service and your competitor's service, they're most likely going to go to your competitor. And you have to utilize a lot of the new hardware, new technology that allows this response to be considerably slower. And especially if you have millions of requests coming in every second or every minute, a database handling all those requests is going to be considerably slower as compared to if you were to use an in-memory data store such as ElastiCache. So the two main engines that are supported by ElastiCache are Redis and Memcached. Now, Redis is basically a data store that provides sub-millisecond latency to power internet scale real-time applications. It's built on an open source Redis and compatible with Redis APIs. ElastiCache for Redis also works with your Redis clients and use the open data format to store your data. So the self-managed Redis applications can work seamlessly with ElastiCache for Redis without any code changes because it combines the speed, the simplicity, and the versatility of the open source Redis with manageability, security, and scalability from the Amazon to power the most demanding real-time apps. The other one is Memcached, which is a Memcached compatible in-memory key value store service that can be used as a cache or a data store. So it delivers the performance, ease of use, and simplicity of Memcached. It's fully managed, scalable, and secure, making it an ideal candidate for frequently accessed data which must be in memory. Again, it's a very popular choice for web, mobile apps, for gaming, for ad tech, and for e-commerce. It just depends on which platform you are using or which technology you are using would determine whether you use Redis or whether you use Memcached. Now here are a few differences that allow you to choose which one you are going to be using for your organization or for your application. Most of the organizations use Redis, but there are times when you use Memcached, and a lot of organizations also use Memcached. So again, this depends on your infrastructure, your deployment, your expertise, but this table just basically gives you a good overview in terms of what features are offered by which one. The main one, again, that you guys need to see is that Memcached is multi-threaded architecture, whereas Redis is not. So that is the only primary difference or advantage that Memcached would have over Redis, but again, depending on the application that's developed or use case, will determine which one you are going to use. Now, some of the use cases for Redis, I just wanted to take you through a couple of them just to give you a snapshot of how it can be used. So one is caching. Is a great choice. Redis is a great choice for it. Again, implementing highly available, distributed, and secure in-memory cache. Again, it allows you to decrease the access latency, increase the throughput, and ease the load off your database. And it can serve frequently requested items at sub-millisecond response times and enables you to easily scale for higher loads without growing the costlier backend databases. So if you were relying solely on your backend databases, you'd essentially have to grow or scale out the databases, which is a lot more costly than using Elasticache. There's also one for chat messaging because it supports PUB and SUB standard with pattern matching. So this allows it to support high performance chat rooms, real-time comment streams, and even server intercommunication. And you can also use those to trigger actions based on published events. So you can basically build a chat application that utilizes Redis and Elasticache in order to increase or decrease latency and increase the throughput. So it's basically providing a better user experience for the users that are going to be accessing the chat. This comes in very handy, for example, in examples you guys see in either stocks, in finance, or in sports. So let's say there's a big sports game going on, and users are going to be chatting a lot more because there's a couple million users, or tens of millions of users logged in to view that event, whether it's the Olympics, whether it's the Super Bowl, whichever sport that you are going to be watching or hosting. This would be a very, very good tool to use to provide that sub-millisecond response to the end users. For Memcached, just quickly, again, two of the main use cases for Memcached are either caching or a session store. So a session store are easy to create with Memcached. You can simply use the hash table that is provided by Memcached and can be distributed across multiple nodes. And scaling the session store is as easy as adding a node and updating the clients to take advantage of the new node. So those are two main use cases for using Elasticache for Memcached, where you have the end user, you have the web server, you have the Memcached working as an in-memory data store in between the database. So essentially that's where Memcached is used. So again, depending on what your use case is, whether you are in a high performance environment such as chat messaging between financial markets or IoT or gaming, Redis would be more suited for your environment. If you are more on a web server environment trying to ease the load off your database, then Memcached would probably be better suited for your environment. Hi everybody, and welcome to this lesson on Amazon AppStream. So we're going to take a quick overview and take a look at what is offered by the application stream that is offered by AWS in terms of the service. So this is a pretty neat feature that is offered by AWS because it allows you to fully manage your application streaming service. So you can centrally manage your desktop applications on this AppStream 2.0 and also securely deliver them to any PC within your entire network, whether it be local or globally. You can easily scale to any number of users across the globe, and the best part about it is you do not need to acquire, provision any kind of hardware or infrastructure in order to do it, because you can utilize the AWS's infrastructure that they have spanned across the globe. And we'll take a look at that and the benefits coming up in the next slide. So overall, this is a very, very good service. A similar thing is offered by the Windows, in which it allows you to distribute your applications throughout your network. But if you are looking to go towards the cloud, this is a very good service to utilize, and you can piggyback off of the AWS infrastructure that they have spanned across the globe. So looking at some of the benefits that are offered by the AppStream 2.0. First and foremost, deliver the desktop applications, again, to any PC. The applications can be accessed by the users anytime they need it. And the AppStream 2.0 streams the applications from AWS to any computer, which includes, it can be a Mac, it can be a PC, it can even be a Chromebook. Next benefit is you can scale without infrastructure or scalability, because it's a fully managed service provided by AWS. And the good thing is you can use the AWS's pay-as-you-go pricing. So you only need to pay for what you use, and you can easily scale your application streaming to any number of users across the globe, again, without acquiring any kind of hardware or additional software in order to do so. Next is the secure applications and the secured data. Because the applications and the data are not stored on the user's computer, it makes them more secure. They're streamed as encrypted pixels and access data secured within the network, because again, it runs on the AWS infrastructure, so you can rest assured and benefit from the data center and network architecture that AWS has built throughout the globe. It also provides a very fluid and responsive user experience, because each user's application is highly responsive because they run on virtual machines which are optimized for their use cases. Now, I've seen a lot of organizations that are running older hardware, but they want to use some of the newer software, and instead of upgrading their 50 or 100 users to use new hardware, they kind of force the application to run on old hardware, which kind of ruins the user experience. The best part about this is, since the application is not running on the user's hardware, you can provision virtual machines which are optimized to whatever software you're using, which again makes the user experience a lot better. The last two benefits are very, very positive for the IT managers especially. You can centrally manage applications, and it can be seamlessly integrated within your IT infrastructure. So each user basically can access the same version of your application, and you can centrally manage which versions are available to which users. Additionally, it connects to the Active Directory, the network, your cloud storage, or even your file shares. So users access applications using their existing credentials, and their existing security policies are used to manage the access. So that's the best part about this is there's no added headache or no added configuration that you need to do. For example, you don't need to add the users, you don't need to create permissions. You can seamlessly integrate this within your Active Directory infrastructure, so all of that can be carried over into this AppStream. Now lastly, the way it works is fairly simple. There's no rocket science in terms of the way it operates. It just makes your life a lot easier. So for example, the first step is you would install the applications the same way you would on any computer, but the different thing is you're doing it on the virtual machine. It connects to your existing identity. Again, if you're using Active Directory, it connects to that. Or you can also use the built-in user management and persistent storage that's offered by AppStream 2.0. So for example, if you do not want to connect it to your internal Active Directory, if you don't want to have that integration, there is a separate user management that is offered by AppStream 2.0. So after that's done, you're going to use the dashboard on AWS to centrally manage the applications and provide that fluid user experience to the users, which again would securely access the application as though, and most of the time they don't know the difference, or they will not feel the difference if the application is not installed locally, if they're accessing it via the cloud. So all in all, this is a very, very good service to utilize, especially if you are deploying lots of applications in a distributed environment. If you're globally diverse or you're geographically diverse, this is a very, very good thing, a good service to use to deploy and manage your applications. Hi everybody, and welcome to this lesson on looking at the Amazon Guard Duty. Now, in today's environment, it's very important. Security is very important, especially cybersecurity. So Guard Duty basically protects your AWS accounts and workloads with intelligent threat detection and continuous monitoring. Now, it's very important that we employ some type of security measures and monitoring measures to ensure that our environment is secure from malware and from viruses, especially if you are working in a sensitive environment. When you're dealing with financial data, it becomes more important. But regardless of what type of organization you are, you still need to have some type of malware and virus protection along with continuous monitoring. So let's take a look at how Guard Duty helps us do that. It's basically a threat detection service that continuously monitors for malicious activity and unauthorized behavior to protect your accounts and workloads. Now, with the cloud, the collection and aggregation of account and network activities is greatly simplified, but it can still be very time-consuming for security teams to continuously analyze the logs and the potential threats. So with Guard Duty, you can basically have an intelligent and cost-effective option for continuous detection in the entire AWS cloud. So it uses, the best thing about it is it uses machine learning, anomaly detection, and integrated threat intelligence to identify and prioritize potential threats. So it's more than just an antivirus or anti-malware service. It's essentially a smart service that monitors your entire workload and your entire network. It analyzes tens of billions of events across multiple data sources such as CloudTrail, your flow logs, your DNS logs, and with a few clicks in the management console, you can enable guard duty with no additional software or hardware to deploy or maintain. Like with most things in AWS, it is a managed service that can be deployed with a click of a button. Now, how it works, again, it's very simple in terms of how it works. It is a threat detection service. So all you have to do is you enable guard duty. So within your management console, you can go into your guard duty to enable it to monitor your AWS accounts. Right? So there's no additional hardware that you need to provision for it. And it continuously analyzes your network and your activity. And the things it analyzes, you guys can see, your VPC flow logs, your DNS logs, your CloudTrail logs. So essentially, all of your logs that are generated from your AWS account are monitored by guard duty. So it's going to go through everything. And these logs contain everything in terms of who's accessing what, when are they accessing it, what data is coming in, what data is going out. And the best thing is it intelligently detects the threats. So it does not go through them in a rudimentary way. It uses machine learning to combine with rule sets to detect which threats can potentially happen or which are bound to happen. So it can use the knowledge it has gained from analyzing all of your logs and say that it is detecting a threat or a potential threat. So, like with most standard malware or antivirus softwares, they'll let you know after a threat has come into your PC. Best thing about guard duty is that you can prevent that from happening, because by using machine learning and preventative measures, you can prevent that malware or that antivirus from getting into your system, because it can detect certain anomalies within your logs. And then you can take action before there's any harm or damage done to your infrastructure or to your data. Again, benefits are immense, as you guys have noticed from it. It's a comprehensive threat identification. Again, it strengthens your security through automation. And it's an enterprise scale with centralized management. So it enables you to manage across multiple accounts. So let's say if your organization is spanned across the globe and it has multiple AWS accounts, with guard duty, you can centrally manage multiple accounts within that same console. Also perform automated remediation actions. You can leverage that through AWS Lambda or through Lambda functions. So let's say you can program it that if it detects certain things, certain actions can happen. Now, whether it's certain emails going on, whether certain security operations, or whatever, you can automate a lot of that process. So you do not need an entire team to analyze the logs, to analyze what guard duty is telling you. Most of the small things you can automate through the other functions and services such as the AWS Lambda, which is offered by AWS. So it's a very powerful tool, and I believe it's a very necessary tool regardless of the size of your organization. It is something that every organization should implement thoroughly within their networks. Hi everybody, and welcome to this section on building our first serverless web application. So let's take a look at what we'll actually be doing in the subsequent demonstrations. So we're going to deploy a simple web application that enables users to request something called a unicorn from the Wild Rides fleet. Now the credit goes to the Wild Rides team. They're the ones that actually developed the backend, the static website, and the JavaScript files that enables us to do that. So basically the application will present users with an HTML-based user interface for indicating the location where they would like to be picked up, and it will give you the interface on the back end with a RESTful API web service to submit the request and dispatch a nearby unicorn. So it's essentially basically a Uber application that we are going to be building, obviously on a very low scale. So the architecture that we're going to use is we're going to be using services in AWS such as the Lambda, the API Gateway, the S3 buckets, the DynamoDB, and the Cognito. So the S3 is the one that's going to be hosting our files. So that's going to host our static websites such as the CSS, the JavaScript, and the HTML files. Now, all the JavaScript that's going to be executed in the browser, it's going to send and receive data from the API that's going to be built using the Lambda and the API Gateway. Additionally, the Amazon Cognito is going to provide user management and authentication. So basically, when the users log in or when they go to the website, we will require them to log in, provide some basic information, and get that verified. And once that is verified, we're going to give the users a token, which will make them authorized to request rides. Because obviously, we want to make sure that we know who is requesting the rides. We don't want any anonymous users requesting rides or requesting resources. We want to make sure that the users on the website are known and authenticated. So essentially, that's what we are going to be building in the subsequent lessons. And just to keep in mind that since the website files have already been created, you are able to modify them as you please depending on your business case or depending on what you want to do, but the underlying process will stay the same in terms of what you need to do in order to get this operational as a serverless web application. So without further ado, let's get started and go into our next step, which is creating our static web hosting site. Hi everybody, and welcome to this lesson on creating our step function. So up until now, we have created the Amazon recognition containers. We've created our backend through the CloudFormation template. Next, we're going to create our initial AWS step functions state machine. So the first thing we want to do is, you guys can see, you can use any text editor that you want. I use Sublime, and we're going to use this writer photo share state machine JSON. So it's basically a simple JSON that's going to detect the face and make sure that it meets the requirements in terms of it not being blurry. A couple of things you want to note is in the resource, you want to make sure that you put the ARN of your specific resource. So if you go back into our AWS console, in our CloudFormation stack that was just launched, you will have an output section. And in the output section, it will give our Amazon resource numbers or names for all of these key functions that have been launched to this CloudFormation template. So first we want to do is we want to grab the face detection ARN and plug that in here for face detection. Next thing we want to do is for this last one, for the photo does not meet requirement, we want to send them a notification, and that's this placeholder function. So you want to copy this and make sure we paste that here. And we're going to save this file as writer-photo-state-machine.json. And I've also included that in the download section, so you can simply download the file and just make sure that you change these two ARNs to whatever the output in your AWS account has been done when you launch the CloudFormation template. So after we do that, next thing we want to do is create the step function. So we're going to go into the services and go into the step functions dashboard. Now, if you have not used this before, you'll get the same exact screen where you can go to get started, and we'll create our first state machine. So for the name, we're going to call it writer photo processing. And what we want to do is we want to copy this code and paste that in here. Once we do that, I'm going to go ahead and click on next. And for the IAM role, we want to choose an existing one because IAM roles were created through the CloudFormation template. And this role should already have been created if the template was launched properly, the step module resources state machine role. So we want to make sure that this is selected. And I want to click on create state machine. So here's where we can specify the execution. Now each execution of a step function state machine has a unique ID. So you can either specify one when starting the execution or have the service generate one for you where it says the entered execution name. So one thing to do is make sure for the S3 bucket, you want to go back into your CloudFormation, and in the output section, find where it says the writer photo S3 bucket. You want to copy this ARN and make sure that's the one referencing your S3 bucket. Then we're going to go ahead and click on Start Execution. There you guys go. As you guys can see that these executions have been successful. So that means our first step function is working properly in terms of them uploading photos and ensuring that the faces are recognizable and that they are not blurry.
Welcome back. Let's talk about the ETL process: extract, transform, and load. So now the source data is messy, right, in 1,000 locations, and really developed with the same style of organization. So trying to make sense of this mess without transforming the source data is like trying to clearly hear a single voice in a crowd. You may catch parts of the conversation, right, but it will lose context and validity quickly. So let's talk about how to get data into your data analysis solution using ETL operations. First, what is ETL, right? ETL is extract, transform, and load is a process of collecting data from raw data sources and then transforming the data into a common type. This new data is loaded into a final location to be available for analytical analysis, right, and inspection as well. Now, in modern cloud-based environments, we often refer to this process as ELT, extract, load, and transform also instead, by the way. Now, the steps are simply performed in a different order, but the result is the same. Now that you know the source data is messy, it's in 1,000 locations already, right, and rarely developed with the same style of data organization. Now, when you try to make sense of this source data without actually transforming it, right, it's very, very difficult, or the data may become corrupted as well. Because you may have some data that is valid and some data that is not. So it's important to transform the data, right? Because the data analysis solution requires a process to transform and then move into a new data analytical store. So this is really what ETL is all about. Now, ETL operations allow you to ensure that your data has the accuracy, precision, and depth you need to properly analyze the data and then produce a complete data narrative through reports and dashboards. ETL provides the opportunity to bring data together, right, from different sources, which helps you gain insights that might not have surfaced if you're only able to analyze one data source at a time. Ultimately, ETL is about transforming source data in such a way that it produces purpose-built data sets, which can be used to produce advanced analytical results. Now, these purpose-built data sets can dramatically reduce the overall time and cost of analysis. Now that you know what ETL is all about, right, and what it should produce, let's talk about the individual phases within ETL. First is extract, which is arguably the most important of the three. It has the most impact on production systems, and if it isn't performed correctly, it can be the root of many data integrity problems. So in this phase, your goal is to find and identify proper sources of relevant data and then gather them into your ETL system. Now, these sources include both relational and NoSQL databases, data lakes, for example, file-based data, and then even flat file. Now, planning is vital for a successful outcome. Now, you must know where the source data resides, right, and how to access the data itself. And you must carefully plan when to perform the extraction due to the potential impact of the copy process on the source system. You must plan for the initial data extraction also, as well as each consecutive extraction. And data engineers must also plan where to store the data during the ETL operation. Now, this is called the staging location, right? Now, depending on the source data types, this may be another database, right, such as Amazon RDS, for example, or data stores such as Amazon S3. Now, in some situations, the service you use for ETL may already contain a method for storing data, as in a case of Amazon EMR. Finally, you must plan how often to repeat the extraction, right? And extraction often occurs multiple times in a day, hourly, for example, or every 10 minutes, and even streaming updates are becoming commonplaces these days. The repetition of extraction is critical in your planning. The next phase in ETL is the transformation itself. Now, data can be transformed in many different ways for many different purposes. Now this phase is incredibly diverse. The ETL developer, for example, creates a series of rules or functions to be run against the extracted data within an ETL application. Data is extracted from the data source, right? And the transformations are processed accordingly. Many transformations, by the way, can be processed against the same set of data. Transformation can be basic, like cleaning data to update formats, or to perform data substitutions. For example, replacing no values from a 0, right? Or replacing the word female to the letter F. Transformation can be more advanced as well, like applying business rules to the data to calculate new values. Advanced transformations also include filtering records, complex join operations, aggregating rows, splitting columns, and data validation. Transformations can also include joining two data sets altogether, right, to provide a single table with attributes from both. For example, you could extract Census Bureau data from a public data source to enrich customer data, employee data, and then even marketing data through these joint transformations. Transformations are also used to perform data cleansing. Let's say your source is an address table, right? And the state field allows both the abbreviation CA or its full name, California. Now, when the data is analyzed, these values will be seen as different locations, right? And will cause problems in the analysis. Now, once you've realized that you can perform a data substitution transformation to reconcile the values into a single form, data cleansing isn't always a single transformation, by the way. It may take numerous transformations to get to where you want it to be. Another aspect of data cleansing is denormalization. Now, if you recall, relational databases apply normalization, right? So that the data has a consistent format and structure. Now, this is part of the database schema. But when you're preparing for transformation into an analytical system, this form often loses its usefulness. Remember that analytical systems require data to be organized so that queries are simplified and then quickly produce to produce aggregates. Now, as you merge the source tables together, be especially careful on how you transform values. For example, ask yourself questions like, do you want to maintain your ID values or replace them with their descriptions? Should you merge all columns or only a few? Now, if aggregating values, should the new table track the data source and its original values? Now, you could spend all day on the transformation phase alone, but you get the idea, right? So one last important, the transformation phase is also an opportunity to change your data storage types. In other words, you could transform NoSQL data into relational data and vice versa. Very important. Now, there are many advantages to both storage types. The transformation stage is when you have the opportunity to make this change. The final phase of an ETL operation is loading the data into the destination system. The planning steps you took in the transformation phase dictate the form that the final data store must take. Now, this could be a database, a data warehouse, or a data lake. Now, once the operation is complete, the data in this location is ready for analysis. So, let's bring this all back to veracity, right? So, during the ETL operation, you have several opportunities to impact the veracity of your data, either negatively or positively. Now, as data collection requirements and transformation processes change, you must be vigilant about maintaining high veracity. Now, this means evaluating the transformations regularly, right? And then making changes as required. Now, it seems that this might be the right time to talk about how AWS services help you create and run ETL operations, right? So, AWS offers two services for ETL operations, Amazon EMR and AWS Glue. Now, I've talked about both of these services in previous lectures. that you can refer back to, right? Now, it's important to carefully decide which tool offers control and management responsibility that's right for your ETL operation. And that could be a good exam question. Now, what's great about AWS, that you can implement both solutions, right? Amazon EMR and AWS Glue side by side. Use Amazon EMR for the more intensive operations of workloads, and use AWS Glue for the workloads that require more flexibility and mobility within your pipeline. AWS services in the ETL process, right? How do they work? So AWS provides services for every phase of the ETL process. From data source storage to reporting, AWS has you covered, of course. Transforming your data, for example, right? Comparing Amazon EMR and AWS Glue, let's talk about where to use what, right? So when you're performing data transaction components of the ETL, there are two options within AWS. So like I mentioned, it's either EMR or Glue. You can use either. Now, these two services provide similar results, but require different amounts of knowledge and time investment. So Amazon EMR is a more hands-on approach to creating your data pipeline. Now, this service provides a robust data collection and processing platform. Now, when you use EMR, you need to have strong technical knowledge, right, and know-how of your team. The upside is that you can create a more customized pipeline to fit your business needs. Additionally, your infrastructure costs may be lower than running the same workload on Glue. So with Glue is serverless, right? It's a managed ETL tool that provides a much more streamlined experience, easier to use than Amazon EMR. Now, this makes the service great for simple ETL tasks, but you will not have as much flexibility as with Amazon EMR. So you can also use AWS Glue, for example, as a metastore for your final transform data by using the AWS Glue Data Catalog. Now, this catalog is a drop-in replacement for high metastores. Now, when making your decisions about which of these tools to work with, decide with the end in mind. So are you going to want to have a continuous data pipeline that requires little overhead? Do you need massive parallel data processing, right? And how much customization will your data solution require? So it's a huge undertaking to understand how to keep data as clean and consistent as possible throughout the life of your data analysis solution. Now, you should know and now understand that at a high level, the process for enforcing data integrity at the database level, right, and maintaining that integrity through the transformation process. You should not be ready, to plan your first ETL operation based on the information that we've just talked about, right? The purpose of this lecture is to ensure that you understand the considerations, right? And the solutions and which solution to use as for the exam purposes, and of course, on a project that you're working within your company, right? And which is the best ETL service that produced analytical sets. So I hope this helps. Kind of makes sense. So think about when you get an exam question, they give you a scenario, right? So based on the scenario, you need to be able to understand and then fit in the right answer, because you should know when to use AWS Glue, for example, or when to use the ETL during the ETL processes, right? Or when to use Amazon EMR. So I hope this helps. Let me know if you have any questions with this. Let's move to the next lesson.
Welcome back. In this lecture, I'm going to talk about AWS step functions and their use cases. A very important topic, because this will allow you to handle your data more efficiently and effectively as well. So let's dive right in. So AWS step functions enable you to implement a business process as a series of steps that make up a workflow. So the individual steps in the workflow can invoke a Lambda function or container that has some business logic. Update, for example, or updating a database such as DynamoDB, right? Or posting a message or publishing a message to a queue once that step or the entire workflow completes the execution, right? So AWS step functions has two workflow options. First is standard and the other one is express. So when your business process is expected to take longer than 5 minutes, right, for a single execution, you should choose the standard. Some examples are long-running workflows such as an ETL orchestration pipeline, or when any step in your workflow waits for response from a human to move to the next step. On the other hand, the express workflows are suited for workflows that take less than 5 minutes, right? And are ideal when you have a high need execution volume. For example, 100,000 invocations per second. You can either use standard or express distinctly, or you can combine them such that a longer standard workflow triggers multiple shorter express workflows that execute in parallel, right? So here you can say that we can automate AWS step functions, right, through standard or express. All right, so here's a simple example of a banking system. Okay, so in this architecture, a new bank account is created after validating a customer's name and address. So the workflow, for example, begins right here where the AWS step functions account processing workflow. This is the entire workflow. And when the workflow begins with 2 Lambda functions, so the first Lambda function checks the name, which runs in parallel state, and the other Lambda function is the check address, right, for the customer. So once both are complete, the workflow executes the approve application Lambda function. Now you can define or retry, for example, a catch clause to handle errors, right? Or from task states. So either way, you could do so. You can also use predefined system errors or handle customer errors thrown by these Lambda functions in your workflow. Now, since your workflow code takes on error handling, the Lambda function can focus on the business logic and have less code. Now, express workflows would be a better fit for this particular example, as the Lambda functions are performing tasks that are together, for example, taking less than 5 minutes with no external dependencies. Kind of makes sense, right? Let's move on to the next slide, and we can see here, for example, in this architecture, sometimes you might need a human to review or approve or reject a step in the business process so that the workflow can continue to the next step. Now, it's always recommended, or it is recommended here, for example, using the standard workflow, right? Now, when your workflow needs to wait for a human or for a process in which an external system might take more than 5 minutes to respond. Now, here you can see that it's been extended, the new account, for example, opening process with a notify approver in between. So here you'll see right in the middle here is the notify approver task state, and it sends to the Amazon SNS queue, right? So the next state, the review required, is a choice state and has 2 possible paths. Now, these paths are either approved yes or approved no. So either send an SNS notification email to the approver in the notify approver task, or proceed to the approve application state. Now, the notify approver task then sends an email to the approver. That kind of makes sense, right? Now, once the email is sent to the approver, it kind of waits for the response before proceeding to the next choice state, which is being approved. Now, based on the approver's decision, the account application is either approved or rejected through Lambda functions. And that's right here, right? So either Lambda functions invokes itself and approves it, or it rejects. And of course, that ends the process. So this is another example. All right, moving on to the next example. So here, an event on a custom event bridge bus satisfies a rule and invokes a step function workflow as a target. So this is the event bridge. There's a custom event bus right here, and that invokes the workflow itself, right? Now, suppose you have a customer service application that needs to handle expired customer subscriptions. Now, an event bridge rule listens for the subscription expired events and invokes a target workflow in response. Now, the subscription expired workflow will disable all the resources that are expired subscription owns, right, without deleting them, and email the customer to notify them about their expired subscription. So you'll see these Lambda functions right here. At the end of the workflow, a new event is sent to the event bus through a Lambda function, indicating that the subscription expired has been processed. So for this example, of course, you can use the express workflows, right? As your business grows and you start to put more events onto the event bus, the capacity to invoke 100,000 workflow executions a second with express workflow is powerful. Next architecture. Now you can use the step functions to create an automated security incident response workflow that indicates or includes a manual approval step. So in this example, you'll notice there's a manual approver step included, right? So the step functions workflow is triggered when the IAM policy is created. So once the IAM policy is created, you'll notice that the workflow compares the policy action against a customizable list of restricted actions. Now, the workflow rolls back the policy temporarily, then notifies an administrator and waits for them to approve or deny. You can extend this workflow to remediate automatically, such as applying alternative actions or restricting actions to a specific ARN. Okay, so that kind of makes sense on this particular architecture. All right, you can also reduce the operational overhead for maintaining your AWS cloud infrastructure by automating how you respond to operational events for your AWS resources. So the event bridge provides a near real-time stream of system events that simply describes most changes and notifications for your AWS resources. So for this stream, you can create rule to route specific events to AWS step functions, Lambda, or other AWS services, right, for processing and automation actions. So here in this example, you'll notice an AWS step function workflow is triggered based on an event source from AWS Health. Now, it proactively monitors the popular code repository sites for IAM access keys, for example, and then those access keys are publicly exposed. Okay, let's suppose an IAM access key was exposed to GitHub. AWS Health then generates the AWS risk credentials exposed event in the AWS account. Okay, so this is where it handles the exposure workflow. So a configured Amazon event bridge rule detects this event and invokes a step function workflow. Now with the help of AWS Lambda, for example, the workflow then deletes the exposed IAM access key, which is right here as number 1, right, that you can see, and then invokes a step function workflow with the help of Lambda. Once it's deleted, right, it summarizes the recent API activity for the exposed key and sends the summary message to an SNS topic to notify the subscriber in that order. So it's 1, 2, and then 3, right? So it's going to delete the access key pair, look up the event, and then notify the admin, all through Lambda functions, right? Great. Next, you can use the Amazon S3 host, for example, to host a static website. So in this architecture, you'll notice we are using the AWS step functions, right? And you can use Amazon CloudFront to distribute the content worldwide. So as a website owner, you might need 2 S3 buckets for uploading the website content. So one is the source S3 bucket, the other one is the destination S3 bucket. Basically one for staging and testing and the other one for production. You want to update the production bucket with all the changes from the staging bucket without having to create a new bucket from scratch every single time when you update the website. So in this example, for example, the step function workflow right here that you see, right here, right? So this step function in this particular example is which performs tasks in 2 parallel and independent loops, right? So here the first loop basically copies all objects from the source bucket to the destination bucket, but leaves out objects already present in the destination bucket, not found in the source bucket, right? So a set of Lambda functions carry out individual steps, validate input, get the list of objects from both source and destination buckets, and then copy or delete the objects in batches, okay? So this Lambda function right here deletes the obsolete objects, and the top Lambda function right here copies the missing objects. All right, great. So next, in this particular scenario, in this architecture, right, we have a data processing pipeline to process the webhook data from multiple sources in real time, and then run Lambda functions that modify the data. So in this particular use case, a webhook data from several third-party applications is sent to Amazon API gateway, right, to an Amazon Kinesis data stream. So here the Lambda function, for example, pulls data off the Kinesis stream and triggers an express workflow. This workflow goes through a series of steps to validate a process and normalize the data. So in the end, Lambda function updates the SNS topic that triggers messages to downstream Lambda functions for next steps through an SQS queue, which is right here. That's where it's downstreaming, right? And once that's done, and that's for the next steps through an SNS queue, you could have up to 100,000 invocations for this workflow per second to scale the data processing, right? So this is another great use case. Perfect. Let's move forward. Now, in this particular step functions ETL workflow that refreshes the Amazon Redshift whenever new data is available in the source S3 bucket. The step function state machine initiates an AWS batch job and monitors its states for completion or errors. The AWS batch job then fetches the ETL workflow SQL script from the source, that is Amazon S3, and refreshes the destination, that is Amazon Redshift, through the PL SQL container, which is right here. Okay. Now the SQL file contains the SQL code for each step in the data transformation. Now you can trigger the ETL workflow with an event bridge or manually through the AWS CLI or using AWS SDKs or even a custom automation script. You can use any one of those, right? You can alert an admin through SNS that triggers an email for failures at any step of the workflow process. Okay? All right. So this ETL workflow is an example where you can use standard workflows. It's pretty straightforward. Okay? All right. Let's move on to the next use case. Now, you can also run an ETL pipeline with multiple jobs in parallel, extract, load, and transform ETL operations, transform raw data into useful data sets, turning data into actionable insight. This is a pretty useful use case. You can use step functions to run multiple ETL jobs in parallel where your source data sets might be available at different times, and each ETL job is triggered only when its corresponding data sets becomes available. So here, the Amazon Event Bridge running the SQL script triggers the step function, right? And then the process starts. So these ETL jobs can be managed by different AWS services such as Glue, EMR, Athena, which is Glue right here, and then you can run the Glue itself, or you can use EMR or Athena also, okay? Or other non-AWS services. So here in this example, in this architecture, for example, you have two separate ETL jobs running on AWS Glue that processes a sales data set and a marketing data set. So we have two data sets here, sales and marketing. Now, once both data sets are processed, a third ETL job combines the output from the previous ETL jobs to produce a combined data set. Okay, so right here is the ETL job that processes sales data. Then you have Glue running ETL job processing marketing data. And then a third Glue job, ETL job, runs and joins the sales and marketing data. Okay, so the step function workflow waits until the data is available in S3. While the main workflow is kicked off on a schedule, an event bridge event handler is configured on an Amazon S3 bucket so that when sales or marketing data set files are uploaded to the bucket, the state machine can trigger the ETL job, which is basically process sales data or process marketing data, depending on which data set became available. All right, great. Now, here is pretty important, right? So you can use step functions to iterate over tens of millions of items in a data set, such as a JSON array, a list of objects in S3, or CSV file in an S3 bucket. You can then process the data in parallel with high concurrency. Now here in this example that you see, in this architecture use case, right? The step functions workflow uses a map state in distributed mode to process the list of S3 objects in an S3 bucket. Now, step functions iterate over a list of objects, okay? So here they iterate in batch through a list of objects, basically within the S3 bucket, right? And then launches thousands of parallel workflows running concurrently to process the items. Now, you can use compute services such as Lambda, for example, helping you write code in any language supported. You can also choose from over 200 purpose-built AWS services to include in the map state workflow. And once executions of child workflows are complete, step functions can export the result to an S3 bucket, making it available for review or for further processing. Great. So here in this example, a step function workflow runs on a schedule triggered by EventBridge to execute once a day. The workflow then starts by checking, for example, new data that is available in S3. Next, it performs an ETL job to transform the data. After that, it trains and deploys a machine learning model on this data with the use of Lambda functions that triggers a SageMaker job and wait for completion before the workflow moves to the next step. Finally, the workflow triggers a Lambda function to generate predictions that are saved to S3. Kind of makes sense, right? Good use case. All right. So the AWS Step Function Data Science, or SDK, is an open source library, right, that enables you to create workflows that process and publish machine learning models using SageMaker and step functions. So the SDK provides a Python API that covers every step of the machine learning pipeline, which is either you want to train, tune, transform a model, or configure endpoints, right? All of these are stages. So you can manage and execute these workflows directly in Python or in Jupyter notebooks. So here in this example that you see, it illustrates the train and transform steps of a machine learning workflow. So the train and transform starts a SageMaker training job and outputs the model artifacts to S3, right? Now, once it's in S3, the state model creates a model on SageMaker using model artifacts from S3. The transform step starts a SageMaker transform job, and then the create endpoint config step defines an endpoint configuration on the SageMaker. Great. You can also extract data, by the way, from PDF. That's another great use case, or images for processing. So here in this example, basically it combines AWS step functions, Lambda, and Amazon TextRack to scan a PDF invoice to extract its text and data to process a payment, right? Now, Amazon TextRack analyzes the text and data from the invoice and triggers a step function workflow through SNS or SQS and Lambda for each successful job completion. So workflow begins with the Lambda function, of course, saving and results of successful invoice analysis to S3. This triggers another Lambda function that processes the analyzed document to see if the payment can be processed for this invoice, right? Kind of makes sense. So I hope this all helps. Now, I've run through several architectures, right? Several use cases and examples. Go through these one at a time. Let me know if you have any questions. I'll be happy to answer because these are useful in understanding how step functions work and their basic architectures. With this, let's move to the next lesson. Welcome back. Super excited moving forward. In this lesson, I'm going to talk about a few core concepts because we will be actually using data, right, as a data source and then bringing and using some of these Amazon services to transform our data, to prepare our data, and then, of course, shifting our data into QuickSight. So it's important to understand these concepts so that you're not actually going all over the place and trying to understand some of these buzzwords and how the entire process works. So I'm going to lay it down fundamentally so it's easier for you to understand and follow as we move and I demonstrate how to use and work with preparing your data using the storage that Amazon provides. So in this lesson, I'm going to talk about Amazon Athena, which is a serverless query service. I'm also going to talk about AWS Glue, the Store S3, and so on. So a few important concepts. First, the AWS Athena. What is this, right? So the Amazon Athena is an interactive query service. So by query service, it rings a bell, right? So what that means is I can now query my data. In other words, I can, sort, filter, ask questions from my data before it actually ends up all the way down to Amazon QuickSight. So Amazon Athena is an interactive query service that makes it easy to analyze data stored in Amazon S3 buckets using standard SQL, right? So it's a simple SQL query language that I can say, and I can run statements like select, update, and so forth to query my existing data sets. Athena is serverless. Now what that means, the basic definition of serverless, by the way, if you've come across this term, think of this as you don't have any servers, right? On premise, you're actually using everything that the cloud provider offers to you. In our instance, it's AWS. So that's why Athena is serverless, so there's no infrastructure to manage on your end, and you pay only for the queries that you run. I believe it's 1 terabyte worth of queries before you actually pay like $5 or something like that, okay? It's easy to use. The performance is pretty fast, secure, and Athena is also integrated with AWS Glue, okay? This is where you can actually build your database schema, your tables, and so forth. And I'm going to demonstrate and talk about that a little later. We can also point your data within Amazon S3 buckets, define the schema, and start querying using standard SQL. So that's really what AWS Athena is, right? So you go from your instances to, let's say, Amazon S3, you have different buckets created, you have different data sets stored in those buckets, right? Bucket is just a file system, okay, in high level or broader context as a fundamental concept. Just think of this as Windows Explorer, right? So you have all these files in your storage. From this storage, Amazon Athena goes into action. You can run interactive queries using AWS Athena, and then with that data, right, with that query results, you can then take them into Amazon QuickSight and run some visuals or do some analysis, run stories, perform calculations, and whatnot, okay? So that's the whole idea. I hope you understand the concept pretty clear. So AWS Glue is the next buzzword, right? From S3 to a QuickSight. So when using Athena with the AWS Glue data catalog, you can use AWS Glue to create databases and tables schema to be queried in Athena. So now you know what AWS Glue does, right? So here you are actually creating databases. Within databases, you're creating tables. And then, of course, you're using Athena to run the interactive query sessions. So what AWS Glue is a fully managed ETL, which is extract, transform, and load data. It's a service that can categorize your data, clean it, enrich it, and move it reliably between various data stores. So this is your like a data warehouse, or the service that does transform your data, extracts your data. And I'm going to demonstrate later on too how to use the actual wizard to do all of these, right? So this is not just concept. I'm going to do a hands-on demonstration so you understand and see it in action. Not just concepts, but actually application of these concepts. AWS Glue crawlers automatically infer database and table schema from your source data, storing the associated metadata in the Glue data catalog. And when you create a table in Athena, you can simply choose to create it using the AWS Glue crawler. So the workflow is fairly straightforward. You go from your S3, which is your buckets, then crawlers will interact with that stored data sets, right? So it will extract, transform, and load The metadata is stored in the Glue data catalog. And then you get to the Amazon Athena part where you run the interactive queries, right? You prepare your data according to your own requirements or needs. Eventually, you get to Amazon QuickSight, which is, of course, where you run the visuals, you create the visuals, you run the analyses, and so forth. So finally, you get to the AWS QuickSight, right? Of course, the high-level overview, once again, for QuickSight is that you can use any of these data sources. You can have your data sets. You can run the analyses on these data sets. Of course, you can create different dashboards, multiple dashboards. You can publish these dashboards. You can share these dashboards, email anyone within the organization so that they can actually take a look at your dashboards that you've created. A story is just a snapshot, right? So it's a snapshot of all these dashboards. Maybe, for instance, let's say you run an analysis on a particular data set, right? So one of the visuals you create is all about the count of customers. So you save it as a story. The next set of dashboard or visual that you create is all about profitability. So you save that as a story. So you build a story. Think of this as a, overall or high level PowerPoint slides, right? So you're actually, when you're presenting to someone or you're playing the story, it kind of walks you through from the customer and the profitability and the sales and so forth. So that way it's easier for your maybe marketing department or sales department to take a look at all these stories that you've created based on the analyses on those data sets that you've created. It's easier for them to manage and just kind of take the necessary action accordingly. So in this lesson, just wanted to briefly talk about the AWS Athena, AWS Glue, and of course QuickSight, and the concept and the workflow as well. So I hope this helps. The next step, of course, is for us to practice, right? So understand these concepts, take a look at what those are, and before I actually end this lesson, let me quickly show you where all these services reside. So I'm going to go ahead and switch to our AWS console. Perfect. So once you're in the console, right, you're logged in, just go to services and notice you'll see all these services that AWS has. So for instance, my storage is right here, S3 that I mentioned, right? That is the storage service where all the buckets are. So if I click on S3, you'll notice it'll give me the list of all of my storage buckets that I've created. You can of course create additional buckets as well. So each bucket contains whatever you want to store in it. So for instance, the bucket called GB88 contains the 5,000 sales record.csv file. Okay. Similarly, let's go back to our homepage here. Let's go to services again. So I want to show you the Athena, right? So under analytics section, you'll see the Athena service. Simply click on this. And this will take you to the actual query editor, right? Remember, Athena is just an interactive query builder. So you have your databases on the left, and then you can execute queries based on your data, and then of course your tables. You run a query. You can save a query, format a query, and so forth. And this is where you would actually use to eventually get to QuickSight. So you prepare this data here. You can always prepare the data directly in QuickSight as well, certain fields, but this is a little bit more powerful area because now you can actually query and create as complex queries as you wish to actually hone in your data. And the reason I'm showing you this, the importance here is the obvious question, why, right? Why do we want to use Athena if we can do this in QuickSight? Well, QuickSight doesn't really give you a whole lot of flexibility, okay, to prepare your data. It only prepares just the field sizes or maybe simple calculations. But here in Athena, let's say you have millions and millions of records, right? What if you have 10 million records and you only want to, obtain a chunk of those records? Let's say out of 10 million records, you want to query maybe 1 million records based on a certain criteria. So this is where Athena would be very helpful. And then you will take the result derived from Athena to QuickSight. So at this point, I just wanted to show you what it looks like. Okay, perfect. Let's go to our services one more time. And then, of course, AWS Glue. Okay, that's under analytics as well. So I'm going to go ahead and click on AWS Glue. And this is where you would be able to, once you get on the AWS Glue dashboard, you can take a look at all these tables that you've created within those databases. So that way, which is an area where a table, you can store these tables to be used by Athena and then eventually by QuickSight. And that was a workflow we just talked about earlier in this lesson. Of course, it uses crawlers, right, to basically extract, transform, and load, ETL, okay? So in synonym to AWS Glue, think of ETL, okay? Where you can extract data, you can transform data, and you can load data as well. So just briefly wanted to demonstrate where these services are within AWS, okay? So we looked at the S3, looked at the Athena, and then the AWS Glue. So practice with these. Hope this helps. If you have any questions, post them in the discussion area. I'll be glad to answer. And with this, let's move to the next lesson.
So welcome to the lesson on Introduction to Kubernetes. I'm going to talk about what Kubernetes really is, what does it do, and how does it solve problems when it comes to scaling our applications. So before I get into the actual Kubernetes, I want to talk about containers one more time because they're very important. Containers are a solution to the problem of how to get software to run reliably when moved from one computing environment to another, which is great. This could be from, again, your developer's laptop to a test environment, from a staging environment into production, and perhaps even from a physical machine in a data center to a VM in a private or public cloud. So we talked about containers earlier, right? But just a refresher on what they are and what problem they solve. So how do they really solve these problems? A container consists of an entire runtime environment. So for example, it'll have the application plus all of its dependencies, the libraries and other binaries, as well as configuration files needed to run it, all bundled into one package. By containerizing the application platform and its dependencies, differences in OS distributions and underlying infrastructure are abstracted away. Okay, so you just create a box, you put everything in a box, and you ship it to a platform. Containers are great, as I mentioned earlier, but what's next? Few words on containers. Technically speaking, containers are a new mode to IT. Obviously, they're new and they're growing. Containers are making us think how we deliver software, unlike the conventional methods. Containers live only inside the Linux kernel, and they are nothing but control groups and kernel namespaces. So here's a shortcoming of a container, right? So how does a container know, for example, if my application needs to span 5 data centers? Well, simple answer is it doesn't really know that aspect. All it knows is what's in the box, okay? And that's important to understand and differentiate, or take a look at what containers can't really do. You may have millions of containers sitting there with each having its own space with its own dependencies, app, code, and everything in it, but that's about it. So how do you scale out your highly resilient app? We need Kubernetes to do that. Okay, so let's say you have a cluster running and you have all these containers within that cluster, and now you need to scale out your application. Well, containers can't really do it by themselves, so we need a tool called Kubernetes. It's an open source, and we'll talk about next what Kubernetes really is, but I wanted to differentiate and make you understand the actual concept of containers and how Kubernetes comes into the picture. So Kubernetes is an open source system
for automating deployment, scaling, and management of containerized applications. Okay, that's important. What it does, it groups containers that make up an application into logical units for easy management and discovery. It's an open source container orchestration and provides broad industry support, and also supports the multi-cloud environment, on-premise VM, bare metal, and so on. So more importantly, just understand and know and remember that Kubernetes is an open source system for automating deployment of your apps, scaling your apps, and management of containers. So a few words and terminology that Kubernetes uses, and we'll be using these terms, in fact, working with these within this course. So a container, again, is a sealed application package, right? And I demonstrated earlier how to download, install Docker, and how to create containers and images, right? And then pod is simply a small group of tightly coupled containers. So you take those containers and you create a pod. Labels identify metadata attached to objects. Selector is simply a query against these labels, producing a set result. A controller, which is a reconciliation loop that drives current state towards the desired state. So as the word suggests, it controls, right? And service is a set of pods that work together. A new concept in Kubernetes or new terminology is the pod, right? So all we do is we create these pods, which are just a bunch of these containers, bunch of these boxes, and each box again contains its own set of code, right? So you may have a box or a container that can have a Node.js application, and another box that may have Ruby on Rails, and so on. Another one with Java, another one with WordPress, and so on. So you take all these containers and you group them together into something called a pod. And then of course you create labels, right, to identify, and then you can use the selector to query against these labels, find out all these labels. Because keep in mind that these containers can be millions, right? Google again creates 2 billion containers a week. So we need some kind of management areas, right? So Kubernetes is all about managing your containers. So therefore it comes up with pods, labels, selector, controller, and service. So in conclusion, containers, we talked about them, what they are, or the shortcomings of these containers. They're simply kernel namespaces. They can't really do anything on their own. They cannot scale themselves. So we need Kubernetes to do that, right? And we also talked about how Kubernetes is useful in scaling these applications. And of course, a few new terms such as pods, service, labels. As far as Kubernetes is concerned, we talked about those as well. So go over some of these terms, understand them. Before I end this lesson, I'm going to go online and show you how to get to Kubernetes and what does it look like. So let me switch back to my browser here. So once I'm in my Chrome browser, simply Google something called Kubernetes, and the first link you'll see the URL, which is kubernetes.io. Okay, so click on the first URL and this will take you to the homepage of Kubernetes, where you can read about it, what it is, what does it do. Once again, it's just an automated container deployment, scaling, and management. Okay, it's an open source, so you can go on GitHub and take a look at the code itself. And of course, you can scroll down and read about it and understand more what Kubernetes really is. So for example, if I were to bring up the GitHub here, notice you can view on GitHub. So I'm going to click on it and take you to GitHub and actually show you the code. So here is where you can take a look at, you can clone or download, okay, Kubernetes as a zip file, or you can use Git or check out with SVN. In this lesson, just wanted to demonstrate the actual concept of Kubernetes and how does it work, how does it solve our problems when it comes to scaling these applications. So hope this helps, and let's move to the next lesson. Welcome back. Moving forward, in this lecture, I'm going to demonstrate how to go about creating the Kubernetes cluster. So we already have an account at Google Cloud Platform, right? We've signed in. And once you're signed in, you can create a project, which I already have created. It's called Syed -5757. So once you create the project, of course, you need to place the project or have the project somewhere in the Kubernetes cluster. Within the Kubernetes cluster, we're going to have an instance, right? Which means that we are going to spin up some virtual machines so that we can start to actually communicate and connect with GitLab and pull the repositories and use the Nginx to get on the web, right? So we can view it on the website. So the entire framework is kind of makes sense, right? Because we have the Google Cloud Platform as our base fundamental platform, right? Like it's a house. Think of it as a house that kind of houses all these things. So within the platform, we are going to connect GitLab, where we actually have developers all across the world, maybe all across the country, connecting and doing some merge requests, some pull requests, some changes to the code on a regular basis. So all of that is reflected in real time, right, using the Kubernetes engine or the Kubernetes tool within the Google Cloud Platform, so that as you're developing scalable applications or enterprise level applications, this whole concept kind of fits in. So, but apart from this entire macro overview, once again, let's specifically focus in this lecture on creating the cluster. So from within the Google Cloud Platform, let's jump right in. Let me go ahead and go to first, let's take a look at the Kubernetes engine, right? So as soon as you navigate to Kubernetes engine, notice at this point, there's no cluster. So we need to go ahead and first create a cluster. So let's click on create cluster. So fairly straightforward, just run through it. Let's give it a cluster name. You can give it any name. For example, I can call it ClayDesk 5 cluster because that's the project that I'm using in GitLab or wherever else, right? You can name it differently if you like. So that's the name of the cluster. The description is optional. You can select the zone. Right now we're in US Central 1A, or you can do the Eastern Zone 1B, Eastern 1C, and so on. There are different zones that you can actually use to create the cluster in. And then the cluster version, the machine type that you wish to choose, whether it's one CPU or more than one CPUs. You can have 8 or 16 CPUs, 96 CPUs. That's going to cost you, right? So remember, keep in mind that this is per minute billing, right? So just this is for our own consumption. But in real world, you may have instances where you have an enterprise level application that needs 96 CPUs. That's pretty powerful. Anyways, we're going to keep it to 1 for now. And then once you select the actual machine type, which is one CPU, it gives you the kind of the memory behind it. The node image provides better security and performance, but has some limitations that may affect some users. So we are going to be using Ubuntu, right? If you're affected by these limitations, or we use the shell and the command line Ubuntu, that's much easier and faster way to do things. So the containers optimized OS is 2 CPUs. It's going to take about 7.5 gigs of memory. You can increase the size to 3 if you like, so it depends on how many cores you like. The cluster instances are pretty standard, so we're going to leave all of this and just go ahead and before I click on create, notice it kind of tells you you'll be billed for the 2 nodes VM instances in your cluster. If I click more, it gives you more advanced options where you can add additional zones and play around with Kubernetes alpha features, the client certificate, auto scaling, the boot disk size, and so on. So I'm going to go ahead, scroll all the way down and click on create, and it's going to go ahead and start to create the cluster called ClayDesk 5. The cluster size is 2 with a total cores of 2 CPUs with 7.5 gig of memory. And it takes about a few minutes, sometimes 3 to 5 minutes. Perfect. So once our cluster is created, we can navigate to connect to this cluster. So let's click on connect, and a couple of options that it provides you: the command line access. You can simply copy it and run it in the shell, or you can open up the Cloud Console dashboard. So let's first run the Cloud Shell here. And what this does is opens up the shell here for you. You can of course go on the top here. Notice this little icon on the top menu, which is the shell, which is the same thing as the Google Cloud Shell. So it's going to try to connect to our cluster. And this is just to demonstrate that now that we are connected to this cluster, it automatically pulls the command for us so that we could actually connect to the cluster itself. And I'm going to hit the enter key, and it's going to go ahead and connect to the cluster. First, it's going to fetch the cluster endpoint and the authorization data, the kubeconfig and regenerated for ClayDesk 5, and we are good to go. So in this lesson, just wanted to demonstrate how to go ahead and create a Kubernetes cluster. So practice with this, and with this, let's move to the next lesson.
Hi everybody, and welcome to this lesson on what is DevOps. So in this lesson, what we're going to do is try to understand what do we mean when we say DevOps. So one of the definitions of it is it's basically a compound of development, hence the name dev, and operations, ops. So it's a combination of development and operations. It's basically a union of people, processes, and technology. And what it allows you to do is continually provide value to your customers. So that's the end goal, is providing value to the customers, which traditional software development lacks in doing. So for teams, what it means, it enables formerly siloed roles such as development, IT operations, quality control, security, to coordinate and collaborate and produce a better, more reliable product. And by adopting DevOps, and it's more of a culture rather than only a process, along with certain practices and tools, teams are able to gain the ability to better respond to customers' needs, increase the confidence in the applications they build, and achieve business goals faster. So that essentially is the end goal, is getting to market faster, implementing changes faster, and allowing teams to collaborate rather than work in silos. DevOps offers a number of benefits. I've just listed some of the main benefits that it offers. Now, adopting the culture, its practices, and tools become high performing. They build better products faster for greater customer satisfaction. So that's one of the first ones, is accelerating time to market. By implementing a continuous integration or continuous delivery, you are able to significantly cut the time that your product requires to actually get to market. And today's such globalized world, time is essentially money. That's a cliche term. Secondly, it allows you to adapt to the market and competition. By going back to the first one, since you're accelerating the time to your market, you can adapt to the changes that the market is producing or the competition that's coming up. And nowadays, market is getting more and more unified in terms of globalization, and the competition is ever increasing on a daily basis. Thirdly, it allows you to maintain stability and reliability. Since you are able to break out of those silos, all of the teams can work together in a coherent fashion. So you have the security, you have the operations, you have the product people, you have the customer services people, and essentially also the customer working together. So it allows you to build a stable and a reliable product. Lastly, improving the mean time to recovery. What that means is, since you have a DevOps pipeline or an automated pipeline, if there are changes that are required, or if there's any bugs in the code or in the software, you can get that rectified very, very quickly as compared to if you were in a traditional software cycle. Now, DevOps influences the application lifecycle through several phases: the plan, the development, the delivery, and the operation. Now, each phase relies on the others, and phases are not role specific. So essentially, in a true DevOps culture, each role is involved in each phase to some extent. So it's not a silo that there's a team that's part of the development, there's a team that's part of the delivery, and so on. Every member, if you are a member of the DevOps team, you are essentially have a role in each one of these cycles. So firstly, we have the plan phase. So here is where the teams ideate, they define, describe the features and the capabilities of the application that they're building. They track, they progress at low and high levels of granularity, and from single product tasks to tasks that can span portfolios of multiple products and multiple applications. So that's essentially in the planning phase. In the development phase, it includes all aspects of the actual code, the actual coding of the application, the writing, the testing, the reviewing. So essentially, this is where the software development physically happens. So now that we have the plan on what we want to do, we've actually developed the software, we've actually coded it. Next comes the delivery. It's basically the process of deploying the application into production environments, but the keywords are in a consistent and reliable way. The delivery phase also includes deploying and configuring the fully governed foundational infrastructure that makes up those environments. So back in the days, you had to provision a server, you had to provision multiple servers and get the whole infrastructure up and running before the application could be deployed. Whether it required 1 VM or whether it required 10 VMs, you had to physically get those up and running in order to get the application operational. Nowadays, with the advent of cloud, with DevOps, and essentially with the serverless infrastructure, the time to do that could essentially be cut down to minutes rather than weeks. So after the delivery phase, we have the operate phase or the operation phase, and that involves maintaining, monitoring, troubleshooting applications in actual production environments. So when you adopt the DevOps practices, teams have to work to ensure, the reliability, the availability, and essentially zero downtime, because in a DevOps culture, essentially you should have zero downtime. And in the operation phase, teams continually seek to identify issues before they affect the customer experience. So what you're trying to do is continually monitor the application or the software to pinpoint issues before the customer brings them to you. Again, the overall goal of the DevOps is to achieve customer satisfaction. And this cycle allows you to do that in an efficient and quick manner. Now, beyond establishing a culture of DevOps, teams bring DevOps to life by implementing a number of practices throughout the life cycle. Here, I've just listed some of the practices or the main practices that are brought to life in a DevOps lifecycle. First, and this one, as you guys might have heard quite often, is the CI/CD, which stands for continuous integration and continuous delivery. Now, continuous integration is a software development practice in which developers merge code changes frequently into the main code branch. So CI employs automated testing, which runs every time a new code is committed, so the code in the main branch is always stable. Consequently, continuous delivery is the frequent automated deployment of new application versions into a production environment. So by automating the steps required for deployment, teams reduce issues that may occur upon deployment and enable more frequent updates. So CI and CD are not synonymous, so they're not the same thing. They work together to bring DevOps to life. So when both practices are in place, the resulting process is what's referred to as CI/CD, includes the full automation of all steps between the code commit to production deployment. It allows teams to focus on building code and removes the overhead and potential human error in manual or mundane steps that are usually required in traditional software development. It makes the process of deploying new code quicker and less risky. So again, the continuous integration is essentially automatically integrating code changes into your code. And the continuous delivery is the automated deployment of new application versions. So you could essentially just have continuous integration in your DevOps lifecycle, or you could essentially only have continuous delivery. So you can have one or the other, or you could have both to have a fully automated DevOps pipeline. Another one is version control. Is basically the main practices of managing the different code versions, tracking them, their change history, and so on. And it's made a lot easier in the DevOps lifecycle, especially if you're using GitHub or you're using one of the Azure repos. It makes version control a lot easier. It also allows for agile software development. It's basically an approach that emphasizes team collaboration, customer and user feedback, and high adaptability, which are the key building blocks of the DevOps culture. You also have infrastructure as a code, which is essentially a code that deploys infrastructure, hence the name infrastructure as a code. So what you're essentially doing is, like I had mentioned a little while ago, where you are deploying a DevOps pipeline and you don't need to provision infrastructure. You don't need to go to your procurement department. You don't need to find vendors to buy physical servers. You can essentially deploy VMs, servers, and entire infrastructure on the cloud in a matter of minutes. Now that can be done manually, essentially, deploying VMs on the Azure cloud one at a time, or you could essentially code everything into a JSON file. Let's say if you want to deploy 50 VMs, you want to have X amount of firewalls and so on. Everything can be coded in a JSON file, and you could essentially just use that file to deploy your entire infrastructure. Configuration management, referring to the managing the state of resources in a system, including servers, your VMs, and your databases. And finally, the continuous monitoring, having the full real-time visibility into the performance and health of the entire application stack, and also the underlying infrastructure if you're not working on a serverless environment, if you're deploying your environment onto the Azure cloud yourself and maintaining it yourself. Obviously, you also have to do the continuous monitoring. So those are essentially some of the main practices in the DevOps culture. So I hope you guys got a good understanding of what we mean when we say DevOps.
Hi guys, and welcome back. In this lesson, we will be learning all about continuous integration and continuous delivery. So let's first learn what continuous integration is. So continuous integration is the practice of merging all developer working copies to a shared code line several times a day, and validating each integration with an automated build. So what does this mean and how does this work? So there is a master branch, and all developers working on a single project write code in small chunks for the particular code that they have to write. So they're all working on one project, but there are all multiple developers working on that single project, and different code is coming from everywhere. So continuous integration combines all that code in one master branch and then builds it for testing and then deploys it. And unit tests are generally executed during the build. So unit tests are those tests that test the lines of code several times a day along with continuous integration, just to ensure quality of code. Continuous integration emerged as a best practice because of software developers often working in isolation. And then they need to integrate their changes with the rest of the team's code base. So one software developer must be working in the United States, one in another country, for example, United Kingdom, and one from another country. So a company has multiple software developers, and if there are like 20 to 30 and even 50 software developers in a company working on one single project, not in the same office, so continuous integration is really important as it will combine the code coming in from all of those developers. Now, what are the benefits of continuous integration? So the first benefit is that it provides quick feedback for code quality. So as soon as the small chunk of code is deployed or commit changes by the developer, the unit test will run and it will check for the code quality and it will give an instant feedback on it. And this helps the developer improve on their code. It also triggers for automated testing for every code change and also code analysis and technical debt management. Continuous integration reduces long, difficult, and bug-inducing merges, as small chunks of code is combined together in one master branch, where quality assurance testers can come in and test the code. It also increases confidence in code long before production. So just after the code is written, it increases confidence in the developers that they are writing the correct code and quality code that is required for that project. So these are some of the benefits of continuous integration. Now moving on to continuous delivery. Continuous delivery is a software engineering approach in which teams produce software in short cycles, ensuring that software can be reliably released at any time. And just like we learned before, these are small chunks of code written by the developers. So these short chunks are known as continuous delivery by the developers, and continuous integration combines these short chunks or small chunks of code. And it aims to build, test, and release software faster and more frequently, and also eventually decreases lead time. And in practice, continuous delivery focuses on an automated deployment pipeline. However, this may have one or more manual approval gates prior to reaching production. So every process in this continuous delivery is automated. However, the project manager that is managing the project can insert manual approval gates into this continuous delivery pipeline in order to increase the quality of the product that is being created. Now, what are the benefits of continuous delivery? So it enables automated testing throughout the pipeline. Nothing is manual, everything is automated along the pipeline. It provides visibility. So using automated testing, error rates can be reduced, and it is much faster. It also provides with fast feedback cycles. It also makes going to a production a low stress activity. So as feedback cycles are fast and much before the production phase, there is much confidence in the developers and also in the operations team that the product will be good, and therefore there is less stress. Continuous delivery also increases confidence in code long before production, just like continuous integration. So these two advantages are the same for continuous delivery and continuous integration, as they increase confidence in code long before it needs to be produced or delivered to the client. Now, what is the difference between continuous delivery versus continuous deployment? So I know these are really similar terms and really confusing, but there is only one main difference that needs to be learned in order to differentiate them. So in continuous delivery, since every change is delivered to a staging environment using complete automation, the application must be manually deployed to production with the push of button. So what this means is that there are automated tasks throughout the continuous delivery pipeline, but it is manually deployed to production with a push of a button. So when the project is ready, someone needs to manually push a button in order to deploy it to production and release it to the client. However, in continuous deployment, this does not happen, because every change that passes the automated test is deployed to production automatically, and the operations receive it without someone manually releasing it to the operations team. So this is the difference between continuous delivery and continuous deployment. Here is a visual representation of the difference between continuous delivery and continuous deployment. So if you see in this diagram, first come the unit tests, and these are automated, and once the unit tests are done, then comes the platform test. These are also automated, and the next stage is the deliver to staging. This is also automated. The fourth stage is the application acceptance test. This is also automated, but here comes the difference. In continuous delivery, someone needs to deploy to production manually. However, in continuous deployment, deploy to production is also automated. And then post-deploy tests occur, and these are also automated. So there is only one difference, main difference between continuous delivery and continuous deployment. So I hope you learned all of these terms that are really important in DevOps process. And with this, let's move to our next lesson.
Welcome back. Super excited. In this important lecture, brief about 5 or 6 slides, I'm going to talk about the key difference between the continuous integration, continuous delivery, and I'll also highlight the continuous deployment as well. But mainly, we'll talk about and try to understand and also apply within our AWS environment. So let's begin by taking a look at what is continuous integration and continuous delivery. First, the basic difference between CI and CD. They're not the same, okay? Just simple answer. CI, CD, they're both two different entities. For instance, continuous integration, you would have to run all tests on every code commit while building code. So you have developers working all across the world, for example. They're using their IDEs to commit code, pushing code through branches. So you'd have to run all tests on every code commit during that process, right? That is continuous integration. Continuous delivery, on the other hand, is continuous integration, right? Which means running all tests on every code commit while building code, plus deploying the updated build tested code to production. Okay, so this is the key difference. Everything is automated within the continuous delivery process. However, you have option to manually approve the changes as well. So there you go. Now you understand the difference between continuous integration and continuous delivery. The benefits of continuous delivery are as follows. So fully automate software release. And that's exactly what we use continuous delivery. And AWS code commit, AWS code deploy, code pipeline allows us to perform continuous delivery and continuous integration. You can deliver updates faster. You can deliver value to your end customers in time and more efficiently. So the customers don't have to wait to get your software release. The important thing here is that you can make developers efficient and productive. Typically, developers have to do other tasks as well, right? But here, in my experience, I've seen developers doing unit tests as well on their own. So in this instance, you can free up a lot of time for developers. And you can also create faster feedback cycle. So essentially, key benefits of CD. Here's a visual example. So you actually kind of see, scope out how CI/CD integrate. And then I'll demonstrate or take a look at the AWS example as well. Here in this diagram, notice the code flow goes to commit the code, and then the CI pipeline, the continuous integration pipeline, entails build, doing some unit tests, behavior tests, functional tests, right? Integration tests. That's all is happening within the CI pipeline. So a tool, for example, for CI pipeline that we typically use, pretty popular, is Jenkins. Okay. CD pipeline, right, entails review, staging, and production. So that's your continuous delivery pipeline. It also sometimes is related to continuous deployment, and I'll demonstrate that next as well. So this is just a high-level visual example of CI/CD pipeline. Perfect. Last but not the least, example of AWS code pipeline. So AWS handles CI/CD very effectively and efficiently using AWS code commit and the entire pipeline itself. So you have an app that needs commit code, right? So developers are creating this app and then they commit code. It goes to source control and AWS code commit comes into play. All the changes are committed. The next process is going to the build, where code is built and the unit tests are performed. Code pipeline follows to the staging environment. Within the staging environment, you have CloudFormation. These are again templates written in YAML or JSON format. You have the Elastic Beanstalk. You can use OpsWorks. AWS now also support Chef and Puppet also. Okay, so the newer console, or one of the newer services in AWS, is that it also supports Puppet server as well. And then finally, you deploy to production. So this is the general pipeline that AWS follows. Now the key important areas is to take a look at where continuous integration takes place, where continuous delivery takes place, and then of course continuous deployment. The continuous integration runs through the app, source control, and build. Okay, so that's really where the continuous integration is. And Jenkins, for example, like I mentioned, is a popular tool, right? It's a popular build tool. So we use Jenkins to do the CI for us. And then continuous delivery goes on through the entire pipeline process where you can approve the deployment. In other words, if you're using continuous delivery, you have the option to manually approve the changes that developers are committing to the pipeline. Whereas in continuous deployment, you have the auto deployment. In other words, from commit to production, everything is automated. And that's really exciting working with AWS, where you have these options. So developers can work on different branches, for example, track issues using Jira, or you can use GitHub Tracker as well. So there's several other elements that come into play within this pipeline. But I just wanted to make sure that you understand the concept of continuous delivery, continuous deployment, continuous integration, and the capabilities of how it fits into the AWS scenario. Because this is something that we'll be doing when we actually run through all the projects of deploying a web app, whether it's a Spring Java app or a PHP Laravel app. So we'll be going through this entire process, and I'll, of course, demonstrate throughout this course how you can deploy app and make changes, create branches, and then use the continuous delivery and integration, as well as deployment techniques as well. So as DevOps engineers, you ought to know in and out about this entire pipeline so that you can make the process efficient. And that's important because developers are just committing code, right? And you are here to monitor the pipeline itself, where the code is failing, for instance, what's not right. You're also taking a look at the QA testers involved in the source control and build stages, for instance, doing all the tests in the staging area. So not only that, you're also maybe taking a look at project managers who have access to this entire project that you're managing or overlooking or monitoring. So DevOps engineer has a multifarious, you need skills and you need techniques so that you can manage the entire pipeline. So I hope this helps. If you have any questions, post them in the discussion area. I'll be glad to answer. With this, let's move to the next lesson.
Hi everybody, and welcome to this lesson on looking at what different benefits that we have in terms of migrating to the cloud. So when you're migrating applications and data and infrastructure, you want to use cloud services that best meet your and your organization's needs. And you want to make sure it goes as smoothly as possible. So in order to get the most out of the cloud once migrated, you need to know that you're getting as many of the advantages of the cloud as possible. So what I've done is I've tried to list as many as possible. Now, this is not an exhaustive list by any means. These are some of the top benefits that I believe organizations can have by migrating to the cloud. First and foremost is the faster deployment times. Now, migrating to the cloud means you should be able to deploy your apps, your services, and your infrastructure more quickly. Now, many of the services provide the ability for you to quickly provision servers and other resources within a few steps and even within a few seconds. As we'll see in AWS, it's essentially a couple of buttons and you have an entire server provisioned for you. Now, that's obviously a lot simpler process in compared to buying the servers, installing the OS, placing it in your data center, and so on. And even for medium to large organizations, even procuring the server is a multi-week process. So this significantly speeds up that process. Next is the enhanced security features. Now, most cloud providers, and especially AWS, take care of some of the tougher security issues, such as keeping unwanted traffic outside a specific scope from accessing the machines on which your data and your apps reside, and ensuring automatic security updates are applied to their systems to keep from being vulnerable to the latest known security threats. Now, one thing you do need to keep in mind is that you will still need to have security policies in place when you're configuring the servers and the virtual machines and the applications. That does not mean that you should not have security in place. That just means that some of the inherent security features, such as the physical security, such as the main OS security, or the managed services that you're opt in for AWS, such as the database services, have built-in security features. So those things you do not need to worry about. For example, a hardware or software firewall. Everything is there in AWS, but it still needs to be configured and operated by you if, for example, you are operating your own. But if you are using some of their managed services, then everything is managed by AWS. Next is the Lex infrastructure complexity. Now, cloud systems tend to peel away the complexity of infrastructure that underlies the architecture being used, and makes it very easy for you to provision new machines. Like I had mentioned a few minutes ago, that essentially in AWS, when you click a couple of buttons, you have essentially provisioned a new server. Now, if that's not less complex, I honestly don't know what is. Then you have the ease of monitoring, or the built-in status monitoring. Now, a lot of services that are provided by AWS are able to provide monitoring, so you can be notified when an app or a machine has potential issues or is actually experiencing an outage. Now, this saves a lot of time in terms of you physically having to sit there and monitor each and every one of your resources. For example, AWS has many services, many management tools that allow you to do that, such as CloudWatch. It sets automatic notifications when certain actions happen. For example, if your CPU is above a certain threshold on some of your servers, or your memory usage is above a certain threshold, it can send you notification. So you are notified when certain things happen, so you don't have to worry about servers going down, or you not being notified about a service going down. And the best part about it is if, for example, a server does go down, you are easily able to provision a new one within a few seconds. Then you have the automatic backups and the logging of key metrics. Now, related to monitoring, backing up and logging services are very important, especially in today's day and age when data is very important. So this makes performing disaster recovery very easy and simplifies that process. The backups allow you to get things up and running in no time. Then you have a centralized management, or some also say a single pane of glass. A good cloud service provider such as AWS makes all of the things appear as though they are a single pane of glass, meaning you have a single dashboard where you're able to see anything and everything within your entire infrastructure. And you are able to do just that within the AWS ecosystem. And second, but not last, but especially not least, is the reduced costs. Now, when you're provisioning servers on AWS, you pay as you go, and you can scale up and you can scale down based on your need and based on your demand. So for example, let's say that you have an e-commerce website and you know that Black Monday is coming up and you are expecting a significant spike in traffic, or you're launching a new product and you're expecting a significant spike in the amount of traffic or the amount of visitors you're able to get. Now, if you were not on the cloud, that would mean you'd have to buy a couple of extra servers to make sure you meet that demand. And that money could essentially go to waste if you know that traffic is not going to last. If that traffic is not going to be sustainable, then the extra servers or the extra hardware that you have bought in provision are going to sit idle until the next time you do have a spike. So you've wasted a lot of money and a lot of resources in getting the servers up and running. Well, all of that is simplified in AWS and in the cloud, in that, for example, you can provision servers to go up when you have a spike in traffic. When the spike in traffic goes down, the servers automatically get decommissioned, and you only pay for what you use. So for example, when that spike in traffic happens and you provision 5 new servers, then you pay for those 5 new servers as long as the traffic is there. When the traffic drops, those 5 servers drop, and so do your costs. And last, and especially not least, saving the planet, as I like to call it, or reducing your footprint. For example, if you are a large organization, you'll have to set up a data center, or you might have data centers which are going to definitely increase your carbon footprint. And for a lot of MNCs and large organizations that are spanning the globe, a lot of them are becoming more and more conscious of such actions that have a negative impact on the environment. They have lots of CSR initiatives that allow them to take such things and take such actions that would reduce their carbon footprint. And by utilizing already data centers and already hardware that's there by AWS, or essentially any cloud provider, you're able to decrease the amount of hardware and the amount of carbon footprint that your organization is putting out. So again, just a few of the benefits. Again, this is not a exhaustive list by any means, but just some of the top ones which I believe are main and core to migrating to the cloud. Now, it's not all up and up on migrating to the cloud. There are a few drawbacks to migrating to the cloud because it's not essentially for everybody. So these are some of the drawbacks which I have come across when migrating certain organizations and consulting with certain organizations to migrate to the cloud. First, you have data sensitivity. Now, a lot of organizations, they have or they work with extremely sensitive data, which might be certain laws, or they might be in certain jurisdictions, which bar them from uploading that data to the cloud, or in some countries in the Middle East, you're not able to take data out of the country. So if AWS or Microsoft does not have a data center in the country, then essentially you're not able to host that data on the cloud, and you need to host it in your own data centers. So those are situations, obviously, when moving to the cloud in that specific or in that particular situation would not be viable for you. Second drawback, again, if you have a very small setup, if, for example, everybody works remotely, you essentially do not have a server environment, then it does not really make sense for you to go to the cloud, because essentially there's nothing to migrate to the cloud, because everybody's kind of working in a work group, they have their own laptops, they're working remotely. So in that sense, obviously migrating to the cloud would not reap you any of the benefits which I just described before. Next, there's latency. So now, obviously, if you're migrating to the cloud, if you put all your servers to the cloud, if you do not have that internet connectivity or that cloud connectivity, then your users are going to experience latency as compared to if the servers were in-house, or if servers are sitting in the same network. So depending on the type of connection where you are geographically, that could be a drawback. Second last one that I mentioned on there is loss of control, because obviously, those physical servers are not in your physical control. So you do not actually sit physically in front of the server. You cannot take the hard drives out and pop them in. So you do lose that sense of control within your hardware, which is potential drawback for an organization. And lastly, switching, which is more of a change management or a cultural shift, but is a drawback because a lot of organizations are hesitant to do that because of the could be the amount of training or the change management that they would have to do. But essentially, if that is the case, then you are most likely working for a large organization, and then the benefits far outweigh the drawbacks. Hi everybody, and welcome to this lesson on looking at the different strategies that are available out there or that we could employ when we are migrating to the cloud. Now there are quite a few different strategies out there. What I'm going to do is just take you through some of the more common ones that are employed by a lot of organizations. So the first one is something referred to as rehosting, which is also sometimes called lift and shift migration, because there's no code or no such advanced coding that you need to do to migrate your infrastructure. You're simply lifting it up and putting it in the cloud. And one of the main reasons organizations employ this is for timing, because this is a very, very quick way to migrate everything to the cloud. Now, each application or each VM is essentially picked up and put on the cloud virtually. And lots of different reasons or use cases when this would be employed. First and foremost is if you need to get it done quickly. So if you're in a time crunch, this would be the main one that you would want to employ when moving to the cloud. Or for applications or services that are already architected to use the AWS infrastructure. Some applications require recoding in order to work on the cloud, but if your applications are already architected to utilize the cloud services, then this would be a perfect choice. Or businesses that require applications but no need to change the capabilities, which again goes hand in hand with the previous one. Or apps or databases requirement that can only be met using AWS virtual machines. So for example, if you are employing a new database or a new app that requires a significant hardware upgrade, then obviously rehosting will be the best option because you can get it done very quickly. And then lastly, moving apps without any code changes, which basically means that your apps can operate efficiently on the cloud infrastructure and do not need any recoding. Then we have something called a refactor, which is also referred to as repackaging. Now this strategy involves some change to the application design, but no wholesale changes to the application code. So your app can take advantage of IaaS or infrastructure as a service or platform as a service products within the AWS ecosystem, such as their managed database services. So why use this when you have an existing code base and dev skills and code portability is a concern? Then this would be a good way. A quick way to modernize your app. So if you've been using one of the legacy applications, this is a good way to not only go to the cloud, but also modernize your app at the same time. Or driving continuous innovation by taking advantage of DevOps and the containers, such as the Docker containers or the Kubernetes container. Moving on down the complexity chain, we have re-architect, which is essentially modify or extend your application's code base to scale and optimize it for the cloud. Now here you would modernize your app into a resilient, highly scalable, independently deployable architecture and use AWS to accelerate that process. You can scale applications with confidence and manage your apps with ease. So this is essentially going down the complexity chain in terms of changing the architecture of your applications. So why or when would you use this? Again, to take advantage of an existing application investments, meet scalability requirements, bring new capabilities that are only available on the cloud in AWS into your organization or into your app, and improve the agility by applying some innovative DevOps practices, like the code commit and the code pipeline can be employed within your applications or within your architecture. And then lastly, we have the rebuild. Now, rebuild basically is an app building it from scratch using cloud native technologies. Now, AWS Platform as a Service provides complete development and deployment environment in the cloud without the expense and complexity of software licenses, the need for underlying app infrastructure, or even middleware and resources. So with this cloud migration strategy, you manage the applications and services you develop, and AWS essentially manages everything else. So this way you can put your resources in developing the app and not really, or the program, and not really have to worry about what underlying infrastructure it will operate on. So why and when to use this? Again, for the rapid development when existing app is slowing you down, and obviously you need to take your business to the next level. Building new apps using cloud native technologies, building innovative apps to utilize and take advantage of IoT or AI or blockchain. Again, blockchain can be done off the cloud, but a lot of the cloud services, especially the AWS blockchain service that's offered, makes life a lot easier. expediting innovation, and again, as the previous one, applying innovative DevOps practices. So those are the four main strategies which a lot of organizations employ, either rehosting, refactor, re-architect, or rebuild. And again, going for simple to the most complex, which is rebuilding. So it just depends on your organization, your use case, your business, what you're trying to do. If you're simply trying to move to the cloud and everything you have can be migrated without any issues, without any modifications, then obviously rehosting would be the case. But if you are an organization that's been using a lot of legacy applications, then obviously you might want to look at some of the other three, or even rebuilding the entire application or the entire infrastructure from scratch. Hi everybody, and welcome back. So in this lesson, what we're going to do is we're going to take a look at the process that's involved in migrating your infrastructure to the cloud. So essentially, there's a four-phase migration process, which is designed to help you and your organization approach migration of, a few tens, hundreds, or even thousands of applications to the cloud. Now, while each phase is common and component of successful migration, they're not discrete phases, but an iterative process. So as you iterate and migrate more applications, you'll be able to dive repeatedly and predictably in processes and procedures and find the migration process accelerates. So there's a comprehensive portfolio of tools which are provided by AWS, and they've partnered with a lot of third-party organizations to provide automation and intelligent recommendations based on their machine learning to simplify and accelerate each step of the four-phase migration process. So the four phases that are involved in the migration process is an assessment, you have readiness and planning, you have the actual migrations, and then you have the ongoing operations and optimizations. So let's take a closer look at each one. So first we have the assessment. Now at the start of your migration journey, what you need to do is identify your organization's current level of readiness for operating in the cloud and the potential business outcomes for the migration. So an initial understanding of your, let's say, existing environment, of your infrastructure is really necessary. And it allows you to develop a business case for the migration, because migration is not really a cheap process. Essentially, it could cost your organization quite a lot of money depending on the size. So you want to make sure that there's a strong business case that you can take to your management. So through data and on actual utilization of your on-prem resources, you can essentially create a more accurate forecast of your TCO, or your total cost of ownership, to run these workloads. So there's lots of tools which are provided by AWS and third parties that assess your on-prem resources and build a right-sized and optimized cost projection for running those apps on AWS. So one is a TSO Logic, which is essentially another company which is owned by AWS, which provides a total cost of ownership projection for AWS based on your actual utilization of resources. So the Migration Hub, which we'll take a look at later in this course, generates correct EC2 instances or virtual machine recommendations for running on-prem workloads. So AWS can help you develop this business case by using Cloud Value Framework, which is a proven method that delivers a compelling business case to sell to your management. Then there's also the CART, or the Cloud Adoption Readiness Tool, which helps you develop plans for cloud adoption and enterprise migrations. It basically assesses your readiness across a few perspectives, such as business, people, processes, platform, operations, and security. So once you complete the survey, it generates a customized assessment chart and readiness that you can take and make part of your business case. Now, it also has a pretty neat feature in terms of a heat map and a radar chart that helps you score the readiness of your organization. So those are three main things that you can use to assess if your organization is ready, or even if the cloud is the right decision. Because if you're a large organization, and let's say your total cost of ownership comes to tens of thousands or even millions of dollars, then it might not be as strong of a business case as you initially thought. So after our assessment is done, let's say if it's proven successful and we're ready to migrate, the next step is readiness and planning. So in this phase, what you basically do is you address the gaps in your organization's readiness that were uncovered in the assessment phase. So in this phase, you get to basically analyze the environment, create a map of interdependencies, of services, of infrastructure, of applications, and determine migration strategies, which we looked at in the lesson earlier. Are you going to rehost or are you going to rebuild? And that allows you to build a detailed migration plan with priorities for each application. So after that, you basically set up a secure and well-architected AWS environment and an AWS account, which is also referred to as an AWS landing zone. So as part of the readiness and planning phase, you can create a migration plan, which includes building experience through initial migrations and refining your business case. And you also focus on building your baseline environment, driving operational readiness, and also building your skills in the meantime. Now, one thing to especially keep in mind, which is critical to migration, is collecting application portfolio data and rationalizing applications using some of the common migration strategies, such as rehosting or replatforming or rebuilding. You have to make sure your applications are ready to be hosted on the cloud. Now, there are lots of different services which are provided by AWS in this phase, such as, there's the Application Discovery Service, which automatically collects and presents detailed info about any and all application dependencies and utilization to help you make more informed decisions in terms of which strategy is going to be right for your organization. They also have third-party partners such as Risk and CloudAmaze and Adadata, Deloitte to help you in these tools or in this phase. Now, the hub automates the planning and tracking of the application migration across multiple AWS and partner tools. So it's kind of like your main dashboard during your migration process. Then there's also the AWS Schema Conversion tool. It makes heterogeneous database migrations predictable by automatically converting the source database schema and a majority of the database code objects to the format compatible with the target database. So let's say you're migrating, you have an Oracle database and you want to migrate to the Amazon Aurora. You will require the schema conversion tool to make sure that your schema is converted to be compatible with the Aurora database. Landing Zone, like I mentioned, helps you set up a secure multi-account AWS environment based on best practices. So before you start to migrate your first few applications, the Landing Zone helps you set up your initial security baseline. And then lastly, you have a control tower, which helps set up an automated landing zone, which is a well-architected multi-account environment. So not only is everything automated and easily done through a click of a button, it makes migration a lot easier. So after we have the assessment done, we have the readiness and planning, everything done, now it's time to actually migrate our resources. So in this phase, the focus is going to shift from the portfolio level to the individual application level, since each application is going to be designed, migrated, and validated. So you'll need the capability to automatically migrate, one or thousands of applications from different source environments, whether they're physical, whether they're virtual, to AWS. Now, these applications typically involve widely used open source databases. And again, additionally, you'll probably will likely require a one-time migration of a large volume of data to AWS. So again, the migration hub helps you manage all of that. Now, the best approach for many applications is to rapidly move to the cloud and then re-architect in AWS. Now, the cloud indoor migration quickly rehosts a large number of machines from multiple source platforms, again, either physical or virtual, to AWS without worrying about the compatibility, performance disruption, or long cutover windows. So for situations where you cannot install an agent-based migration service on your server, the Server Migration Service provides an agentless service to make it easier and faster to migrate thousands of on-prem workloads to the AWS environment, essentially in a snapshot. Now, if you have a VMware Cloud Foundation-based environments, the VMware Cloud on AWS quickly relocates hundreds of apps virtualized on vSphere to AWS Cloud in just a matter of a few days. And the best part about it maintains the consistent operations with your on-prem environment. So it's a very robust software and a set of tools that AWS has developed for the migration process. And then after the migration is done, obviously the job is not done. Then you have the ongoing operations and optimizations to make sure that the apps and services that were migrated to AWS are operational and they're optimized. So at this stage, again, you would efficiently operate, manage, and optimize workloads in the cloud. In an ideal situation, you would build off the foundational expertise you've already developed. And you can use the AWS Management and Governance Service for an end-to-end IT lifecycle management for both your AWS and non-AWS resources. So the AWS Managed Services can essentially help you accelerate your migration by providing ongoing management, cost optimization, and operations of your infrastructure. So essentially, if you do not have the expertise to migrate your infrastructure or your applications to the cloud, you're also able to utilize the services of AWS through their managed service and their management and governance to help you migrate and optimize your applications to the cloud. So those are essentially the 4 main steps in the process of migrating to the cloud. Again, you have the assessment, you have the readiness and planning, you have the actual migration, and then you have the operation and optimizations. Hi everybody, and welcome to this lesson on looking at the Migration Hub. So now that we know or have a good understanding of what the Migration Hub is, we have a good understanding of the cloud infrastructure and migrating strategies and why we should or should not migrate to AWS. The Migration Hub is basically the main tool that is utilized by AWS to help you migrate your resources to the cloud, to AWS, in a very streamlined fashion. So this is the main dashboard that is provided by AWS that allows you to essentially manage everything, your entire migration process. One thing to note, you'll see Cloud Indoor. It is a free service, free migration service, which we'll take a look at in the next lab, which helps you migrate your infrastructure to AWS. It's essentially like I mentioned in the previous lesson, a company which is owned and operated by AWS, which is why it makes it very seamless to use Cloud Indoor to help you migrate within AWS. So in the main dashboard, you can see it'll show you, your most used applications that you've been using, the tools, the migration status in terms of, the servers and applications which have started, the progress and the complete, and the overtime. So it gives you a very good detailed view of your entire migration ecosystem. And here on the right-hand side, you have quick access to a lot of the different tools which are provided by AWS, which we had briefly discussed, the connectors, the tools, the programs, let's say if you wanted assistance by AWS and so on. So here on the left-hand side is where we have all the different options for using the dashboard provided by AWS. So the main steps in terms of migrating to the AWS ecosystem or to the cloud in general is first step is obviously discovery, which is where we discover all the different infrastructure and applications that you have operating within your environment. So after the discovery is done, that's when you go ahead and you migrate all of that infrastructure to AWS. And here there's also an option for assessing, which is a good tool, which we'll quickly take a look at in an upcoming lesson. It gives you recommendations on what type of virtual machines or hardware you should use in AWS based on your current hardware. So it's a very, very good tool, especially if you are looking at a rebuild strategy in your migration. This would be a very good tool to utilize. So in the Discover options, we have multiple options within the Discover pane. We have servers, applications, the data collectors, and tools. In the servers, it gives you a good overview in terms of how many servers you have within the migration process, what servers you're what servers you're including, what servers you're not including. As you guys can see, there's an error because I'm in the process of deleting this and going back to the original state. Now, each server is grouped into what's called an application. So application is a good way to group various servers, because most of the time, let's say if you are working in a web environment, you'll have one or two or multiple servers that are acting as web servers, or that are acting as database servers, or that are acting as file servers, and so on. So it's good to group those servers within applications, and so you can logically move your infrastructure to the cloud. Now, obviously, that's not the case for every organization. So you might only have one server and essentially one application, because you only have one server that does everything for you, or you have one server that's a web server, and then you have another server that's a file server, and so on. So it's not a requirement that you have to have multiple servers within each application, but they are grouped with applications. Then you have the data collectors, which are basically the agents that are running on the servers in your network to collect the data of your server. And we'll look at how we use the data collectors in collecting information about our hardware or our applications within our infrastructure. And here are the three main tools which are provided by AWS. So first, we can either import our infrastructure into AWS. So for example, let's say if we don't want to run any kind of discovery agent on our infrastructure, we simply want to hard code what should be imported into AWS in terms of what should be provisioned. We can import a CSV file. So if I click on the import template, so here's basically an import template. So here we can populate it with as many servers as we want, right? So, but it does get very detailed in terms of the BIOS ID, IP address, MAC address, and so on. So I will include this in the download section for you guys to view, or you can, again, or better yet, you are also able to download it directly from your AWS dashboard. So if you want to do it manually, you are able to do that, or you can have a discovery connector or a discovery agent. Main difference is if you are running a VMware environment, then you would want to use a discovery connector, because it's an agentless connector that works with vSphere and your vCenter. If you are not working in a VMware environment, then you'd want to use a discovery agent, which basically gets installed on your physical server or on your virtual machines, and it collects all of the data. And we'll look at how we use a discovery agent in the upcoming lab. Additionally, you can also click on this. It gives you a good information in terms of how each one differs. So it gives you a good breakdown in terms of the cost. All three of them are free. The supported OSs, importing or the discovery connector or the agent, it's a very good table for you to use and understand which one will be better suited for what you are trying to do. And you also have partner solutions, which can be looked at the various partners that AWS has that help you migrate your infrastructure to AWS. So these are all the different tools that are provided by AWS in terms of discovery. Then you have the migrate, which again takes you through your migration process of what's currently pending, what's completed, or if anything has errored out. Here would be all the applications, the file servers, the database servers, and so on, and the tools. Before, these three tools are the import, discovery connector, and the agent are for discovering your infrastructure. Now, after the infrastructure is discovered, to actually migrate to AWS, there are various tools. We have the server migration service. We have the Cloud Indoor. Now, the server migration service, again, is inbuilt within the AWS ecosystem. Cloud Indoor is a separate organization, but also it is an AWS company. Or you also have third parties, which is ATA Motion or River Meadow, which you can utilize to help you migrate your infrastructure to the cloud. And then the AWS also has the database migration service, which is specific to helping you migrate your databases to the cloud. So after you have your discovery, you can use any one of these 4 or 5 services or tools which are provided by AWS or third parties to actually do the migration of your infrastructure, of essentially copying everything that's in your server and moving it to the cloud. So that's essentially the Migration Hub, a very, very good and powerful tool to help you manage your entire migration process. Hi everybody, and welcome to this lesson on discovering your network infrastructure through the Migration Hub. So there are a few things that we need to do before we go ahead and get started with discovering our network infrastructure. So the first thing we need to do is, in the Windows server, we need to modify the firewall to allow a certain port number 443 to go through. That is what the agent uses to communicate. So that's one of the things that we need to do and ensure that our firewall has that port open. Now, for the purposes of this tutorial, I am working on a Windows 2019 or 16 server in terms of demonstrating how we can discover the network infrastructure and have it migrated to the AWS environment. So as you guys can see, I have a virtual machine open that has a Windows 2019 server running on it. It's a standard edition evaluation version, but that does not make a difference. The only difference is the Hyper-V is not available in the eval version, and especially if you are working in a virtual machine. Nonetheless, the first thing I'm going to do is I'm going to create a new rule in the firewall that is going to allow the TCP port, which I just mentioned, to go through, just so the agent can work properly. So I'm going to go ahead and create a custom role and click on Next. I want to apply that for all programs, and the protocol type that I want is specifically TCP. Port number, I can allow all ports, but again, that would be a security no-no. So I'm going to specify a certain port, specifically 443, and go ahead and click on Next. Which local IP addresses does this rule apply for? I'm just going to do all for the purposes of this demonstration. But for in production environments and for security purposes, you would want to make sure that you only allow certain IP addresses in and out. But since this is a demonstration, I'm just going to go ahead and allow all, and I want to make sure that I allow this connection to go through. And I'm going to give it a name. And go ahead and click on Finish. There we go. So now that we have our firewall rule created, we can go ahead and move on to the next step. Now, the next part is I want to install a Visual C+ installation just so the network agent can run. So as you guys can see, I've navigated to the download center in Microsoft. And what I want to download is the VC REDIST x86. You want to make sure that it's the x86 version and not the x64, regardless of what architecture you're working on. Even if you have a 64-bit OS that you're working in, make sure you download the x86, just because the network discovery agent operates specifically with the x86 architecture. So you want to make sure that you download the x86 and not the x64, regardless of what architecture you are operating in. So I'm going to download this file. Next thing I want to do is I'm going to navigate to my AWS console, and I'm going to go ahead and go into IAM because I need to create a user account that has credentials. So I'm going to go to users. I'm going to go ahead and add a new user since I don't have any created at this point in time. I'm going to call it Agent Discovery for the purposes of this demonstration. I want to make sure they have programmatic access. And just for the sake of it, I'm also going to allow the Management Console access, but you can get by with only programmatic access if you want. Let me just change the display settings of this virtual machine real quick so you guys can see the entire screen. I'm just going to change the resolution to, let's go with 1600 by 1200. There we go. Let me go back into my console. Now you guys should be able to see the entire screen. There we go. So now you can see all the options. So as you guys can see, I've selected programmatic access, and for the sake of it, the console access, I'm just going to give it a password for logging in. And just uncheck this box. We don't need to have them create a new user. Now, as for the permissions, we want to make sure that we attach existing policies with this user just so the discovery agent has the proper permissions to interact with your AWS environment. So what we want to do is we want to click on Attach Existing Policies, and instead of scrolling through, I'm just going to go ahead and search for AWS Application Discovery. There we go. So we have two options. So we're going to select both the options and make sure that the user is added into these policies. Go ahead and click on Next. If you want to add tags, you're more than welcome to, but I'm just going to go ahead and create the user. There we go. Now, a couple of things we want to do is we want to make sure we note down the access key and we note down the secret access key. They will be utilized by the discovery agent for logging in and interacting with your AWS environment. So I'm just going to quickly copy these into Notepad just so I have them for reference. So that's the access ID. And I'm also going to copy the secret access key. Make sure you do copy this, because once you get out of this screen, you will not be able to see the secret access ID again. So you'll have to create a new user account. So make sure you note these down for programmatic access. So now that we have those two prereqs done, we have the Visual C++ agent downloaded, and we also have the user account created in IAM. Next thing, I'm going to go on and head out over to the Migration hub. I'm going to click on Discover because I want to discover my network infrastructure. Either one, we can click on the yellow button or here. We want to use the discovery tools which are provided by AWS in order to do the network discovery. Again, three different options we have. I'm going to go ahead and do the agent for Windows, and it's going to download that agent on in my download section or on my desktop, depends on where you go ahead and save it. So that's the third step. So again, going on with the first step was downloading that Visual C++. Next one was creating the IAM user for the agent to have discovery. And then lastly is downloading the discovery agent to get that up and running and started. There we go. So now we have both those items downloaded in my desktop. Next, I'm going to go ahead and open up. The command prompt. And I'm going to go ahead and install the AWS Discovery Agent MSI with this code. And again, the key ID and the key secret you guys see here is just copy and pasted from my notepad, which I saved. One thing I did forget is obviously we have to install the Visual C++ distributable files before we go ahead and install the agent. So I'm just going to quickly double click on that. It's a pretty quick install. And once that is done, that's when we can run this command again to install the discovery agent. It's again very simple and quick process to install the discovery agent. There we go. So once that's installed, we're going to go ahead and click on finish. Now when that's done, we're going to go into data collectors because obviously we want to collect the data of our infrastructure or of our servers. We're going to click on the Agents tab. And here we see that agent is automatically populated in my dashboard. You guys can see the agent ID, the host name, the collection, the health, and so on. So what we want to do is start the data collection. And here we have different options for, not different options, we have one option for a data collection. We can enable the data exploration in Amazon Athena. So let's say you have a large footprint in terms of servers and applications. We can do that if you want to use the powerful querying of Amazon Athena. So we're going to go ahead and get that agent started so the data collection can happen properly. If I go back into my server manager, you guys can see those two services are automatically started. The AWS Discovery Update and the Discovery Agent have been started on my server. And my server is also populated, or the discovery agent is also populated in my migration hub. You guys can see the status is healthy. And once it's started, you guys will notice that the servers will start being populated in the server section. At this point in time, I only have one server in my virtual machine. That's why only one is showing up. But if you had 10, 50, or 100, all of them would slowly start showing up as the agent starts to discover the various infrastructure that you have within your environment. And here it populates all of the detailed information about your server. To verify, we can see that the IP addresses of what's in my AWS dashboard and what's actually the IP address of my server do actually match, which is 10.0.2.15. Just so we can confirm that it is indeed the same server that the discovery agent has discovered. We can see the cores, the CPUs, the disks, so a very detailed information. Now for more detailed information, we can go on to Amazon Athena in our dashboard. And here we can see that there's already been a database that's been created for us in terms of our server. We can run different queries to query the data about our servers, about our infrastructure, to get more detailed information about what we have, and how we can migrate that to AWS. So that's essentially what the discovery agent actually entails in terms of discovering what you have on your network and how you can get that populated and moved on over to AWS, which is the next step, is migrating this information or this server into AWS. Hi everybody, and welcome to this lesson on the EC2 instance recommendation services provided by AWS. So within our Migration Hub dashboard, we have an option for EC2 instance recommendations. So when we get started with this, there's a few options that we can specify in terms of AWS recommending what EC2 instances we should be using. So the first sizing preferences, we basically specify what type of utilization this server is going to have, and then what region we are going to be having or launching these servers into, what type of tenancies we want in terms of shared, dedicated, the pricing models, and also if we want to exclude any type of server. So let's say if you want to exclude the very expensive ones for accelerated computing so it doesn't consider them, we can go ahead and check this box. So when we do this and we export this recommendations, what it basically does, it generates an Excel file that compares your existing servers that have been discovered using the network discovery tool, which we used a few lessons ago. And it compares them to industry best practices that have been, and it generates basically a recommendation file for each server that's been discovered. As you guys can see, there's only one line since only one server has been discovered. I only have one server running, but it will generate recommendations for each and every single server that you have discovered within your migration hub. It's a very detailed Excel file in terms of giving you full recommendations for basically everything, your CPU, your memory, whether it should be reserved or dedicated, what type of hard disks you should have, how large this should be. So it's a very detailed Excel file that gives you again, these are all only recommendations that AWS believes based on your data input and based on your servers that have been migrated. Because remember, the servers that are migrated, the discovery agent also checks, what your CPU utilization is, what your memory utilization is, what your network bandwidth utilization is. So it compares all of those metrics. And here is a basic table that takes you and describes each one of those fields in a bit more detail. So as you guys can see, it's a fairly exhaustive list in terms of the details, in terms of what AWS provides, in terms of recommendations. So I've found it very useful for a lot of organizations that want to, if you're not only rehosting in terms of your migration strategy, if you're rebuilding, this is a very, very good tool to use because you can use the industry best practices knowledge that AWS has gained, with their extensive data centers and lots of small to large companies that have used their hardware. They've developed some very, very good metrics to help you choose which hardware will be best suited for your usage. Again, this is not a one-size-fits-all, and not every recommendation will be perfect. But if you are rebuilding your network infrastructure, it's a very, very good tool to use to give you an idea to what you should be utilizing and provisioning within the AWS.
Welcome back. Let's talk about value in data analysis solutions. So when you have massive volumes of data to support few insights, you may be missing the value of your data. So let's bring this into focus, right? So over the previous 5 or 6 lectures, I've talked about the volume of data coming into the systems, right? The velocity of ingesting and processing this data, and the variety of data sources to ingest and analyze. So I've also talked about the problem of veracity, right? The 3 V's so far, the integrity and trustworthiness of data. So here, I'm going to talk about the challenges of value, right, in the data analysis solution. Now, before making decisions, it's important to extract value from your data. Now, I'm going to talk about the analytics that are needed to, produce meaningful information and the AWS services to perform analytics and to produce reports and dashboards. I've also talked about data collection, the speed of collection, data storage, capacity, processing, and analytics. All of these have one thing in common. They do not evaluate the data for usefulness. So, storing terabytes of data that no one will ever look at, analyze, or visualize is a futile effort. Now, the real effort should be placed in finding out what the value of the data actually is, right? And then learning ways to extract that value, from the terabytes of data that your business has collected. Now, data in the absence of meaning is meaningless, right? Words in a language you don't understand are equally meaningless. So it is only when meaning is applied that the data or words can be understood easily. Now, data analytics comes in two classifications: information analytics and operational analytics. Now, information analytics is the process of analyzing information to find the value contained within it. Now, it is a broad classification of data analytics, right, that can cover topics from the financial accounting for business to analyzing the number of entries and exits in a secure building. Now, the second form of analytics is operational analytics. So it's quite similar to information analytics, but it focuses on the digital operations of the organization. Now, let's talk about the different methods on how you analyze data to extract value, including which AWS services you can actually use to do so. So, how do you get data to make decisions, right? Analytics is the answer. Now, there are two forms of analytics that I'm going to be talking about, right? That I've already talked about: information and operational, right? The main two. Now, information analytics is the process of analyzing information to find the value contained within it. Now, it is a broad classification, of course, right? That can cover topics from financial accounting for business to analyzing the number of entries and exits in a secure building. The second form, which is operational, right? Now, it's quite similar to the first one. However, it focuses primarily on the digital side of the organization itself. For example, the way software applications behave, or the connection between network device and services. But let's begin by focusing first on the information analytics. So, an analytics solution begins by determining what you need to know. What is the question, problem, or position that the solution should explore or define? Now, this will direct you in the type of analysis required to fulfill the need. Now, once this is determined, you select a program to visualize the result in form of a result or dashboard. Now, there are 5 types of analysis: descriptive, diagnostic, predictive, prescriptive, and cognitive. Now, this is often called data mining, right? The first one. This is the oldest and most common. Now, this method involves aggregating or comparing historic values to answer the question, what happened or what is happening? For example, were your sales last month, right? Or what has been the highest grossing cat food in the 4th quarter so far, right? Now, this form of analysis provides insights and requires a large amount of human judgment to turn those insights into actionable information. The next form of analysis is diagnostic. Now, this method involves comparing historic data, often gathered into descriptive analysis, to other data sets to answer the question, why did it happen? Now, with this information, you can answer questions such as why, the social media impressions dipped last month, or what is the likely cause of the increase in customer complaints? So, as with descriptive analysis, this form of analysis provides insight and requires human judgment to turn those insights into actionable information. The next form of analysis is predictive. Now, this method involves predicting what might happen in the future based on what happened in the past. For example, what are sales likely to be in, maybe in the next 10 years based on the current sales? What is the total number of subscriptions that you can expect based on last year's trajectory? Now, this form of analysis provides insight called predictions. Now, these predictions also require human judgment to evaluate the validity, ensuring they are realistic. The next form is prescriptive analysis. This is where the action really heats up, right? Now, this method involves looking at historic data and prediction to answer the question, what should be done, right? Basically, that's what it is. And now, this form of analysis deviates from the three previous and requires applications to incorporate rules and constraints to make intelligent recommendations. The greatest advantage of this form of analysis, right, is that it can be automated. Now, applications that implement prescriptive analysis can make recommendations or decisions and take action based on those recommendations, right? Machine learning, for example, makes this method possible easily. Now, machine learning models, for example, perform the analysis. Now, these models become more accurate through a process called training. You train the model, right? And during training, the application runs the data through the rules and constraints several times. This refines the model's ability to make accurate recommendations. For example, Amazon.com recommends, for example, or AWS recommends based on purchases history. The only time human involvement is required for prescriptive analysis is when you're building and training the model itself. Now, once the model is in production, it can run independent of human interaction. This form of analysis provides insights and recommendations. And the final form of analysis is cognitive. Now, this form of analysis uses a type of artificial intelligence called deep learning. Now, deep learning, along with prescriptive analysis, right, is used to make decisions and take actions based upon visuals, auditory, or even natural language inputs. Deep learning mimics human judgment by combining existing data, patterns, and to draw conclusions. Now, with each analysis, the results feedbacks into a knowledge database to inform future decisions. This creates a self-learning feedback loop. Now, think of Amazon Alexa, for example, or Amazon Q that just came out. The more the system learns from you, the better it is. So as with prescriptive analysis, human involvement is focused on building and training models. Now, once the model goes into production, it can run with little human involvement. But the model thrives based on human inputs, right? This form of analysis provides insights and decisions. It can even suggest and perform actions accordingly. Now, each of these 5 forms of analysis that I just talked about can take advantage of the analysis performed by the other forms. It is the power of combining the analysis that the most powerful analytics solutions are created. So, since I've already talked about, right, which is another form of analytics, it is really a sub-form, by the way, of information analytics known as operational analytics, right? Now, this form of analytics is used specifically to retrieve, analyze, and report on data for IT operations. Now, the data includes systems and security logs, right? Complex IT infrastructure events, for example, or processes, user transactions, and even security threats. Now, operational analytics uses mathematical algorithms and other innovations to extract meaningful information from, the sea of data collected by management and monitoring technologies. Operational analytics also utilize 5 forms of these information analytics analyses, right? Now, operational analytics is provided in a form of software applications, of course, right? Makes sense. Now, these applications can provide root cause analysis, which can help users identify the causes of system behaviors, service impact analysis, and problem assignment, which can help organizations assign events to the right team for investigation. Now, many of these applications are now offering real-time behavioral tracking also, right, using cognitive analysis with deep learning in it. These apps, learn from behaviors and usage patterns from other applications and systems within the environment. This is done by implementing cognitive analysis. Now, information analytics is the process of analyzing information to find the value contained within it. Now, this is pretty synonymous with data analytics, by the way, right? Businesses are making thousands of decisions with or without solid information to back them up. But the hope, of course, is that there are solid facts that back up each decision. But the unfortunate reality is that decisions are often based upon assumptions. Now, these assumptions may have a basis in reality, but they are still assumptions, right? What businesses need is a fast and efficient way to get meaningful information from all of the data that you're gathering. Now, this is where information analytics basically plays a role, right? So, it is basically a series of processes with the goal is to provide insights to business. Whereas the operational analytics, like I talked about, right? They have, systems or thousands of applications or systems that are constantly generating data. So the ops analytics simply collects that data for you to evaluate. This could be logs, could be security logs, could be any threats that are associated to or within the organization. It gathers all the IT operations data. Now this data is system logs, security logs, complex IT infrastructure events, for example, or other assets that you have within your platform or within the entire organizational infrastructure, right? So, for example, the IT research or IT analytics is simply to extract meaningful information from the entire operations of your IT infrastructure. Now, within AWS, for example, the Amazon Elasticsearch service is used to implement analytics. Operational analytics benefits, for example, right? Why do you need those? So you need those to basically, it provides the means to gather insights from the operational data collected from streaming data and in real time. So when you know more, you can do more. So by aligning your on-premise systems with your cloud-based infrastructure, you create an environment allowing operational insights to drive decisions and save time and effort. So seeing is believing, right? Visualizing the results of the data gathered using operational analytics allows you to gain intelligence on enterprise systems and big data sources. So creating interactive dashboard, for example, allows users to find the information that they need immediately. Knowledge is power, right? So operational analytics produces powerful fact-based decision-making systems that enable businesses to explore historical events and then begin using advanced analytics to predict future trends, potential threats, and big opportunities. So, I hope this helps. I've covered extensively the information analytics and operational analytics, right? Which is the value of data itself in a data analysis solution. Let me know if you have any questions. With this, let's move to the next lesson. Let's dive deeper into the types of analytics, right? Now that you understand the two types of classification of analytics, right? It's time to talk about how you actually analyze the data itself. Now, these analytic types can be used with both information and operational analytics. So why do we analyze data? Hopefully, so far, all of the lectures and what we've been talking about has helped you with data analysis solution, right? So it's all about getting high value, actionable insights from your data assets. Now, ideally, data is made available to stakeholders through self-service business intelligence tools like Amazon QuickSight. So simply throwing data into bar chart is not enough. As a data analyst or data engineer, right, it's your job to describe, report to consumers what they're actually seeing and why is it important and how to move forward with the information provided. Now, it is also your responsibility to know what types of analytics are needed to meet the needs for each analytic request that you receive. So, predictive analytics, let's talk about that, right? AWS has Amazon ML, machine learning, and a set of services including artificial intelligence, AI, for example, that make it easy for developers to apply predictive analytics to their data and add new smart data processing features to their applications. Amazon has a long and rich tradition around machine learning, right? And much of this accumulated technology has been packaged up for customer use with this service. The machine learning stack has three key layers. Application services to enable developers to use pre-built AI functionality into their app without having to worry about the ML models that power these services. Platform services makes it easy for any developer to get started and get deep with ML. and framework and interfaces for ML practitioners, for example, right? So here you notice in the architecture, you see an example using Amazon ML to produce real-time predictions to users of an application. Now, in this architecture, there are several services working together to produce the predictions. Amazon DynamoDB, for example, is the storage location for the application data. Now, AWS Data Pipeline orchestrates the flow of data and preparation for use in Amazon SageMaker. You can then train a machine learning model to use the data within Amazon SageMaker to make real-time predictions based on user activity. Cognitive analytics is next, right? So, this is the newest form of data analytics. So it is providing an incredible opportunity to provide highly specialized recommendations, right, to businesses without any human involvement, past the initial configuration and training of the ML models. Some real-world examples, right? Let me give you some real-world use cases and examples. So, financial software providing accurate and real-time fact-based investment recommendations is one. Healthcare software giving customers access to reliable recommendations on treatments and up-to-date healthcare options is another example. Or veterinary software helping those doctors to help quickly and accurately diagnose, or software like Fantasy Football League to manage their teams, right? Analytics services and velocity. Basically, the first time you push data into a data analytics system, right, the data will flow from ingestion into a staging storage location. Now, data will then be processed from the staging location and may result in a data being placed in an analytical data store. Now, processing of the data from this staging location may be repeated many times to produce many different analytical results. It's important to have a solid understanding at this stage that what you can expect from different processing types. Batch analytics, for example, involves querying large amount of data. And batch analytics are implemented on large data sets to produce a large number of analytical results on a regular schedule. MapReduce-based systems such as Amazon EMR are examples of platforms that support batch analytics. High-level frameworks that run on Apache Hadoop, for example, can streamline and significantly speed up your batch analytics. The framework you should use basically depends on what type of workloads you have. And some of the most popular frameworks used with Hadoop are Hive, Tez, HBase, right? Presto, or Pig, or Spark. Each of these frameworks can be installed on Amazon EMR clusters. So, various systems and platforms, by the way, can be stacked or combined with each other. So, for example, the Hive query engine employs MapReduce jobs to implement various components of its SQL queries. And most data warehouses have some, right, or even extensive support for running batch analytics. Interactive analytics basically involves running complex queries across complex data sets at high speeds. Now, this type of analytics is interactive in nature and allows the user to query and see results right away. And batch analytics are generally run in the background, by the way, right? Providing analytics in the form of scheduled report deliveries. So for interactive analysis, Amazon Athena makes it easy to analyze data directly in Amazon S3 and Amazon S3 Glacier using standard SQL queries. So Athena is serverless, so there's no infrastructure to set up or manage. You can start querying data instantly, get results in seconds, and then pay only for the queries you run. Simply point to your data in Amazon S3, define the schema, and then start querying using standard SQL. And most results are delivered within seconds, by the way. Amazon ES allows you to search, explore, filter, aggregate, and visualize your data in near real time. Now, the service has easy-to-use APIs and real-time analytics capabilities alongside the availability, scalability, and then security that production workloads require. Amazon Redshift provides the ability to run complex analytic queries against petabytes of structured data, and includes Redshift Spectrum also, which runs SQL queries directly against exabytes of structured or unstructured data in Amazon S3 without the need of unnecessary data movement. And then Stream Analytics requires ingesting a sequence of data and incrementally updating metrics, right? Reports and summary statistics in response to each writing data record. This method is best suited for real-time monitoring and response functions. Streaming data processing requires two layers, right? A storage layer and then a processing layer. So the storage layer needs to support record ordering and strong consistency to enable fast, inexpensive, and of course, that kind of makes sense, right? So reads and writes of large streams of data, for example, are in the storage layer. And the processing layer is responsible for consuming data from the storage layer, right? Running computations and then notifying the storage layer to delete data that is no longer needed. Many platforms have emerged that provide the infrastructure needed to build streaming data applications, including Amazon Kinesis, for example, Apache Kafka, or Apache Spark Streaming, or Apache Storm. Amazon Kinesis is a platform for streaming data on AWS, of course, right? Offering powerful services to make it easy to load and analyze streaming data and enables you to build custom streaming data applications for specialized needs. Now, Kinesis offers two services, Amazon Kinesis Data Firehose and Amazon Kinesis Data Streams. So if the data in your stream needs format conversion, transformation, enrichment, or filtering, you can pre-process the data using an AWS Lambda function, right? You can do this easily before your application SQL code runs or before your application creates a schema from your data streams. You can install streaming data platform of your choice on the Amazon Elastic Compute Cloud, right, or EC2, and Amazon EMR, and build your own stream storage and processing layers. So by building your streaming data solutions on Amazon EC2 and Amazon EMR, for example, you can avoid the friction of, infrastructure provisioning or gain access through a variety of stream storage and processing frameworks. Now, options for this layer includes Apache Kafka, Apache Flume, and options for the stream processing layer, for example, include Apache Spark Streaming and Apache Storm. So, data analysis solutions and AWS services go hand in hand. So, for example, ingestion, collection, right? You can collect data in ways in large batches or in a stream process. So services that help you are Amazon EMR. So for example, if you need to take a look at and how to house data, you can use Redshift or Amazon Glue or Athena, right? All these services can work together based on your solution, right? So whether you're using Kinesis or Kinesis Streams or Firehose, that's really what you need to based on your own project. And you can store data in two ways, by storing objects or by storing records in a database or a data warehouse. And services, by the way, for these, you can use Amazon S3, right? That's a powerful, and I've talked about it, and you've seen the hands-on also on Amazon S3, right? Or you can use data lake architecture, right? You can create an entire architecture or data lake. Or you can use Amazon RDS for relational database, or DynamoDB, right? So you can use that as well. So all of these services are related to your DBs, right? Or Amazon Redshift, or Redshift Spectrum. So all these services go hand in hand, like I mentioned earlier, right? And that's really what it is. So processing and analyzing data is done in several stages, and it is an interactive process. So the initial processing, cleansing data will go through first, right? Then the data will be placed into an analytic data store. Now this can be, be an added object or a record level. It's not uncommon for data to be reprocessed or analyzed from the analytic data store. Services for these, for example, you could use Amazon Machine Learning, right? That kind of creates models, and you can then create analytics. Or you can use Amazon EMR that allows basically or uses other services, right? Or Glue or Athena and all these services like I mentioned, right? So the idea is that you can use these projects based on your own requirement, right? Now that could be a good exam question because they give you a scenario and then they ask you to identify which service would be the best suited service for this particular scenario, okay? So make sure you go through all of these exam questions as I provided those as well, right? So you understand the scenario base. So understanding each of these services and where these services fit in, right, would be the correct answer or the right solution based on what you're working on, okay? So other services like Redshift or Spectrum or Glue or Athena, all these services, you need to understand each one of these and then see how they work. So I hope this helps. I've talked about primarily all these services and how they relate to different types of analytics. With this, let's move to the next lesson.
Welcome back. Super excited moving forward. In this lesson, I'm going to demonstrate how to create your first visual based on your own data source. So what we're going to do here is first, of course, import a CSV file that contains sample sales data, and then we'll create a first visual, and then I'm going to demonstrate how easy it is to actually use AWS QuickSight and then take a look at the power features of the visuals. So first, of course, you have to log into your AWS account. Once you're logged in, just navigate to Services, and then under Analytics, click on QuickSight, and this is going to take you to the QuickSight homepage. So once you're on that homepage, notice you'll see several data sets. So I'm going to go ahead and import dataset by either clicking on Manage Data or New Analysis. Either way, it takes you to the same page, right? So I'm going to go ahead and click on Manage Data. And this gives you the existing datasets that you have. So I'm going to click on New Dataset. And then, of course, choose Upload a File because I'm going to import a CSV file. So let's go ahead and click on Upload a File. And then let's start off with a simpler dataset with just 100 records. So just select 100 sales records, and I'm going to provide you these sample files for you to practice as well. So click Open, and what this is going to do is upload the file into QuickSight and import the data. A dialog box appears. It just says Confirm File Upload Settings. You could change the fields. For instance, there may be instances where you do not want to import certain records or certain fields, right? So you can click on Edit Settings and prepare your data. This is something that I'm going to talk about a little later, but for now, let's focus on creating our first visual based on existing data. So click Next, and this is going to give you the data source details. Tells you that there are 100 sales records.csv, that's the name of the file, and it's going to import to Spice, right, which is the memory engine running behind the scenes. Has about 1 gigabyte of space, and you can see it kind of on the background here as well, right side. So once we confirm the sales record.csv, let's click on Visualize, and this is now going to take you to the actual visual page where you can go about creating your own visuals. Now once by default you import, right, and it kind of gives you the message on the right side that 100% success, import completed, 100 rows were imported to Spice. So I'm going to close this message dialog box. Let me go ahead and increase the size, and you can do so by just dragging from one of the bottom right corners. And what Amazon QuickSight gives you is the autograph, right, where it says choose one or more fields and let QuickSight choose the most appropriate chart. So if you choose one of the field lists from the left side here, AWS is going to suggest the chart for you, but we're not going to do that. We're going to create manually our first visual. So we know that all of our fields are listed here, right? These are the fields from our CSV file. And of course, the icon represents the type of the field. So the number would be, let's say, total cost is the calculated field, number field, or text field, and so on. So first, let's select the type of visual, right? The type of chart that you want to create. So I'm going to go ahead and select the vertical stack bar chart. As soon as I click on it, on the top here, the field welds section appear, which gives me the x-axis, the value, and then the group color. So I can add a dimension in any one of these boxes. I could, of course, drag and drop the field list from the left side, left navigation pane, and drop them on the x-axis, and my graph will show up. So since we're creating the vertical stack bar chart, that requires at least one dimension in x-axis. Okay, so that's the type of the chart. Let's take a look at another example before we come back to this. If I were to choose a vertical bar chart, notice as I hover over each one of these, it shows me that what type of dimensions are required on a minimum. So the horizontal bar chart would require one dimension in y-axis. For example, a pie chart would require one dimension in group color. The tree map, one dimension in group by. Line chart, one dimension in x-axis, and so forth. So you can kind of take a look at, for example, the scatter plot requires at least one measure in x-axis, which means a calculated field, right? A measured field. And one in y-axis also measures with custom aggregation need one dimension in color. That's how you would get the scatter plot. So you need to be able to understand the different visual types so that you can create your own chart accordingly. Since our data relates to sales information, right? So this is our sales data. So we have country, we have item types that we sell, we have the order date, order ID, priorities, region, sales channel, how do we sell, whether it's online or offline, ship data, total cost, profit, revenue, and so forth. So I'm going to go back to the vertical stacked bar chart, which requires one dimension in x-axis. I could also choose, of course, simply the vertical bar chart. So let's go ahead and just do a simple vertical bar chart. Okay, let's go ahead and start with the simple visual, and then of course I'm going to demonstrate others as well. So the vertical bar chart says one dimension in x-axis. In other words, I can pick a field list here on the x-axis, which is the horizontal axis, right? So let's say I'd like to choose the sales channel. As soon as I try to drag the sales channel onto the workspace, notice it gives me a blue area, right? A blue circle, dotted circle, and then of course the circle in the center, and then the green on the bottom here as well. So notice on the top here on the field welds, I can drag it and add it to the x-axis. I could have just added directly on the chart as well. Okay, scroll down here a little bit or make it smaller so you can a little bit see better. Perfect. So now, as soon as I drag the sales channel, which means either we're selling online our products or we're selling offline our products. So it shows us both online and offline. And there are 50 products that we sell offline and 50 that are sold online. So half online, half offline, because they're a total of 100 records. Next, notice it gives me the scale as well, right? 0, 20, 40, 60, and so forth. The sales channel, as I hover over this, notice it brings me to this little icon here. It says arrow pointing to the left, arrow pointing to the right. So if I click on this particular button, it's just going to sort. Okay, so this is your sort feature, which is A to Z, which means in ascending order, offline and online, right? Similarly, from Z to A will be online and offline. Okay, so just a quick way to sort directly from within your visual. Okay, perfect. Next, let's add another field. to our chart. So I'm going to go ahead and select, let's say, the order priority, right? So I'm going to drag order priority, and let's say I'm going to do this by group or color. So as soon as I do this, notice it gives me 4 different types of order priorities that I'm actually using, right? C, H, L, or M. And then each are color coded by default by QuickSight. So as soon as I get this, it tells me that the order priority C has 9 online sales, and then of course H is 13, online L is 15, and then M is 13, and so forth. Same with the offline. It's very easy for me to change the color coding. So for instance, if I need to change, let's say, the green, I can simply click on this vertical green bar and then go to color M and then simply change it to red. And it's going to change for both online and offline sales. Similarly, of course, I can change the other colors as well. Maybe the online H priority, order priority, I need to change this to maybe a different color, yellow. Okay, so you get the idea. It's very powerful, very easy to use. So now we have our priorities and of course our sales channel. I can also add other fields. So for example, if I need to, let's say, add total revenue, okay? So if I add total revenue to the measure here, it's going to give me the sum of total revenue by sales channel and order priority, okay? So now my revenue is on the y-axis, right? So it tells me that this is 20 million, this is 40 million, 60 million, right? So the yellow bar, which is the highest priority item here at this point on offline sales, is about $31,772,954 and so forth. So that way you can easily drag and drop and create your visual based on your own requirement. If I were to change the visual type, it's fairly straightforward. Let's say if I do a pie chart, just click on pie, and this is going to create a pie for you. If you need a stacked, vertical stack bar chart, this is going to give you that as well. Same thing with, let's say, the horizontal bar chart, it's going to give you that as well. If you do not want any of these fields, you can simply click on the drop down arrow within the field wells area and click remove, and this is going to remove the field for you. Similarly, if you do not want the sales channel, you can remove it and you'll be back to square one. So that way you can create your own visual based on your own requirement, right? Let's say I want to add unit price. I want to see the measures of unit price. Then it's going to show me that 5,000, 10,000, right? So this is going to be on the x-axis. So based on your own requirement, of course, you can generate and play with the type of visual that you require. So just to give you a small flavor of how easy it is to create your own visual. There are other features, of course, there are other powerful elements that I'm going to get into, like calculated fields, preparing your data, a little later on in the course. But for right now, just get comfortable in dragging and dropping fields and then adding or creating your own visuals. One thing I also want to show before I end this lesson, for instance, if you want 2 values on either the x-axis or the value axis or the group color, let's say I like to choose the country, right? So I'm going to drag the country and drop it on the group color. So now it shows me horizontal, right? Since I have horizontal, let's select the vertical bar chart. And this shows me the countries list as well, based on my sales channel for both online and offline. So here, I can, of course, expand, make the chart bigger, right? And also notice that there's a scroll bar on the right side, right? So I can scroll down to different countries and then select each one of them and just kind of take a look at how many different countries I have from top to bottom in alphabetical order. And same thing for these charts, I can click on any one of these. For example, if I need to change the title, I can simply click on the title itself and then change the text. So it says sum of unit price by sale channel and country. I can maybe just change this part and country, right? So you get the idea. It's pretty powerful. So that way you can now add and manipulate your chart or visual details as you like. Of course, same thing, you can change the color by clicking on any of these vertical bars. And then, of course, you can focus on the offline only. You can exclude offline. You can simply focus only on Sierra Leone, for example, and so forth. So let's go ahead and focus only on this. So this is now going to give me just the country called Sierra Leone and give me the offline sales for that country. And you'll also notice as soon as I do this, it creates a filter, right? So the filter icon appears, and on the left navigation pane, it says applied filters. And right now, I've automatically applied a filter to my chart. So if I uncheck this box, for example, it's going to bring me back to the original visual. So it's very easy to actually create a visual and then try to identify and hone in exactly what you're looking for. So I hope this helps. I just wanted to cover the basics of creating a visual. If you have any questions, post them in the discussion area. As a homework, try practicing with different data sets, right? So if you have a small Excel file, perfect. Use that, bring it in, upload it, and then create different visuals. So with this, let's move to the next lesson. Welcome back. Once you're on the QuickSight dashboard, in this lesson, I'm just going to give you the overview of the interface itself and what it looks like. It's fairly simple as compared to other BI tools like Power BI and so on. So I'm finding, AWS to be pretty robust and powerful. So within the dashboard, you have, of course, your home page, right, or your dashboard itself for QuickSight, which is this particular icon up on top, and you can search for analyses, data sets, and dashboards if you already know the names of your existing data sets or dashboards. On the right side, on the first menu bar here is the location of where your instance or where your account is located to the nearest location. And then this is your account for QuickSight, the account number for your QuickSight. You can either click on Manage QuickSight Account to navigate to another page where you can actually take a look at and manage settings like your buckets and your permissions and so forth. So before I demonstrate this, let me complete the visuals or other areas on this particular page. On the center here, you'll see the all analyses, all dashboards, right? So currently there'll be none because we've not created here anything at this point. And of course, some tutorial videos. And as a homework, you can just run through these basic ones just so that you get comfortable with working with the first set of creating your first visual or customizing your visual and so forth. So let's navigate back to all analyses. These are the default samples that come with QuickSight dashboard, such as the web and social media, sales pipeline analysis, people overview, and then of course your business review analysis. Right below the QuickSight icon, you'll notice the new analysis. If I were to click on this button, it'll bring me to the data sets, which are the same data sets that we just saw, right? The sample data sets that already come with the QuickSight. On the right, it shows you the Spice usage. Again, remember, Spice is just the memory engine, right? That stores all of your data, so it gives you the feedback instantaneously, so you don't have to wait and fetch data. So you get by default gigabyte, right, on your standard account. All right, perfect. So back to the home page here. Manage data button also takes you to the same page, right? Data set. So it's fairly straightforward, okay? So either way, you can create a new data set or you can use the existing samples. If I click on the new data set, it takes me to the create a new data set page. And from here, I can choose several sources, right? Data sources, in fact. And this is where I can either upload a manual file, such as a CSV file, a TSV, maybe an Excel file. I can connect to the Salesforce, the existing S3, RDS, MySQL, SQL Server, and so on. So there's several data sources. And if you work with, let's see, the other cloud platforms like Google Cloud Platform, for instance, or OpenShift, you'll see pretty similar data sources that you can connect to, right? You can connect to Spark, MariaDB, GitHub, Twitter, and so on. So this gives you the ability, and by the way, also to ServiceNow, okay? Perfect. So several options if you wish to create your own data set. I'm going to be demonstrating, right, as we move along, how to connect to most of these and how they actually work. Perfect. Let's go back to our homepage. So that's really all about the interface itself, fairly straightforward. One thing I want to show you is the account, right, which is Manage QuickSight. So let me go ahead and click on Manage QuickSight here, and this will take you to your account name, which kind of tells you the existing user, since only one user, which is the admin, active. And of course, you can take a look at your subscriptions, the Spice capacity, for example, which is about 1 GB at this point. You can purchase more if you need to. But by default, on this free account, it comes with 1 gig. You can click on account settings, and here you can change your permissions, right? In other words, if you need to connect to another bucket, for example, you could do so. So if I click on edit AWS permissions, this will take me to a page where I can specify additional and edit the QuickSight access to my existing AWS resources. So in one of our earlier lessons, remember, we chose our own bucket, right? Storage area, instead of using the default QuickSight bucket. So here you can, of course, choose your own bucket. You can create your own buckets if need be, and so forth. So this gives you an idea of what you can do. In our instance, we're using the CLIDESK-admin bucket, right? Perfect. So I'm going to close this. If you have additional ones, by the way, before I close this, if you have additional ones, you can click on S3 buckets. You can choose a different bucket here, or you can choose accessible buckets from other AWS accounts. So it's up to you. So let's close this. Let's go navigate back to our homepage of our QuickSight dashboard. Perfect. So this is all about the interface, fairly straightforward. Just going to practice with this. If you have any questions, post them in the discussion area. With this, let's move to the next lesson. Welcome back. Super excited moving forward. In this lesson, I'm going to demonstrate how to upload or store your data sets within S3, which is the file storage or the buckets in AWS. So let's get started. I'm going to go ahead and directly go to my console first, because of course that's where the S3 is, not in QuickSight. So I'm going to navigate and shift tabs here. So within the services, right, AWS services, notice the under storage section, you'll have the S3. So I'm going to go ahead and click on S3, and this will take me to the Amazon S3 page where I'm going to see the existing buckets or storage that I already have. So I have 5 buckets. 1 is public and 2 regions. What this means that region could be, let's say, US East North Virginia, and I believe I have 1 in Ohio as well. So it depends on where you wish to have your buckets created. The word of caution here, as you work more and more with AWS, you'll notice that these regions matter a lot. So if you have a bucket here in this region and you have buckets in other regions, so just be aware that sometimes pulling data might not work based on the permissions and the roles. Okay, so keep that in mind. All right, so once you're in the Amazon S3, I'm going to go ahead, either you can create a bucket or use the existing buckets. So I have some of them created here. And as a homework, go ahead, practice. I'm going to not create the bucket here, but this is your homework for you. So go ahead and create a bucket. So I'm going to use the existing GB88 bucket. I'm going to see what's inside. So there are two things inside. One is the 5000 sales record.csv. This is the same file that we've been working on in the earlier lessons as well. And there's also a movie data.json file. I'm going to go ahead and upload. So I'm going to click on upload. I can either drag and drop files or simply click on add file, which will take me to the Windows Explorer. And within my resource datasets folder, I have all of these files that I can upload. So I can choose, let's say, the 5000. I believe this is already available. So let's upload these. So I'm just going to copy all of these, right? And then click open and click upload. And what this is going to do, it's simply going to upload all these files within this particular bucket called GB88. And of course, you can name it anything, right? So this gives you an idea, a fairly straightforward task, because once we have these files within the storage, next, of course, we are going to work with AWS Glue, which is extract, transform, and load. We are going to create a database. We are going to create tables and bring these data sets into those tables and then query them using AWS Athena. Remember our earlier lesson, right? That's the workflow. And then from Athena, we will jump into QuickSight. Okay, so that's the whole idea. So it takes a little while to upload depending on the size of the file. So once everything is completed, we're done with this particular part where we have our files stored in Amazon S3. Perfect. So once all of the files are uploaded, notice you'll see them here. You can also create additional folders or subfolders. Okay, so this is pretty straightforward. Just organize your files as per your own requirement. And once you have these files, of course, you can just kind of click on them if need be. That will show you that you can download the file, you can copy the path, you can see the details of this file as well. So in this lesson, I just wanted to show you how easy it is to actually upload file within the storage Amazon S3. So I hope this helps. Practice with this. If you have any questions, post them in the discussion area, give some feedback. I'll be glad to help. So with this, let's move to the next lesson. Welcome back. In this lesson, I'm going to demonstrate moving forward how to create a database using AWS Athena. So without further ado, let's jump right in. Let's navigate to our services. Let's go to Athena, which is under the analytics section. Once you click on the Athena, it's going to take you to the home page of the query editor. And this is where on the left navigation side or left navigation pane, you can see the databases, right? So currently, by default, it selected the default database, and there's no tables, no views at this point. So what we are going to do is I'm going to go ahead and create a database, right? So I'm going to go ahead and create a database. By the way, if I click on the drop-down arrow, notice there's a sample DB and a test DB and a default. So there are three databases that exist at this point. But we are going to create our own. So the simple syntax, SQL syntax for creating a database is create called database, and then of course the name of the database, which could be any. So you can call it maybe sample DB, or you can say maybe a different name, right? How about my first DB and a semicolon. So once I have this simple query created, and what this is going to do when I run the query, it's going to create a database. Okay, so let's go ahead and execute. Click on run query, and at the bottom it shows you the result, right? So it says query is successful. And now if I click on the drop down arrow, I'm going to see my first DB. Pretty neat and fairly straightforward. If I don't see it, just refresh, right? Manually refresh the table list, and you should be able to get your newly created database. So once I have the database created, right, next step is, of course, to create a table, and then the data within the table is going to come directly from our data set. For that, matter, we would need help of AWS Glue. Remember the ETL, extract, transform, and load concept that we talked about in one of the previous lessons? So the AWS Glue would allow us to transform our data. I call it maybe preparation 2, right, so to speak, even though you could go to QuickSight and prepare your data there as well. But this is more powerful, okay? So I'm just demonstrating and showing you the more powerful and practical way of managing your data sets, and then creating your data sets, managing them, and then bringing them into QuickSight, okay? All right, so perfect. At this point, we have our my first DB. So I'm going to go ahead and make sure you select this, because all queries that you run now will be affecting this database, okay? So once I have the database created, so let me get rid of this. There are a couple of ways you can do this. You can either write the SQL syntax to create a table, right? Bring in the data. If you do not know the SQL syntax, that's fine. No worries. AWS gives you the way. So I'm going to go ahead and create a table. So make sure your my first DB is selected. Let's go ahead and click on create table, because at this point within this DB there are none. So I'm going to go ahead create table. As soon as I do this, I get two options. One is use the AWS Glue crawler, or I can create the table manually. Okay, so I'm going to go ahead and select the AWS Glue. Click on this. This brings up a dialog box and simply pops up a message saying you will go to the AWS Glue console to set up a crawler. And what this crawler would do, it will connect to the data store, right, which is my data set that I've uploaded in the buckets in Amazon Storage, and then automatically determines its structure to create the metadata for your table. So I'm going to go ahead and click continue, and I will be navigated. Yet another tab will open, and this will take me to the add crawler page, and here are the steps. So I'm going to provide the crawler info, specify the data store, in other words, where my data resides at this point, the role, permission set, schedule, output, and then review all the steps, and then run the crawler. So I'm just going to give it a name here, which is going to be my first crawler. And I can specify a description, security configuration, and classifiers. That's optional. And grouping behavior for S3 data. That's optional. So for the purpose of this course, I'm not going to go in depth of all of this. Again, the purpose is just to walk you through the basic fundamental concepts of how things are managed within QuickSight. So once your data eventually reaches QuickSight, what it is that we do and how we do it. And of course, the concepts and the application as well. So I'm going to click next. Choose a data source, which is great because I'm going to use S3, right? You can use others as well, like JDBC, DynamoDB. But since we uploaded our data sets in a bucket, so I'm going to choose S3. Crawl data in specified path in my account or specified path in another account. Since I'm using my own account, right, which is the same account as this, called Claydesk, I'm going to specify the path here. And this is straightforward, so it kind of shows you that you can say S3 and then colon 2 forward slashes and then the name of the bucket, right? So I'm going to say S3 and the name of the bucket is GB88. Okay, how do I know this? It's easy. You can just navigate to services and go to your S3. I'm going to open this link in a new tab. So within your S3, this is GB88, right? Because this is where my data set resides, and that's the data set I'm going to use to run the ETL on. So if I click on GB88, notice all of these CSV files exist. Perfect. So now going back to our Glue console, we know the path is GB88. So this is the path of the S3. Okay. So I'm going to go ahead and click next. Add another data store. Say no. By default, it's selected no. Click next. And notice on the left navigation pane kind of gives you the nice check boxes, right? Green check boxes. Everything is working fine. If not, it's going to give you an error. So here I'm going to choose the IAM role, which allows the crawler to run and access the Amazon S3 data stores. So I'm going to create, either you can create one, which is fine. This is the AWS Glue service role. I'm going to call this my name and then click next. So here's the frequency. I can either run or schedule the crawler, which is either run on demand. I can run the crawler hourly, daily, Tuesdays, weekly, monthly, and custom. So I'm going to say run on demand because whenever I would like to, I'm going to run. So click next. So now it asks me for the database that it wants to go and crawl. Okay. So I'm going to choose the database called SampleDB that we created. Now I can add a database by clicking on this button and then creating a database right from here as well. The prefix added to tables is optional, and this is where you would typically see tables within a database starting with a naming convention, right? So they would say something like tx underscore and then the name of the table, tx underscore and the name of the table, right? So, or if it's a sales database, so it will say sl underscore. So you can choose your own naming convention, but that's optional. So I'm going to go ahead and click next. Or in fact, let me go back to the output. It's not the sample DB, it's actually my first DB. That's the one that we actually, I just remembered. All right, perfect. So let's select my first DB. And of course, you can always go back to any of these steps by just clicking on the links here. So our database is my first. Now I'm going to go ahead and click next again. And this gives me the output and the review of all the steps. So it shows me the name of the crawler, and it's going to create a single schema for each S3 pass. It's going to be false. Data stores are defined. The role is created. Schedule is run on demand, and the output. I can also choose configuration options, by the way. Okay, but that's if you choose to do so, you could use those. So I'm going to go ahead and finish because all of my steps have been completed. So once I click finish, it's going to go ahead and AWS Glue page is going to tell me that my first DB crawler is now ready. So I'm going to click on my first DB crawler and run crawler. I could run this, by the way, on the same page, but I wanted to show you all the details once again on the page, and I'm going to say run this particular crawler. So it's going to give me a message saying attempting to run crawler and so on. So it's going to take a little bit of time to run this, and then once it's completed, it's going to load and it's going to start the crawler. You can see it right here under the status column, and after a while it's going to say it's ready or completed. So you'll notice that status keeps changing, right? So it says my first DB crawler is now stopping, gives you the time, and also tells you the tables that it added, right? So far it added 8 tables based on the dataset store. Perfect. So once it's done, the status is going to say ready and 8 tables are added. So where do I go and verify these 8 tables? Notice on the left navigation pane, I see an option called tables. So if I click on this, it's going to show me these tables. Perfect. And of course, I can click on databases and it's going to show me all of my databases. The connections will give me the connections. If I don't have any, I can add a connection. But typically, that's all it does. It just goes out there, crawls to your dataset store, and then brings in your tables, creates the table. Okay? So once this part is done, next we go back to our Athena page here. So let's go to our services, bring up our AWS Athena. And now we should be able to see these tables perfect right here under my first DB. If you don't see them, just refresh them. Okay. In our instance, all of these 8 new tables were added. This table already existed, right? So 1, 2, 3, 4, 5, 6, 7, 8. Well, because it was blank. So it took all of the data set or all the CSV files within the bucket and then it added them within these tables. Okay. Now I could of course create the table manually, and this is a homework for you. If you need to create additional table, just click on create and create it manually. So this is your homework. Straightforward, by the way. It'll walk you through the same steps. You just have to enter all the names manually. Okay. So once now we have the tables here created, you guessed it right, we can now query any of the tables. And then based on the query, we will move to QuickSight for our visual analyses. So in this lesson, very important, just wanted to demonstrate how to go about actually creating a database, creating a table, using the S3 Amazon buckets to bring in your data into these tables. So practice with these. Hope this helps. Let's move to the next lesson. Welcome back. Super excited moving forward. In this lesson, I'm going to demonstrate how to go about creating a manual table within AWS Athena, and then of course getting into QuickSight and analyzing our data sets. So let's jump right in from within the AWS Management Console homepage. I'm going to navigate to Athena here and just kind of take a look at what we have at this point within the query editor. On the left navigation, I have the database, and of course all of the tables have been created, right? So I'm going to go ahead and create a new table by clicking on Create Table, and then two options that I get is automatically using the AWS Glue crawler or manually. I've already demonstrated this in one of the previous lessons, right? And manually I assigned this homework, so I'm sure you've done it, but if not, then perfect. Let's do it together. So I'm going to go ahead and click on manually, and what this is going to do is going to take me to step 1, which is name and location, and there are about 4 steps in this particular process. So first I simply need to select the database name, which is my first DB because that's the one that we've been working with, and then the new table name that I like to create. So I'm going to call this, let's say, currency. You can call it anything, right? And then the location or the input of data set. We know that our data set is located in a bucket called GB88 in my particular example. Of course, in your instance, whatever it is that the path is, you can get from by going to the storage or S3 storage. Alright, so once we specify the database, the table name, the location, click Next, which brings us to step 2, the data format. So I'm going to use maybe CSV, you can use the TSV or text file, and so on. So in our instance, it's the CSV file as our data set or the source. Click Next, and here I need to create the columns, right? So the column names that I need to provide must be single words that start with a letter or a digit. So one of the first columns is, let's say, currency. And again, you can name it anything you want, but typically you would look at the data set that you have. So I'm going to open up the Excel file here. So this is the file that I'm going to reference as part of the table that I'm creating, right, based off of this particular CSV file. And I'm going to provide this as a downloadable resource so you can practice from here as well. So I'm not going to enter all of these columns, but just for our demonstration purposes or scenario, I'm going to pick maybe a few of them, right? So let's say, maybe let's do country code or country name, or let's do currency unit first, okay? So let's switch back. So it's currency unit. Make sure my spellings are correct. So once I have the currency unit column name, and this is going to be a string or whichever data type it is, I'm going to leave it as string. I'm going to add another column, and my next column is going to be, let's say I'm going to pick any one of these. How about income group? This one. So I'm going to choose income group. And then this is also a string type. And then maybe another one, right? Let's do another one. Let's do a country. Perfect. And this is also a string. Just to verify, I should have a country column here, right? There's the region. Okay, I can do a region. I do not seem to have a country column here. So let's go ahead and select the region, or use region, not countries. So probably better. Perfect. So I have 3 columns. I'm going to click next. And the 4th step is partitions. That's optional, but typically these are just logical columns that are created, by the way. Okay, so partitions are just virtual columns. In case of these partition tables, any subdirectories that are created under the tables data directory for each unique value of a particular column or partition column. And in case the table is partitioned in multiple columns, then nested subdirectories are also created based on the order of partition columns. But for now, I think for our purposes, let's just stick to the basics here and understand that we're selecting a database and we're adding a table, and then we have created 3 separate fields. So once we're done, let's go ahead and click Create Table, and this is going to go ahead and create the table within AWS Athena. Now, instead of going through all of the steps, if you were to just write this particular SQL query and execute, it would do the same thing. Okay. All right, so I'm going to go ahead and refresh my database and select my first DB, and I should be able to see currency unit right here. Perfect. So this is our table with 3 columns, right? That's what we've created so far. If I need to preview this, so I'm going to click on these 3 ellipses and click on Preview Table. The good thing about this is that it automatically writes the query for me, so I don't have to write or type select everything from, and then the name of the database, dot, and then of course the name of the table, and then limit to 10 records. Okay. And on the bottom here, notice I should be able to see my 3 columns: currency unit, income group, and then region. Perfect. So this ran successfully, right? So once I'm done with this particular part, in other words, I've sort of prepared my data, right? That's simply preparing my data because I've added only 3 columns, and that's the data that I like to visualize in QuickSight. So once I have all of this taken care of, next let's navigate to QuickSight and let's manage our data. Create a connection to Athena, to the same data set, so that we can create some visuals. So let's click on Manage Data, and I'm going to go ahead and create a new data set. Choose Athena here. The data source name, of course, is my first DB, right? That's the name of the database. Check to see and make sure that connection is validated. If you do not know the name of the database, of course, go back to Athena, find your database name, and then you can type it. So once everything is good, let's click on Create the Source. It's going to go ahead and bring me to a dialog box, and here I can select the table, right? So from the My First DB, I'm going to go ahead and select My First DB as the database that contains the set of tables that I want to use as a data set. And then since I've created this table with 3 columns called currency unit, I'm going to select this. I can choose to either edit or preview data, or I can simply continue. So I'm going to go ahead and first edit and preview data just to be on the safe side. So let's click on this button. So here I can basically further prepare the data, right? So if I do not wish to see any of these columns, I could just uncheck them and they're not going to be displayed within the data set. Perfect. So now I see all the records as well. So if everything looks good here, simply click Save and Visualize, and this is going to take you to the QuickSight homepage or the workspace where you have a blank autograph. You can either create a visual yourself or simply select the fields and so forth. So this looks probably familiar, right? We've created several graphs and charts earlier on other sets of data. So by this time, you should be pretty comfortable with the AWS QuickSight interface. All right, so once we're here, all we have to do is, of course, start to create our charts. So depending on the type of chart you want, you can select the chart, or you can simply click on, let's say, the currency unit. It'll give you the count of records by currency unit, for instance. Or you can also use the income group. Okay, make this bigger so you can see. Or in fact, let's maximize. Perfect. If I don't want to see the currency unit, I can remove it from the field wells area. And I can choose, let's say, income group. Okay, let's get rid of this, remove this, add the income group. And this is just the count of records by income group. I could change the visual type to a vertical bar chart or a pivot table. Again, it depends on my own requirement. And once I see the visual, I can, of course, make it collapse or expand or go from one country to the other or from one region to the other. And that way, it's easier for me to take a look at. So now I'm looking at the records by income group, right? So the count of records by income. If I need to add a region, I could do so. This way, I'll be able to see the count of records by income group and region. And if I need to change the visual, of course, I could do so. So you can play around with this, and I've, I think, demonstrated enough so that you're comfortable with working based on your own data. So I hope this helps. Practice with this. If you have any questions, post them in the discussion area. I'll be glad to help. With this, let's move to the next lesson. Welcome back. Moving forward, in this lesson, I'm going to demonstrate some additional user interface elements once you open a sample project. So from within the QuickSight dashboard, notice you have 4 sample projects here, or areas where you can actually do some data analysis. And these are data sets, by the way, right? So I'm going to open up any one of these. So for instance, I'm going to click on People Overview Analysis. Okay, and again, it says sample. So once I click on it, this will take me to the actual dashboard where I can now begin to not only see within my workspace the data set or the visuals, right, in different charts such as the pie chart here or the bar graphs and so on, but also there are other areas that I want to highlight and kind of talk about so that you get comfortable with this particular interface. So I'm going to start with the menu here, of course. First, I mentioned that this is just the home icon. Then you can click on the add, which is either add a visual, add a title, description, calculator field, or a parameter. Okay, and of course I'm going to do demonstrations on each one of these. But for now, just a high-level overview of what are various options that are available within this user interface area. So here, all I'm doing is here, once I've selected any one of these elements on my workspace, right? So for instance, if I were to select the hiring by region, notice it just places a blue outline, and I can add maybe another title to it, right? Or I can edit the title directly from this particular tile as well. So I don't need to go anywhere else. I can just simply highlight this and change it, right? Similarly, I can navigate to each one of these and then, of course, change and edit as per my own requirements. Now, the left side, the left navigation, the far left navigation pane has icons such as visualize, filter, suggested, story, and parameters. And this is where I can filter my data. For example, I can apply a filter. If I click on suggested, QuickSight just gives me suggested visuals. We talked about story, right? which is just the interactive or capture button for that particular scene from my data that I can capture and create. And then parameters. So currently there are no parameters for this particular analysis, and I can create one if I choose to. So let's go back to visualize. So the next navigation pane is the data set, which tells me that I'm using the people overview as a sample data set, which is the sample provided by QuickSight. And here it tells me that the spice is being used, right, which is the memory engine being used to house all of the data set within its memory. That's why I get instantaneous results as I navigate and click on each one of these fields if I need to see some other or perform some other data analysis. So the field list displays all of the fields within this particular data set. So for instance, I have the business function field. Since I have the hiring by region selected, notice if I click on a field, it changes the impact on this particular tile. If I click on employee by region and select this, I should be able to change the field types here as well. So similarly with date, with date of birth, education, and so on. So as I click on each one of these, it changes and tells me the field welds. And field welds is the area where I can simply drag and drop these field lists onto the field weld. So if I need to, let's say, do an education, I'm going to demonstrate this later on too. For example, the education needs to go here, I can add it to this particular hiring by region. And of course, change the visuals. If I need to see the horizontal bar chart, that's fine. If I need to see maybe a vertical bar chart, I can do that as well. So again, depending on my own choice and the type of visual I like to see, I could do so. I can make it bigger or smaller. That's my own options as well. But just to give you an idea that this is the field list where I can actually use and then drag and drop and customize the charts. The visual types, I just demonstrated that I could change the visual type from bar to pie chart, for instance, or map or a stack bar combo. And there are several options that are available to me at this point in time. I can click on the drop down arrow and just make this bigger or collapse the visual types, or I can uncollapse it by clicking on the down pointing arrow as well. Alright, so I talked about the field weld, right, which simply tells me the names of the fields on the y-axis, the employee name, value, and group color within the hiring by region. On the right side, it just tells me that the sample data has been imported, 100% success. There are 1,956 rows that were imported to Spice. And I can click on the view summary, and it will just generate a simple summary in a pop-up dialog box where I can also have the choice now to edit the data set, which I'm going to demonstrate later. But just so you know that it just gives you the summary of the file import log. Let's close out of here. Let me close the import complete. Notice the downward arrow within the same menu as the field welds. If I click on this, this will give me the actual name, which is on the y-axis is my employee name. The value, I can add measures if I need to, or the group color, I can add a dimension as well. So right now, it just tells me the employee name on the y-axis, and you can see on the visual as well that on the y-axis you have the employee name. And here I can change by clicking on the employee name, the right pointing arrow, and of course I can maybe pick education, and it's going to change the y-axis to education. So it's pretty powerful and robust in this particular manner. So I'm going to demonstrate this later on as well, but just to give you a high-level overview of the actual interface once you open up your data set. Okay. Similarly, if there are any other calculated fields or group color, I can do so. I can add a dimension here, simply drag and drop, for instance. if I need to, let's say, have, and again, let me do that later on, but right now just stay focused on the concept of field wells, where you can actually drag and drop fields, and then it will change the visual for you. All right, perfect. Similarly, if I were to select the gender diversity, for instance, notice in this instance, this is going to, let me move this chart here, and then of course make it bigger. And all I'm doing is just dragging and dropping, by the way, okay? And then I'm expanding it by one of these corners. So here on the x-axis, I have the date. And of course, the color is gender here in this instance. So that way you can just simply quite easily navigate and customize your field wells. On the top menu bar, of course, on the left here, I have the undo, and I can add. I demonstrated that earlier. Undo my changes or redo the change. And then capture is the story. So if I need to capture a certain scene, for instance, I can use the capture icon here. I can share and collaborate and email users this particular chart, or I can publish the dashboard, or I can share my analysis. All right, great. So I think this is my workspace with several visuals in this instance that you've created. You can create others as well. For example, in this instance, in this sample, you have the average tenure and monthly compensation, education profile, web business function, and each tile that you select on the workspace, right? Each visual that you select on this particular workspace, notice the field wells changes, and it gives you that particular information based on the selected visual. So if you have any questions, post them in the discussion area. Before I end, just give you the idea that this is an autosave on. You can choose not to save. So if you say autosave off, then it's not going to save the changes, right? Automatically. So you'd have to make sure that you keep it autosave on so that any changes that you make, even if you close, the changes will be saved. Also notice that the field list have certain tags to it. So for instance, the shapes, right? So you'll see the number sign, you'll see the region, like an oval shape, right? Those are just icons telling you the data types. So you can change the data types as well. Of course, I'm going to demonstrate that as well. But for instance, monthly compensation, here I can remove from this particular visual because that's the one that I've selected. I can add filter from this field. I can show number as number, currency, or percent. I can change the format types, even select more formatting options. And again, I'm changing things here, right, on this particular field, on the fly. So in this lesson, I just wanted to quickly cover some additional UI areas for you to understand and take a look at as you work more closely with AWS QuickSight. If you have any questions, feel free to ask, post them in the discussion area. I'll be glad to answer. And with this, let's move to the next lesson. Welcome back. Moving forward, talk about how to upgrade your standard QuickSight version to Enterprise, because you would need the Enterprise version to connect to the AWS Data Sources, right? So for instance, if you were to connect to the RDS, which is the relational data system in AWS, or Redshift, or S3 containers, or buckets, you need the Enterprise version for QuickSight. So currently, let's navigate to and see what version we're using. So on the menu on the right side, let's click on Manage QuickSight, and this will take you to the version that you have. Now notice it says account name, which is CladeSk, and then the edition is Enterprise. If you do not see this, you should have, if you're running the standard version, by the way, once you get here, you should see a button here that says Upgrade to Enterprise. And all you have to do is just click on that button and then click Upgrade. That's all you need to do. And then you will be navigated to this particular page, where now the only new thing that you will see here is called Manage VPC Connections. Okay? Because this is the virtual connections that you need to actually connect to the AWS. So once you see this and you upgrade to the enterprise, let's click on Add a VPC connection. And this will allow you to do a few things. You can connect QuickSight to your data, secured by the VPC, which is the virtual private cloud. And then here the VPC ID can be obtained by navigating to the AWS VPC console. So I'm going to click on this console, and of course you already have the AWS account, right? So you'll be navigated directly to that virtual private cloud page, and by default you should have the VPC ID. So if I click on or select this, I'll see the details on the bottom here, right? So this is the ID, so I'm just going to copy this for now by simply selecting it and doing a Control-C. So we know that we already have a VPC by default available, okay? So let's go back to our QuickSight and just give a connection name. That could be any name, so I'm going to say QuickSight AWS, give it any other name. Choose a VPC, of course. As soon as you click on the drop down, notice by default it gives you the same ID that we saw in the VPC Management Console. You can also choose a subnet for your connection, security group, which is the security ID group. I'm going to use the same as the VPC ID, or you can use the security ID group as well. Click Create, and this is going to load and of course create the connection. But if it gives you the error, that means you need to navigate to the security group console to obtain the security group ID. And then same thing with the subnet ID. So far all we've done is selected the VPC ID. Let's navigate to the subnet console, same way, and just verify our subnet. And that's a good way. So all of these subnets are available. And the one that we're using, let me navigate back to the connection, is 7FF57318, which is one of the available ones. If not, then you need to select the subnet here, copy it, and then go back to your VP connection, and then make sure you use the correct subnet, which is 286, or start with 31A577, any one of these. Okay. So 286 is here, 577 or 7FF, either one. Okay, so I'm going to select the subnet, and then security group ID. I'm going to click on or visit the security group console and try to obtain the ID from here, right? So this is the group ID for the security group. So I'm just going to copy it, go back to my VPC connection and QuickSight, and then paste it. Perfect. So it looks like we have all the requirements here. Let's click Create, and this is going to go ahead and actually create the connection. Perfect. So now I have a QuickSight connection to the AWS source. Let's navigate to the account settings just to verify. Within account settings, I have an option called account permissions. So I'm going to click on Edit AWS permissions just to verify and make sure that we have all of the permissions necessary to connect to AWS buckets, storage and analytics, or the IO. And I can click on Choose Bucket just to ensure that I have the right bucket selected, which is Claydesk Admin. I already have this selected. So make sure all of these are checked. Great. So let's go back to our QuickSight homepage. So this way, in this lesson, just wanted to demonstrate how you can actually upgrade from your standard version to the enterprise version, and then how to create a VPC connection to the AWS. So I hope this helped. Practice with this. If you have any questions, post them in the discussion area. With this, let's move to the next lesson. Welcome back. Super excited moving forward with AWS QuickSight. In this lesson, I'm going to demonstrate how to import a CSV file, maybe your own data set that you have, and you like to analyze that particular data set. So from within the QuickSight dashboard, let's dive in and move to our new analysis, or you can use manage data, right? So either one of the tools on the left or the right side, same buttons. So let's click on new analysis, brings up your existing data sets. Notice in this instance, we only have our samples, right, that are provided by AWS QuickSight. But we are going to create our new data set in this instance. As soon as you click on this, it gives you several options. One of the first options that you see here is the upload a file, right? So I can upload a CSV file, TSV, CLF, ELF, XLSX, or JSON. So I'm going to click on upload a file. It takes me to the Windows Explorer. Here's my sample data set of 5,000 records. I'm going to provide you this as a downloadable resource practice for this as well. So just simply select the CSV file, click open, and what QuickSight is going to do is going to import that particular file. But before it actually imports the file, it is going to give me the option to edit the field, okay? Which is pretty straightforward even with Microsoft Excel, right? If you import a CSV file, you'd have the option to edit the field before you actually import the data. Fairly common. So perfect. In this instance, a dialog box comes up, it says confirm file upload settings, and kind of lets me preview the fields within this data, right? So I have the region column, the country, item type, and then I have the sales column, order, order date, ID, and so on. So I can kind of take a look at all of the fields that are going to be imported. If I click on the edit settings and prepare data, this would give me the ability to select and choose which fields I would like to import and manipulate these fields as well. So this is pretty powerful that I'm going to discuss a little later on, but right now just a standard import into QuickSight. So once you see a visual of the data to be imported, just click next. And AWS is going to actually give you some feedback on the table itself, which is just one single sheet that's going to be imported. Table size is about 1.2 megabytes. It's going to be uploaded in Spice, right? So it's all being stored in memory. The data source contains 5,000 sales records, and the file name is salesrecords.csv. So I'm going to click on Visualize, and this is going to import the CSV into QuickSight. So it's still working. Notice it's just going to take a few seconds. It's going to import. On the right side in the dialog box, it says import complete with 100% success. 5,000 rows were imported to Spice. If I click on View Summary, it's going to give me the same results, right? It's going to tell me that 0 rows were skipped out of the total of 5,000. Everything was successfully imported. So let me go ahead and close. So at this point in time, notice my autograph, right, which is the default workspace, and my first visual is blank. To do this, let me close the import complete dialog box. So here I can choose one or more fields and let QuickSight choose the most appropriate chart. And this is the benefit of QuickSight, right? If I were to click on, let's say, one of the field lists and then start to drag, QuickSight is going to give me some feedback as well. So notice in my data set, it tells me that Spice has 5,000 sales records, a CSV, just sitting here for my consumption. So once I have the data imported successfully, next I can simply begin to create my own charts. I can play with the data. Notice the total profit, costs, the number signs. And again, these are just the different types of fields that are part of my Excel, and I can now start to create a visual. So for instance, let me in fact quickly do this. Let's go ahead and do a country. So I'm going to drag the country onto the visual, and it'll give me all the countries here from the records. And then I need the, let's say, the ship date, right? And notice as I drag, it gives me several options. It gives me the blue and then of course the green, which is the x-axis, right? So if I click on, if I let go on the green area, the ship date, notice the ship date is now on the x-axis and the country is on the y-axis. Similarly, total cost, I can also do the same with total cost. So that way I can start to build the visualizations, okay? And the good thing about QuickSight is that it also gives me the ability to scroll down and view my records within my data source, right? Instead of defining a range and then updating the visual, it's actually letting me in real time take a look at all of my countries list here. So just a small example of what you do after you import the data, right? For the next lesson, I'm going to actually demonstrate how additionally you can work with this imported data. If I need to change the visual type, of course, I can change it to vertical bar type. I can change it to maybe a pie chart and so forth. So I hope this helps practice importing your sample Excel data into Amazon QuickSight. And with this, let's move to the next lesson. Welcome back. Super excited. In this lesson, I'm going to walk you through and maybe troubleshoot area as well, how to in fact take a look at your RDS instances, which is your relational database, right? So you can use AWS to actually create these instances. I have several of them created, and if you need to, you can also create them for your data sets. So this lesson, I'm not going to show you how to do it because a little out of scope, but I wanted to give you the flavor at least so that you're comfortable understanding one of these data sources. So let's jump right into our management console first. So let's tab to our management console within AWS. And within services, click on the drop down arrow. Within the storage, or rather the database section, you'll see the RDS. Okay. So I'm going to go ahead and click RDS, and this is where you can actually create your own database. And then within the database, you can restore a snapshot of your tables or any other data or data sets that you wish to store. Now, this is a little bit advanced or intermediate, I guess, but I just wanted to give you the flavor of how this process kind of works and just kind of show you where to go and look for. But again, this is just a bonus that I wanted to give you guys. Perfect. So once you're on the dashboard of your Amazon RDS, click on instances, and this will give you all of the DB instances that you already have. Also the engine that they're running, like MySQL instance has been created, status, CPU, and current activity. So if you do not have an instance, you can of course click on create database. I'm going to go ahead and why not just create one for you. Select the engine. I'm going to pick MySQL, scroll down, make sure you check this box. It says only enable options eligible for the RDS free tier usage, otherwise you may get charged. So click next, and then here just specify, or it tells you the DB engine, which is MySQL Community Edition. Scroll down the instance, pretty much the T servers are low end, so not low end, but low to intermediate end servers, but at least gives you the option to choose as a free tier. The allocated 20 GB by default storage, and then you can specify the DB instance identifier. So I'm going to say TG99, and this is just a master username, which will be TG100, and then the password, firm password. Click next, and then here you can specify additional settings such as your default virtual private cloud, which is important because this will allow you to connect to your QuickSight, okay, Enterprise Edition. If you do not have QuickSight Enterprise, you don't have the VPC, so make sure you have the QuickSight Enterprise Edition. And the way you find out is just, let me quickly go to QuickSight, go to your settings on the top right corner of the menu bar, click on Manage QuickSight, and here you can say that your edition is Enterprise, okay? And then Manage VPC Connections will give you the existing connections. Perfect. Let's switch back to our console. So now you know the virtual private cloud. And then the subnet is default, which is fine. Whether you want this instance to be publicly accessible or DB instance will not have a public IP address. So it just depends on your own requirement, whether you wish to choose this as public or no. So I'm going to leave it as no. The availability zone is also important because right now you're in North Virginia, for instance, that's the US East 1A. If you choose a different zone, you may not have the right connectivity, by the way, okay? Because you need to be in the same zones to have the VPCs created successfully and managed accordingly. The VPC security groups, create a new group or choose an existing group. So if you already have one, that's fine. I'm going to call it Quick Security. I have a couple of them set up. Otherwise, you can use the default as well. And then the database name, the name of the DB you're actually going to create. So I'm going to say TG111. The port is, of course, always 3306. That's the standard TCP/IP port for the DB instance. And then the parameter group, option groups, the IAM role, the DB authentication, which is disabled, and I'm going to enable it so that you can actually manage your own user credentials through AWS IAM user and roles. In other words, if you're logged on to the AWS console, you should be good as far as if you're a user of AWS. Encryption and backups are optional. You can take a look at those. If you want to have the DB backed up or encrypted, you can certainly use those two options. And then monitoring, you can enable monitoring if need be. This is just enhanced monitoring metrics that are useful when you want to see how different processes or threads use the CPU. Log reports, you can select the log types to publish to Amazon CloudWatch logs if you need to. And then maintenance as well. So once you're done with all of these options, click Create Database, and this is going to create the instance for you. So it may take a few minutes to launch. Sometimes it takes maybe less than a minute. I've seen maybe take a couple of minutes. So let's click on View DB Instance Details. So here's the details of my instance. And if I scroll down, well, first it shows me the summary, right? Standard summary that it's still creating. And then if I scroll down, somewhere in the middle here, right above right here where it says connect, okay? So this is your endpoint URL. So once it's done creating the DB, it's going to give you a URL here, which is your endpoint URL and your port, and then whether this DB is publicly accessible or not. And then similarly, the details section gives you all of the details, like the DB name, the username, the option group, subnets, VPC, instances, and so on. So if you ever need to reference anything, like if Amazon wants to ask you your DB name, right, or you forget your DB name, that's where you come and actually see which instance you wish to connect to. Similarly, resource IDs, the publicly accessible, yes or no, security groups, right? So these are important because if you don't have the right groups, you may not have the right connectivity. So once the DB instance is created, let me go back to instances here on the left navigation pane, and notice it says the TG99 is actually in the process of being created. So once this is created, there's another area that I want to show you so that you don't have any issues connecting to QuickSight later on. So I'm going to click on TG99, scroll down to, let's say, within my details area, and then I'm going to click on VPC because this is your virtual private cloud. So I'm going to click on this, and this will take me to the VPC page or the groups page, and I just want to show you the inbound and outbound rules for TCP that you wish to create. Okay, and if not, you must have created them in order to have connectivity to QuickSight. So here's the VPC. It's available. Again, I can either create a new one. Let me scroll up here. Perfect. So here's the summary. The CIDR blocks, that's the IP blocks associated, the flow logs, and tags, if any. So just to make sure that you have the VPC ID stored somewhere, and if not, you can always reference this here as well. Perfect. So let's switch back to our AWS console and click on instances, just kind of see whether it's still okay, still in the process of being created. So I just wanted to kind of go through this and give you an idea. Let me show you an existing T55, right? That's the instance that's already available. So let me go ahead and click on T55 and scroll down. And here's the endpoint for T55. Okay, so that's the endpoint, and of course the port number, and I've made this as publicly accessible. The security groups, the inbound is important and the outbounds are also important. You need to have these rules, by the way, likewise. So you need to have 0.0.0.0/0, which means all IP incoming traffic is allowed, right? Or outbound means going out is allowed, and same with inbound. And this is important. You need to have these rules set up within the security groups so that you can connect to QuickSight. Okay, perfect. So just wanted to give you an idea quickly on the concept of Amazon RDS and how it's actually set up. You can create your own instances. So go ahead, practice with these so that you get comfortable. If you have any questions, feel free to ask. Before I end, let me once again go back to instances. And perfect. So it's almost done. It's backing up. And once it's backed up, the TG99 database instance will be available. While this is being backed up, let me go ahead and click on our newly created instance. Kind of scroll down, and then perfect. So we have our endpoint, we have our port. It's publicly accessible at this point. No, we already have the security since we clicked on or we selected the quick security group as being part of this group. Notice the inbound and outbound rules with the correct IP addresses or the block is associated with this. Okay. So once your instance is created, let's navigate to our QuickSight. Okay, so I may need to connect to the TG99 RDS instance. Let me go ahead and do this, by the way. Let's go to Manage Data, click on New Data Set, select RDS, right, as part of the instance. The name of the data source, you can call it anything, right? So this is just TG120, just a random name. And then here's the instance ID. Perfect. So it shows up within my instance ID. This is TG99. And then the database name is TG111. The username, I believe, let's go back. The username is TG100. So let's go back here. It's TG100, and of course the password that I used to create the database. I can click on Validate Connection. And as soon as this is validated, I can create the data source. Perfect. So let's go ahead and create the data source. As soon as I do this, I would now have a valid data source to QuickSight. And then if I have any tables within this particular DB instance, they will all show up here. I can simply select the tables and then create the visuals that way. So just wanted to kind of walk you through, even though that's not part of the course here, but this is good to know. I know that you're working with AWS. You need to know the fundamentals of at least navigation or navigating around the AWS console and some of these important areas. So if you have these tables, of course, you could select and then you could go forward from here. Since we just created a blank database, it'll just create the connection and that's it. So close this, just go home. Now you should be able to see the RDS instance that you've created as an existing data source. So if I click on New Analysis, and this is the data sets, let's scroll down, New Data Set, perfect, right here. So now I have
the TG120 as an existing data source. Perfect. So I hope this helps. Just kind of wanted to run the quick overview of the Amazon RDS concepts and what to look for. I hope this helps. Again, this is not something related at this point, but at least it gives you, as a bonus, some idea of Amazon RDS. So I hope this helps practice. If you have any questions, feel free to post them in the discussion area. We'll be glad to discuss. With this, let's move to the next lesson.
Hi everybody, and welcome to this lesson on looking at the Virtual Private Cloud, or VPC. Now, the Cloud Practitioner's exam does have a few questions related to VPC, so it is a very important topic. And then if you're moving on to the Solutions Architect, that one focuses a lot more heavily on the Virtual Private Cloud and the details associated with it. So the VPC lets you provision logically isolated sections of the cloud where you can launch resources in a virtual network that you define. You literally have complete control over your vital networking environment, including selection of your own IP address range, subnets, routing tables, and gateways. You can use both IP version 4 and IP version 6 in your VPC for secure and easy access to resources and applications. You can easily customize the network configuration for your VPC. For example, you can create a public-facing subnet for your web servers that has access to the internet, and place your backend systems such as databases or app servers in a private-facing subnet with no internet access. You can leverage multiple layers of security, including security groups and network access control lists, to help control access to the EC2 instances in each subnet. Additionally, you can also create hardware VPN connection between your corporate data center and your virtual private cloud, and leverage the AWS cloud as an extension of your corporate data center. Now, the VPC provides advanced security features such as security groups and access control lists to enable inbound and outbound filtering at the instance and subnet levels. In addition, you can store data in S3 and restrict access so that it's only accessible from instances in your VPC. Optionally, you can choose to launch dedicated instances which run on hardware dedicated to a single customer for additional isolation. You can create a VPC quickly and easily using AWS Management Console. You can select one of the common network setups that best match your needs and press Start the Wizard, and we will do that and we'll take a look at the wizard and the different options that are available during the lab that's coming up next. Additionally, it provides all of the same benefits as the rest of the AWS platform in terms of the scalability and reliability. Now, a variety of connectivity options exist for the Amazon VPC. You can connect your VPC to the internet, to your data center, or other VPCs known as VPC peering, based on AWS resources that you want to expose publicly and those that you want to keep private. So for example, you can connect directly to the internet by using public subnets. You can launch instances. You can connect to an internet using a NAT, or a network address translation. Private subnets can be used for instances that you do not want to be directly addressable from the internet. Instances in a private subnet can access the internet without exposing their private IP by routing their traffic through a network address translation, or NAT, gateway in a public subnet. And just an exam tip, always keep in mind that a NAT gateway sits always in a public subnet. You can also connect securely to your corporate data center. All traffic to and from instances in your VPC can be routed to your data center over a encrypted IPsec hardware VPN connection. And again, you can also privately peer VPCs, which is connecting one VPC to another. You can privately connect to SaaS solutions supported by AWS Private Link. Now, just as a side note, Private Link basically simplifies the security of data shared with cloud-based applications by eliminating the exposure of data to the public internet. Private Link provides private connectivity between VPCs, AWS services, and on-prem applications securely on the Amazon network. Now, just some VPC limitations to keep in mind, especially for exam purposes. You can have up to 5 non-default VPCs per AWS account per region. You can have up to 4 secondary IP ranges per VPC. You can create up to 200 subnets per VPC. You can have up to 5 VPC elastic IP addresses per account per region. And you can have up to 10 hardware VPN connections per Amazon VPC. Now, for those of you who are not familiar with what an elastic IP address is, it's basically a static IP4 address designed for dynamic cloud computing. So an elastic IP address is basically associated with your AWS account. With an elastic IP, you can mask the failure of an instance or software by rapidly remapping the address to another instance in your account. An elastic IP address in a public domain is reachable from the internet. So if your instance does not have a public IP4 address, you can associate an elastic IP address with your instance to enable communication with the internet. For example, to connect to your instance from your local computer. And keep in mind that as of right now, Amazon does not support elastic IP addresses for IP version 6. So let's go ahead and go into our management console and check out some of the other options and configurations that we are able to do with a virtual private cloud.
Hi everybody, and welcome to this lesson on looking at the basic building blocks of VPCs or virtual private clouds. So a virtual private cloud is a virtual network dedicated to your AWS account. It's logically isolated from other virtual networks in the AWS cloud, and you can launch your AWS resources such as EC2 instances in your own VPC. Now, when you create a VPC, you must specify a range of IPv4 addresses for the VPC in the form of a class interdomain routing or CIDR block. For example, you guys see 10.0.0/16. This is an example of a CIDR block. Now the diagram that you guys see, it shows a VPC with an IP4 CIDR block and the main routing table. The VPC spans all availability zones in the region. After creating a VPC, you can add one or more subnets in each AZ. When you create a subnet, you can specify a sitter block for the subnet, which is a subset of the VPC sitter block. Each subnet must reside entirely within one availability zone and cannot span multiple zones. Availability zones are distinct locations that are engineered to be isolated from failures in other availability zones. And by launching instances in separate availability zones, you can protect your applications from the failure of a single location. So in this diagram, you see a VPC that has been configured with subnets in multiple AZs. So we have 4 subnets, 1A, 1B, 2A, and 3A. Now an IPv6 sitter block is associated with the VPC, and an IPv6 sitter block is associated with subnet 1. An internet gateway enables communications over the internet, and a VPN connection enables communication with your corporate network. If a subnet's traffic is routed to an internet gateway, the subnet is known as a public subnet. So in this diagram, subnet 1 is a public subnet. If you want your instance in a public subnet to communicate with the internet over IPv4, it must have an public IPv4 address or an elastic IP address. If you want your instance in the public subnet to communicate with the internet over IPv6, it must have an IPv6 address, because by default all IPv6 addresses are public. Now if a subnet does not have a route to the internet gateway, the subnet is known as a private subnet. And in this diagram, subnet 2 is such a subnet. Now if a subnet does not have a route to the internet gateway but has its traffic routed to a virtual private gateway for a VPN connection, the subnet is known as a VPN-only subnet. So in this diagram, subnet 3 is a VPN-only subnet. And currently, just keep in mind that AWS does not support IPv6 traffic over a VPN connection. So in an Amazon VPC, each EC2 instance has a default network interface that's assigned a primary private IP address on the VPC network. You can create and attach additional elastic network interfaces, or ENIs, to any EC2 instance in your VPC. Each ENI has its own MAC address. It can have multiple private IP addresses, and it can be assigned to a specific security group. The total number of supported ENIs and private addresses per instance depends on the instance type. The ENIs can be created in different subnets within the same availability zone and attached to a single instance to build, for example, a low-cost management network or a network and security appliances. Now you can set up your VPC subnet as a public, private, or VPN only like we saw before. Now in order to set up a public subnet, you have to configure its routing table so that traffic from that subnet to the internet is routed through an internet gateway associated with a VPC. By assigning an EIP address to instances in that subnet, you can make them reachable from the internet as well. Now it's always best practice to restrict both ingress and egress traffic for these instances by leveraging stateful security group rules for your instances. Stateless network filtering can also be applied for each subnet by setting up network access control lists for each subnet. And we will look at security groups and network access control lists in another lesson. Now for private subnets, traffic to the internet can be routed through a special network address translation or NAT instance with a public EIP, which resides in a public subnet. This configuration allows your resources in a private subnet to connect outbound traffic to the internet without allocating elastic IP addresses or accepting direct inbound connections. AWS provides a pre-configured NAT server image, or you can use custom AMIs that support network address translation. So this figure basically shows an example of a VPC with both public and private subnets by using an internet gateway. Now finally, by attaching a virtual private gateway to your VPC, you can create a VPN connection between your VPC and your own data center. The VPN connection uses industry standard IPsec tunnels to mutually authenticate each gateway and to protect against eavesdropping or tampering while your data is in transit. Now for redundancy, each VPN connection has 2 tunnels, with each tunnel using a unique virtual private gateway public IP address. Now there are 2 different routing options for setting up a VPN connection. There's the border gateway protocol for static routing, and for that you need the IP address and the BGP autonomous system number, or ASN, of the customer gateway before attaching it to the VPC. And then you can also use the AWS Direct Connect to establish a private logical connection from your on-prem network directly to your Amazon VPC. The Direct Connect provides a private, high-bandwidth network connection between your network and your VPC. Now you can use multiple logical connections to establish private connectivity to multiple VPCs while maintaining network isolation. And with Direct Connect, you can establish either a 1 gig or a 10 gig dedicated network connections between AWS and any of the AWS Direct Connect locations. And finally, you may combine all of these different options in any combination that make the most sense for your business and security policies. For example, you can attach a VPC to your existing data center with a virtual private gateway and set up an additional public subnet to connect to other AWS services that do not run within the VPC, such as an Amazon S3 bucket. Amazon SQS, or Amazon Simple Notification Service. In this situation, you could also leverage the IAM roles for EC2 for accessing these services and configure IAM policies to only allow access from the elastic IP address of the NAT server. Now, in the beginning, we looked at something called sitter. Now, I briefly mentioned it, and it's something that's required. But before ending, I just wanted to briefly give you an overview about what is sitter, or classless interdomain routing. It's basically an IP addressing scheme that improves the allocation of IP addresses. It replaces the old system based on Class A, Class B, or Class C. This scheme also helped greatly extend the life of IPv4, as well as slow the growth of routing tables. So in the old method of IP addressing came with inefficiencies and exhausted the availability of IPv4 addresses faster than anybody thought. So the classful routing system included 3 classes, A, B, and C. Class A had over 16 million host identifiers, Class B had 65,000 and odd, and Class C had 254. Now, the problem would commonly occur when an organization required more than 254 host machines and therefore could no longer fall into Class C, but rather Class B, which jumped about 65,000 addresses. So basically, this meant that organizations were wasting a lot of IP addresses when they only needed to use a few. So with sitter, you can define prefixes of arbitrary lengths, making it much more efficient than the old system. The sitter IP addresses are composed of 2 sets of numbers. The network address is written as a prefix, like a normal IP address, and the second part is a suffix which indicates how many bits are in the entire address. For example, /12, /18, /24. Now, I suggest you guys go ahead and go on Google, and there are a few tables, and I've also included that in one of my handouts, that shows you what these prefixes and suffixes mean and how many addresses a /12 would make or a /22 would make. Now, you don't need to know all of these specific details for the exam, but just keep in mind what is sitter and it's required for a VPC. So let's go ahead and log into our AWS console and get our first VPC created. Hi everybody, and welcome to this tutorial on virtual private clouds, or VPCs. So in this exercise, what we're going to do is we'll create a non-default VPC with a single subnet. And just as a reminder, subnets enable us to group instances based on our security and operational needs. So there's 2 different types of subnets. There's a public subnet, which is accessible by the internet, or a private subnet, which is accessible only within that VPC. So after doing that, we'll create a security group for our instance that allows traffic only through specific ports. We'll launch an EC2 instance into our subnet and associate an elastic IP address with that instance, which will allow our instance to access the internet. So first and foremost, we're going to go ahead and create our VPC. So let's navigate to our VPC section. And from our VPC dashboard, we're going to launch the VPC wizard. And here we have several options in order to launch VPCs. We can launch it with a single subnet. We can have VPCs with public and private subnets. We can have VPCs with public and private subnets and hardware VPN access, or with private subnet only and hardware VPN access. And the hardware VPN basically allows us to connect our on-prem network onto the VPC hosted by AWS. So we'll stick with the single subnet. Let's give this VPC a name. And up here it mentions an IPv4 CIDR or sitter block. Now, this is a bit outside of the scope of the Cloud Practitioners exam. We'll need to know about this in the Solutions Architect course and exam. So this just basically gives us a number of IP addresses that we're able to use in binary formats. In a total, there's 65,531 IP addresses available. So if you want to limit the number of IP addresses that are allocated to this subnet, we can do that through this sitter block. The availability zone gives us a choice of where we want to create this instance in based on the region, which I'm currently in London. We'll just leave it as no preference. We can also additionally give this subnet a name if we will have multiple subnets. It's always good to differentiate between private and public ones. So with the service endpoint, in the service endpoint section, we can select a subnet in which to create a VPC endpoint to Amazon S3 in the same region. So here we can either allow DynamoDB or S3. We can limit the amount of access that these services will have to this VPC, or customized access. And in the custom one, we'll just have to use either this JSON editor, or we can use the policy creation tool. So with this enabled, DNS hostnames, when set to yes, it ensures that instances that are launched into our VPC receive a DNS hostname. And the hardware tenancy option enables us to select whether instances launched into the VPC are run on a shared or dedicated hardware. Just keep in mind that if you select dedicated tenancy, it incurs additional costs. We'll go ahead and click on Create VPC. So if we go into our VPCs, we see there are two VPCs, the one that we just created and the default one that's created when we launched our first EC2 instance. So now that we have our VPC created, let's go ahead and create a security group. And if you remember, a security group basically acts as a firewall, a virtual firewall, to control the traffic for its associated instances. So for a security group, we need to add inbound rules to control incoming traffic to the instance, and outbound rules to control the outgoing traffic from the instance. Now, VPC does come with a default security group. Any instance not associated with another security group during launch is automatically associated with the default security group of the VPC. So let's go ahead and navigate to our security group section in security. Well, we're going to create a security group. And here we're going to select the ID of the VPC that we just created and create the security group. So here you can see the security group that we just created. So once we select it, on the bottom we can see a description, and here is where we can specify the inbound rules and the outbound rules. So in the inbound rules, let's go ahead and click on Edit. We're going to add a rule, and here are all of the rules that we can add. So let's go ahead and allow HTTP traffic, and the source is basically the 0.0 means from anywhere. And let's also add in an HTTPS. And if you guys can see, it automatically detects the default ports for both HTTP and HTTPS. So now that we have our VPC created, we have a security group associated with it, let's add instances to this VPC. So if we go back to our dashboard before we selected Launch our VPC Wizard, so let's go ahead and select Launch EC2 Instances. We'll just select the default instance that we created in the previous lesson. So here is where we can select the VPC that we want this to be associated with. If you guys remember, the last one that we created was associated with the default VPC because we only had one. Now that we have the other VPC created, we can associate this instance with this VPC. And here also, if we had multiple subnets, they would show here, but since we only have one, only one is showing up. And here is where we can associate security groups with this instance. So here we can either create a new security group or select an existing security group. We want to select an existing one because if you recall, we just created this one previously. So we'll associate this instance with this security group, and here it defines what the security group allows. It allows both HTTP and HTTPS traffic inbound and outbound. So once we have that instance launched, we go back to our VPC dashboard and attach an elastic IP to that instance. And an elastic IP address is basically a static IPv4 address designed for dynamic cloud computing. So an elastic IP address is associated with our AWS account. And with it, we can mask the failure of an instance or software by rapidly remapping the address to another instance in our account. And just keep in mind that an elastic IP address is a public IPv4 address, which is reachable from the internet. So if we were to associate an elastic IP address with the instance that we just created, it will allow HTTP and HTTPS traffic from the internet to reach this instance. Basically now the instance is accessible from the internet with the elastic IP address being associated with it. So those are the steps that we would need to do in order to create a custom VPC, but just a few things to keep in mind. In security, we have both a network access control list, or NACL, and security groups. Now, a network access control list are applicable at the subnet level. So any instance in the subnet with an associated NACL will follow the rules of the NACL. The security groups, as we saw, have to be associated with a specific instance. By default, our default VPC will have a default NACL which will allow all traffic both inbound and outbound. So if you want to restrict access at the subnet level, it's always good practice to create a custom network access control list. Also keep in mind that network access control lists are stateless, unlike security groups, which are stateful. So in a security group, let's say if you add an inbound rule for port 80, it's automatically allowed out, meaning outbound rule for that particular port need not be explicitly added. But for the network access control list, you need to specifically provide an explicit inbound and outbound rule. Lastly, in security groups, we cannot deny traffic from a particular instance. By default, everything is denied. We can set rules only to allow. Whereas in a network access control list, we can set rules both to allow and to deny. In the peering connections is where we can do VPC peering. If we want to connect two AWS VPCs together, we can accomplish that through peering. The NAT gateways allow two subnets. Let's say if you have a private and public subnet, they will access the internet through a NAT gateway or network address translation gateway. And the endpoints and endpoint services allow applications to connect to instances in the VPC. Hi everybody, welcome to the third lesson on VPCs, and in this lesson we're going to look at the different networking components that make up a virtual private cloud. So route tables contain a set of rules called routes that are used to determine where network traffic is directed. Now each subnet in your VPC must be associated with a route table, and the table controls the routing for the subnet. A subnet can only be associated with one routing table at a time, but you can associate multiple subnets with the same route table. Now a few things to keep in mind about route tables. Now a VPC basically has an implicit router that comes with a pre-built route table. You can add additional custom route tables for your VPC. Keep in mind you cannot delete the main route table that is built in with AWS. And a route table specifies a destination, sitter, and a target. And remember from the previous lesson we discussed different sitter blocks. Now your VPC can have route tables other than the default route table. One way to protect your VPC is to leave the main route table in its original default state and explicitly associate each new subnet you create with one of the custom routes tables you've created. This ensures that you explicitly control how each subnet routes outbound traffic. Now in this diagram you can see the routing for a VPC with both a internet gateway and a virtual private gateway, plus a public subnet and a VPN only subnet. The main route table came with the VPC, and it also has a route for the VPC only subnet. A custom route table is associated with a public subnet. The custom route table has a route over the internet gateway. The destination is 0.0.0.0, which means everyone, and the target is the internet gateway. If you create a new subnet in this VPC, it's automatically associated with the main route table, which routes its traffic to the virtual private gateway. Now if you were to set up the reverse configuration, meaning the main route table with a route to the internet gateway and the custom route table with a route to the virtual private gateway, then the new subnet automatically has a route to the internet gateway. Now a VPC console shows a number of subnets explicitly associated with each route table and provides information about subnets that are implicitly associated with the main route table. Now subnets can be implicitly or explicitly associated with the main route table. Now they typically won't have an explicit association to the main route table, although it might happen temporarily if you're replacing the main route table. Now you might want to make changes to the main route table, but to avoid any disruption to your traffic, you can first test the route changes using a custom table. After you're satisfied with the testing, you can then go ahead and replace the main route table. Now this diagram that you see shows a VPC with two subnets that are implicitly associated with the main route table, table A, and a custom route table, table B, that isn't associated with any subnets. You can also create an explicit association between subnet 2 and route table B. After you've tested route table B, you can make it in the main route table. Note that subnet 2 still has an explicit association with route table B, and subnet 1 has an implicit association with route table B because it's the new main route table. Route table A is no longer in use. And if you dissociate subnet 2 from route table B, there's still an implicit association between subnet 2 and route table B. If you no longer need route table A, you can go ahead and delete it. Next, we have something called Internet Gateways, which is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the Internet. It therefore imposes no availability risks or bandwidth constraints on your network traffic. A gateway basically serves two purposes: to provide a target in your VPC route tables for the Internet routable traffic, and to perform network address translation, or NAT, for instances that have been assigned public IPv4 addresses. Now, to enable access to or from the Internet for instances in a VP subnet, you have to attach an Internet gateway to your VPC and ensure that your subnet's route table points to the Internet gateway. You also have to ensure that instances in your subnet have a globally unique IP address, IPv4 or an elastic IP address or an IPv6. Lastly, you have to ensure that network access control and security group rules allow the relevant traffic to flow to or from your instance. Now, the diagram that you guys see, subnet 1 in the VPC is associated with a custom route table that points all internet-bound IPv4 traffic to an internet gateway. The instance has an elastic IP address, which enables communication with the internet. Then we have a network address translation, or NAT gateway. Now, you can use a NAT device to enable instances in the private subnet to connect to the internet or other AWS services, but prevent the internet from initiating connections with the instances. A NAT device basically forwards traffic from the instances in the private subnet to the internet or other AWS services, and then sends the response back to the instances. When traffic goes to the internet, the source IPv4 address is replaced with the NAT device's address, and similarly, when the response traffic goes to these instances, the NAT device translates the IP address back to those instances' private IPv4 addresses. So the diagram that you guys see illustrates the architecture of a VPC with a NAT gateway. The main route table sends internet traffic from the instances to the private subnet to the NAT gateway. The NAT gateway sends the traffic to the Internet gateway using the NAT gateway's elastic IP address as the source IP. Now, there are some limitations and characteristics of NAT gateways that you guys should keep in mind. It supports up to 5 gigs of bandwidth and automatically scales up to 45 if it's needed. You can associate only one elastic IP address with a NAT gateway. And once it's associated, you will not be able to disassociate that elastic IP from that gateway. It supports TCP, UDP, and ICMP, and you cannot associate a security group with a NAT gateway. You can use security groups for your instances in the private subnet to control the traffic to and from those instances. You can also use the NACLs to control the traffic to and from the subnet in which the NAT gateway is located. And it can support up to 55,000 simultaneous connections to each unique destination. This limit also applies if you create approximately 900 connections per second to a single destination. Now, I just want to point out a difference between a NAT gateway and a NAT instance. Now, a NAT gateway is fully managed by AWS, whereas a NAT instance is fully managed by you. So you would have to do everything in order to do and manage the NAT instance. Whereas if you select the NAT gateway, everything is managed and routed automatically by AWS. Now, a VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them privately. Instances in either VPC can communicate with each other as if they were with the same network. You can create a peering connection between your own VPCs, with a VPC in another AWS account, or with a VPC in a different AWS region. Now, AWS uses the existing infrastructure of a VPC to create a peering connection. It's neither a gateway nor a VPN connection and does not rely on a separate piece of physical hardware. There is no single point of failure for communication or a bandwidth bottleneck. Then we have VPC endpoints, which enable you to privately connect your VPC to supported AWS services and VPC endpoint services powered by Private Link without requiring an internet gateway, NAT device, VPN connection, or an AWS Direct Connect connection. Instances in your VPC will not require a public IP address to communicate with resources in the service. Traffic between your VPC and the other service does not leave the Amazon network. And endpoints are basically virtual devices. They're horizontally scaled, redundant, and highly available VPC components that allow communication between instances in your VPC and services without imposing availability risks or bandwidth constraints to your network traffic. Now, there are two types of VPC endpoints: interface endpoints and gateway endpoints. An interface endpoint is an elastic network interface with a private IP address that serves as an entry point for traffic destined to a supported service. It supports many services such as CloudWatch, Cold Build, EC2 APIs, SNS, and so on. Whereas a gateway endpoint is a gateway that is targeted for a specific route in your route table used for traffic destined to a supported AWS service. Now, it's only supported by two services at the moment, the Amazon S3 and the DynamoDB. For all of the rest of the services, you have the interface endpoints. So let's go ahead and log in and see some of these advanced features that are available within VPCs. Hi everybody, and welcome to this lesson on security in the virtual private cloud. Now, the Amazon VPC provides features that you can use to increase and monitor security for your virtual private cloud. Now, they're done with three basic things that they offer: security groups, network access control lists or NACL, and flow log. When you launch an instance in a VPC, you can associate one or more security groups that you've created. Each instance in your VPC could belong to a different set of security groups. Now, if you don't specify a security group when you launch an instance, the instance automatically belongs to the default security group for the VPC. You can secure your VPC instances using only security groups. However, you can add network access control list as an additional layer of defense. You can monitor accepted and rejected IP traffic going to and from your instances by creating a flow log for a VPC, subnet, or individual network interface. Flow log data is published in CloudWatch logs and can help you diagnose overly restrictive or overly permissive security group and network access rules. Now, you can use the AWS IAM to control who in your organization has permission to create and manage security groups, network access control lists, and flow logs. Now, the table you guys see gives you a good summary in terms of the differences between a security group and a network access control list. It's good to have this memorized and in mind, especially for the exam. Now, the security group operates at the instance level, means you apply it to specific EC2 instances, while the network access control list operates at the subnet level. For the security group, you can only allow rules, whereas for the network access control list, it supports both allow rules and deny rules, which means for a security group, you cannot specifically deny HTTP traffic. You can only allow everything in, because by default, everything is denied in the security group. Additionally, one is stateful while the other is stateless. With security groups, you can evaluate all the rules before deciding whether to allow the traffic in, whereas for the NACL, they process rules in number order and when deciding whether to allow the traffic in or to allow the traffic out. And one of the biggest differences is the NACL will apply to all of the instances that are within a subnet. Now the following diagram illustrates the layers of security provided by security groups and NACLs. For example, traffic from an internet gateway is routed to the appropriate subnet using the routes in the routing table. The rules of the network access control list associated with the subnet control which traffic is allowed to the subnet. The rules of the security group associated with an instance control which traffic is allowed to the instance. Now, VPC flow logs is a feature that enables you to capture information about the IP traffic. It can be published to CloudWatch logs and to Amazon S3. Now, flow logs can help with a number of tasks. For example, to troubleshoot why specific traffic is not reaching an instance, which in turn helps you diagnose overly restrictive security groups. You can also use flow logs as a security tool to monitor the traffic that is reaching your instance. Now just keep in mind that CloudWatch log charges apply when using flow logs, whether you send them to CloudWatch logs or to Amazon S3.
Hi everybody, and welcome to this lesson on Identity Access Management, or more commonly known as IAM. First, talk about what is IAM. Now, the Identity and Access Management is a web service that helps you securely control access to AWS resources. You can use IAM to control who is authenticated or signed in and authorized or has permissions to use resources. So if you guys are familiar with the Windows environment, these are basically just your users that you can create that would have access to Amazon Web Services. Now, when you first create an AWS account, you begin with a single sign-in identity that has complete access to all AWS services and resources in the account. This identity is called the AWS account root user and is accessed by signing in with the email address and password that you used to create the account. Now keep that in mind because sometimes the Cloud Practitioner's exam will ask you about the credentials more commonly known as a root user. So basically know that they have complete control over the entire AWS user account. And it's strongly recommended that you do not use the root user for your everyday tasks, even the administrative ones. Instead, we have to adhere to what AWS has created in terms of IAM users and IAM policies. And that way you can securely lock away the root user credentials and use them to perform only a few account and service management tasks. Now, you can also integrate IAM policies and permissions with directories you already manage. For example, the Microsoft Active Directory or the AWS Directory Service or OpenID, Connect Provider, and so on. That's more commonly known as federated access. And again, we will also discuss federated access a little bit later on, but again, it's also a key exam term. So there are a number of features that IAM gives you. For example, it gives you shared access to your AWS account. You can grant other people permission to administer and use resources in your AWS account without having to share your password or access key. You can grant different permissions to different people for different resources. For example, you might allow some users complete access to an Amazon EC2 or a Amazon S3, which is used for storage, or any database or any other AWS services. For other users, you can allow read-only access to just some of those resources. For example, if you have data on AWS stored in an S3, you can allow some users full control, while others you can allow read-only access. You can secure access to AWS resources for applications that run on Amazon EC2. You can use features to securely provide credentials for applications. These credentials provide permissions for your applications to access other AWS resources. So again, just keep in mind that an IAM user can be a physical person or it can be an application. They also support multi-factor authentication, or MFA. You can add two-factor authentication to your account and to individual users for extra security. It also has identity federation, which I just discussed a little bit ago. You can allow users who already have passwords elsewhere, whether it's Facebook, whether it's Microsoft Active Directory, to get temporary access to your AWS account. It also has PCI DSS compliance. It supports the processing, storage, and transmission of credit card data by a merchant or service provider, and has been validated as being compliant with the payment card industry or PCI data security standards. So if anything is compliant with the PCI DSS, you can rest assured that it has extremely strong security because it's been certified to handle credit card information. Now you can work with IAM in a number of ways. For example, you can access it through the Management Console, which is a browser-based interface which we looked at. And after this lesson, we'll go ahead and log back in and see how we can manage IAM roles through the same console. We can also use the command line tools to issue commands to perform IAM and AWS tasks. For example, a lot of people are more comfortable using command line than using the Management Console, and they're also useful if you want to build scripts that perform AWS tasks. Now, Amazon provides two sets of command line tools. You have the AWS command line interface, and you also have the AWS tools for Windows PowerShell. You can also access it through SDKs, which are software development kits that consist of libraries and sample code for various programming languages and platforms such as Java or Python. The SDKs provide a convenient way to create programmatic access to IAM and Amazon Web Services. For example, the SDKs take care of tasks such as cryptographically signing requests, managing errors, and retrying requests automatically. And lastly, you have the HTTPS API. You can access IAM and Amazon Web Services programmatically by using the HTTPS API, which lets you issue HTTPS requests directly to the service. Now, when you use this API, you must include code to digitally sign requests using your credentials. So just keep in mind these 4 different ways that we are able to access and configure IAM within AWS. Now, before you create users, you need to understand how IAM works. Now, it provides the infrastructure necessary to control authentication and authorization for your account. Now, it includes a number of elements. First and foremost, we have the principal, which is an entity that can make a request for an action or operation on an AWS resource. Users, roles, federated users, and applications are all AWS principal. Your account root user is your first principal, and as a best practice, like I mentioned before, do not use your root user for your daily work. After the principal, we have the request. Now, when a principal tries to use the AWS Management Console or the API or the CLI, the principal sends a request to AWS, and it can include a number of information, for example, such as actions or operations that the principal wants to perform, any resource object upon which the action or operations are performed, the user, the role, the federated user, or application that sent the request, environment data, such as the IP address, the user agent, or if SSL is enabled, or the resource data related to the resource that is being requested. And this could include information such as a database table name or a tag on an Amazon EC2 instance. AWS gathers the request information into a request context, which is used to evaluate and authorize the request. After the request, you have the authentication. And as a principal, you must be authenticated or signed into AWS to send requests to AWS. Now, although some services such as the S3, which is a storage service, allow a few requests from anonymous users, they are an exception to the rule. Now, to authenticate from the console as a user, you must sign in with your username and password. To authenticate from the API or the command line, you must provide your access key and secret key. You might also be required to provide additional security information, so just keep that in mind. For example, if you have multi-factor authentication enabled. So after authentication, we have authorization, during which AWS uses values from the request context to check for policies that apply to the request. It then uses the policies to determine whether to allow or deny the request. And most policies are stored in AWS as JSON documents and specify the permissions that are allowed or denied for principals. Now, there are several types of policies that can affect whether a request is authorized. And those policies can be categorized as either permission policies or permission boundaries. Now, the policies define the permissions for the object to which they're attached, and these include identity-based policies, resource-based policies, and access control lists, or ACLs. A permission boundary, on the other hand, is an advanced feature that allows you to use policies to limit the maximum permissions that a principal can have. After authorization, you have the action or operation, because after your request has been authenticated and authorized, AWS approves the action or operation in your request. Operations are defined by a service and include things that you can do to a resource, such as viewing, creating, editing, or deleting that resource. For example, IAM supports about 40 actions for a user resource, such as creating, deleting, getting a user, updating a user, and so on. And finally, we have the resources. After AWS approves the operation in the request, they can be performed on the related resources within your account. A resource, again, is an object that exists within a service. For example, an EC2 instance is a resource. An IAM user is a resource. The service defines a set of actions that can be performed on each resource. If you create a request to perform an unrelated action on a resource, that request is denied. Now, since IAM is an integral part of AWS, there are some best practices that you need to keep in mind when you put into practice, and especially for the Cloud Practitioners exam, you need to keep this in mind as it relates to IAM. And like I've already mentioned, make sure you lock away your AWS account root user access keys, because if anybody gets access to them, they can basically go ahead and provision 10,000 EC2 instances on your account, and your company will be liable to pay for them. Next is create individual IAM users. Don't use your root user, don't give your credentials to anyone. Instead, you can create individual users for anyone who needs access to your AWS account. For example, first and foremost, create an IAM user for yourself and give yourself administrative permissions. Next, use groups to assign permissions to IAM users. Instead of defining permissions for individuals, it's usually more convenient to create groups that relate to specific job functions, such as developers, administrators, accountants, and so on. After you do that, define the relevant permissions for each group, and then finally, assign users to those groups. Next tip is use the AWS defined policies to assign permissions whenever possible. Now, there are a bunch of predefined policies that are already created for you by AWS, and it's always recommended that you try to use those, but obviously there will be some instances when they will not apply to your use case. Then you can go ahead and create and define your own policies, but in my experience, 98% of the time, you should be able to use policies that are already pre-built by AWS. Next step is grant least privilege. Now, when you create policies, follow the standard security advice of granting the least privilege. That is, granting only the permissions required to perform a task. Determine what users need to do, and then craft policies for them that let users perform only those tasks. Use access levels to review IAM permissions. To improve the security of your account, you should regularly review and monitor each of your policies. Make sure that your policies grant the least privilege that is needed to perform only the necessary actions. And when you review a policy, you can view the policy summary that includes a summary of all of the access levels for each service within that policy. So AWS does make it easy for you to review all the policies that you have created and used. So it's not a tedious task, but it is a task that should be performed by you on a regular basis. And the last two just pertain to a stronger security level, which is having a strong password policy, which you are able to define within IAM. And then lastly, the multi-factor authentication for privileged users to make sure that you identify all of the administrators that will be logging into your AWS account to ensure that only the people that are authorized and authenticated have access to it. Continuing on, some last few best practices to keep in mind. For EC2 instances, make sure that you use roles. Now for applications that run on them, they need credentials in order to access AWS services such as storage services. And to provide credentials to the application in a secure way, use the IAM roles. A role is basically an entity that has its own set of permissions, but that is not a user or group. Roles also don't have their own permanent set of credentials the way IAM users do. In the case of the EC2, IAM dynamically provides temporary credentials to the instance, and these credentials are automatically rotated for you. Now, when you launch an EC2 instance, you can specify a role for that instance as a launch parameter. You can use those roles to delegate permissions. Don't share security credentials between accounts to allow users from another AWS account to access resources in your account. Instead, use roles. The next one goes without being saying, which is do not share your access keys. Rotate credentials regularly, which is changing your passwords and access keys. And again, when you're doing the review, removing any unnecessary credentials that might not be required anymore or that were created and that should not have been created. Use policy conditions for extra security. And to the extent that it's practical, define the conditions under which your IAM policies allow access to a resource. For example, you can write conditions to specify a range of allowable IP addresses that a request must come from. And lastly, monitor. You can use logging features in AWS to determine the actions users have taken in your account and the resources that were used. The log files show the time, the date of actions, the source of an IP, which actions failed due to inadequate permissions, and much more. So it's very important that we regularly monitor our AWS activity. So let's go ahead and take a look at IAM and all the different features that we just discussed.
Hi everybody, and welcome to this lesson on IAM roles and policies specific to EC2 instances. So by default, IAM users don't have permissions to create or modify EC2 resources or perform tasks using any kind of API for EC2. So we have to specifically allow the users to create or modify resources and perform certain tasks, based on their responsibilities. Now, when you attach a policy to a user or a group of users, it allows or denies the user permissions to perform specific tasks on specific resources. So we have to actually create those policies and those users and attach those policies based on what kind of task we want who to perform. And they must grant or deny permissions to use one or more EC2 actions. So before we do that, we kind of have to understand the policy syntax or the structure of the policy. So policy is basically, again, a JSON document that's going to consist of the statements that you guys see on the screen, right? So there's a few things that we need to keep in mind that we need to specify in the statement. The first is the effect. So the effect, again, can be either allow or deny. So by default, IAM users, again, like I mentioned, don't have the resources, so they're denied by default, right? So we have to explicitly allow and override those denies. Then we have the action. So the action is a specific API action for which you're granting or denying the permission. Then we have the resource, again, the resource that's affected by the action. So some EC2 API actions allow you to include specific resources in your policy that can be created or modified by the action, right? So to specify a resource in the statement, we have to use the ARN or the Amazon resource name. Then we have the condition, which is optional. So again, they can be used to control when your policy is in effect, and so on. So these are the basic, or this is the basic syntax of a policy that we need to specify in order to do that. And on the right-hand side, you guys see some examples, right? So the first one, we can specify multiple actions in a single statement. So we can separate them with a comma. You guys see, EC2 action 1, comma, EC2 action 2, and so on. And then we can also specify multiple actions using wildcards. So, For example, we can specify all actions whose names begins with the word describe, that you guys see the second example, or we can specify all Amazon EC2 API actions by using the wildcard, as you guys see in the last one, which is EC2 with a wildcard that allows all actions. So that might be something that you might want to do for administrators of those EC2 instances. So the couple of examples you guys see. So the first one on the top left-hand corner, again, the version is just for the reference. So the statement is essentially it's going to allow the action of describe. So any action that begins with describe is going to allow on all EC2 resources. So basically, if I want to describe the system status, or if I'm running commands from the command line interface, anything that begins with describe, I will be allowed if this policy is attached to my IAM user. And on the bottom right is another example. So this one is more of a deny. So it's going to deny all actions on EC2 instances on all regions other than EU Central 1. So let's say if we want to limit, the access of certain IAM users to certain regions. So we can specify this statement that, this user does not have access to any EC2 resources outside of EU Central 1. So just a couple of examples. Again, they can be as simple or as complex as you want, but the point being that we have to make sure that we allow certain accesses through IAM users and policies, right? Because obviously, if you are testing it out, or if you created the free tier account, most of the time users log in with the root user account, which is the user account you use to create the account. But as a general practice, it's always recommended that you create IAM users and do your daily tasks through those IAM users by attaching policies or putting them in groups. And these roles are also important because we can also attach roles to our EC2 instances. So let's say if our EC2 instance is going to be making calls to our RDS database, or if it's going to be making calls to other resources within AWS, we have to specifically allow that EC2 instance, or give that EC2 instance a permission to do that. And the way we do that is by creating a policy that allows the EC2 instance access to other resources in AWS, and attach that policy to that EC2 instance. So it's not really only for users, meaning it's not only for people. These policies are also attached to EC2 instances, because most of the time, if you have a network fully configured in AWS, you'll have more than one resource, meaning you'll have a database, you might have Sumerian, you might have other AWS technologies that you would be using within your environment, and those EC2 instances might require access to those other resources. And the way we do that is through IAM policy.
Hi everybody, and welcome to this lesson on looking at and working with IAM groups and users as it pertains to EC2 instances. So now we know that IAM basically enables us to do quite a few different things, like create users and groups under our AWS account, assign security credentials for the users to log in, but also the policies and users and groups are also associated with EC2 instances, because EC2 instances essentially also act like people when they're accessing other resources within the AWS environment, in terms of requiring access and credentials to log and use those resources. So how we go about creating IAM groups and users? So in my console, what I'm going to do is I'm going to go ahead and navigate into IAM, which again stands for Identity and Authentication Management. And first thing we're going to see is how we go about creating groups. Again, most of this is a fairly straightforward process. So on the left-hand side are all the different options in terms of the dashboard, the groups, the users, roles, and policies. So in the groups, as you guys can see, I do not have any group created at this point in time. So I'm going to simply go ahead and create a new group. I'm going to call this group EC2 since it's going to be associated with my EC2 instances. In the next step, now here is where I can attach various policies to this group. Now all these policies are pre-created by AWS for us, and they basically allow us to do anything and everything within the AWS environment, including the admin access. As you guys can see, there are 471 different policies that are created within AWS for every single service that we offer, or that AWS offers, for example, Alexa, QuickSight, S3, and so on, or even administrator access. Let's say if you want power user access,
If I just type in power, it basically filters them down for me, so I can do power user access. So if I want the EC2 instance to have power user, or this group to have power user access, let's say select power user. I'm going to go ahead and click on the next step. And here it just verifies these are the policies that are going to be attached to this EC2 instance. And I have an option to edit the policies if I want. Let's say if I want something else, but let's just keep the power user access. I'm going to go ahead and create the group. There we go. So now we have the group EC2 created. Now, obviously, we also need to add users to this group also. So I'm going to navigate to the users option. So I'm going to add a new user. I'm also going to call this user EC2. Now, two different types of access, programmatic or the AWS Management Console. The programmatic access obviously is used for the CLI, or if you're using APIs or any software development kits, then you would need the programmatic access, or the Management Console access. This is what we're accessing here. Password can be either auto-generated or a custom password, and you can also require password reset. So let's say if I do a custom password. Next are where we can assign permissions. So three options. We can either add the user to a group. We can copy permissions from an existing user if we had what users created. Let's say if this user is going to be working in the same department, we can simply copy those permissions, or we can attach policies directly to this user. So the same policies that we attach to the group, we can attach to individual users also. So it just depends on your modus operandi, what type of policies and procedures you have in terms of managing your users and groups. You can either attach policies directly to users, or you can attach policies to groups and then add users within those groups. So I'm going to add this user to the EC2 group, which has power user access, which I just created. Here we can create tags, again, for our reference purposes. And then if we click on next, we can review the final access and then go ahead and click on create user. Now, since we did programmatic access, it lets me know the access key and the secret access key. Just keep in mind that once we show this secret access key, or once we leave this, we will not be able to see this key again. So it's always good practice to download the CSV, because it has the access key ID and the secret. So you can keep it in a safe place, because once I click on close, I will not be able to see the secret again. And here, if I just click on the arrow, it lets me know the process that was done. A user was created, it was added to the group, and it created the access key, and it created the login profile for the management console. So that's users and groups, right? So now we also have policies within IAM. Now, by default, users don't have permission to create or modify EC2 resources or perform tasks, using the EC2 API. So we have to specifically give them access. So the policy structure, again, is basic JSON format policy structure. And the policies, just to give you guys, a little more specific. So if I click on the policies that are created by AWS, I can also modify them. Or if I want to create my own custom policies, I am also able to do that. So let's say if I want to create a policy, I can do that specifically. There's a visual editor, so I can choose which service this policy is going to apply for. So let's say the elastic load balancers, and here I have specific actions within those elastic load balancers. Let's say list and read, the resources, and then the request conditions, whether they want the source IP or I want the MFA and multi-factor authentication. So here I can do either the visual editor wise, or if I click on the JSON, it'll translate everything that I've done in the visual editor into JSON format, or I can simply type out the JSON file here. So this is if you want to create custom policies and attach them to our EC2 instances.
Now let's take a look at the federated users, right? So for any organization, for example, looking to leverage AWS services, might be thinking I already have a number of organizational users, maybe an Active Directory, right? For example, such as LDAP or a Microsoft Active Directory. Maybe you have web and mobile application users who log in with, let's say, Facebook accounts or Google accounts or some other third-party provider accounts, and you want to grant them access to AWS resources. So the question becomes, how can you actually allow users to authenticate with existing credentials that they already have and access AWS resources? How can you avoid duplicating user accounts altogether? And the answer to that is to leverage identity providers. Within AWS, you have a number of options for identity providers that would allow you to use or provide those users wherever they are to authenticate within their existing accounts. So you can manage accounts centrally and grant those users temporary access to AWS resources. These options would be, for example, SAML, right? You can use the SAML 2.0, for example. You can grant access to AWS Management Console, to the CLI tools, to direct API access for users authenticating with existing enterprise credentials. You also have AWS Directory Service. That would allow, access to AWS Management Consoles to users authenticating with Active Directory username and password. You don't have to create a new account in AWS, right? So this is an ideal scenario if you already have credentials. So if you're focused around, let's say, the management console, or if your employees, team members need more lower level access, right? Maybe CLI or direct API access, then you would probably want to look at SAML. You also have Amazon Cognito service, right? So Cognito can actually provide API access for web and mobile application users, who are actually authenticating, using their own connections or logging in with Facebook, for example, or Twitter or Google. You also have AWS Single Sign-On service. Single Sign-On provides access to multiple AWS accounts and business applications. It has, let's say, built-in SAML integration with business applications such as Salesforce, Office 365, and so on. So it's a very common practice within AWS to leverage multiple accounts. As I mentioned earlier, they can use AWS organizations to manage those accounts in a hierarchical structure. So that would allow you to integrate existing credentials that can then be used to access multiple AWS accounts. So as you can see and observe that you have a number of options to satisfy whatever scenario you may encounter as a solutions architect. So if you have a team that needs access to AWS, there's absolutely no reason to duplicate those accounts. Leave those accounts wherever they are and just simply leverage one of these tools to provide that temporary credentials in a straightforward manner of gaining temporary access to various AWS resources, right? And that's the key to designing an effective infrastructure or architecture itself. So now let's take a look at the IAM best practices. First, with, let's say, the new accounts, there's some first steps, very critical first steps that you should take as a solutions architect. If you just recently signed up, let's say, and still logging in with your email or password, there are things that you need to really be careful. First, you should enable CloudTrail. CloudTrail, remember, is a service that reports all of the API calls made to the AWS APIs, right? So by enabling CloudTrail first, that will then record and leave, let's say, an explicit log of everything that you do, and that's pretty powerful. Then you can create an admin user, perhaps a super admin user, as an IAM user, right? You can then, let's say, add an optional condition. Remember, we talked earlier about conditions in policies, right? You could further contain, say from where or from what time a user is allowed to log in, or, actually use those permissions. So you can create an admin user, but perhaps, they're only allowed to use that account from on-premises, right? You should then enable multi-factor authentication on top of that, on the root account. Remember, the root account has absolute access to all resources all the time, and access cannot be limited. And we'll talk more about root account later on as well. So you should then enable, cost reports. And so one of the things that is generally done with the root accounts, for example, and then you should log out of the root account and then log back in as the admin user. So once the new account or accounts have been cleaned up and secured in this manner, you can then go on with that admin user to create additional users, groups, and so on. Some other best practices to keep in mind regarding IAM is to remember that the master account or the root credentials, if you're logging in with, let's say, email addresses and passwords, then you're accessing the master account. Keep that in mind. So you should protect that account at all costs. So your master account has, let's say, root privileges that cannot be limited. If someone compromises the master account, they could perform any number of attacks or any number of operations. They can spin up expensive resources that you would have to pay for, right? Or they could delete resources that you'd have to pay for in other ways. So be very careful. You should then, delete all of the existing access and secret keys, right? Because they will not be used. They only, leaving them there basically increasing the surface area for a potential attack, right? So you should not be using your master account for day-to-day operations. You should only log into the master account rare occasions where you really would have to use, or maybe some billing purposes or other purposes that require the master account. So again, as we talked about earlier, you should be following the principle of least privilege, giving your users and roles and EC2 instances and applications only those permissions, to provide or what they need to do on a limited basis. And you should, of course, rotate long-term credentials. So if your users have access keys, let's say, and passwords, those should be rotated regularly. And lastly, for anyone who logs into the console, especially the master account, you should enable multi-factor authentication. I've talked about that before also. It's very important, right? This is a key area or a security layer built on top of another layer, right? That would save you a lot of trouble in the long run. So I hope this helps. All of these areas are best practices when you're working with the IAM roles. So by following these best practices, you can continue to ensure that your AWS resources are best kept secured. I hope this helps. Practice with this. If you have any questions, post in the discussion area. With this, let's move to the next lesson.
Welcome back. In this lesson, moving forward, I'm going to demonstrate some of the best practices for monitoring and also how to set up an alarm for, let's say, your EC2 instances, right? So you'll have a better understanding as a DevOps engineer that following some of the best practices for monitoring within AWS is going to save you a lot of time and a lot of headache. So let's jump right in. I'm going to go ahead and navigate first to my EC2 instance and just kind of take a look at what instances we currently have available. So at this point in time, I have 2 running instances. I'm going to go ahead and click on this, and it provides the entire list. So some of these are stopped. I've terminated some, and then a couple of them are running because we still have our apps running. The AWS Cloud instance is stopped because we're not using the cloud-based IDE anymore, which is attached to our web apps. So I'm going to select an instance. For instance, I'm going to go ahead and choose the Java web app. As soon as I click on it, notice the status checks, and next to status check, there's a tab called monitoring. So I'm going to go ahead and click on monitoring. Make this a little bigger so you can see. And at this point in time, there are no alarms configured for this particular instance. In other words, I cannot get an email, I cannot get an SMS, right? If something happens to this instance. So I can go ahead and actually monitor this instance by creating an alarm. So if I click on, for instance, CloudWatch, but before I actually do CloudWatch at this point in time, let's go ahead and click on Create Alarm. So I'm going to do it right on the fly here. So once I click on Create Alarm, it brings up a dialog box. And notice it says that you can use CloudWatch alarms to be notified automatically whenever metric data reaches a level you define, right? So in most enterprise organizations, we have laid down policies, okay, that stipulate what are these levels, right? These metric levels. And you can set them yourself as well. For instance, in this diagram, you can see that the CPU utilization % has been set. So if it goes beyond the set criteria, you should be able to get an alarm raised. And you could either receive a notification, an SMS or an email, for instance. So that's the idea. So in creating the alarm, the first thing it asks us is to send a notification to an SNS. Well, what is an SNS, right? We're aware that AWS has multiple services. So this is one of the AWS service that's called Simple Notification Service, right? So it's the Amazon SNS. And what you can do with this is you can create topics, and then different elements, right, can subscribe to this topic. So services or email or you can subscribe to this topic. So if something happens, then you can simply send out the notification. So it's going to send out the notification to a particular SNS topic, which at this point does not exist because we have not utilized the SNS service at this point in time. However, since I'm doing this on the fly, you can always create a topic right here as well. And then once the topic is created, you can then take the action as well. So if I were to select this, I could either select recover this instance, stop, terminate, or reboot. Or I can do the conditional statements here as well. For example, whenever the average of CPU utilization is greater than or equal to a certain percentage for at least one consecutive period, 5 minutes, I can name the alarm and then I can create it, right? But before that, I need to create a SNS. Now, before I actually go ahead and create a topic, I'd like to give you the best practices for SNS because it's important to know a little bit of theory too, right? As we're doing hands-on. So let me bring up my slide here. Great. So just a word on Amazon Simple Notification Service. It's a highly available, durable, secure, fully managed, right, messaging service that enables us to decouple microservices, distributed application systems, and serverless applications. We can use this with Lambda as well. So Amazon SNS provides topics for high throughput, push-based, many-to-many messaging. Okay, so this is the Amazon definition to SNS, and it's good for the exam, okay? Not to worry. The SNS can be used to fan out notifications to end users using mobile push SMS and email. And here's how it works. So the diagram that you see is that the publisher publish messages from distributed systems, microservices, or other AWS services. It goes through the SNS, which is a fully managed pub, sub, messaging, and event-driven computing service. Looks for the topic. Message filtering and fan out is conducted, where it's going to filter messages according to subscription filter policies and deliver them to subscribers. And it's pretty powerful. And then once it delivers to subscribers such as AWS Lambda, Amazon SQS, HTTP, you can receive messages and subscribing serverless functions, queues, microservices, and much more. So now you have a good understanding of SNS. Next, let's take a look at quickly the best practices. Okay, again, this is also good for the exam. So as a best practice, you want to make monitoring, the entire concept of monitoring within AWS ecosystem, a large priority. Okay, to head off small problems before they become big ones. Typically, the monitoring part is maybe overlooked at times, but some engineers are big on monitoring. Okay, and that's good to do, is recommended. So you want to create and implement a monitoring plan that collects the data from various parts of your AWS solution. So not just one particular service or one particular instance. You want to create or monitor all of your instances, okay? Because you may have instances running different apps in different regions. And the benefit is that you can easily debug a multi-point failure if one occurs. So your monitoring plan should address several questions, such as what are your goals, what resources you want to monitor, how often you want to monitor, and which tools you want to use. And more importantly, who will perform the monitoring tasks? Obviously, you're not going to sit there and just look at all the monitoring data, right? So that's important. And who should be notified when something goes wrong, whether it's yourself or some other admins. And you want to automate monitoring tasks as much as possible. Check out the log files on your EC2 instances. So this is good practice provided by Amazon as far as monitoring is concerned. Great. So let me minimize this. Back to our create alarm. So since we do not have an SNS topic, I'm going to go ahead and click on create topic. I can either manually enter a topic name, which I'm going to do. So I'm going to say, I'm going to add EC2 instance alert as well. So with these recipients, right, I can enter an email address, for example, and I'm just going to go ahead and enter the same email address that I'm using here to log in. And now I can specify the recover this instance, stop this instance, terminate, reboot. Okay, so it just depends on what exactly I'm looking to do. For instance, the recover would typically repair the instance in the event of a status check failure. The stop the instance, you can stop the instance if it's backed by an EBS volume at the backend. I can terminate the instance, which you will not be able to terminate the instance if termination protection is enabled. Okay, and this is a good exam question. Reboot the instance, I can reboot the instance, or I can take the action if I don't want any of these. Wherever the average CPU utilization is greater than or equal to, let's say 50% or 80%, depending on your own requirement, for at least one consecutive periods of 5 minutes, or I can stipulate 15, 1 hour, or 6 hours. So increments. I can name the alarm, and I believe this instance, I'm creating this for my web app, right? So I'm going to go ahead, or name the alarm rather, called Java Web App. So once I've filled this out and I understand the concept of SNS and how it's applied and the best practices, I'm going to go ahead and click on create alarm. And of course I need to select an option here. So I'm going to say take the action whenever this happens, whenever the instance is. I'm going to say recover this instance. Whenever status check failed, the system is failing for at least 2 consecutive periods for 1 minute, I can name the instance. If I choose stop this instance, for instance, then it's going to give me the required details. Similarly, terminate the instance would have its own set of conditions that I can specify, and then reboot the instance. It will create the following service linked role in your account to perform the EC2 action. So based on my own requirement, I will select one of these. So let's say I'm going to go ahead and say recover this instance. So whenever is status check failed, system is failing for at least 2 consecutive periods of 1 minute, it's going to raise the alarm. So I'm just going to call it for this particular Java web app instance because that's my app is running on this particular instance. So once I've identified all of these settings, simply go ahead and click on create alarm, and AWS is going to successfully create the alarm. Now I can simply click on this particular alarm and I will be navigated to Amazon CloudWatch, something that I'm also going to demonstrate later on as well. But just for now, we can click on this to navigate to CloudWatch. But also a note here, if you created a new SNS topic or added a new email address, each new email address will receive a subscription email that you must confirm, right? So since I used claydesk198 Gmail, I'll have to navigate to my Gmail account and simply confirm that email, right? Straightforward standard process. So you may want to keep this at the back of your mind, this particular note. It could be a good exam question as well. So I'm going to go ahead and click on this link, and I will be navigated to the CloudWatch Management Console, where you'll notice I have one alarm already created. So at this point in time, it just gives me the detail for this particular alarm that I've just created. And the state is okay for now, right? Config status is pending confirm because I need to go back to my email and confirm my email as well. And below here, it also shows the warning. It kind of warns you twice, pending confirmation, and then of course, it also provides the message as well. The history will tell you the history for this particular alarm. So that way you can set multiple alarms for each of the instances at anything that you want to. monitored. So let's navigate back to our console where we successfully created the alarm and click close. So now I already have under monitoring tab for this particular instance, Java web app instance, I have created successfully a CloudWatch alarm. Practice with this. If you have any questions, post in the discussion area. I'll be glad to help. And with this, let's move to the next lesson.
Hi everybody, and welcome to this lesson in which we're going to look at CloudTrail and how they relate to EC2 instances. So basically, we can log EC2 and EBS API calls with CloudTrail. So CloudTrail is basically a service that provides a record of actions taken by a user, by a role, or by a service in EC2 and EBS. So it captures all API calls for EC2 and EBS as events, including calls from console and from code calls to the APIs. So if we create a trail, we can basically enable continuous delivery of events to an S3 bucket, including events from our EC2 instances, including their EBS volumes. So basically, CloudTrail is enabled on our account by default when we created it. So it's nothing that we need to enable. When an activity occurs in EC2 and EBS, the activity is recorded in the CloudTrail event along with the service event in the events history. So as you guys can see, I've navigated to the CloudTrail, and if I click on the events history, you can see the different event history that's happened, right? So I have not enabled CloudTrail. I have not configured. This is literally the first time that I've gone into this dashboard with this account, and you guys can see that it automatically has started populating all of the trail events. So a trail is basically a configuration that enables delivery of events to an S3 bucket for our analysis. And the log files that CloudTrail basically creates contain, log entries that give us information regarding the status of that specific event. So we can use CloudTrail to audit users that connect to our instances via the EC2 Instance Connect. So as you guys can see, we can use this to audit the SSH activity via the EC2 Instance Connect. So as you guys can see, if I filter an event source, right? So there's different filtering options that I have with this. So if I filter an event source, and in the event source, I'm going to specify the EC2, and I can optionally specify a time range, right? So obviously for audit purposes, the more granular you have, the better it is. So I can specify an audit range of when I want, specific day, specific time, and it lets me know all the entire trail for this event source in terms of who logged in, what happened. So there's a describe tags event, right? In the US East region, this was the access key that was used. This was the request ID, the source IP address. So very detailed information in terms of every single event that happens within the EC2 instance. And if I click on the view event, this basically gives me a full event information in JSON format, right? So the again, the account ID, the access key that was used, the time, the source, what happened, what the event was. So describe tags was the event, the user agent, who was used, the source IP. So very, very detailed information for our logging purposes. Now, if we've configured our account to collect the trail events in an S3 bucket, we can download them and audit them and search through them and basically put them in a database if we want. Make an application to conduct our audits. It's very useful information for the internal audit team to keep track of who's accessing what, just to ensure that our policies and procedures are being adhered to, especially if you have sensitive information on certain servers, on certain EC2 instances. This is a very, very good tool to use to keep track of that. So here in the trails, I can basically create a trail to monitor my EC2. And I can apply the trail to all regions or to specific regions. And I want to apply the trail to, again, my organization, yes or no, right? So the organization could have multiple AWS accounts. Whether I want specific things, I want read or write or both. Basically, here's where it's going to store the trail. I want to create a new S3 bucket. There we go, the logging is turned on. So all the logs are going to be basically saved in this S3 bucket. And if I were to go ahead and go into my S3, there we go, I can verify that the S3 bucket has been created. There's already a folder in there, AWS logs, this is my account number, and the trail digest and the cloud trail. So it will start getting populated for each specific region. As you guys can see, it's getting more and more detailed, right? So it's the account name, the cloud trail, the region, the year, the month, and the day. So it's basically 9th of October 2019, and these are all of the cloud trails and lets me know what's happening with what. So very detailed information it will keep track of. Just keep in mind that this is a chargeable event. So if you're working on a free tier account, just keep that in mind. But it's a very useful tool for audit purposes to keep track of who's accessing what, and even very, very specific information in terms of what was accessed within those EC2 instances in terms of the services that were accessed. So I'm going to go ahead and go back and quickly delete this cloud trail. And in order to delete the trail, it's fairly simple. So if we go into our cloud trail, open it up, there's an option up here for deleting it, just to clean up all of our resources. We're just going to confirm the deletion, and there we go, it's deleted. And if we go into the event history, again, this is done by default, and the event history is populated for free. So this is nothing that we pay for, and optionally, we can also download all of these events. So if you don't want to have a paid cloud trail automatically populating in the S3 buckets, you can come in here manually and download these, let's say for a specific time range. You can download it as CSV or JSON files and do your analysis that way. That way you're not charged for the cloud trail service.
Now let's take a look at the design principles as they relate to the IAM, or Identity Access Management. This is one of the very important key areas as a solutions architect. So when you think about the IAM management, the design principles that you should keep in mind are that you're wanting to create a strong identity foundation. You can do that by leveraging the principle of least privilege. So not everyone needs to be an admin, right? Not everyone should be an admin. So members of your team should have, minimal permissions to do what they need to do, and not necessarily, have all access. So all of these components within your infrastructure, such as EC2 instances or Lambda functions, should have the permission, only to those individuals that need to do their jobs, and not necessarily more. You should also enforce separation of duties, and you should also reduce or eliminate the need for long-term credentials. So remember, within the IAM management service, you have the ability to create roles, and roles are very powerful, very effective, and that would allow you to delegate permissions to other Amazon services, maybe Lambda, Elastic Beanstalk, EC2 instances, or, let's say to another account even, cross account. So instead of relying on long-term, right, embedded in the code, for example, or sharing long-term credentials, you can rely on roles to grant temporary credentials, so that if those credentials were somehow compromised, you would know that they will expire. So as you move forward, as we move forward through this IAM, keep these core design principles in mind. And these are important because they will take you a long way. And even in my experience working on enterprise projects, IAM roles, groups, they play an extremely important role. So with this, let's move to the next phase of IAM. Now let's take a look at the securing identities and credentials. How do you do that? So with the Identity and Access Management Service, this is responsible for authentication and authorization of, let's say, for users for accessing various AWS resources. You can create users. You can organize those users into groups, like I mentioned earlier. You can also set a password policy and enforce certain types of passwords to be created. And these are pretty basic, right? You can also enable MFA, multi-factor authentication. But remember, the management and configuration of these things is your responsibility. Any of these credentials that you actually create for end users, it's actually the solutions architect's responsibility as well as the organization's responsibility to protect those credentials. And those credentials come in different forms. You have access keys, for example, which is simply a pair of access ID, right, with a secret key and ID. And those are used to access AWS APIs. You can, use the CLI tools or the SDKs. And those credentials, you can access, or secret keys are considered long-term credentials. You can also give your users the ability to log into the management console by granting them a username and a password, and that's typical. It's worth noting that when they log into the management console actually makes use of the API in the backend. So the management console does not have any kind of special hook, right, that bypasses the APIs. So all of these would be long-term credentials. But again, that's your responsibility to create and manage and secure and follow those principles, or the design principles that I just talked about earlier. As far as the users are concerned, you can use the IAM management service to create users, straightforward, and those are created and exist within the IAM service. Just like we talked about that you can give them, the ability to log into Management Console. Each person can create its own access keys. You can create policies that allow them to create their own access keys, but also prevent them to interfere with someone else. And of course, they can use those long-term access keys to configure the local environment, local tools, CLI, SDK, for instance, or other resources. You can also enable the multi-factor authentication device per user. So you have additional controls such as policies, so that each user can configure their own MFA device and not interfere with someone else's device. You can also organize users into groups, right? Let's say John is part of the developer team, right? So you can create a DBA group or developer group, right? So like we talked about in the design principles, you should be following the principle of least privilege, remember? So the users should have enough permissions to do their job, but not enough to step on someone else's toes, right? So if a user needs more permissions than what they currently have, then they should be following a change management process. In other words, they have to seek approval or explicitly request the additional permission from the solutions architect or the engineer, right? And so these are some of the core key areas that you need to kind of think about. So remember, we have different credential types. So if you find yourself logging into the AWS Management Console within, let's say, an email address and a password, you are logging into the master account, which has the root account or root access, right? Or the admin access, for example. So if you're logging in with simply a username and a password, then you're logging into AWS as a web management console as an IAM user rather than the master account user. And then you have the access keys, secret keys, that are again used to configure the CLI tools for the SDKs. You also have temporary credentials, right, that we just talked about, and I'm going to talk about also in future lectures as well. So just to recap quickly, the IAM to choose the credentials carefully, right? So, and recall the shared responsibility model. So as a customer, your responsibility is to configure users, right, for the customers appropriately. And it's your responsibility to protect those credentials, whether it be a master account credential or a credential or particular credential for an IAM user. So as a solutions architect, you need to be very careful and also document these credentials, because over time they grow and you'll find yourself going all over the place if you don't have a solid documentation. So this is also just a tip for you as a solutions architect. So I hope this helps. Just kind of follow along the design principles of least privilege, understand the different types of credentials, know when to use them, only grant minimal access to particular users, including creating groups, policies, and roles. With this, let's move to the next lesson.
Welcome back. So finally, we're at the end of this course, and here are some key takeaways, very important that I'd like to cover that we've been talking about and practicing and doing hands-on and understanding all the concepts, right? So becoming an AWS Certified Data Engineer Associate involves mastering various data-related AWS services and tools, and also understanding how to design, implement, and manage AWS-based data solutions and data pipelines. So, for example, we talked about understanding data sources, right? And we talked about the fundamentals of data itself, the data lifecycle. So, knowing how to identify and differentiate between various data sources, including streaming data versus batch data, or data lakes, data warehousing, and understanding how AWS services can manage these sources effectively. Another important key takeaway from this course was the AWS Data Services mastery. So master the different AWS data services such as AWS Glue, AWS Kinesis, Redshift, Athena, Glue, EMR, DynamoDB, RDS, right? All these services that we've covered extensively. Also understanding their features, use cases, and how they integrate, more importantly, into the data engineering solutions. Another key takeaway that we talked about was data processing and ETL. So here was the extract, transform, and load processes, right? So being proficient in ETL processes using AWS Glue and other services and how these services integrate, and knowing how to clean data, how to transform data, and how to move data effectively across different storage solutions such as AWS S3 or Amazon Redshift, right? All right, now the key takeaway was data storage solutions. So understanding the various storage solutions provided by AWS such as S3, Redshift, DynamoDB, and their optimal use scenarios based on data requirements, scalability, and performance. Next, key takeaway was the data security and compliance. So comprehending data security practices, best practices, encryption methods, access control mechanism regarding IAM, security policies, groups, VPCs, and compliance standards related to managing data on AWS. Next, key takeaway for this course was analytics and visualization. So knowing how to leverage AWS services for data analytics, including setting up data pipelines, running complex queries, and visualizing data effectively using tools like Amazon QuickSight. Next is optimization and performance tuning. So understanding how to optimize your AWS data solutions for performance, cost, and scalability. Now this includes fine-tuning data storage, right? Fine-tuning processing, performance issues, log and analytic components. Next is troubleshooting and monitoring. Here we gain some expertise in monitoring data workflows, identifying bottlenecks, troubleshooting issues, implementing effective monitoring strategies using AWS CloudWatch and other monitoring tools. Next key takeaway was data governance and compliance, right? Comprehending the concepts of data governance, compliance requirements, and more importantly, the best practices for ensuring data integrity, consistency, and compliance with regulations. And finally, we also took a look at some hands-on real-world applications. We're gaining practical experience through exercises, labs, practice exams, and real-world scenarios to apply your knowledge in building, managing, and optimizing data solutions on AWS. So, preparing for the AWS Certified Data Engineer Associate exam involves hands-on experience, in-depth understanding of AWS services and how they relate to each other, and a solid grasp of data engineering principles within the AWS ecosystem. So here are the key takeaways. I hope this course has helped you. Let me know if you have any questions with this. Let's move to the next lesson.